Bob Ziroll is one of the most viewed React instructors in the world. And now he's back with a brand new complete React course that will teach you modern React using patterns like functional components and hooks. If you want to learn the React JavaScript library, this is the video.
Hey free code campers, welcome to my newest course on learning React. In this course, you're going to solve over 140 different coding challenges and work on 8 different projects, all of which have an associated Figma design file to guide your work. And you actually have 2 options for following along. Either by using your local machine, I actually have a few lessons that'll show you how to do that starting pretty early in this course. Or you can head over to Scrimba.com where there's an interactive version of this course so that you can solve the challenges directly in your browser. It's totally up to you what you want to do. The link to the course on Scrimba.com is provided below. And actually, this course is part of a larger front-end career path, which we have at Scrimba, which takes people from zero to hireable as a front-end developer. This course is module 11 in that career path, and my more advanced React course immediately follows this free React course as module 12, where I go even more in depth into React, React Router, using the context API, and so much more. If those topics sound confusing to you, don't worry at all. You don't need to take them to understand this course. Now, I always appreciate any feedback you have for me about the course, so you're welcome to reach out to me on Twitter at @BobZiroll, or if you have any questions about your specific code, the best place for those is to either reach out to the freeCodeCamp forums or Discord server, or you can check out Scrimba's own Discord server, which is becoming a more and more deeply integrated part of the whole Scrimba.com experience. And with that, good luck and have a ton of fun learning React.
Hey there, and welcome to the Learn React module. I'm super excited you're joining me for this course because by the end you'll have built not 1, not 2, but at least 8 projects using React. There's so many of them, I don't even have time to go over each one of them in detail right now. I could barely even fit them on this slide. So why are we doing so many projects? Well, it's because I designed the curriculum for this course to be project-driven. In each of the sections, we will start with a goal project that we are working toward, and then we'll learn everything we need in order to build that project. Now, in order for that approach to actually work, I'm going to be asking a lot from you. So let's talk for just a bit on how you can get the most from this course. Just like everything in life, what you put into this course is what you will get out of it. Or as I like to say, my philosophy about learning is that the easiest way to learn something is to do it the hard way. In this course, I'm going to be asking you to do a lot of the work. For much of it, you'll have me there after each challenge to walk you through a solution, but for some of it, you won't. Either way, what I'm asking of you now is to avoid the trap of tutorial hell, where you end up passively watching me do all the work. Remember, this is not school. You're presumably here because you actually want to finish the course with the ability to write React code by yourself. School has taught a lot of us that the goal of learning is to get a good grade. In fact, I heard something really interesting that said that education is the only thing that humans try to get less out of than what they paid for. So don't let that be you in this course. If you really give it everything you've got, meaning you do all the challenges and projects, you're involved with the community, and you are an active participant in your own learning, I can promise that you'll probably finish off in a better spot than many students getting their degree in computer science. And I really don't say that lightly. Along those lines, remember that spaced learning and repetition are your best friends. Binging the course from beginning to end, even if you are doing all the assignments, is kind of like trying to run an ultra marathon without training. Your brain actually needs rest, so take breaks often. By taking this course, the goal isn't just to get to the end, it's to get to the end with some honest-to-goodness React skills. Then after you come back to this course on maybe the next day, don't be afraid to re-watch some of the past lessons and even redo some of the past challenges. Because repetition really is your best friend whenever you're trying to learn something new. So what should you already know coming into this course? Before jumping into React, you should have a solid grasp of the fundamentals of web development, namely HTML, CSS, JavaScript, and preferably a pretty solid understanding of the new syntax that was introduced back in ECMAScript 6, ES6, and above. If you're feeling at all rusty on any of these topics, you can click the logo for each one of these, which will send you to another free course here on Scrimba, where you can brush up on those skills. My name is Bob Ziroll. I'm going to be your instructor throughout this whole course. My username pretty much everywhere online is Bob Ziroll, but these days I'm really most active on Twitter. You can click the Twitter icon to go to my profile if you want to follow me. That would be great. And so without any further delay, let's jump right in and start learning React. In the first section of this course, we're going to be learning everything we need in order to build a basic static page using React. And I know what you might be thinking, but I already know how to make static web pages. I know you're probably super excited to really dive in and learn dynamic web applications with React, and we are going to get there in this course. But in order to start off, this section is all about learning the basic syntax and you could say the vocabulary of React. Because I found that the best approach to learning React is to first start learning how to think in React. The reason for this is because React really does kind of change the game in terms of how you build applications. Later in this section, we are going to start learning the differences between declarative and imperative programming, and you're going to find that React approaches web development in a completely different way. So the point is, we're first going to be dialing in our brains to start thinking in terms of using React to build websites by first building some static web pages, not unlike the ones that you normally would just use HTML and CSS for. So this might not seem terribly exciting right now, but I think you'll soon see that writing composable, reusable components in React can actually be a bit addicting and pretty fun. So I know that you'll find a lot of benefit in starting off with the milk before we get to the meat, or of course we have a vegetarian option as well. The content in this section will be driven forward by the goal of creating our first static web page in React. And that's the page you see here in the screenshot that has a list of fun facts about React. Now, this screenshot is actually also a link to the Figma file for the design of this page. So if you click this screenshot, it will open up in Figma. You'll have to make sure that you log into your Figma account. If you don't have one yet, it's free to create. And clicking the screenshot will lead you to a sort of shared file that everyone will have access to. In that shared file, you'll see something near the top that looks kind of like this, where it's got React facts and then this little drop-down arrow. Your best bet is going to be to click that drop-down arrow, go over to duplicate to your drafts, and click that. Duplicating this design to your own drafts is going to make it possible for you not only to edit the design if you want to change it a little bit, but also to help you avoid any distraction you might see on the design page of anybody else's cursors or maybe some comments that they may have left. So I'll go back to this design here. Make sure to click on it now so at least the URL gets saved up in your tabs in your browser. And lastly, we're going to look at the different topics that we'll be covering in this section. So what are we going to learn about? Well, first we're going to learn why we even care about React in the first place. I think knowing why React is so exciting and so popular will help make your learning journey of React a much simpler one because you'll be so excited about what you'll be able to create in the end by using React. We'll also be talking about a proprietary React syntax called JSX, and we'll get to see how that sort of changed the game for React and made writing React a much more familiar experience. Then we'll dive into creating custom components, and you'll learn all about what that means and how to actually do that yourself in React. And of course, in order to build our project, we're going to need to know how to apply CSS styling. Again, the goal is for us to be able to build this simple static page in React. I'm really excited for us to get started. So without any further ado, let's jump right into the deep end and start writing our first React code. Before we just jump right into theory and why we care about React and how all the little pieces of React work, I want to get your hands on the keyboard typing some React code as soon as possible, mostly just to show you that React is not a scary library to be working with. So let's see how we can set up React. Now, I like to think of there as being an easy way to set up React in your project and a correct way of setting React up in your project. For our sake in learning, we're going to start with the easy way, which will also make it so that you can actually just do this in your local environment. Hopefully you're following along here on Scrimba.com, but if you're curious and you're interested, you can always do this on your local environment as well. Now you can see I have a very basic HTML page set up. I have nothing in my JavaScript at all. My CSS is minimal, and we're going to walk through this together. Now I have some slides here, And you can actually click on this screenshot and that will send you to this exact page. In the React documentation, it tells you how you can include React into your project. And we can actually pull in these libraries that we need straight from a CDN. In other words, we can just copy these two script tags here and start writing React code. There's a little more to it, but what I'm going to do is click here, and that's going to open me up to the React page. I'm just going to copy the two script tags that you can see. And over in my index.html, I'm going to put it in the head here. Let me fix the indentation. And I've pulled in the React library and another library called Reactdom. Theoretically, this is all I need in order to start writing some React code. Now, I'm going to take it one step further, and that's because just pulling in React and Reactdom is going to be pretty extremely limiting in terms of using the power of React, unless we also pull in something called Babel. I'm not going to jump in too deep into why we need to pull in Babel. For now, all I'm going to do is click on this screenshot here, which will take me again to a page where I can copy the script tag that you see. And I will paste that in underneath this script tag. And if we look really closely below here, it says you can use any JSX. We'll cover what JSX is later in any script tag by adding type equals text/Babel. So I'm going to do that here in my script tag down here. Type equals text/Babel. And that's all the setup we really need. By pulling in the React-DOM library in this script tag, I now have access to a global variable called Reactdom. I'm going to use that to render something to the screen. Once again, I'm going to be covering everything that we're talking about here. It's totally okay if this is moving pretty quickly. Reactdom.render allows me to render something that looks very much like HTML. Now, this might be blowing your mind a little bit because this probably looks a little strange writing some HTML inside of my JavaScript. We're going to see how this is kind of one of the beautiful things that React has added so that we can write really declarative code. Now, let's put something inside this H1 that's meaningful. We had hello React over here. Maybe I'll say hello everyone. Okay, in my index.html, I'm going to get rid of this H1 so we're not confusing this H1 with what I'm seeing over here. Now, Reactdom.render, the first thing is what do I want to render to the screen? The second thing is where do I want to render it? Well, let's go to our HTML and I'm going to create a div here. Just a completely empty div, and I'm going to give it an ID so that I can select it. We'll call it root because this is going to be like the root of our entire application. I like to think of this div as a container for the entire website that we're going to build in React. And now that I have a place where I can put my H1 here, I'm going to select it with a regular DOM API document.getElementById root. And surprise, we've written some React code. I'm going to hit save. We'll see that it tells me, hello, everyone. In a single line of code, I was able to use React to insert something that looks very much like an H1. Obviously, this is a little different because we're still inside JavaScript. And I was able to put it right inside of this real DOM element in our index.html. Now, I have an entire lesson that's dedicated to understanding exactly what's going on here. But in an effort to get your hands on the code, get a quick win for you to see that you can write React and it's not too scary, I'm going to give you a few seconds of silence where you can pause the screencast and study this line of code, and then I'll be erasing it and letting you type it again from scratch. In fact, let me write that down as a little challenge here. Okay, pause the screencast here, spend just a minute memorizing this line of code. Do that now. And then I will add a little comment with the next part. Okay, your time to shine. Rewrite the line of code as best you can from memory. You don't have to put hello everyone or hello React or whatever. You even don't have to use an H1 like I did. You can put whatever HTML you want in there. So pause the screencast now and work on that. Because I pulled in that React DOM library in my CDN, I have a global variable called Reactdom, and it has a render method, which allows us to render something to the screen, or kind of, in other words, place something on the screen. And I don't know, let's do a paragraph this time, just to switch it up a tiny bit. Say, hi, my name is Bob. Okay, so that's the element that I want to place inside of this div. Again, this div is a container for the actual elements that I plan on putting on the screen. And the second parameter that I need to include with Reactdom.render is, you could think of it as a DOM node that I have to go select with document.getElementById, or because I can also get DOM nodes with something like query selector, that would work just as well. In this case, I'd have to put #root because that's how query selector works. It's the ID of root. Just so this isn't confusing, we'll just keep it as getElementById for now, but just so you know, either one should work just fine. So the first parameter is what do I want to place on the screen, and the second one is where should I be placing this? I imagine under the hood, what render is doing is it's taking this DOM element that we are grabbing with getElementById, and it's running something similar to .append or .appendChild to it. And what is it appending? It's appending this paragraph. We're going to see that it's a little more complicated than that, but that's a good way to kind of build a mental model for yourself as to how this is actually working. So I haven't refreshed the page yet, which is why this still says hello everyone. I'm going to hit save, which will refresh my browser, and there we go. Hi, my name is Bob. This time it's a paragraph instead of a header element, and that's awesome. We have written React in a single line of code. You might have noticed that our console is popping up with this error. You're using the in-browser Babel transformer. Be sure to pre-compile your scripts for production. A bunch of jargon here that may not totally make sense to you. And that's fine. That's a symptom of us setting up React the easy way instead of the correct way. Soon down the road, we'll be kind of shifting our setup here, and that warning will go away. And awesome. Okay, because this is Scrimba, you can always delete this. If maybe you weren't able to memorize that, you can try deleting it, rewriting it again from scratch. Practice with it. I'm going to ask you to do that a million times throughout this course because the only way to learn React is to write React as much as you can. Now, I have found it really helpful for my own learning to understand why the heck I even care about React in the first place. So in the next couple screencasts, we're going to be talking about some of those really awesome benefits that come with using React as our library for building web applications. But as always, if you want to spend more time with this, go ahead and do that. Pause, click into the editor, start typing what you want to type, practice it. And when you're ready, I will see you in the next lesson. Surprise! If you know my teaching style, I wanted to include a practice in here. Essentially, you're just going to be rewriting that same line of code that we just wrote in the last lesson. However, this time we'll extend it just a little bit. I want you to see if you can figure out how to render an unordered list with 2 or more list items inside. Last time we just rendered a paragraph. You can see it's still kind of left over here. If I refresh that, that'll disappear. I've left the entire setup here for you. We're still pulling in the script tags for React, Reactdom, and Babel. So essentially your main focus is just to rewrite that same one-liner of code, but see if you can figure out how to add a couple more elements inside, like having an unordered list with some nested list items. Pause here and try to work on that challenge. Okay, pulling in the Reactdom library that gives us access to a render method. Before we did a simple paragraph like this and put some code inside. However, I can put this as an unordered list and then just actually stick some list items inside of here. So it's going to look a little confusing at first. I'll clean it up in just a minute. We have list item, we'll just say thing 1, and I'll do another list item here, thing 2. Okay. Now I'm going to move this onto its own line here, this whole HTML thing right there. And the second parameter I need to separate with a comma is where to put this. So I'm going to use document.getElementById root. And let's cross our fingers, see how this goes. Cool. Okay. Hopefully that was some good practice. Now let's keep moving forward and learn a little bit more about why we care about React. One more thing that was highly requested from the first time I recorded this React course was how can I set this up on my local environment? Everything that I'm doing will be done on Scrimba.com so that you can interact with the same code that you see me writing. However, it's also a good experience to run it locally on your own computer and get a feel for what it would be like to actually develop React on your own computer. Again, our setup here is more of the easy way than the right way, but for now what you can do is you can click the little gear icon in the lower right of your Scrimba editor, which will pop up a little menu here, and there's an option that says download as zip. That will download a zip file containing the files that we're working on here. You can uncompress that like you normally would any zip file and open that up in any editor that you'd like, for example, Visual Studio Code on your own machine. Now, in order for that to run, I'm going to show you what that looks like on Visual Studio Code. Inside of Visual Studio Code, which is what you see in this screenshot, there's a menu icon for some extensions, and you'll need to search for an extension called Live Server. It's created by Ritwick Day, and you'll need this installed to your VS Code in order to run the code that we have written in React. So you'll click the little install button. That's going to put an icon down at the very bottom menu bar in Visual Studio Code that says Go Live. And all you need to do is click that Go Live button, which will open a web page on a local server. I think it's maybe port 5000 that it runs. And that should launch your own React project on your local machine. As soon as you see me move toward a different setup for React that includes Webpack and downloaded dependencies from NPM and so forth, this is no longer going to work in quite the same way. But for now, for those that are curious, I thought I might just explain how you can get this set up on your own machine. Okay, that's enough delaying. Let's keep moving forward with the course. Let's spend a little bit of time understanding why we even care to learn React. One of the main reasons that people will talk about is how React allows us to write composable code. So what exactly do I mean by composable? Well, an analogy that I came up with has to do with sculpting. If you think of the statue of David, for example, this statue was created originally from a single giant block of marble that was then sculpted down to the sculpture that we know today. So in the end, what results is one giant single piece that makes up this piece of art. Now, what if instead of starting with one giant piece, we instead used a bunch of small pieces to put together something that is greater? These are Lego bricks that obviously are small, each in their own right, that were put together to create something large. In this example, they all kind of work together to accomplish a goal, so to speak, the goal of looking like the statue of David. Now, this example is not perfect because the original statue of David obviously is more beautiful than this replica made of Lego bricks. But hopefully the concept makes sense. Let's look at an example in actual web development. What I have here is copy and pasted from the Bootstrap website. If you're not familiar with Bootstrap, that's really not important right now, but it's enough to know that these 30 or 40 lines of code, copy and pasted from the Bootstrap website, represent a navigation bar that is pre-styled. Now, in the old days of web development, a single page on a website was usually a single HTML page. So if this is just the nav bar, a lot of times those web pages would end up being thousands and thousands of lines of HTML code, essentially making it one giant sculpture. Well, with modern frameworks like React, we can take code like this and we can put it into our own custom components. And we can put those components together to make something that is larger. But in our case, our code becomes a lot more maintainable and a lot more flexible. You can see I've given these kind of silly names to show you that these are not regular HTML elements. I can combine elements together that are real HTML elements, like you see here, into my own custom component called, for example, my awesome navbar or my awesome footer. We're not quite ready to dive into the syntax of React quite yet, but I'm going to give you a taste of it and a chance to play with it before we move on. So let's see this in practice. Over here you can see I have my Reactdom.render and I'm rendering a custom component called navbar. And if I scroll up, you'll get a chance to see how I created that navbar. As a quick aside, one thing you might notice is that I'm using class name everywhere instead of class. That's not a mistake, that's just how you have to assign classes in React. We're going to cover that later. But for now, I'd like to give you a challenge that's going to require you to deduce what I've done here and try to replicate it for yourself. So let me put that here. Okay, your challenge is to see the navbar component that I have created and see if you can deduce how to create your own component called main content. It can return something really simple like a single h1 element, and afterwards I want you to render it below the navbar. You'll have to figure out how to render it below the navbar. Now, I've changed this a little bit for reasons that we'll talk about soon. But this line here, 51, this is where you're going to figure out how to render your own custom component main content. So first, build your custom component, looking at my example above to try and figure out how to do that. And secondly, render that component down here in Reactdom.render. Pause the screencast and work on this challenge. Well, following the example above, we see that I created this component by creating a function. and the name of the function is the name of my component. So I will open up that function and return the content that I want to show up on my page. Above, I created a set of parentheses because I have many elements that I'm trying to return. I'll just do that just to keep things consistent for now. We'll create our H1 that says I'm learning React. And secondly, I can take my main content and I can render it by making it look kind of like an HTML element. In this case, it's a self-closing one, so I have main content as a single tag here, and if I hit save, we'll see that my H1 actually showed up on my page. And that's the concept of composability. It goes quite a bit deeper than this. We're going to see how we can make our components much more composable and reusable. But for now, let's move on to another reason why people really love React. And we'll cover that in the next lesson. Another major reason people love React is because it's something that we call declarative. So let's talk about declarative. To understand declarative, it's helpful to know that its opposite is something called imperative. When a program is declarative, we can simply tell it what should be done. More specifically, it's like the computer saying, just tell me what to do and I'll worry about all the nitty-gritty details on how to get it done. Its opposite, imperative, is when we need to tell the program how it should be done. Like the computer saying, I need you to describe to me every step along the way how to do something, and then I'll do it. Up until now, if you've mostly been just using vanilla JavaScript anytime you needed to create elements on the page, you've been doing it in an imperative way. In fact, let's go look at what that has been like. I've commented out my Reactdom.Render, and I'm going to put a challenge here for you. Okay, your challenge is to recreate this above line of code where we are rendering something to the screen using vanilla JavaScript by creating and appending an H1 to our div with the ID of root. We have our div ID of root. You'll need to select it and then append a new element. And I give you the step-by-step instructions right here. One little caveat is I don't want you using inner HTML because that kind of breaks the analogy down a little bit. Generally speaking, this is actually just a good way to practice the vanilla JavaScript that you have been learning so far, so it's always good to give it some practice. I'll give you a couple lines here, pause the screencast, and work on this challenge. Okay, let's work on this. So I'm going to create an H1, and I'll use document.createElement, and I'll make an H1. And then if I'm giving it some text content, I need to use the text content property of this DOM node and set it equal to, I don't know, maybe this is an imperative way to program. Then I need to give it a class name, so I'll use the class name property here and set it equal to, I think we said header. And finally, I need to append it to my div with the ID of root. So first I need to say document get element by ID root, and then use the append property or method to append my H1 to the DOM. So when I hit save, it should show up. This is an imperative way to program. Perfect. Now this example's a little bit on the nose because if you were really just putting something static that had nothing to do with user interaction, you probably would just go to your HTML page and stick it right inside the div here, right? But with React, we're building our entire page in JavaScript. And so doing something imperatively this way, where I have to tell it step by step how to create the element and then to add some text content and then add a class name and then append it to the DOM, that's going to get old pretty fast, especially even with something mildly more complicated than a single H1, like a very simple web page like this. As soon as we have more than one element, suddenly our 4 lines of code will become probably dozens or maybe even hundreds of lines of JavaScript code just to create and append all of these elements in the correct order and in the correct way. And so that brings us back to the idea of writing our code declaratively, and React allows us to do that in a really simple way. As we see back up top, when we comment this out and uncomment this, we essentially get to write our JavaScript as if it were HTML. We are relying on React to figure out how to turn what we have declaratively written as an H1 into the JavaScript code that's needed to append it to the DOM. In fact, if I were being strict and wanted to make this more equivalent, in order to add a class name, I can just add a class name as if this were an HTML element. Again, this is class name instead of class for a good reason, which we'll talk about. But that's a pretty minor difference to be able to do all of these lines of code in one single section right here. And that difference is going to compound as we get into more and more complicated UIs like we see here. So at this point, I could probably continue talking about different reasons that we're choosing to use React and that it will be really beneficial for you to learn React. As you see on my little list here, it's a very hireable skill and it's actively maintained by really skilled people at Facebook. However, at this point, I think we're overdue to just jump into the syntax, get your hands on the keyboard, and start learning and practicing React. So when you're ready, let's keep moving forward. Okay, let's finally address this elephant in the room, what we're looking at here, why we have what looks like HTML stuffed right inside our JavaScript. Well, fairly early on in the days of React, the React team created a syntax that's called JSX. JSX stands for JavaScript XML, but that's not terribly important for you to memorize. What's most important is to think of it as sort of a flavor of JavaScript that looks a lot like HTML. And with the introduction of JSX into React, it really made it so that React was very declarative instead of imperative. We can see up above what it took for us to create an H1, give it some text content, and give it a class name in regular vanilla JavaScript. But with JSX, the benefit is that we can just write what we're already used to writing with HTML. Now there's a couple of small differences. For example, instead of using class, I need to use class name. So I might say class name equals header, for example. And there's a few other of these, but for the most part, with JSX, we can just write the HTML that we're used to writing. At first, it might be a little bit confusing to write your HTML inside of your JavaScript, but I promise as you start doing React, it's really going to start making sense. You're going to learn to love JSX. Now, one thing that was really helpful for me to understand as I was learning was to see the difference between what JSX is and what our regular DOM elements are. So I'm going to do a few things. I'm going to uncomment these lines of code here, and I'm also going to take this piece of JSX and set it to a variable. We'll call it element. Then I can fix my Reactdom.render by just putting element down here, and this will work exactly the same. But this allows us to console log it. So let's console log element, and I'll hit save so that this code will run. I'll open the console, and we'll see the differences here. First of all, on line 4, we are console logging the DOM element that we created with document.createElement. And that's what shows up in our console as what looks like an HTML element here. So that's this line right here. However, when we console log our element that we created with JSX, what actually got returned to us was this. And let me copy this out. And we can see that this is just a regular JavaScript object. Let me clean it up just a little bit to make it even more clear. So in the end, what we get from JSX, or rather what React is creating with JSX, is actually just plain old JavaScript objects. And those objects describe the DOM element that we want React to put onto the page for us. And if we look closely, we can see some interesting information here. First of all, we see that it has very similar properties, like we have class name, where we're setting that to header. And down here we have props, or short for properties, and we have class name. We also have something called children, and we can see that's actually the text that we put inside of our H1. That's about all I care to touch on with the object nature of React elements, but I thought it would be helpful to kind of kick us off understanding that JSX is kind of like a function that when it's run, returns us objects that React can interpret and use to create actual elements that get put on the screen for us. I'm going to comment this out so we can talk about one more thing, clean up this a little bit. And I'll go ahead and put this directly back in line to my Reactdom.render, move these onto their own lines. The last thing that I wanted to touch on was that with JSX, we need to make sure that we are only returning a single parent element. In other words, I can't take this one H1 and place, say, a paragraph directly next to it. because in this case, we're rendering or attempting to render two sibling elements that sit side by side. In fact, if I try to run this, you can see React complains, and I guess in this case it says unknown error. Sometimes it will say that you have to wrap the elements that you're trying to render in some kind of parent element. Now, this doesn't mean that I can't put two elements on my page at any given time. It just means that I need to wrap them in something like a div, for example. So if I say a div that has an h1 and a paragraph inside, now I am rendering just one parent element, and it doesn't really matter how many children elements are included, as long as I have one parent element that I'm rendering. So I can hit save. We'll see that this is working just fine. Now, remember how I was able to save my h1 as a variable? Well, I can actually save a whole collection of JSX, for example, this div with the h1 and the paragraph, as a variable. So let's say const page equals, and then I can paste in my elements here. Now, to me, this looks a little bit crazy. So normally what I like to do is move my elements, my JSX, onto their own lines as if this were HTML. But in that case, I need to go ahead and wrap everything in parentheses. Now, take a second and think, how is it that I can then fix what I have down here? We can see we have a syntax error. How can I fix this so that when I refresh the page, this is still working? Pause here and see if you can figure out how to make this work again. Well, all of my JSX is being saved under the variable of page, so I should just be able to put page here and hit refresh, and sure enough, that's working just fine. Hopefully some of you were kind of curious to see what this looks like as a JavaScript object. If we console log page, we can see that essentially we got what we had last time, but this time it's a little more involved. Specifically, in the children property of our div, we see that there's other React elements in there. I'm not going to dive too deep into that. Feel free to copy and paste what you see in the console, maybe clean it up a little bit and analyze it. But the point is, I can save a whole bunch of JSX into a single variable and then use that variable kind of like any other variable. And the key is, that's because what I'm getting back when I write my JSX is just a JavaScript object. Okay, I'm going to clean this page up a little bit. And I'm going to comment out our page because I'm going to give you a challenge. Okay, I left our example of const page up here just for reference, but I did delete our code that we had at the bottom, which actually enabled us to put something on the screen. And that's because I want you to practice it again. So your challenge is to create a navigation bar using JSX. I've given you some instructions here on what the content should actually be. And as I mentioned at the very end, don't worry about styling yet. We're going to cover styling soon, but for now, what you're going to have is just going to look like plain HTML that's unstyled. So pause the screencast here and see if you can complete this challenge. Okay, before I worry about the Reactdom.render bit, I'm going to create a new variable. We'll call it actually, let's call it navbar. And I'm going to use my parentheses so that I can start my element on the next line. And like I mentioned, we want to use the semantic nav element. And inside of there, I'm going to have an h1. Let's call it Bob's Bistro. Maybe this is a restaurant. Okay. And then we have an unordered list. And hopefully while you were playing with this, you came to realize that it doesn't matter how nested I get. Just like in HTML, I can nest this as deep as I want. We'll create 3 list items. And it said pricing, about, and contact. And I don't know, maybe if this is a restaurant, I'll say menu instead of pricing. Okay, I've got my JSX for my navbar set up. And then the last bit, which was just meant to be something repetitive that allows you to get some muscle memory for this, is to use Reactdom.render. And the first parameter is what do I want to render, and that's my navbar JSX. And the second thing is where do I want to render it. I'm going to do that by selecting with getElementById my div with the ID of root that is over in my index.html right there. Okay, I should hit save, and sure enough, it's pretty ugly. Obviously, we want to style this. We're going to get to that soon. I hope that challenge went well for you. If you struggled, please don't keep pushing forward. Go back, rewatch this lesson, see if you can do this again from scratch, or maybe just try typing it 10 or 15 times if you need to. Also, if you get totally stuck, don't forget that this is a community. You can reach out on Discord, ask your question, and you are more than likely to get a really friendly, helpful response back. When you're feeling pretty good about this, let's keep moving forward. Okay, at this point, it's probably time for us to switch away from the easy way of getting React set up in our project to the more correct way. Now, inside of Scrimba, that means something different than it means inside of your own local environment. Scrimba has kind of some magic that's happening under the hood that's helping React just kind of work in our project. So I'm going to show you a couple steps for how I do this in Scrimba. You won't really have to worry too much about that because even when you're creating your own new scrim in Scrimba, it'll just ask you what type of scrim you want, and you'll just tell it that it's a React scrim, and it'll set everything up for you. So what I need to do is in my index.html, I'm actually going to remove all of my unpackage.com CDNs here. So I can get rid of these 3 lines. And I don't need this type text Babel anymore because I'm not pulling in Babel. And instead, over here on the left, I'm going to add the dependencies that I need. And I need React, and I need React-DOM. If you're a little bit more familiar with developing in JavaScript, you might recognize that these dependencies are similar to having a package.json where you install these packages through npm. If pretty much everything I just said doesn't make sense, don't worry about it at all. I am going to talk about different options for local setup later. If you absolutely need to follow along in your local environment instead of here on Scrimba.com, you can continue to use the CDN way that we were just using like this. But otherwise, I just recommend doing things here inside of Scrimba. Our main focus is not going to be how to set up React, but rather how to write React. So I will take those back out. And now that I have taken those CDNs out, it means that I no longer have global variables added to my window like React DOM. So if I try to save this, we're going to see I have an unexpected token angle bracket. And that's because, well, it doesn't know what React is at all. What I need to do now is actually import React from React. This might not seem like it's doing anything because I'm actually not referencing React anywhere here. I've got React DOM, but that's something different. However, React is where the JSX syntax is defined, and so I need to import React in order for this to work at all. Now, the astute among you might be familiar with the fact that with React version 17, I technically don't need to import React. However, currently, at the time of this recording, Scrimba is not yet set up to support the fact that React version 17 and above no longer requires you to import React in order for JSX to work. So anyway, throughout the duration of this course, I will be using import React from React, and that's because, well, I need to in this environment currently. Let's hit save again and see what we run into next. And this says, cannot use import statement outside of a module. And oh, you know what? I think that has to do with another sort of magic piece that is happening under the hood with Scrimba. So I'm going to add this .pack. That's not something you'll need to do in the real world. So this should be, yep, React DOM is not defined. That's the error I expected to see. And that's because whenever we're using React DOM, I will also need to import React DOM from React-DOM. And now, fingers crossed, I should get something that works again. Okay, there we go. We're back on the screen, and everything is set up a little more similar to how you normally would see a React project set up. Don't be overly concerned with all of these implementation details. However, this is how I'm going to be setting up my projects from here on. And at this point, we actually have enough knowledge for us to start working on this section's project, which is a static HTML page in React. However, before we jump into that, I want to exercise your brain with a little thought experiment, and we are going to do that in the next screencast. I'd like to do a quick thought experiment with you, and that is to figure out why we're using React DOM.render instead of just using the DOM append method that you've probably used before in JavaScript. I've written the first line for you, and that's to import React from React. That will just allow you to write some JSX. Your challenge, as you can see in this little 4-step process here, is to create just a really simple sample page in JSX. It has to be greater than or equal to 4 elements, just to get your fingers working a little bit. And I want you to save that JSX to a variable. Remember that that variable needs to be one parent element with some children elements nested inside of it. In other words, we can't just have 2 sibling elements saved in a variable in JSX. Then I want you to select the div with the ID of root using whatever selector you want to use, and then use .append to append your JSX. If you need to do a quick Google search for how to use .append, that's totally fine. And then before you run your code, I want you to see if you can guess what's going to show up in the browser before you run the code, and then run your code and see if you can explain what does show up in the browser. Pause here and play around with this a bit. Okay, well, let's create our JSX. We'll say const page equals, and I'll open my parentheses so I can write my JSX on its own line. And we'll start with a div just to surround everything. And I don't know, let's say I'm making a page about why I love React. We'll say this is my awesome website in React. And then maybe an H3 that says, here are the reasons I love React. And we'll use an ordered list. It's not terribly important what you actually put in here. I'll just use some of the reasons that I've been talking about. It's composable. It's declarative. It's a very hireable skill to have. Let's see, I need to get rid of this. And it's very actively maintained by some very skilled people. Again, the JSX you chose to put in here is not terribly important. So we'll use document.getElementById root and then use the DOM nodes append method to append our page, and we'll see what shows up here. Now, of course, I know what's going to show up, so I'm just going to run the code, and we see that we get object object. This object object is sort of a string representation of a regular JavaScript object. Something I can do to actually make that object appear is to stringify it using JSON. So I can actually say json.stringify, and we will stringify that object so that it puts JSON on the page. I'll hit save, and look at that. We get a JavaScript object. Now, step 4, see if you can explain why this actually shows up in the browser. Well, kind of the whole purpose of this thought experiment was to remind you that JSX returns plain JavaScript objects. At this point in time, it has nothing to do with the DOM. It's not recognized by the browser as anything important dealing with the DOM. It's only when we try to render it using Reactdom.render that React can take these JavaScript objects and actually turn them into real DOM elements that the browser can interpret as things like first level headers or ordered lists. So let's go ahead for the sake of practice and fix this. I'm going to update our challenge here. Okay, simply put, your challenge is to fix our code. And don't forget, we're not using those CDNs in our HTML anymore, which is what used to give us a global variable called Reactdom. So you'll have to see if you can remember how we get access to Reactdom. Pause the screencast here and try to fix our code. In order to use Reactdom, I will need to import it, and we'll import it from the Reactdom package. Then instead of selecting my div with the ID of root, actually I'm going to need that anyway, so I will leave that code there. I'll say Reactdom.render. The thing I want to render is my page, so we'll put page, and the where I want to render it is inside of that div with the ID of root. I'm going to comment this out so it doesn't break it. We'll hit save, and there we go. Awesome. So simply put, Reactdom's job, or the Reactdom.render method's job, is to take React elements and interpret them in a way that turns them into real DOM elements that the browser can understand. Okay, with that understanding, it's only a small jump to work on our section project, which is to build a static page in React. We're going to start the first steps of that in the next screencast. Okay, we're finally at our first challenge. I'm really excited to start working on this. I've included a Google slide of what you're aiming for with this challenge. Notice there's really no styling being applied here at all. It's just bare HTML. So if we go look at the challenge, essentially you are starting completely from scratch, and your job is to build the HTML for our section project as you see it here. We'll be adding just a little bit of styling to it later after we learn how to do that. And I've included a couple hints here. For simplicity, I've imported the React logo file directly into our file explorer here, which means that you can reference it in your image element that you create with source equals and then using a /react-logo.png. I also have a hint here about how to set the width attribute. Just remember that JSX is almost identical to HTML. And in fact, for what you're working on here, you really shouldn't see any difference between the JSX that you'll write and what you would normally write in HTML. Don't forget that we are no longer using our CDNs, so you'll have to remember how to bring in React, Reactdom, and so forth. That's all the hints I'm going to give you, so pause the screencast here and work on this challenge. Well, first things first, let's import React from React and import React DOM from React-DOM. We can't really do anything until we've done that. Then I'm going to save a variable called page. And as a heads up, this isn't actually going to be a very common way for us to deal with JSX. We're going to see very soon how we can do this in a more conventional way. For the sake of learning, though, I think this is a good way for us to start. Just to do a bit of a sanity check, I'm going to just throw an H1 in here. It says testing, and then do my last step, which is Reactdom.render. And we want to render our page. And we want to put it at the div with the ID of root. Let's see if that's working. Okay, cool. We have testing showing up. That means that everything else is set up correctly. Okay, so let's start building our page here. I'm going to surround everything in a div just because I can only have one element here, rather one parent element here instead of any sibling elements. And the first thing I'll put in is an image. And just like in HTML, I can provide an image source. And like I mentioned up in the hints, I'm going to have react-logo.png. The / just means look in the same folder for a file called react-logo.png. Now, if I refresh this, I'm going to get a pretty large image here. So just like in HTML, I can set the width to be something specific like 40 pixels. And that looks a little more manageable, a little less crazy, not taking up my whole screen. Next, I've got something that looks kind of like an H1 that says fun facts about React. So we will add that in there. And awesome. Now, because my H1 is a block element, it has floated below my image, even though my image is technically an inline element. And that's kind of to be expected, or rather that's what we're aiming for. And then it looks like the last thing is an unordered list with these 5 list items. So I'll go ahead and add that unordered list. We'll do some list items. I'm going to hold Shift Option down to copy these lines, and then just start typing in some of these facts. Okay, and yeah, these are some pretty interesting facts about React. I'll hit save. And awesome. It looks like we essentially got to where we wanted to get to with our goal here. I'll go ahead and clean up some of my comments up here from the challenge. And great work. Hopefully you were able to follow along with that. Now, like I mentioned, saving all of our JSX to a single variable like this actually isn't really that common, nor is it convenient at all. So what we're going to start covering is a much more common way, and that is by creating custom components. Before we jump into that, I want to give you a quick quiz over the topics that we've talked about so far, and we will do that in the next screencast. Before jumping right into the next topic, I thought it would be smart to have a quick little pop quiz on some of the topics that we've covered up to this point. Because this is Scrimba, you can just click into this quiz.md file and answer the questions here. So pause the screencast and work on this quiz. Why do we need to import React from React in our files? Well, it's because the JSX syntax is defined in React. And if we were to remove React, we would see that it's telling us React is not defined. Even though we're not using React in our code, the JSX here sort of demands that React be a part of our code base. So I will go type that over here. React is what defines JSX. So in order to use JSX, we need to import React. If I were to console log the page in our index.js file, what would show up? Hopefully you actually attempted to answer this question before just going ahead and console logging it. Before I hit save, I know that page is a bunch of JSX, which in reality just returns some JavaScript objects. So when I console log page, I should just see a JavaScript object here. And sure enough, there it is. If you look closely at that object, you'll see a children property, and that children property has more React elements nested inside. Well, that's because we have our React element here with children that are more React elements. So over here, we can say a JavaScript object. These are React elements that describe what React should eventually add to the real DOM for us. Okay, number 3, what is wrong with this code? Hopefully you noticed that our JSX here is 2 sibling elements, and remembered that we actually need all of our JSX to be nested under a single parent element. As a quick sneak peek, in the future you may learn that you can use something that looks like an empty tag like this in order to wrap your JSX in something that doesn't actually create another parent element. These are called fragments, but that's more a little piece of trivia. We're not going to concern ourselves too much with that in this course. Next is number 4. What does it mean for something to be declarative instead of imperative? The way we described it before was to say that declarative programming meant I could tell the program what to accomplish and it would know how to accomplish the specific step-by-step details, whereas imperative meant I still needed to tell the computer step-by-step how to do everything. An example I like to think of this is to imagine myself asking a friend to make a peanut butter and jelly sandwich for me. If I were doing that declaratively, I could simply say, could you make me a peanut butter and jelly sandwich? And I would assume that they knew how to take care of the individual steps to do so. If I were being imperative, on the other hand, I would have to tell them to grab a slice of bread with their fingers and place that slice of bread gently on a plate, then to grab a knife from the drawer and to put the knife into a jar of peanut butter, and so forth. There certainly are times when something imperative is warranted. However, generally speaking, writing code declaratively is a much better developer experience and honestly usually leads to fewer bugs in the end. So declarative means I can tell the computer what to do and expect it to handle the details. Imperative means I need to tell it how to do each step. And lastly, what does it mean for something to be composable? Well, that just means that I can create small pieces that I put together to make a greater whole. In terms of web development, it means I can take pieces of my UI, my user interface, and put them into their own components, and then piece those components together to build my page. So what does it mean for something to be composable? It means that we have small pieces that we can put together to make something larger, and I'll even say greater than the individual pieces. This is a pretty broad definition of composable because the idea and concept of composability extends throughout all of computer programming, not just web development, and especially not just React. But I think we've gotten the point across. I'm really excited to keep moving forward. We are now going to jump into sort of the baseline level of React and start learning how to create our own components, and it's just going to get more and more exciting from there. So strap yourselves in and let's keep moving forward. When we talked about composability being one of the major benefits of React, we talked about the possibility in React to create our own custom components. What we currently have going on is we're saving our JSX elements here, our React elements, in a variable, and then rendering that variable directly with Reactdom.Render. And although this has been working for us so far, it doesn't allow us a lot of flexibility when it comes to creating our own components in React. And even further, it's also pretty obvious we wouldn't want to take all of our markup and stuff it directly into Reactdom.Render, even though I think technically this might work just fine. Actually, I'm curious. Let's give this a shot. I'll comment this out. Okay, so everything is technically still working, but we run into the same issue as we used to in kind of the old days of creating HTML code, where if we're trying to stuff everything into one place, not only do the elements not become reusable, but it becomes really difficult to maintain as a developer. So creating our variable up here got us one step closer, but it's still not quite good enough. Instead, what we are going to start learning about is creating our own custom components. Now, I gave you a taste of this early on in the course, but we're going to actually learn it the real way now. In programming, the concept of a function is one that allows us to write some code that we can then execute over and over and over again just by calling that function. And React adopts this same concept of having a function that allows us to create user interface or create elements over and over and over again if we wanted to. Knowing how functions work, it's really tempting to say, okay, well, I'm going to create a function and let's give it a temporary name for just a second. And we might say, well, I have a function and I want it to return my UI, my elements here, anytime that function gets called. So I might try something like this. Let me get rid of page here, and then instead of page, we might say, well, let's call our temporary name function, and that is going to return the React elements that we asked it to, and therefore we have a function that we can reuse. Well, let's see what happens. Look at that. It actually worked. And what we have here is basically 90% of the way into creating our own custom components. A function like this that returns React elements is considered in React a component. However, there's a couple of conventions that we need to follow for everything to work correctly all the time. The first one is we need to use Pascal case instead of camel case for our component names. All that means is I need to capitalize the first letter of my component. And secondly, instead of calling this function with parentheses like we might be used to, we actually need to wrap it in angle brackets similar to an HTML element. And I still need to change this to a capital letter there. And that's the only changes we need to make from a regular JavaScript function that you have probably written hundreds of by now, and a React component that uses the same concept of functions to create reusable user interface pieces. You'll see if I hit save, everything is still working as we would expect. Okay, maybe you can feel it. It's time for a practice. I'm actually going to erase everything because you are going to write everything again from scratch. First, I'll write out the challenge for you. Okay, I've erased our code and saved it so that our page went away. This challenge is going to be given to you in two parts. The first part is to create an ordered list that enumerates the reasons why you're excited to be learning React. Don't spend too much time trying to come up with a huge list. Just put a few things in an ordered list. And then I want you to render your list to the page. This is going to require you to remember all of the steps that we've learned so far on the basics of setting up a React app. So pause the screencast and work on part 1 of this challenge. To get started, we need to import React from React. I need to spell React correctly there. And we'll import React DOM from React-DOM. We'll go ahead and use React DOM to render. Let's start with just some inline JSX here. We'll say it's working. And I need to select my root element as the place to put this H1. Hit save as a sanity check, and we know it's working. Awesome. Now the meat. We are going to create our own custom page component by using a function called page, using a capital letter to begin. And this function is simply going to return some UI, or in other words, some JSX that we can put in the page. Just as another little sanity check, I'm just going to remove the H1 here and put it inside my page component, and then render my page component as we've learned. And I refresh and everything is still working, and just to make sure, I'll just make a change. I'll say it's still working. Okay, so now the next part. We are going to turn this into an an ordered list, and we'll just put a few list items in here. And let's see, these are reasons that we're excited to be learning React. Maybe for one, it's a popular library, so I'll be able to fit in with the cool kids. This probably has a pretty loose definition for what the cool kids are, but that's okay. Okay, we'll put a second item here. And just so you can see everything, I'm going to move this onto its own line there. We'll say I'm more likely to get a job as a developer if I know React. And hopefully you have some other good reasons. I'm going to leave it at that for now, just for the sake of learning. I'll go ahead and refresh, and there we go. We've got our two pretty ugly, unstyled elements that we have on the page, but it seems to be working. Okay, nice work on part 1 of the challenge. In part 2 of the challenge, which will be in the next screencast, we're going to add a little bit more to our simple page here. However, before moving on, if any part of this was still confusing for you, I really encourage you to go back, try to rewatch some of these videos. You could even start from the beginning. Maybe you'll have some additional context that will help in your understanding. And as always, reach out to the Scrimba community on Discord. If you have any questions, people are always happy to answer. But don't just plow forward if you're still feeling confused. Do some research, rewatch some of the videos, make sure you're doing all of the challenges, and then when you're ready, let's go forward and we'll work on part 2. The next part of our challenge is to add some more elements to our page here. First, I want you to add a header element with a nested nav element inside, and then inside the nav, you'll have a nested image element with the source that I've mentioned here, and some other notes that you should read through. I also want you to add an H1 element that will go below the header element, but above the ordered list. And at the very bottom, underneath the ordered list, I want you to add a footer element with some text that I have here. Make sure to read through the whole challenge there so you get a better idea of what you need to be working on. And as always, pause the screencast here and work on this challenge. One of the biggest tricks in this challenge is to make sure that you don't just try to add a header. Hopefully that didn't cause too many headaches for anyone, but the biggest problem with this is that, again, I'm trying to create two sibling JSX elements here, one with the header and one with the ordered list. Inside of a component, I just can't do that. I have to have one parent component. So I could either use those fragment tags that I briefly mentioned earlier, like this, or a lot of times you'll see people just wrap it in a div like this. Now that I've done that, everything is working again the way I'd expect. Inside of my header, I'm going to include a nav element. Nav is just basically an HTML5 semantic element that is basically the same thing as a div, except it's better for screen readers and assistive technologies. Inside of my nav, I'm going to have an image element, and that one needs to have a source that I included up here. So I'll just copy this and make sure I get that quotation mark there. Get rid of that extra space. And let's just save this and see how things are looking. Okay, and my React logo is huge, so I'm going to give it a width of 40 pixels like I've done before. Okay, that's more manageable. Next, we need to add an H1 with some text describing the page, like reasons why I'm excited to learn React. We'll just copy that. Let's see, that'll go underneath the header, and we'll put an H1 there, and I'll just paste that text in right there. Refresh it, and okay, that's starting to look good. Then at the very bottom, so this is above this ending div, because I still need it to be a part of my page component, but below my ordered list, I'm going to add a footer element. And inside the footer, we need to have this text here, but we'll customize it to be relevant for me. So currently it's 2021. This has got semantic problems because I have those elements there. And I'm going to call this Ziroll development because Ziroll's my last name. All rights reserved. Real official. This is not going to be stolen by anyone for sure now that I have this footer here. And let's go ahead and refresh this. Sometimes people will put this inside of a small tag. I'm kind of just curious to see what that looks like. I need to end this correctly. And yeah, I guess that looks a little better. We'll leave it like that. Okay, nice work. Now, some of you may have been wondering, well, why am I just building everything as this monolithic page component? I thought the whole reason that we were creating our own custom components is because then I can compose them together instead of just shoving everything into this one component. And you would be right. So in the next lesson, we are going to learn how to compose these elements together, learning the concept of parent and child components and so forth. Before we do that, though, I want to make sure that you've been awake and that you're following along. We're going to have a quick quiz. So that is coming up next. Okay, it's quiz time again. Read through the questions in the quiz, actually click into the editor, type down your answers. And if you find yourself not knowing the answer to one of these, don't just kind of plow ahead, but instead actually do some research. See if you can figure out on your own with Google and whatever other resources you have available to you what the answer to the quiz question is before just moving on. So pause now, answer the questions to the quiz, and then we'll go through them together. All right, number one, what is a React component? Well, basically put, a React component is simply a function that returns React elements. Well, what exactly are React elements? React elements are the objects that get created when we return JSX. So although this looks very much like HTML, remember this is JSX, which is a special syntax of React, and under the hood, it's returning a regular JavaScript object. Those objects are eventually turned into real DOM elements that people can see on the screen. So sometimes you'll hear people refer to this as UI or user interface. And that just means that it's what the user can actually see on the screen. And just like any other JavaScript function, a component can be reused over and over. Here I'm creating a page component, but I can run my page function, so to speak, or in other words, create an instance of my page component by just rendering page again. Okay, let's go to number two. What is wrong with the following code? It's a really small difference, but it's an important one. Any components that you create need to begin with a capital letter. This is called Pascal case, where it's essentially camel case, but where the first letter is also capitalized. Basically, anytime you might want to have, I guess you could say, different words in your component name, like my component, all you do is capitalize the first letter of the next word. This would, of course, be instead of putting some kind of space in between there, like in a regular sentence. And then finally, what's wrong with the code in number three? Hopefully this one wasn't too difficult to find, but if you look way down here, instead of calling our function like you might normally be used to by adding parentheses at the end, with function components in React, you instead surround these with the angle brackets as if it were a regular HTML tag. And in React, this is the correct way to, I guess you could say, call your component or create an instance of your component. Okay, short and sweet. Nice job on that quiz. Hopefully you were able to follow along. Next, we're going to move forward and see how we can do a better job of composing our components together. As we've mentioned, it's not ideal to be taking our entire markup and stuffing it into one component like we're doing here. So let's learn through practice the concept of creating a parent and child component. We're going to start this off by having you do a mini challenge. So let me type out that challenge here. Okay, your little mini challenge is to take the header element from our page and to put it into its own component that's called header. Technically speaking, I'm not necessarily asking you to then render the header inside the page, but if you want a little extra credit challenge, you can render that header component that you just made inside of the page here. Pause now and work on this mini challenge. Okay, just like it says, we are going to create a separate header component here. And we're doing this outside of page because they're different components. And basically, I can just cut out this whole header section and return it from my header component. And that's really all the mini challenge was asking you to do. Now, if you didn't try to do the little extra credit I gave you and render the header inside here, I want you to think for a second, what might that look like? Well, just like we are creating our page component down here, or rather we're creating an instance of our page component down here, I can create an instance of my header component by just typing it out like this, as if it were an HTML element amongst my other code. And here we see the concept of composability in practice. I've set aside some of my UI to be managed by a single header component, and then anytime I want to essentially insert these elements into my page, I can create an instance of my header component just like this. Now, in a web page that's this small, it's really not that necessary to do this, but I'm sure you can imagine if this were a much larger application, especially one that had pieces that had a lot of user interaction and so forth, it becomes really, really beneficial to move these things into their own separate components. Okay, so that leads us to the next part of this challenge, which I will type out now. Essentially, I want you to do the same thing, but now with the footer as its own component and the rest of the content as its own component. Pause now and work on this challenge. Okay, just like before, we'll create a new footer function or component here, and it's going to return the footer content. I'll just cut that out of there, put it right here, and down here in its place, we will render the footer component. Okay, and then we'll do the same thing for the main content component. I'll take everything here, including the H1. And there's a little trick here because if you tried to just paste that in, you'll notice that this is two sibling elements, which again, we can't just render side by side. We need a parent element to surround them. So I will put this div down there, indent there, and we will render an instance of our main content component. Now, I should be able to refresh the page and essentially have the exact same thing. Of course, now that I've wrapped this in a div, very technically speaking, these elements are now children of the div, and the div exists right here on this level. For my purposes now, this div is not harming anything, it's not changing my styling or anything, so I'm not terribly worried about it. So hopefully you can understand now the idea or the naming of parent-child components. We have a parent component, which is our page component, and just by virtue of it rendering other components, these other components become, by name, children components. And just like HTML, this can go deeper and deeper down the rabbit hole. I could have main content rendering another component that we have also made. And then relative to main content, that other component would be a child component, and main content would be the parent component. This really is no different than in our HTML, how you can have different levels of parent, child, and even grandchild, or whatever you want to call it. Nice work on this challenge. You can see that we are now composing our page together of other components. Now, we're pretty overdue in learning the ability to add some styling to our page, so that's what we're going to work on next.
We're going to start off this lesson with a sort of mini challenge. Our goal is to add a navigation bar to our little site here. And navigation items like this are usually handled with something like an unordered list with list items. So that's your challenge. Underneath our image here, your challenge is to add an unordered list with 3 list items for pricing, about, and contact. In the end, this will essentially be like adding some HTML to your page, so this should be pretty quick. Pause the screencast and work on this challenge. Simply enough, we can add an unordered list with our 3 list items for pricing,
about, and contact. Let's hit save and see where we are. Okay, pretty ugly, but we're going to style this now. Fortunately, styling something in React is as simple as adding classes, just like you would in regular HTML. The only difference you need to know about is that instead of using class equals, we're going to use class name equals. And that's because under the hood, if you remember, React is taking these JSX elements and turning them into native DOM elements. And just like when we were creating things in vanilla JavaScript, we would say something like const unordered list equals document.createElement with unordered list as the type. And then we would say ul.className equals something if we wanted to set the class name. So in the end, that's why we're using class name instead of class in React. And so I will set the class name here to maybe nav-items. Hit save, and then in our style.css, I can add nav items. And maybe first let's take the list style off. So we'll say list style of none, and sure enough, our bullets go away. And that brings us to the next part of this challenge. Using Flexbox, I want you to line up the nav items horizontally so that they sit next to each other like this. And then also using Flexbox, I want you to line up the unordered list with your newly horizontal list items to be in line with our logo so that everything is nice and aligned just like we have in this image. In doing so, I want you only to use CSS classes. I don't want you to select any bare elements like the whole nav or anything like that, mostly just so we can get some practice typing out class name. Pause the screencast and work on this part of the challenge. Well, let's piggyback off our nav items class, which we already have. I should just be able to change the display to flex, and sure enough, that gives me all of my items in a row. Now let's put our list item in line with our logo image here, and then we'll worry about some spacing between these items. Back in my code, I'm going to probably give my nav a class name of nav. Of course, I could have just selected the whole nav element, but like I mentioned, we're here to practice class names. So I'll make a class name of nav, and we'll select our nav. Let me hit refresh over here so that the styles will apply immediately. And I'll give this a display of flex. Awesome. Our elements are in a line. Now, because my nav only has two elements, the image as the first element and the unordered list as the second element, I guess I should say two direct children, I can just use justify content space between to push that pricing about and contact items to the far right. It also looks like our logo got a bit stretched. That just kind of happens in Flex containers. So I'll say align items center, and that should fix my aspect ratios of the image. And then I'll go ahead and add a little bit of space between my list items there. I know I mentioned using classes, but in the case of list items, I usually prefer to select the unordered list by its class, and then just select all the list items. That way I don't have to go in and add a class name to every single one of my list items. Let's just give those a padding of maybe 10 pixels. Okay, that's looking pretty good. Now, my image is looking a little bit small to me. I want to make it bigger, but oh yeah, we added this width attribute. But now that we know how to style with classes, let's have sort of an impromptu third part of this challenge. Okay, your task is to change the image styling to happen in the CSS instead of right here in line. And of course, for practice, let's add a new class to the image just so you can style it that way. Pause the screencast and work on this part of the challenge. Simply enough, we can take our width out, which is going to make our image pretty huge if I refresh, but we'll give it a class name. Let's call it nav-logo. And then we will select our nav logo, and let's give it our width of 40 pixels again. I have to hit refresh over here. Okay, we're back where we were. Actually, this logo is looking a little small. Let me try 60 pixels. Yeah, I think I like that size better. At this point, I think it's a perfect opportunity for you to continue practicing styling this page. Obviously, this page is really small in its scope. And so before we just push forward, I would like you to spend at least a few minutes styling up this page, making it look a little bit nicer, add your own flair to it. In fact, I actually did that and put maybe 5 minutes of styling into it, which obviously shows it's not going to win any design awards. But I did change the font to use a Google font. I added this little box shadow under our nav bar. I moved the footer down to the actual footer section of our page, the bottom of our page, and added some really basic styles to it. So this is a great opportunity not only for you to flex your CSS skills and get your hands on the keyboard and do some practice, but also to interact with the Scrimba community, especially on Discord. Once you've styled something up that looks, well, pretty much anything's going to look better than this, once you have some kind of style added, take a screenshot and share it in Discord. As you make changes to your code here in Scrimba, it will create a note that you can save, and you can even share that on Twitter. You can share the link to that in Discord, whatever it takes for you to get involved with the Scrimba community. Once you've had a chance to apply some of your own creativity to this little page, the next thing we're going to do is clean up our code here, where right now we have everything kind of stuffed into our index.js file, and we're going to learn how we can move these components into their own folders and clean up our code a bit. There are practically innumerable ways to organize your projects, and so I'm hoping to, in this screencast, just teach you some of the principles, and as we go through the course, you may see different methods that I use. And of course, as you look at other people's code, you'll see the ways that they use as well for organizing their code. Now, what we have here is a very small site for React. There's hardly anything here. I barely have 50 lines of code to make this page. However, anything substantial that you have will end up being hundreds, more likely thousands, or even tens of thousands of lines of code in total. So it's really important to have an organization system that makes sense to you, to your group, and something that you agree upon in the beginning and stick to as you continue to develop. So I'm going to show you with separating one of these components into its own file, and then I'm going to give you a challenge to do the same for the others. So what I'll do is work on the header, and we're going to move header into its own file. So I'm going to create a new file in my Explorer up here called header.js. A convention that I personally like to stick to is that any file I create that will essentially house a React component will start with a capital letter the same as the component's name itself. Now I'm going to copy, or actually cut, this entire component out, and over in header.js I'm going to paste it. Now there's a couple things I need to change here. I want you to pause the screencast and see if you can think of two things that I need to change in this file in order for me to then be able to import it into this file so that it's working the way that it was before. So take a good look at this, pause the screencast, see if you can figure that out. Well, remember, in order for the program to make any sense of JSX, I always need to import React from React. Even though we're not explicitly using capital REACT anywhere here in my code, for JSX to work, I will need to import React from React. Again, this is something that has recently changed. If you're working in an environment that is actively using the updated React 17, then you may not have to do this. The other thing is currently this component is completely stuck inside of this file. I'm not sending it outside of this file anywhere. And so I need to export it. And oftentimes, if this is the only component that I'll have, I choose to export default the component. So I'll say export default header. Alternatively, I could save myself a little bit of lines of code here and just put export default function header right up at the top, and then I don't have to create a separate line down here that does it separately. Personally, I kind of oscillate between these two, so you can just choose whichever one you think you prefer the most and stick with that convention. If you're feeling a little bit rusty on export, import, export default, and so forth, you may want to spend some time researching import and export in ES6, because we will be using it quite a bit in this React course. Now that I have exported my header component, it means that over in my index.js, I can import it, and I'll say import header from, and then I have to use ./H header. And I could say .js, but that's the default extension for imports, so I don't need to specify .js. In this case, ./ is a way to indicate that I'm talking about a file in my own project here, not a package that's in my dependencies like React and Reactdom. And I have to make sure that I spell this the exact same as my file name, not necessarily the name of the component. I could have chosen to call this head like that, and I still would have to say import header from /header. Or in this case, I could say import whatever because I'm doing an export default. If that's confusing, don't worry too much about it. I prefer to keep the names all the same so that I don't run into any confusion there. Okay, we'll put an extra line here. What's nice about this is now my code is sort of sequestered into the header.js file, which means that if I want to change the header, I can logically come to my header.js file to make changes to my header. And I don't need to change how it's rendered down here because when I import it, I'm importing everything that I have in my header.js file, just like it was when it was declared here in the index.js file. Okay, let's get some practice. Let me type out your challenge. Simple enough. Just move the footer component and the main content component into their own files. And then, of course, do what you need to do to make it so that our site doesn't break down. Pause the screencast and work on this challenge. Okay, let's do this. I'm just going to cut my footer out, create a new file called footer.js, paste my code in, and we'll import React from React so that our JSX works. And then I'll export default my footer function, my footer component, and make sure that I import it here. Say import footer from footer. And just by importing it, now my footer should just be working the same way as it was. I'll hit refresh and everything is working. Awesome. We'll do the same thing for main content. And I can clean up some of these extra lines. Create a new component or file called main-content.js. Paste it in. Export default. Import React from React. And of course, we haven't yet imported it, so we will import it. Main content. Hit save, and we're back up and running. Can remove this challenge, and all of a sudden, we're down to 17 lines of code. We're importing these components from other files, and that way we have a much better organization on our app here. Again, like I said, there's a million different ways to organize your code. It's also not uncommon for people to even take this component that's sort of organizing our other components and put it in its own file. A lot of times, instead of calling it page, they'll call it app. That's actually the convention I tend to use. So maybe I'll go ahead and just change this to app while I'm at it. But because of the limited size of this project, I'm not terribly concerned about moving this component into its own file and then also importing all of those other components into that separate file. It just feels like maybe over-engineering it for such a small project. Okay, awesome work. Hopefully this has been helpful. We're going to be using organization like this throughout the rest of this course. So again, if you're feeling confused about how we're exporting things or importing them, then you may want to spend some time researching export and import in ES6 just to become a little more familiar with it. Or another great way to do that would be to just play with this code. See if you can delete these lines, delete the export default line, and just try to recreate it. See if you can get it to work again. When you feel comfortable with everything we've covered so far, let's keep moving forward. Earlier in the course, we saw sort of the quick and easy way to get a local version of React up and running using some CDN links and an in-browser Babel transpiler to get everything working. You see, since React uses a syntax that isn't normally understood by the browser, there needs to be some kind of tool to translate this weird-looking JavaScript, like JSX, into something that the browser can actually make sense of, like regular old JavaScript. However, that in-browser Babel transpiler that we were using is not really a good long-term solution, which is why we saw that warning that says, well, basically you should do this in a different way if you're going to be pushing it up to production. So instead, what you normally need to do is set up a whole bundler system using something like Webpack. I've linked to the Webpack homepage if you want to go visit it there. and you would teach your Webpack configuration how to use Babel, the transpiler or compiler, so that essentially it would take your React code and transpile it or compile it down to something that is readable by browsers with regular JavaScript. Just to be totally clear, Babel and Webpack are not specific to React, but in order for React to work on most web browsers, you would normally have to use Babel and Webpack to translate it into something that a browser would make sense of. And the truth is, unless you've already dealt with Webpack a bunch before, it's honestly a bit of a high bar for beginners to clear when they're just learning web development. So to help significantly reduce that overhead in getting started with React, the React team created a package called Create React App, which does all of the heavy lifting for you, and it even hides a bunch of that implementation detail of Webpack from you in the code. So in the end, it really just makes setting up a new React app on your local machine really simple. So let's take a look at the process of using Create React App to create a new React app on your local machine. Before you can jump into Create React App, you have to make sure that you have Node.js and npm installed on your machine. To see if you have these installed, you can open up your terminal and type node -v. That's a flag to check the version of Node. If it spits out any number, that means that you do have Node installed. And if you do have Node installed, then you also more than likely have npm installed as well. But for good measure, you might as well run npm -v. And again, if it displays a version number, that means you do have npm installed. Now, the next few slides are going to give a very high-level overview of how to install Node and npm. So if you already have Node and npm, you can sort of tune out the next couple minutes or skip ahead. And honestly, there's a lot of help already out there on how to install Node.js. I would just recommend going to YouTube and searching install Node.js, but specifically install Node.js with something called nvm. So I would recommend using nvm, which is the Node version manager. Its purpose is just to make switching and installing different Node versions extraordinarily easy. But it does mean that you have to install another package. If you're on a Mac or Linux machine, you can use NVM. I've included a link to their GitHub repository here. Or if you're on Windows, you can click here to go to a package called nvm-windows. But again, I would just default to following some kind of install Node.js with NVM tutorial that you find on YouTube. Okay, so now you have NVM installed. The next step is to open your terminal again, and this time type nvm install --LTS. Now, this command is specific to the NVM for the Mac or Linux. I think it might be slightly different for NVM-Windows. I think that might just be nvm install LTS with no --, but you'll have to check the documentation and follow the instructions in that YouTube video to be sure. Then once that finishes installing, we come full circle and you should be able to double check your Node version and your npm version the same way we saw before. And again, by the time you're watching this, it very well may not be these versions. It might be a newer version than this. Now with Node and npm installed, we're ready to actually use Create React App. On the Create React App website, you can see this Getting Started section. The main thing we care about are these commands down here. Just to make things even more confusing, there's another thing called npx. We won't really get into what npx is, but for now, it's enough to know that you can just type this top command, npx create react app, space, and then the name of whatever you want the folder that holds your app to be. After typing that first line, you can hit return and you'll see an output in your terminal that's more or less similar to this. You can see at the very bottom, it says we suggest that you begin by changing into your directory that you just created. If you didn't choose my-app as your folder name, then obviously choose whatever your folder name is. And once you're in that directory, you can run npm start. So you can see on my machine, I did that. I went cd into my app and then I ran npm start. Sometimes this command can take a little bit of time to get everything up and running, but once you do, you should see something that looks like this in your terminal. If you remember back when I showed you how to run React locally just using those CDNs and the VS Code extension called Live Server, well now we're essentially replacing that. You won't need to click anything in your VS Code using Live Server, but instead you're running your development environment through the terminal. In fact, after you run this command and it says compiled successfully, it will probably open a browser window for you and direct you to localhost :3000 automatically. And when that opens, you'll probably see the default Create React App screen, which looks something like this. So where exactly does this screen come from with the React logo? Well, this is a boilerplate version of the Create React App code that is automatically built in this new React app that has been spun up for you. If you really just want to start from scratch, what I recommend doing is just taking all of the files in the source folder. You can see I've highlighted them all here in my VS Code and just deleting them. And then you can just start from scratch the same way we have been so far by creating an index.js file and writing the code that we're used to writing. One thing to note here is that you don't need to create your own index.html. That is being handled inside of this public folder. And of course, I recommend poking around the code just to better understand exactly what's going on, but you'll see that inside that public folder, there's an index.html file that has a div with the ID of root in it. So inside the new index.js file that you create, you can already select that element by the ID of root when you're using Reactdom.Render. And it's a bit small in this screenshot, but you can see that it's rendering an H1 that just says, hello, create React app. And in the browser that popped up automatically on localhost 3000, it updated automatically for me. Now, usually any changes that you make to your code, when you hit save, it will automatically refresh your browser. Every now and then, I found that that becomes a little disconnected and you just have to go to your browser and hit refresh. But either way, it should update your browser to reflect what you have written in the code. And that's it, you're all set. Now, as we continue to go through this course here on Scrimba, I still highly recommend that you do the challenges I give you right here inside of the Scrimba environment. One of the huge benefits of Scrimba is that the environment is already interactive and it's already set up for you. And so the barrier to getting your hands on the keyboard, typing the code, practicing React is very low. So although you now know how to set up a local environment, please don't feel like you need to do that every time you're going to do one of the challenges that I give you, because honestly, in this course, we're not practicing how to set up React apps. We're practicing how to write React and build cool applications with React. But now you have the knowledge you need if you feel like jumping away from what we're doing in the course and just practicing your own thing and being creative, being curious, and building whatever you want to build without necessarily having to deal with the Scrimba environment. And then, of course, when the time comes to deploy your projects to a real website, well, you're going to have something local on your machine that you can push up to GitHub and to whatever host you're pushing it to. Okay, sorry that was such a long aside. Let's jump right back into the course and continue to learn. I am coming to you from the future because you can see in the background we have our React Facts static site almost completely built out, but there's an issue for anyone who is going to be using Create React App to follow along with some of the projects that we will work on. And namely, those issues are when we need to load CSS styles and when we need to load images in Create React App. In Scrimba, this will just kind of work out of the box. But if you're using Create React App to follow along, you might notice that, well, your site's going to look something like this. Not only are the styles missing, but also our image link is broken. Fortunately, these are relatively easy fixes. You can go to the React docs to check out this adding images, fonts, and files. It also has a link to dealing with CSS in there as well. You can actually click on the screenshot to go straight there, but I'm going to show you what this looks like in VS Code. So if you are using Create React App, it's generally recommended that you put your styles inside of your source folder. There's much more in-depth ways to also organize your styles on a per component basis, but for now, we're just going to assume you have one global style.css, and that's going to live again inside the source directory. And the Webpack instance that's running Create React App behind the scenes is using something called Style Loader that allows you to just import the styles directly into your index.js. This might seem a little weird to just be importing a string that represents a CSS file, but Webpack is set up behind the scenes to make this work fine. The main issue is that when you build your project, it's going to build in a way that doesn't have a ton of different files and folders inside your source directory. Instead, Webpack is going to bundle everything up essentially into one giant JavaScript file. And that JavaScript file is going to live near index.html, and essentially in the end you'll have an index.html, an index.css, and an index.js files. That's nothing that you have to do manually, it's just going to happen behind the scenes for you. I think that will make more sense when we look at fixing our image issues, but right now, by simply importing our style.css, we get our React Facts site back to an almost perfect condition. You can still see that our logo icon in the upper left is broken. So loading images, we do something relatively similar. In the code behind me here, you'll see that we have a navbar component, and in that we are able to set the source directly equal to a string that has a path to the image that we need to exist in the navbar. However, because this path is relative to where the navbar.js file currently lives, this is going to break when things get bundled up into that one giant index.js file like I mentioned. So anytime you have an image that you want to include on your site, you will likely want to put your images inside the source directory. And then instead of hard coding the path directly into our image source, we're first going to import our image from that path that's relative to where the navbar.js file lives. And we import it with some kind of name. We can call it whatever we want. I've chosen React logo in this case. And then once we've done that, we simply replace our source with React logo. That way, when Create React App is bundling up this project, it essentially has a reference to where that image file exists relative to the current file, and it can create a better absolute path when everything gets bundled up so that there isn't a broken link between your component and the image that you're trying to use. And once we do that, we have our logo back and running, and everything else about this page is looking good. Now, there is another way to solve this problem, and that is to put your styles and your images inside of the public folder instead of inside of the source folder. However, this is sort of gently advised against. If you go to the documentation, there's a whole page dedicated to using the public folder, but if you read carefully, it says there's a lot of benefits to not using the public folder, but if you really need to, you can, and here's how. You can click the screenshot here to go read more about that if you'd like. Okay, hopefully that answers some of your questions if you've been trying to follow along with Create React App on your local machine. If not, and you're just working here in Scrimba, you essentially don't need to know any of this until it comes time to start using Create React App on your own machine. But either way, it's good information to know because eventually you won't be just working here in the Scrimba environment. With that said, let's go back in time and we'll jump right into this project. One thing that I really like to do when I'm starting a new project, especially if I have the design right in front of me like we do here, is to make a sort of mental outline of the elements on the page and how I'm going to lay this project out. All that really helps me do is to make a sort of mental model of how I'm going to create everything on the page. This can be especially helpful when you're thinking about layout and how you're going to place certain elements in the right spot on the page, especially when you start thinking in terms of using Flexbox or Grid to do that kind of layout. So as a first sort of mini challenge, what I want you to do is pause the screencast and look at this page, try to determine what kind of elements you would use, what kinds of CSS layouts you might use. Fortunately, this project has a fairly simple layout, but I still think that it's something that will be helpful for you to practice. So pause the screencast and try to imagine what elements you would use and how you would lay them out for this project. There's certainly more than one way to lay out any given page, but the way that I see this is having two primary sections. The top section, which is sort of a nav bar, and the bottom section, which is sort of the main content. Inside that nav bar, we have a little React logo, the React Facts logo text up here, and then a little blurb about what project this is in this course. Already, I can start to see that I'm probably going to choose to lay this out with Flexbox because that's a really easy way to make sure everything's in a nice, neat line. And with Flexbox, all I need to do to push this text all the way to the right is to give an auto margin to my React Facts text here, or rather a margin right of auto so that it pushes this React Course Project 1 text all the way to the right side of my navigation bar. Then down below, it looks like I just have an H1 and an unordered list with some list items. So with this kind of mental outline, I can start putting together what the actual elements will look like on the page. I usually end up creating some kind of container div, so we'll call it a div with the class of container, and this will just surround my whole page. And then we have our main two sections, that nav bar, which we saw at the top, and the main section. Inside the nav bar, we had a couple elements like the image, and then maybe let's call the React Facts text an H3, and this React Course Project 1 an H4. And then in the main section, there was our H1 and an unordered list with some list items inside. Now, in terms of React, this can be a really helpful exercise because I can start to see that I will probably have two main components. First, a custom nav component, which will house my nav element with its children elements. And second, a main custom component, which will house my h1 and my unordered list with the list items. In terms of those nested items, like the image and h3, those are going to be simple enough that they won't need their own custom React component. And then I would take my custom nav component and my custom main component and probably collect them together in one more custom component, which I usually end up calling app. And that will be what renders my div with the class of container. And then that app component, since it contains all the elements on my project, will then be rendered with Reactdom.render. So I hope this has been a helpful exercise for you, at least to see the way that I usually like to break down my projects. If it's a layout that's fairly basic like this, I usually will just kind of think about it ahead of time without actually writing it down or putting a bunch of dotted squares around the elements or anything like that. But once you've practiced this enough times, a simple layout like this might take you a total of maybe 10 seconds to think through, but in the end could end up saving you a lot of time. So now it's time for us to get your hands on the keyboard. We're going to have a series of challenges, which will help you be the one that actually builds out this project. Hey there, I'm jumping in at this point to let you know that I've created a very quick Figma tutorial. Throughout this course and many others here on Scrimba, we're going to be providing you with a Figma design file, and I do think you'll find Figma fairly intuitive, but I thought it would be a good idea to just record a quick tutorial to help you along. The first thing you'll have to do is go over to figma.com and create a new account. And as I was signing up for a second account just to kind of test this process, I realized that there's actually a lot of steps, so I figured I would walk you through it. First, you're going to click sign up. You'll obviously either sign up with Google or you can provide an email and password. I believe if you provide an email and password, it will have you go verify your email, so it'll send you an email to verify. Once you've done that and you come back, it will have you choose which kind of plan you want. Figma has a really generous free tier, so I would just start for free. You'll click that button down there. When it asks you to tell you about your team, you can, at this point, honestly just say skip this step. And then when it says, what would you like to do first? I just think it's easiest to say, I'll explore by myself. And when you do that, it's going to drop you into the Figma interface. Now, from that point on, I've actually recorded a whole tutorial using the Figma program that is now over on the Scrimba YouTube channel. So at this point, you're going to continue onto YouTube by clicking on the screenshot here, which will take you to the video that I recorded. And hopefully that quick introduction to Figma will really help make things easier for you as you use Figma as a part of your Scrimba coursework. So click on the screenshot you see here, head over to YouTube. When you've watched that video and you're done, you can close that window, come back here to Scrimba and continue on in this course. Let's start by getting some of the project setup out of the way. I've written some step-by-step instructions here in the challenge. It is going to be a little bit more involved because we're creating everything completely from scratch, or almost completely from scratch. So your challenge is to create a components folder, and this components folder is going to have two files in it, the navbar.js file and the main.js file. For now, they should just render an h1 that says something like navbar goes here and main section here. Then I want you to create an app component, which will be outside of the components folder, and have the app component render the navbar and main components that you just created. Then inside of this file, the index.js, you will import the app component and then use Reactdom.render to render that. The last step is to go and get the Enter Google font, specifically with the weights of 400, 600, and 700. Once you've selected those font weights, you should see a series of link tags that you can use to put inside of our index.html. Make sure to put them above style.css so that we can reference them in style.css. And if you haven't used Google Fonts before, this one might take a little bit of extra research outside of Scrimba here to learn more about. But I know that you can do it. Fortunately, Google Fonts makes it relatively easy. Just know that you can ignore the @import or any npm options it talks about for installing this font. Remember, we're not dealing with any kind of styling right now, so by the end of this challenge, you'll just have a basic white page that just shows navbar here and main section here, or something like that. So pause now and work on this challenge. Okay, let's just go one step at a time. We'll first create a new folder called components, and inside components, we can create a new file for main.js and navbar.js. As always, we will import React from React, and we will export default our navbar function, our navbar component. And for now, this is just going to return an H1 that, let's have it say Navbar component. Then our main.js is going to be almost identical. We'll just copy this, paste it in, and instead of Navbar component, we'll say main component, and we'll call this element the main element. Okay, I'll hit save. This is just going to bring up my preview window, but that's still empty. So I need to create a new file called app.js. And inside of app.js, again, we'll import React from React. We'll also import our navbar component from ./components/navbar. And we'll do the same thing for main, so I'll just duplicate that line and change navbar to main. Then this app component, we will export directly here with export default function app. And we will just have this return, well, we want our navbar to be in here, so we'll say navbar, and we want our main component to be in here. But I want you to think for a second, what's wrong with the way that I've done this? We can see there's a syntax error. So what's wrong with the way that I've set this up? Inside of components, we can only return a single element. That element can have children elements, but right now we're trying to have two sort of side-by-side components. So what we need to do is wrap those in some kind of container like a div. So I'll move this div around and indent those. If you remember from the last screencast, we talked about how this would probably just be set up as a container. So we'll give it a class name of container. We're not going to deal with any styling now, but I might as well add that class name since I know I'm going to need it. Okay, let's go check out our challenge and see where we are so far. So I created a components folder. I created the navbar and main components already. I created my app component, which is rendering the navbar and main components. So here we are. Let's import and render the app component here. I will import app from ./app. Oh, and I am going to be using some JSX syntax, so I also need to import React from React. And in our index.js, I will also be using Reactdom. So I need to import Reactdom from Reactdom. And then I'll use Reactdom.render to render my app component, which I just imported. And we're going to put it inside of the element with the ID of root. So we'll use document.getElement by ID root. And let's hit save and see if we get our elements showing up on the page. Awesome. Navbar component, main component, just like we expected. Okay, so that completes this part of the challenge. And then the last thing was to go to Google Fonts to get the Inter font. Hopefully this wasn't too terribly tricky. Going to Google Fonts will give you a couple link elements. So I'm just going into my index.html. And above my style.css, I will just paste in those link elements. You can see that we have this pre-connect to Google Fonts, this one to gstatic, but then this one is for our actual fonts. Here you can see the font family is Inter, and it shows our weights of 400, 600, and 700 there. Again, I'm putting this above my style.css so that inside of my style.css, I can reference the font family of Inter, and my browser will have already read these other link tags to know exactly what the Inter font is. Okay, let's go back here, and we have finished everything from this challenge. I'll just do a little bit of cleanup. Now, we did just cover a lot of ground. However, every step that we did here was something that you should have already been able to do, maybe with exception to the Google Fonts if you've never dealt with Google Fonts before. So if you did find yourself struggling to get some of this basic setup done, that might be a good signal to you that it's time to go back and restudy and especially repractice some of the past challenges that we've done instead of just kind of plowing ahead in this course. The reason for that is because I'm essentially going to assume that you understood how this works from here on. And the last thing that I would want for you as you're learning React is to just continue on without actually having learned some of these basic setup principles. Okay, let's jump into maybe something a little more fun, and that is adding some actual styling and elements to our project. But before we move on, I wanted to give you one more opportunity to access the Figma design file. We talked about this much earlier in this section, but since it's been a while, I figured this would be a good reminder. If you click on the screenshot here, it will take you to the Figma file where you can get access to the design elements for this, like the colors, the spacing, the fonts, and everything like that. When you click on this link, it will take you to a shared version of this. However, if you'd like, you can avoid seeing everyone else's cursors and selections by clicking on the little arrow at the top and choosing to duplicate this to your drafts. That'll make it so that you aren't seeing everyone else's cursors and selections, but also so that you can make changes to it if you'd like. Okay, let's do it. Let's jump right in and start working on the navbar portion of our project. Okay, this is the fun part. We're actually going to make our navigation bar look the way that it looks in the design. A couple pieces of advice. I highly recommend you reference the Figma file that contains all of the fonts, colors, spacing, and everything instead of just looking at this quick reference that I've put here, but this is meant to be just a quick reference for you if you need it. Another thing is I have added a couple of base styles to our styles.css. I ran into some problems trying to record this without putting my box sizing, and just because it helps a lot, I'm going to remove the margin on the body, especially to make our navigation bar go all the way to the edges. Also notice that I have included the React icon small image here inside of the images folder. You can see that's part of the design up here in the upper left. So without further ado, pause the screencast and make the navigation bar look as close to our design as you can. All right, let's do this. Instead of rendering an H1, I'm going to open this up and render a nav element because this is a navigation bar. And inside of there, we know we have an image. We'll give it its source while we're here. I have to use /images because I'm inside of the components folder when I'm here in the navbar. And it's React icon small.png. Let's just refresh and see if that's working. Okay, cool. And let's call this maybe an H3, I guess, and maybe this an H4. It really doesn't matter because, well, you could just give it a class name and call it a paragraph, but I'll just call it an H3 and H4. This one says React Facts, and this one says React Course-Project 1. Okay, refresh that, and we've got our elements on the screen. Now, we talked about earlier how the navbar will probably be a Flexbox container. So I think because I'm only going to have one nav element on my screen, I'm just going to style the element nav. If you want, you could always give it a class name as well. I'm going to put display flex. We'll say align items in the center. From the design, we can find that the background color is this color here. It also looks like it has about 30 pixels of padding on the top and bottom and 25 pixels of padding on the left and right. And we can also see from the design that it has a height of about 90 pixels. Okay, so it doesn't look like our top and bottom margin is applying, and I suspect that's either because our image is a little bit too large, or I think maybe more likely because our H3 and H4 here have some top and bottom margin by default. So I think I might just select the H3 directly inside of the nav. Let's say margin is 0, and then let's see if that also works for the H4. Okay, it might be that the image is just a little too large. Let's take a look at the image, and it looks like from the design it's got a height of about 30 pixels. Okay, so maybe our padding is doing fine, and it was just that the image was a little bit large. While we're here dealing with the image, I'm going to give it a margin right, just to bump it away from the text there a little bit. We'll say, I think the design shows it's about 7 pixels. That looks pretty good. And let's go ahead and use the margin right of auto on our H3 just to bump that H4 all the way to the right side. Cool. All right, well, while we're working on that, we can go ahead and give the color to our React facts. So we'll say the color is this color from the design. Okay, that does it for the color. Let's get the fonts right. And actually, I think all of the fonts on this page are inter, so I'm just going to change that in the body. We'll say inter, and then I think a backup of sans serif makes sense. Let me just comment this out. Yeah, okay, so that's making a difference. So awesome. Our Google fonts are coming through just fine. I can also see from the design that the React Facts logo words there have a font weight of 700, so we'll bold those up a little bit. Or maybe that's the default. Doesn't look like it's making much of a difference. And then let's do the same thing for our H4. It has this color from the design, and it looks like it has a font weight of 600. Okay, that's making a slight difference, so that's good. And it kind of looks to me like React Facts maybe needs to be a little bit bigger. And yeah, I can see from the design that it has a font size of something around 22 pixels. Okay, that's looking awesome. Now, when I can avoid it, I usually don't love to style things with their native components if I don't have to. Maybe just for practice sake, I'm going to go into my navbar and I'll start providing some class names here. So let's give a class name to everything on the page. Let's go class name equals, and then up here, maybe I'll use something kind of like BEM syntax. I'll say this is part of the nav block, and the element is the icon. And then we'll say this is the nav block, and the element is it's kind of like the logo text. And this one is part of the nav, and let's call it maybe like the title of our project here. And what's nice about that is I don't have to do these kind of nested selectors anymore. My H3 was nav logo text, and I can also select my nav title and change these other selectors as well. And one thing I've learned about Scrimba is I have to make sure I save this when I change my class names before I come to the CSS. Otherwise, the CSS updates live, but the markup does not. So once I hit refresh there, that kind of put everything back the way it was. Awesome. This is a really excellent start. Frankly, most of what we did here was just CSS instead of actually doing React. But my goal with this course is not just to focus entirely on React. I want to synthesize some of the information you have been learning so far, including revisiting the CSS and markup and stuff like that as much as we can. Frankly, in this first section of the course, we aren't doing much of the detailed side of React. We mostly have just learned some of the very basic syntax. But I think it's important for us to kind of remind ourselves of the past information we've learned by practicing it here. So the next thing we're going to do is fill out the body section here, or the main section here. There's a couple of gotchas with this that we're going to actually address later. But whenever you feel good about everything we've done here in this challenge, then let's move on to the next one. Okay, let's work on this main section here. I do want you to skip two aspects of the design right now. We're not going to worry about changing the colors of these bullets, and we're not going to worry yet about adding this logo over here to the right. Everything else, though, is fair game for this exercise, so pause the screencast and work on this task. All right, let's go ahead and make this into a main element. This is another semantic HTML element, and it represents the main section of our app here, so we will call it that. And it looks like it really only has two elements in it. It's got this H1 and an unordered list with 5 list items. So that should be relatively straightforward. And it says fun facts about React. We have our unordered list. And I'm going to hit Option Shift down to create copies of those so I don't have to type them out manually every time. And then I will actually go ahead and just copy and paste the text from the Figma file, so you don't need to sit and watch me do that. All right, let me move this over just a tiny bit. And let's hit refresh. Okay, that's a good start. Let's get some of the design aspects going here. I've got my main element, and I think I feel okay styling that as the main element because I will probably only have one. Well, I know that I'll only have one. And we will give it a background color, which we can go ahead and grab from the Figma file. Okay, and well, this highlights some issues here. Now, I haven't set up my body or my main element to be a full height, and it looks like maybe it's a collapsing margin. I'm guessing this H1 has a margin on top, which is causing this whole section to collapse down below. So let's give, first of all, the main section a height of, let's try 100%. Yeah, sometimes that doesn't work. Maybe if I give my body a height of 100 view height. And let me refresh this. Well, okay, you know what? I think this is highlighting another problem that I was planning on addressing later. So for now, what I'm going to do is actually move this background color to the body so that it does cover everything. Okay, and that'll be a good enough start. We'll fix this a little bit later, but it did highlight the fact that what we had here is our main section is not taking up the entire body here. In a couple of screencasts from now, we'll see why that's a problem, but for now, I'm just going to put my background color on the body. Okay, and I probably actually don't need this height of 100% right now. We'll come back to that later. Oh, however, I do want to give it some padding, and it looks like from the design I have about 55 pixels. It says 57. We'll just go ahead with 57 on the top and bottom, and then about 27 pixels on the left and right. And well, you know what, I think that margin, this looks a little too much. I'm going to guess that the margin of my H1 here is a little bit high. Let me just check that. If I set this to margin 0, yeah, that normalizes it a little bit more. So instead of selecting all H1s, let's go here and give this a class name. And similar to the last one, I'll say this is the main block and it's the title element. And that way I can be a little more specific about which H1 I want. And again, I need to refresh this in order for that class name to apply. And awesome. Okay, the sizing is looking good. Let's get our color correct. Now our H1 here also has a font size of about 39 pixels. And everything else needs to be white. Maybe I'll just color the entire section here. Yeah, that'll work. Okay, awesome. Well, now that I have removed the margin from my title, it looks like my unordered list is bumping a little bit close to my title. Rather than giving my title a margin bottom to push it down, I personally prefer to have elements push themselves away from other elements, if that makes any sense. And when I see this, I think of the unordered list as being too close to the H1 as opposed to the other way around. That might not make any sense. That's just how my mind is working. I'm going to give my unordered list a class name. Let's say this is main dash dash, we'll say facts. And we will select our main facts, and I'll give it a margin top of, it looks like the design says 46 pixels. Okay, now actually I just looked at the Figma file and noticed that our title actually has a slight change to the letter spacing. So I'm just going to copy and paste that here, and yeah, that compresses our H1 a little bit, actually quite a bit. So we will go ahead and leave that there. Sometimes these rules like this are really easy to overlook if you aren't looking closely in the Figma design. Something that's really nice is I can actually just copy all of the rules if I need to and paste them here, and then I can decide which ones are actually making a difference or are necessary. Now, I already have that one. I can just comment these out. This one's technically making a slight difference. I'm not terribly worried about it. The font size we already specified. Font weight of bold is already the default, font style of normal, and so forth. I can get rid of some of these as well. But we can see this one actually did make quite a bit of a difference, so it's good that we put it in there. Okay, now these are really close together, so I'm going to select all of the list items under main facts. I'm doing this just so I don't have to give a class name to every single LI or give the same class name to every single list item there. And actually, let's go ahead and do the same thing I did before. I'm just going to copy some of these font styles that we have inside of Figma and see if any of them made a difference. I don't need that. That's not making a difference. That's already the default. That's already the default. That makes a tiny difference. Maybe I'll leave it in there. It did separate them a little bit. I'm guessing, however, I'm going to have to apply some padding to these. So let's give a little bit of padding. There's a relatively new CSS property called padding block that allows me to only specify the padding on the top and bottom in one go. Let's start with 10 pixels and see how that looks. And yeah, that looks fairly accurate. Another thing I'm noticing is that the text is actually wrapping around here and mine is not. It's going all the way to the right. This probably isn't much of a problem. If I did want to fix that, I could probably just apply a max width on my list items. That way it's not taking up the entire left to right. maybe something like 400 pixels. And yeah, that seems to wrap it a little bit. And awesome, this is a great start. We're only missing two minor things. We're going to change these colors of these bullets to be the same color as our logo up here, and we're also going to add this little React logo over here to the right. However, both of these have a little bit of a gotcha to them, so I thought it could be good to do them each as a separate assignment, and that is what we're going to cover next. Originally, my plan was to give you a challenge to color the bullets and make them just a little bit larger like we have in the design. However, as I was researching this, I came across a relatively new CSS property, or rather pseudo selector, that makes this challenge extremely easy. So just this once, you can sit back and relax. I'm going to show you just how easy this is. There's a little bit of a gotcha with it, but I included a slide here that shows you the MDN docs for the marker pseudo element. And believe it or not, this very specifically selects the bullets on list items. And even look at this example. It's changing the color and it's making it a little bit larger with its font size. That's exactly what we want to do. You can click this slide to go check out the docs, poke around these allowable properties, and of course, you should probably play with this a little bit, but fortunately, this is a really easy thing for us to implement. I'm just going to copy this and add my pseudo element selector for marker. One thing to keep in mind is that this is not accepted by all browsers. However, Safari, Firefox, and newer versions of Chrome have all adopted the marker pseudo element selector, and I'm certain as time passes, this is going to become even more widely accepted, and therefore I feel pretty confident using this method for accomplishing this task. So, simply enough, I can change the font size to, let's say, something like 1.4 rem, and sure enough, that made our bullets a little bit larger. Now, as I was playing with this, I noticed that if we get too large, let's say 3 rem, things become pretty misaligned. And at least at this time, when I was researching, I could not find a good way to realign these bullets with the text. So in my playing around, I found that 1.4 made the bullets larger without getting them misaligned with the text. So for now, we have that limitation. I'm just going to work within that and say the font size is 1.4 rem. It's not quite as large as what we have here, but that's okay. And then again, simply enough, I'm just going to go take the color of our text here. This is the blue color that we want, and stick it right here as our color. And sure enough, we have the blue color on the bullets. Easy peasy. Well, I hope you didn't become too comfortable letting me do all the work, because in the next screencast, we are going to add this logo. And by we, I of course mean you, in a challenge. So that's what we'll do in the next screencast. I actually debated a little bit whether or not I should include this as a real challenge for this section, only because it touches on some CSS that you may not be super familiar with. But in the end, I settled on remembering that you guys are capable and you can use Google to your advantage just like a real developer. So here it is. I decided to add it in. Your challenge is to place that gray React logo in the background. We have that logo here under images as React icon large.png. Something important to know about this icon is that it is actually half of the React logo. It looks from the design like maybe it's a full React logo that's just bleeding off the page, but if you look closely, once you put this React icon large on your actual page, you'll notice that it's only half of a logo. At first, that threw me off. That just had to do with the way that I exported it from Figma. Honestly, I think it makes our job a lot easier as we're placing it on the page. So just keep that in mind as you move forward. One last little piece of advice I'll give you is to add this background image to the main element. It probably would work just fine to add it to the entire body element, but I'm going to be doing it to main, so you might as well do it to the main element as well. Again, Google is a developer's best friend, so don't be afraid to use Google while you're trying to solve this challenge. Pause now and work on adding this background image. Okay, hopefully you found this wasn't actually that big of a deal. So I'm going to add first the background image to my main element here. I'm going to use the URL function so I can specify the location for these images. This is relative to my style.css file, so I'm going to say ./images/react-icon-large.png. Okay, and we see that it automatically is repeating around the entire page, so that's where the background repeat comes in, and we want to say no repeat. Of course, here by default, it puts it in the upper left of our page, or rather the main element. And this is where background position comes in. Now, background position is actually a combination of background position X and background position Y. In fact, let's start out there. We can say background position X, that's my position to the left and right. I want to push it all the way to the right. This is where having half of a logo becomes pretty handy for us because it automatically looks like it's bleeding off the side of the page. And then with background position Y, we can specify something like top, which is where it is now, or bottom. Bottom, I think, is a touch too low, although center is maybe a touch too high. I can also use percentages, so we can split the difference and say something like 75%. And now that we've seen these as two separate properties, I actually can just combine these and say background position, which is background position X, and then I'll use a space and then Y of 75%, and that simplifies it a bit. If I really wanted to, I could use the shorthand background property, which would be background, and then I would just copy and paste this one first, space, this one, space, this one. Honestly, I always forget what the background property is short for, so I'm actually going to leave these as three separate properties so that in the future it's really easy for me to remember what each of those pieces means. And awesome, this represents a culmination of everything that we've learned so far about React. Let me go ahead and clean up this challenge. Now, of course, we've been spending a bit of time in CSS land here, and as I've mentioned, I still think that's a really important thing to do. Even though our main focus in this course is to learn React, it's really important to synthesize some of that other information that you have learned in the past so that it doesn't become stale to you and you just forget it. That being said, in the next screencast, let's spend some time looking back at everything that we did learn about React, because that's actually what we're here to learn. And at the same time, we'll take that opportunity to have a quick quiz and to look at a self-assessment project that you can do on your own. So that's what we'll be doing next. You've done a great job so far in this course. Before you just plow ahead to the next section, it's time for a solo project. This is meant to be a chance for you to flex your new React skills that you've been learning about so far in this section, but this time without the training wheels. And there's going to be a few of these throughout this React course, and these projects serve a really important purpose. They're meant to be a tool for you to gauge whether you are actually ready to keep moving forward in the curriculum or not. Unlike the challenges that I usually give you, I won't be walking you through a solution to this one. Instead, I'm going to be asking you to sort of go out on your own to build this project. That said, you're not actually completely on your own. We've got a thriving community here on Scrimba that's very willing to give feedback on your code. We'll talk more about that in just a minute, but first I want you to keep in mind that no one here is giving you a grade for these projects like they would if you were in school. One of my personal objectives is to shift people's understanding of how learning occurs. In school, we're trained to complete the project for the grade. But here, you're completing the project to test yourself and to practice. So skipping one of these solo projects will really only deprive you of the best chance you have to test out your skills and to really help you decide if you grasp the concepts that we've been learning so far. Okay, with that guilt trip behind us, let's actually take a look at what we're building. For this project, you're going to be building a digital business card. Everything here is static, and you can see there's actually two different designs that you can choose from. In fact, if you click the screenshot, it will send you to the Figma design file. You'll see that there's actually more designs, including a light mode version of these designs. And what you can do is just choose the one you like the best and build that one. When you get to that design file, make sure to click the little arrow at the top and choose to duplicate to your drafts. And as far as actually coding the project goes, I recommend that you just build your project here in Scrimba. On this screencast, if you look in the very lower right, you'll see a menu with 3 dots. If you click that, there's an option to fork this screencast to a new scrim. Doing that will make a duplicate of this project that you will have in your own account so that you don't have to worry about losing your work. You can see I really didn't give you a whole lot to work with here. We have a very basic HTML file that has our div with the ID of root, an empty index.js file, some very basic styles, and the 2 dependencies that you'll need to get React set up. Okay, let's come back to the requirements of this project. First of all, I want you to be building this project from scratch, which is why I'm not giving you any starter code at all. Next, and probably pretty obvious, I want you to fill in your own information for the digital business card here. And while you're building it, I want you to make separate components for the info section, which is what I'm calling this whole top half up here. The about section, which is really just this header and a paragraph. The interest section, which is another header and a paragraph. And a footer section, which has the social icons. While you're working on this solo project, make sure to share your work. In fact, you don't even need to wait until you're completely finished with the project. You can be asking for code reviews and help all along the way. If you click the Discord icon here, it will open the Scrimba Discord server specifically to a channel called I Built This, but in reality, you can share your project in any of the channels that make sense to do so in. And then for anyone who is learning in public and likes to use Twitter, you can click this Twitter icon, which will open Twitter and pre-populate a new tweet where you can include a link to your project so that you can share it to the world. Okay, I wish you the best of luck, and I'm looking forward to seeing everyone's projects. Awesome job building some of your first React projects. I know that these are just static sites, and so far you're really not seeing the benefits of using React to build these kinds of projects. But now that we have some of the basic React syntax under our belts, we're ready to start dipping our toes into a few of the really neat features that React has to offer as a framework. But first, let's take just a minute to recap what we've worked on so far in this section. In the beginning, it can be really helpful to know why we even care about React in the first place. We learned about how it is composable and declarative, what those terms mean, and how that's beneficial to us as web developers. Then we learned about the JSX syntax and how that allows us to write code that's much more familiar to us because it looks like we're writing HTML code inside of our JavaScript. Then we saw how we could actually apply the composable nature of React by creating our own custom components. For example, in our React Facts site, we created our own components for the main content of our page, but also for our navigation bar. Obviously, in this case, our navigation bar and our main sections are pretty simple, but hopefully you can imagine as your sites get more and more complex, how the ability to segment each of the pieces of your page into its own components can be a really beneficial thing. And soon we'll be really tapping into the power that comes with that as we learn more about React. Then we started learning about how we can style our projects because, well, obviously adding CSS is one of the key things that we need to make it look polished. Truthfully, there are a ton of ways to add styling to React. For now, we'll just be sticking with CSS classes because they're familiar, and all of these things combined have enabled us to create our own static pages in React. Like I mentioned, because we've only been working on static things so far, you might not yet be understanding why we're using React in the first place, but I promise we're going to get there and I promise it will be worth it. Before just moving on, you should celebrate your wins. Over in Discord, there is a Today I Did channel. If you click on the screenshot here, it will take you there, and you should let everyone know that you have just completed the first section of the Introduction to React. Also, this might be a good time to realize if you've been sitting down for too long or watching too much of this in one sitting, make sure you take a break. Your brain needs to rejuvenate itself, especially with all the new information you've been learning. So once again, congratulations on completing this section. You really should be proud of yourself. When you're ready to jump deeper into React, I will see you in the next section. Now that we've covered the basic syntax and concepts of building a static page in React, we're now ready to jump into the next phase, which is learning how to use data to create our web pages. In regular HTML and in the React code that we've done so far, all of the content that we're displaying on the page has been hard-coded directly into the React components. And it turns out this has some major limitations, which we'll be discussing in this section. First, let's look at the project that we just made. This little React Facts page, all of the data on this page was actually hard-coded directly into the components themselves. But now let's look at this section's project, which is a clone of the Airbnb Experiences page. Up near the top, we have some elements that are likely just hard-coded pieces of data. However, when you get toward the bottom and you have a list of different experiences, you can probably imagine that there isn't a developer sitting around waiting for a new experience to become available on the Airbnb website, and then immediately going into the code and updating this list to include that new experience. Instead, the data that's living in Airbnb's database is what will be driving the list that we see here. And once you start thinking in terms of components on a page that are actually being driven or displayed based on the data that underlies the page, you'll start to see this same architecture existing all over the web. Basically, any e-commerce site or page that has any kind of list on it is probably not using anything hard-coded into the code of the page, but instead is using the data that lives behind it to drive the content that exists on the page. If that's confusing at all, don't worry, we're going to dive into the specifics and see exactly what I'm talking about. Just like before, you can click on the screenshot you see here to go to the Figma design file for this section's project. And also just like before, when you get there, you'll see a screen that looks similar to this. I'd highly recommend that you click on the drop-down arrow near the top, go down to Duplicate to your drafts, and choose this option to create an editable copy that will live in your own drafts instead of trying to use the one that is shared amongst everyone coming to this page. Once you click Duplicate to your drafts, you should see a little modal at the bottom that pops up that says that the file was duplicated to your drafts, which also includes a quick button that you can click to go directly there. And by the way, you can click any of these little screenshots to go to this design file as well. So let's see what we're going to be learning. The first thing that we'll be diving into is a concept called props in React. Props is one of the major topics in React that will help you create reusable and composable React components. And so we'll be spending a pretty good amount of time covering the concept and the syntax of props. And the other major topic we'll be covering in this section is how to create React components from an array of data. This is what will allow us to create those designs like in our Airbnb design here, where we have a list of items that we won't need to manually update anytime the data behind it changes. Now, before we jump into some of those more crucial topics in React, the first thing we're going to do is spend a bit of time creating the top half of our project here. And I'm going to say something that might shock a few of you, and that is that if you already feel very confident in doing styling in React like we did in the last few screencasts of the last section, I'm going to give you permission to skip the next few screencasts where we talk about designing the nav bar at the top and designing this hero section up here. Now, this isn't a free pass to just skip those sections. If you feel at all like you need additional practice using styling in React, I highly recommend you do not skip those practices. However, I did just want to warn you ahead of time that we will be spending a bit of time working on some of those design aspects before we jump into the main topics for this section. So again, click on the screenshot here to open it in Figma, create a copy in your own drafts, and then let's jump right in. We're going to start off this section as mostly a review of what we learned in the last section, which was how to create our own custom components. The way that we'll be reviewing that is by first building the top section of this project, which is really just static elements. You can see up at the top we have a little navigation bar. Well, it's not even a navigation bar, it doesn't lead anywhere, but we'll call it a nav bar. And that's what we'll be working on in this first challenge. After this, we'll build this little photo grid and the text down here. And those will be two separate components, a navbar component and what we'll call a hero component. You can click on the screenshot you see here at any time to be sent to the Figma file in order to look for the design specifics. And because we already hammered it in the first section, I'm not going to have you build this completely from scratch. So let me walk you through what we have so far. In index.js, we're simply importing app and rendering app. Our app component is, well, basically as simple of a component as it could possibly be at this time. And this is also where your challenge is to build the navbar component. I've also included the Airbnb logo image as well as the photo grid image, which we'll get to in the next challenge. But in this challenge, the Airbnb logo is this little Airbnb logo in the navigation bar that you'll be working on now. The last couple things you'll notice is that I have the styling about as basic as it can be at this time, and I've also already imported the Poppins Google font that you'll notice is used in the design file. As such, when you're setting the font family, you can just say Poppins, but in this screencast, I don't think you need that. Yeah, this navbar doesn't have any text, it just has the image. Okay, let's go. Pause the screencast and build out our navbar component. I think what I'll do, even though this isn't going to be a particularly large application, I'm going to add a new folder called Components. And that is where I will put my new Navbar.js component. In Navbar, I'm going to import React from React and export default my Navbar function. I'm going to use the semantic Nav Element here. And the only thing we really have in here is an image, so I'll use the image element, and I'll provide the source, which will be /images, since I'm now inside of a components folder, /airbnb-logo.png. Okay, we have our component built. Obviously, this image is not sized correctly, so as soon as we get it displaying, it's going to look a little bit funny. But in our app.js, let's go ahead and import our navbar from /navbar, or actually it's /components/navbar. And then for our app component, let's, instead of rendering this h1, we'll put a div as our wrapper for the elements we put here, and we will render our navbar. Okay, again, I bet our logo is pretty huge. Yeah, that's much larger than we expect, but that's okay, because now we can turn to the CSS in order to style this. Because this app will be pretty limited in size and I'm only going to have one nav element, I'm just going to directly style the nav element. I can see from the design that it has a height of 70 pixels. And of course, that's not going to stop our image necessarily from expanding beyond the borders of that nav. However, in order to center that logo and get it over there on the left and everything, I think I would like to just make this a display flex. I think that's also going to, yep, our logo will be confined within the Flexbox because now it's a flex item and it's automatically resized to fit within its boundaries. If I add a little bit of background, let's just do something temporary. We'll say background color is blue. That lets me see exactly what I'm working within. And I bet if we just add some padding, we will get to resize that Airbnb logo a little bit smaller. Let's give it about 20 pixels on the top and bottom. Oh, that's already looking a lot better. And we'll say maybe 36 pixels on the left and right. That'll just bump it a little further to the right. Then if we look on the design, we can see that there's actually a box shadow on the bottom of this nav bar. It kind of helps separate it from the rest of the body. This isn't always a perfect way to go, but you can actually just copy that CSS directly from Figma and paste it. You can see when it was designed, it might not have been perfect. We have some weird decimal values here, but for now, I'm not going to be too concerned about that. It's a little difficult to see with our blue background, so let's get rid of our blue background. And awesome, we can see that's looking pretty good. One kind of strange bug I noticed when I was practicing this earlier is that on a Safari browser, this Airbnb logo will sometimes stretch the entire width for some reason of this navbar. So before I move on, I'm going to go to my navbar and give a class name to my image here. Let's call it nav-logo. And I'll hit save so that we can style that in our CSS. We will select nav-logo. And if I give it something like a max width of 100 pixels, that fixes the problem in Safari. Awesome, this is a great start to our app. In the next screencast, we'll pick up with another challenge and complete the hero section, which is right below, and that will conclude the review, at which point we can move on to the topics for this section. The next part of this review is for us to now build our hero component. That includes the photo grid, this H1, and this paragraph. To make things easy for the photo grid, I exported all of these photos as a single PNG, so you don't have to worry about laying out these images in a really cool way like this. Just as before, you can click this screenshot to go to the Figma design file for the specifics. The font being used is that Poppins font that we're pulling in through Google Fonts, so you can set the font family to Poppins. From a design perspective, you might also notice that this image grid is centered in its container, whereas the text is left aligned, although obviously there's this padding here. So your challenge is to build the hero component, pause the screencast, and work on this challenge. I'll work backwards this time. I'm going to duplicate my navbar line that I'm importing and change this to hero, even though this component doesn't exist yet. We'll do the same down here and render a hero. I'm not going to hit save because that's going to cause this to crash. Instead, let's go ahead and create our hero.js file. we will import React from React and export default a hero component. And first, let's get our bare element set up. I'm going to return, maybe we'll call this a section element since it's a section of our page. And we can see we have an image element, an H1 element, and a paragraph element. So I'll include those now. I'll go ahead and just paste in the text of these from the design file. Let's add our image source, and that'll be from ..images/photo-grid.png. And just like our logo, this is probably going to be a little too big for us. Yep. If I scroll down though, I can see some of this stuff popping up here. That's good. It's a good start. I'm going to set us up for some success with the CSS just by giving us some class names. Let's give the image a class name of maybe hero-photo. We'll do the H1 is a class name of, let's say, hero-header. And we'll do the same for the paragraph. Let's call it hero-text. I'll hit save, and then we'll go over to our styles so we can style some of these up. One thing that I've liked doing in the past is if I'm going to have a section that represents an entire section of my page, I just will style the entire section element or the section element directly and give it something like a padding of 20 pixels. That way, if in the future I want to use sections as, well, sections of my web page, it will automatically have the padding applied. Similar to what we did with our navbar, I think I want to make this section a display flex, but I'll have it be in a column direction. That'll make it really easy for me to center this photo grid, but keep these left aligned. I don't want to do that on all of my sections, however, so I think I'll go back to my hero and I'll give this section a class name of hero. And that way it's acting kind of like the hero container. And let's style our hero to be display flex with a flex direction of column. I have to hit save over here so that applies. Okay, that's already looking a lot better. I'm going to make this just a little bit bigger so we can see how it compares. One thing I noticed when I resized that is my image is growing probably infinitely to fit this container. Because I'm working in a fairly small space, I'm really only designing for mobile right now. But I think what I want to do is give my hero photo something like a max width of, it looks like in the design it's around 400 pixels. And we can see doing that is making it align to the left side there. So let's give this the flex item property of align self to the center. Okay, well, the only other thing I notice when I'm looking at the design is that my H1 and my paragraph are spread a little ways apart. Oh, and they're not the correct font family quite yet. So let's actually give the entire body a font family of Poppins, and we'll give it a backup of sans serif. And let's see. Oh, whoops, not popping, Poppins. Okay, and yeah, that's making a difference. Awesome. And then I'll come back down and I'm going to simply style my hero header. And let's specify a bottom margin. So margin bottom of, it looks like it's about 16 pixels in the design. And I think my paragraph might have some margin that's automatically applied. I'm just going to style my hero text to have a margin top of 0. Okay, those are sitting a little closer together, a lot like the design. Okay, I know that was a little bit lengthy to work on mostly CSS here, but like I said, I really think it's important to be synthesizing some of the past things that you've learned before they, you could say, atrophy or get stale and you just forget them. Especially as a front-end developer, there's almost no way to completely escape CSS if you hate it, and hopefully if you love it, then you really enjoy these reviews. So with this top half out of the way, now for the rest of this section, we'll be learning what we need to know in order to handle the bottom part of this app. So that's what we'll start doing in the next lesson. Let's jump right in and start building an instance of our card component. The main purpose of this exercise is to really illustrate how we're not quite yet prepared to build a series of components like we have down here. So for now, you're just going to build out one instance of our card. There's a few things that I've done for you. I've created, first of all, this card component. So you won't have to build this from scratch. And right now we're just rendering one instance of our card component. You'll notice too that I moved our hero out and commented it out. That's just so we didn't have to keep scrolling down in our app in order to see the progress that we're making. And let's go to card.js and look at our challenge. Your challenge is to build out the card component. And for now, just hard code in the data for this first one with Katie Zephyrus. For some of the notes, only render one instance. I already did this for you. Also, the little star icon and the photo of Katie Zephyrus are here in our images. We have katiezephyrus.png and star.png. I just talk here about making sure to include all of the pieces of data that we have. And again, that the main purpose is to show that we have some limitations currently in our understanding of React. So don't worry about the fact that you're just hard coding all of this data into the card component for now. All right, it's time. Pause the screencast and work on this challenge. Okay, so when I look at the card component that we have in the design, I think what I'll do is make one div that will surround everything in the card, both the image and all of the data below. I'll probably put all three of these pieces of data and this little star image into its own div so that I can use Flexbox to make sure that they're all center aligned. And then I'll probably just put this Life Lessons with Katie Zephyrus in a paragraph and these prices here in a paragraph. I may end up putting this bolded section in a little span inside of that paragraph just to make it bold. If you were feeling adventurous, you might have put this little badge here. I'm going to ignore that badge for now. We're going to cover that a bit later. So let's get some of the elements on the screen here. We're not going to have an H1. Instead, we'll surround everything with a div. I think I'll go ahead and just give this a class name now of card because I already know I'm going to be styling this. The very first thing I have is an image, and we'll hardcode in our source. That's going to be in ./images/katiezephyrus.png. I'm sure this is going to be a bit large as well, so I'll go ahead and give this a class name. We'll say card-image. And then, like I mentioned, I think these elements here, we've got the star, the rating count, and the location all here in a line. So let's create a div. Maybe we'll call this a class name of card stats. And we'll put in our image, which will have the star.png as its source. Then I think just to get these other things in line, I'll use an inline element like span. So let's go ahead and create, I'm going to have 3 spans here. And remember, I'm just hard coding in some data. So we'll put 5.0. We had a parentheses with a 6. And I might actually just put my little bullet here as well. And then the location was USA. I guess let's hit refresh and see where we are. Okay, obviously some styling to handle, but at least things are showing up. After those stats, I think we just had 2 more paragraphs. So let's go ahead and create a couple paragraphs. We have Life Lessons with Katie Zephyrus. And here we had from 100, was it 136? I guess it doesn't really matter, per person. All right, let's see where we are. Okay, well, we have the elements on the screen. Let's start doing some styling here. I'll go over to Styles. First, I'll start off with my card, and it looks like from the design that it has a width of about 175 pixels. And while I'm here, I'm noticing that the text of this card is a little large. I think I'll just style all of that right here. We're going to say font size of, it looks like it's about 12 pixels. Okay, that's starting to look better. I had my card image, which is looking a little large. And in fact, the image is spanning outside of the boundaries of the card. So if I add a width of 100%, yeah, that's much better. And from the design, it looks like we also have a bit of a border radius. Looks like maybe 9 pixels. Awesome, the image is looking good. Then we had this div that contained our image and our 3 spans. I think we called that card stats. And like I mentioned, we're gonna make that display flex and use align items to the center. Okay, and my star is looking pretty huge compared to the other things. I can't remember if we added a class name to the star. Not yet. Let's go ahead and add a class name, and maybe we'll call it card --star. Then I'll hit refresh somewhere so we can see those styles right away. Card star. It looks like the height is about 14 pixels. Okay, that's looking a lot more manageable. In the design, the review count of 6 here and the location are both in gray. I think what I'll do is actually just create a bare gray class that isn't specific only to this card, just because it seems like something I might want to do with a few other elements. So I will give both of these spans a class name of gray. And then since that's a little bit more of a generic style, I think I might move it up maybe just right here below the nav. We'll create a gray class and we'll just say that the color is the kind of grayish color from the design. So I just copied and pasted that straight from Figma. I need to go and refresh here. Okay, we have a bit of a light gray tint there. The only other thing I think I might do is change this to bold right now. That seems like another thing I might want to do elsewhere. If I just want to bold this text, I suppose I could surround it in a B tag or a strong tag. I think I'm going to actually surround it with a span so that I can style that span and just do that in line. We'll surround the from $136. We'll give that a class name. I think again, I'll make this generic. We'll just say bold. And in my styles.css, we'll add a bold class that sets the font weight to bold. And let me hit save over here. Awesome. Let's give ourselves a little more room. Okay, this is certainly looking good enough for now. Hopefully, as you were building this, you could start to see some of the limitations that we have with the way that we built it, especially by hard coding all of this data directly into the card component. So in the next screencast, let's start talking about what the problem is with the way we currently have this, and that will set us up perfectly to learn the solution to this problem. I assume many of you watching the last screencast were thinking to yourselves, okay, I'm creating this card component, but because I'm hard coding the data in, it's not going to be reusable. I've updated the Google slide to show you maybe a more realistic version of the design that we're looking for, because we're not just going to have the same experience with all of the same data inside. These kinds of repeated components are found everywhere online, and if you just start looking for them, you will see them everywhere. I pulled up screenshots from some of the first designs I could think of. In Amazon, every component or every product is going to have a repeated element. Here's IMDb that has something that looks relatively similar to what we're doing. And here's Apple, which has different product components, which really just have an image and a title, image, title, image, title. And you can imagine that when a new movie comes out to put on IMDb, there isn't a developer out there that is actually typing in new HTML or copy and pasting the HTML that they already created and then just changing out some of the data. But instead, these components are actually data-driven. On IMDb, for example, all they need to do is add a new movie to their database, which includes things like the cover image, the rating, the title, and so forth, and then the website will automatically update to include a new movie in its list here. We're going to cover the data aspect later, but for now, the main problem we have is that our component is so hard-coded that we can't really reuse it in any meaningful way. And in React, this is where the concept of props comes into play. Now, in my years of teaching React, I have found that props can be one of the more difficult subjects for students to grasp. And so what I plan on doing is taking the topic and just spreading it a little bit thin over a few different screencasts, and you'll get your hands on the keyboard and get to really practice with it so that you can understand the concept of props. So let's jump right in and get started. Let's start by understanding the basic concept of props in React. What you see here is just a plain index.html file. We haven't introduced anything dealing with React in this. I want you to take a close look at the elements that you see here and see if you can figure out what's wrong with them. Let's start with the anchor tag. An A tag, an anchor tag, is intended to link you to another place. But currently we don't have an attribute like the href specified. Without an href, this link is essentially useless. We need the href property in order for us to send someone to another page, maybe like google.com. Similarly, the image element is basically useless without any kind of source property. We need to add this source attribute or property in order to specify exactly what image will be here. We could put the path to a local file, or we could put the address of a file that's hosted somewhere on the internet. Input is interesting because I think on its own, it actually will put an input box that we could type into if we wanted to. However, there are attributes or properties that we can add to the input that will make it a lot more, let's say, beefed up or capable. For example, I can add a placeholder that says something like first name, and that suddenly makes the first name text appear inside of my element on the page. Or there's ones that have even more consequence to them, like the type property. If I change the type of this input to something totally different like submit, now it changes from an input text box to a button. Similarly, I could change it to radio and it completely changes the visual look of this input. These are concepts that I'm sure you're already very familiar with. Let's look at a similar parallel example in JavaScript. Here I've written a function that's called add two numbers together, and it just hard returns 1 and 2. Think for a second, what is wrong with this function? It's syntactically correct, but what's wrong with a function like this? Well, it's very, very limited in its capabilities. Right now, if I call add two numbers together, it will always return 3. Essentially, it's a useless function. Now, you might already see where I'm going with this. If I add some parameters, like let's say A and B, to this function, now I can dynamically add and return the result, or rather the sum, of the two numbers that I pass in. And with the small addition of these two parameters that I've added, I now have sort of beefed up this function in a way that it's capable of adding whatever two numbers I want, not just the hard-coded 1 and 2 that used to be there. Again, these concepts should be familiar to you by now, but this is just a primer for us to understand the concept of props in React. In both of these instances, in JavaScript and HTML, we can see that passing additional information to our maybe elements, or in this case, functions, allows us to reuse these elements or functions in multiple different ways. So with that primer under our belts, let's look at another conceptual parallel that is a little more visual. Let's try to understand props with a little bit more of a visual example. This is a screenshot taken from YouTube, and as you spend more and more time with a framework like React, you will begin to see these patterns of elements on the page that are repeated pretty much everywhere on the internet. For example, if you look here, you'll see that there are multiple components being displayed here, but all of them have essentially the exact same structure. They each have an image toward the top that takes up about half of the height of the component. Each of them has bolded text that represents the title. There's the view count showing the number of days ago that it was published. There's even little timestamps embedded inside of the image in the lower right. And as I've mentioned before, there certainly isn't a developer at YouTube that every single time a video is posted to YouTube, they go in, copy the code from an old tile, and paste it in again so that it can exist on the site. Instead, a developer has created a single component, maybe let's call it a video tile component, and has made that component flexible enough to take in as a property the image and the title, the view count, the number of days ago it was posted, who posted it, the timestamp, and so forth. And as you become more experienced in React and you start to see these patterns for yourself, you'll begin to realize that they can be nested inside of each other. For example, not only do we have repeated video tile elements here, but we have something that let's suppose is called a video list. Each one of these is made up as a parent-child relationship of video tiles. Even small things like on the left side of the page, you can see that these are probably individual components that are taking in properties to help them display something slightly different. In this case, it's probably just two elements. There's an image and there's some text. So that's probably enough of the conceptual. I think you're starting to understand the concept. Now let's go back to React and we'll start looking at how this is actually applied in code. Before we can continue on with props, we need to take a quick aside to talk about something. We've learned how our components will be returning JSX, which is a special syntax of JavaScript, or rather it's something that's created by React and allows us to write our React code in a very declarative way. However, one of the most common things that you'll find yourself doing is trying to insert values from JavaScript inside of your JSX. Right now we just have some text inside of our H1, but let's assume we had a value like first name. Maybe this is Joe and a last name. let's say Schmo. Think for a second, how would you change our H1 to no longer say hello world, but instead to say hello Joe Schmo? Well, we can probably see ahead of time that just trying to input first name, last name, or maybe even adding a space in there as if this were regular JavaScript isn't really going to work. If I do this, I'm going to get the literal text of first name plus last name interpreted as the text content of my H1. Fortunately, React has made it really simple to interpret something as JavaScript instead of text when it's inside of a JSX element. And that is by simply surrounding it with a single set of curly braces, almost like it were an object. So at this point, before I even hit save, I'm going to give you a quick challenge. Simply enough, I want you to finish off the H1 that we have here so that it says, hello Joe Schmo. And actually, let's put an exclamation point in there for good measure. Pause the screencast and do this challenge. Well, if I hit save, we'll see that it interprets the Joe correctly. Instead of saying first name, it's now taking the value of our first name JavaScript variable and inserting it here. And then, of course, the rest of this text is still there. If I were just to surround last name, then I would get a little bit closer, but I still have my plus and my quotation marks. So at this point, I can just get rid of those, put a space in between my two values, hit save, and there we go. Hello, Joe Schmo. The way I like to think of this is that as soon as I start seeing JSX, the interpreter sort of goes into JSX mode. Anything after this greater than symbol is going to start being considered the text content, or in the case of having nested elements, other JSX elements. And we're currently in what you could call JSX land. However, as soon as we see this opening curly brace, we switch back into our JavaScript mode or JavaScript land. And then anything inside of my set of curly braces will be considered JavaScript. Once I get to this closing curly brace, I'm now back into JSX, which is why I have an actual space in the text between my first name and my last name. Then it sees my curly brace again, so I'm back in JavaScript land. The closing curly brace tells me I'm done with JavaScript. I get the exclamation point as part of my actual text. And then I close off my JSX tag. Now, once I enter JavaScript land, I can actually do more than just take in values from my JavaScript up above. In fact, anything that I put inside of my curly braces can be run as JavaScript code. Let me clean up this challenge really quick. Something that's important to note is that anything I put inside of my curly braces will be run as regular JavaScript code. So I'm not limited to just pulling in values like this. For example, I could do something like, say, I have a new date, which is a new date object, and then change this to something like it is currently about, and then run some JavaScript code inside of my curly braces, saying date.getHours. And then let's say we want to do a modulo 12 so that we get the AM PM hours, or rather like on a 12-hour clock. I hit save, and there we go. It's currently about 3. Maybe I say o'clock. And that's because for me, when I'm recording this, it's currently 3:21 p.m. And in fact, I wouldn't even necessarily need to create my date outside of here. I could say new date dot get hours, and I'm going to get the same result, even without doing it out here, because anything that I put inside these curly braces will be run as regular JavaScript. Now, personally, I think it's a lot more readable to do the actual JavaScript outside of my return value in my JSX. So if I were doing this in the real world, I'd probably say something like const hours equals date.getHours modulo 12, and then inside of my render down here, all I'm doing is putting hours. And of course, we get the same result that way. One thing that's nice about doing it this way is you can sort of separate the logic that your component is running with the display that your component needs to show on the screen. So for example, let's say I wanted to say, depending on the time of day, good morning, good afternoon, or good night. Well, I could do all of my logic up here to determine what should display after the word good. For example, I want it to say good afternoon because for me right now it's afternoon. I could do something like this, and I'll probably speed this up so it doesn't take up too much time. All I've done really is created a changeable variable, let time of day, and then said if the current hours is less than 12, it's morning. If it's between 12 and 17, then it's afternoon, and otherwise it's considered night. I probably should make something for evening because 5 o'clock p.m. seems a little bit early to say goodnight to someone, but whatever. So here's another mini challenge for you. Okay, your challenge is simply to fix the H1 below to use the time of day string that we determined in the code above. Pause the screencast and work on this challenge. Simply enough, all we really need to do is remove the hard-coded afternoon, put a set of curly braces, and then say time of day. Now, of course, because it is afternoon for me, this will still say afternoon. I suppose I could just trick this. Maybe I change this to say if it's between 12 and 1, then we consider it afternoon, but otherwise it's goodnight. I should be able to hit refresh, and sure enough, it says goodnight. I'm going to change that back so that's not so weird. Okay, with that concept, we are primed to now jump back into props and to see what the syntax of props actually looks like. To help guide us through learning the syntax of using props in React, we're going to look at this little contact book that I created here. As you can see in our app component, everything is hard-coded. Each one of these divs, which I separated with a little space in between each one, represents one of the contact cards. But of course, all of the data is hard-coded inside, which means if I ever needed to make a change, especially to something like the styling, I'm going to have to make that change to every instance of this contact card that we see here. Before we can really talk about props, though, we have a challenge for you, and that challenge is to create a separate component called contact, which, as the challenge shows, will be in a different file. And then I just want you to choose one of the contacts that we have here to move into that file. Essentially, you can just copy and paste one of these contacts over into your contact component. Then, once you've moved one of these contacts over to the contact component, I want you to import the contact component and render 4 instances of it here inside our app component. While you're working on that part of the challenge, I want you to think ahead what's going to be the problem with doing it this way. Okay, pause the screencast and work on this challenge. Okay, so I'll create a new file called contact.js, and in contact.js we'll import React from React. We'll export default, our function contact. And for now, we're just going to copy and paste one of the contacts. Let's choose Mr. Whiskerson here. Okay, that should have been easy enough. Inside of app, we will then import contact from our contact file. And then instead of completely deleting all of these, because I think I want access to this data, I'm going to actually move them down outside of my component and then just comment them out. That way I still have access to them, but they're out of the way. And now I'm going to render 4 instances of my contact component. If you didn't make it this far, or you didn't take the chance to think ahead what's going to be wrong with doing it this way, I want you to think now, what's going to be wrong when I create 4 instances of this contact component? Well, if I hit save, we get 4 Mr. Whiskersons. And as much as we love Mr. Whiskerson, we still need the data from our other contacts here in our contact book. Why exactly is this happening? Well, when we copied one of the contacts and pasted it over, we pasted the data with it. Just like a function, let's say add 2 numbers, that takes no parameters and simply returns a hard-coded amount, in this case 1 plus 2, every time we call this function, it will always give us the same result. In the same way, our contact card has that data embedded inside of it, or hard-coded in it, and therefore it's going to show up every time we make an instance of that component. Now, similar to how we instead will usually pass some parameters to a function which make it more flexible and reusable, I can say return a plus b, and now suddenly I have an infinite number of possibilities with this function because all I need to do when I'm calling it is pass in the real values that I want this function to use. We can do essentially the exact same thing in React. The remainder of this screencast is going to be focused on how we pass data into our contact component. And in the next screencast, we're going to look at how we can consume that data from our contact component so that we get back to a working state where we have 4 different contacts in our contact book. Let me delete this function. We'll go back to app.js and focus here on our instances of the contact component. Just like we talked about how HTML allows us to pass attributes which can alter the behavior of the element, React chose to do things in a very similar way. However, in HTML, where we are limited to using only the attributes that are allowed for any given element, for example, I couldn't pass a whatever I want attribute to a link tag because that's not defined in the HTML spec. With React, because this is a custom component, I can pass in any property or attribute that I want. We have 4 pieces of data in each one of our contact cards that we need to pass down to our instances of the contact component. So to do that, I can add an image prop, or let's call it img. This image prop can be the value of the path to the image. So I'll go ahead and copy that from Mr. Whiskerson here. Again, in the next lesson, we'll be learning how to actually consume these properties that we're passing in. But for now, we're just going to be dedicated to adding these properties to the contact component on our instances. Now, the upcoming challenge might be something that you decide you really hate me for giving to you. I'm going to do one more of these props, and then I will update our challenge to give you a chance to practice typing out your own props to each one of these contact cards. I'm going to put this on its own line because I already know I'm going to be adding a bunch of these. The next piece of data that I'll need in each one of my components is a name. So let's choose to call it name. I'll come down here and just copy Mr. Whiskerson's name and pass it in. And this is the point at which I'll update this challenge for you. Okay, once again, I promise I'm not doing this to be mean, but I do want you to do a little bit of busy work, mostly just to get your hands on the keyboard and start practicing what it's like to add your own props to this contact component. Remember, we get to decide what we call these props. We could call this whatever we want, but of course that's going to be more confusing, so I'll stick with name. The other 2 pieces of data we still need to pass down are the phone number and the email. So finish up the first contact first by adding a phone and email prop, and then I want you to fill out all the data for the remaining 3 contacts with the image, name, phone, and email props. All of the data, of course, can still be found here, so you'll have a bit of copying and pasting to do. Pause the screencast and add the rest of our props to our contacts. Okay, hopefully that wasn't too painful for you, and hopefully you got a good sense of what it's like to add props to React components. I'll finish up this first contact together, and then I'll probably skip over the rest. So let's add a phone prop here. I can just come down and copy Mr. Whiskerson's phone number, and we'll add an email prop as well, and we'll copy this as well. Now, I'm going to go ahead and finish up these contacts, but I'll skip over that so you don't have to watch me monotonously copying and pasting the data from below. Okay, that wasn't so bad, was it? At this point, I can come down and get rid of this old version that we have here, just to clean things up a little bit. I'll also clean up our challenge. And at this point, you probably can see that things are a lot more organized. Sure, we still have a good number of lines of code here, but the data is the primary focus. We can see exactly what data we're passing into our contact component, and then our contact component contains the specific display logic on how the data should be used. Of course, at this point, we haven't made any changes to the contact component. So if I hit refresh, what do you think will happen? Well, hitting refresh won't change anything. We're still going to have 4 instances of Mr. Whiskerson, because essentially what we have now is a function like our add to numbers that takes parameters A and B, but still is returning hard-coded data. So even if we call add to numbers, or let's say, let's call this numbers, and we pass in 5 and 10, it doesn't really matter at this point that we're passing in 5 and 10 because the body of the function is still returning hard-coded numbers. So in the next screencast, let's see how we can make use of the properties that will be passed into this component so we can get back to a place where we have our 4 different instances of our contact card. In the last lesson, we learned about how to pass values into our components using a very similar syntax that we're already used to with attributes in HTML. In React, we don't call these attributes, we actually call them properties, or usually for short, just props. Unfortunately, it's very easy to get the data that we're passing into our components inside of our component itself. Right here, just like a function that takes parameters, I'm going to put the word props. In truth, I could call this whatever I want. In fact, I'll show you exactly what happens. I'm going to console log what we called whatever, and let me make a little room here, open the console, and hit save. Now, 4 things got logged to the console. I want you to think for a second, why did it console log 4 times? It console logged 4 times because I have 4 contact instances. Every time React rendered one of my contacts, it ran the console log line inside of the code of that component. And if you look closely, you'll see that we have 4 properties in that console. Let me copy one of them out here so I can actually reference it. We got 4 properties here. If I clean these up each onto their own line, you can see that what we received, what we're calling whatever, is an object that has properties that match exactly with what we put here as our prop inside of the component here. Let's see what happens if I maybe change img to something like the whole word of image. Again, I can change these to whatever I want them to be. So now when I hit save, if you look down below, the first item is receiving an object that now has an image property all spelled out, whereas all the other ones are still receiving an img property. Anyway, I don't want to go down that rabbit hole too much, so let's come up here and change whatever to props, because props is what you'll usually be calling this. And at this point, I want you to pause the screencast and see if you can figure out how to use this object that has all of the properties we want to update our component. This one's going to take some critical thinking, but I want you to really think through it, see if you can figure out how to essentially make it so that our components are not 4 instances of Mr. Whiskerson, but rather have the correct data and images displaying here. Let me type that out as a real challenge. Okay, there's your challenge. Pause the screencast and see if you can make it so that essentially we finish this little contact book where each one is its own separate contact. Pause now and work on this challenge. Well, if props is an object and I can access the values of that object by using props dot, for example, name, props.image, then all I really should have to do is update this hard-coded data, for example, the name here, to curly braces props.name. Of course, if I didn't put the curly braces in there, it would literally interpret the text props.name, and then all of the names would say props.name. When I surround it with curly braces, awesome, my names are changing. Obviously, nothing else has changed. So let's go ahead and do the rest. I'll start with these easy ones. We'll get props.phone and props.email. Okay, the phone and email are coming through correctly. Now the image. This one may have been a little bit trickier for you, but simply all I'd have to do is erase the entire source, including the quotation marks, and put my JavaScript here. Because the value that's coming in through props.image, or img, is already a string, it's going to fill in the string value for my source. I hit save, and there's all of my values. But here's a bug. I introduced this when I was teaching the concept. Hopefully this was a good chance for you to do some debugging. If you didn't, I want you to see if you can figure out why the picture for Mr. Whiskerson is not coming in. Pause the screencast and try to fix this bug. Well, right here for our image source, we're assuming that we're receiving a prop called img. Back in app.js, however, I did change this to image. So I'll change this back to img. Hit save, and now the photo for Mr. Whiskerson is coming in just fine. Now, I hope I'm not belaboring the point. Understanding props is one of the most crucial things that you can do in React when you're learning. So yes, we've spent a lot of time covering props. However, you will use props every single day of your React life. So this is a really big milestone. If you feel like you've understood everything in React that we've talked about so far, you should really congratulate yourself, pat yourself on the back, and probably at this point, take a little break. Don't try to bite off too much more than you can chew. And I do want to show you a little cool trick that we can do with our props here in the next screencast. Okay, it's time to give you a prop quiz. Sorry, I couldn't help myself. Like before, your task is to read through each of these questions, to actually click into the editor and type down your answers. Don't forget, in Scrimba, if you have any changes that you make to the code, you can always save it as a note so that you have access to it later. You can even record your own voice talking over the top of the note if you wanted to keep an audio note. And all of those are saved here in your account on Scrimba. So pause now, answer the questions through this quiz, and then you can hit play and we'll go through the quiz together. Number 1, what do props help us accomplish? Well, just like parameters being passed into a function, props being passed into a component help us make that component more reusable. As you become more and more experienced in React, you'll realize that there are times when it makes a lot of sense to pass props into a component so that it's reusable, and other times when it might be possible to pass props into a component, but it's just not always necessary. I can't tell you how much time I have spent trying to create a component that's very reusable and then ended up only using it 1, maybe 2 times. That's just one of those things that will come with experience as you write more and more React code. Remember, when we pass props into a component, it could be data that actually gets displayed as a part of that component, or it could sort of be like metadata that you're passing into the component that in a way configures it to act a certain way. Either way, it helps us make any component that we create more reusable so that we can keep our code as dry as possible. Okay, so number 2, how do you pass a prop into a component? In the same way that you pass attributes to HTML elements, like a source attribute for an image, you essentially do the same thing when you're passing props to a component. So if I have my own component like, let's say, my awesome header, I'm using a strange name just to make it very clear that this is a custom one. You can pass a prop of your own choosing, like maybe title, into that component. That brings us to number 3. Can I pass a custom prop, like, for example, blah, 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 to a native DOM element? So, for example, a div with a lowercase d. Well, the answer is no. So we come to the next part, why not? And that's because under the hood, when React sees a regular HTML element that we're trying to render, we express that element through the JSX syntax, and that JSX syntax actually returns an object, and the object describes the actual DOM node that should be created. When we add an attribute to a regular DOM element like a lowercase d div, the object that this JSX creates is expecting to be able to add this property to the DOM element. And since DOM elements don't have an attribute called blah, 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 I can't just choose the props that I want to add to native DOM elements like this div. So let me try typing out a summary of that. So the answer is no, because the JSX that we use to describe those native DOM elements we want React to create will eventually be turned into real DOM elements, and real DOM elements don't have whatever properties, let's say properties, or attributes specified in the HTML specification, which, as we all know, doesn't include properties like blah, blah, blah. Okay, I think we understand that concept. How do I receive props in a component? Simply enough, the parameters to that component function will receive a value called props, which of course we could name whatever we want, but by very strong convention will be props. And that leads us to the last question, which is what data type is props in the component when I receive it? This parameter, which we're calling props, is an object, which means if I want to access the properties of that object, I use dot syntax. So props dot whatever the prop was that I passed in. Let's use blah, 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 because that's what we said before. Okay, awesome job on that quiz. If you struggled with any of these questions, of course, don't hesitate to go back and review the things that we've recently learned. And when you're ready, let's move on. At this point in the course, you should be somewhat familiar with the concept of object destructuring. However, just in case, we'll do a quick recap. Say I have an object called person. In ES6 and later, I can destructure the properties of that object in order to get simpler to use variable names. For example, if I wanted to log person.phone, I obviously could just use console log person.phone and everything would work just fine. However, in certain circumstances, it can be nice to destructure this object and pull out the property names for your own use. That looks kind of like this. I might say const, and then I'll use an object syntax, say image, comma, name, and then set that equal to person, my object. What that does is it declares two new variables, img and name, which I can then use in order to, say, console log the name. If I open the console, you can see I'm getting Mr. Whiskerson here. So that's the concept of object destructuring. The reason I bring that up is that it's a fairly common thing to do this in React with the incoming props that you receive. The parameter that you put inside of your component will be an object that represents all of the props that your component received. So what I could decide to do is just destructure that object immediately as I receive it inside of my function here, which means that I could say curly braces, image, name, phone, and email. It's important to note that I can't rename this to something else like image unless I do a little bit of trickery using colons, like image, colon, image. But we're not going to be too concerned about that for now. The point being, I don't get to change the name of the prop while I'm bringing it in. I need to make sure that it's exactly as the prop was being passed in at the time that the component was being rendered. If I decide to destructure my object like this, then I will need to change some of my code here. You can see if I refresh, suddenly I get an error that says props is not defined. So let me give you a challenge to fix it. Okay, your challenge is to fix our bug now that we've destructured the props object. Pause the screencast and work on this challenge. Well, by destructuring our props, we're essentially declaring four new variables up here: image, name, phone, and email. So instead of props.image, I can just reference image and name and phone and email. I hit save and everything should be back to normal. Yep, there we go. The main reason I wanted to show this is just because you will certainly run into React code that either has the full object of props written here, or very commonly the destructured object, which pulls out each of the individual components, or rather properties, of the props object. Frankly, you can write it either way. In my own personal experience, I've experimented with both ways, and in the end, I've found it a little bit easier, in my opinion, to put the props object here and then reference props.image and name and so forth. The only reason being, if I decide to declare other variables inside of my component, let's say right here, it becomes less apparent which variables came in as props and which ones were declared inside of my component. So that's my reasoning for usually sticking to putting the whole props object. It does cause a little bit more of the clutter here by having props dot everywhere, but honestly, that's okay with me. Whichever way you choose, just try to be consistent with it. There certainly are other things that we will learn about props as we go forward, but now it's time for you to get your hands on the keyboard and start practicing the things that we've learned about props. Well, it's been a minute since we've started a new React app totally from scratch. So one last time, I promise the last time I'm going to make you do this, I want you to set up a React app completely from scratch. I guess as a reminder, Scrimba is doing a little bit of magic for us. When we pull in these dependencies, it's setting up our React app basically for us, but I just mean in the coding part. I want you to get a little more practice on doing that from scratch. You can read through the challenge for the specifics on what you're supposed to do. There's also some extra credit down here that would be worth looking into if you're interested and if you were able to do this top part all by yourself. And although I would like you to include your own favorite jokes and maybe share it on Twitter or in Discord, I did include some jokes for you to use just in case you didn't have any jokes on hand that you knew of. So pause the screencast and work on this challenge. Since we've done this a number of times, I am going to move through this fairly quickly. So I'm going to import React from React and import Reactdom from React-DOM. We're going to use Reactdom to render an app component, which I haven't yet created, but will in just a second. And we'll render it to that div with the ID of root. I'll also import an app component, which isn't yet created, so I will create a new file called app.js. Inside of app.js, again, I'll import React from React. Anytime we need JSX in our code, then I'm going to import React. And I will export my component. For now, I'll just do a quick sanity check. We'll do an H1 that says hi. Okay, good. We're showing up on the screen. You might notice too, I included some basic styling. I changed the font just to switch things up a little bit. Okay, and then it says to have the app component render 4 or 5 joke components. So I will kind of work backwards. We'll have this return a div that surrounds our 5 joke components. And those don't exist, so first I need to import them from a file called joke. And then I need to actually create that file. So in joke.js, again, import React from React, export default our joke component. Okay, we'll have this return a little sanity check H1 for us. Joke here. Hit save. Okay, our 5 joke components are being rendered correctly and showing up on the screen. Now, if you did struggle at any point in just this part of the setup, I really recommend that you just go back, spend the additional time you need to revisit what we've talked about so far. Everything here should not be confusing at this point in the course, and if it is, it's okay. You just probably should go back and revisit some of the stuff that we've learned already. Okay, now comes the practice for actually using our props. We know that we need a setup prop, and I actually copied these already, so I'm just going to paste in the setups for these jokes. And then we have a punchline. Now I can tell that my punchline is going to make each of these a little bit too long. So while I'm here, I'm going to put these on their own lines. Okay, and then I have all the punchlines copied as well. Now think for a second, I haven't hit save yet. Think for a second, what is going to change, if anything, on my screen here? If you said nothing's going to change, then you're right. And that's because I am passing props in, but my component is not making use of them at all. So let's do that. I'm going to receive the props. Just for giggles, let's take a look at what console logs when I console log these props. We see we get 5 instances of the props object. So really quick question, if I typed console log 1 time, how come I'm getting 5 console logs? Well, just like any function, whenever I run it, it will run this console log. And in our case, because we have 5 instances of a joke component, it's running this joke function 5 times. Now, because props is an object, I can access the setup and the punchline through dot syntax. I can say props.setup and props.punchline. Let's make this not an H1, but a div. And I don't know, let's make these H3s maybe. And I'll separate each one with a little horizontal rule. Now, here's another check for you. If you weren't able to get to this point, I want you to think now, how am I going to actually make my setup and my punchline display on the screen? In fact, you can pause here and actually make that happen. Well, I can't just say props.setup because, of course, that will make it literally put the text props.setup on the screen. To insert our JavaScript value inside of my JSX, I just need to wrap it in curly braces. I'll do the same thing here. We'll say props.punchline. And I need to make sure I spell that right. And let's hit save. And awesome, we get everything showing up. Now, one thing I just thought of, I might want to change this to something like a paragraph just to change the boldness between these two or give it a little bit of contrast between the setup and the punchline. And I think that that hits all of the points from our original challenge here. Go ahead and delete this. Now we come to the extra credit, and if you were able to complete this extra credit, then you're pretty far ahead, because we haven't yet taught things like conditional rendering. But I did think that I would just give you a little sneak peek on it. So here's an example of one of my favorite jokes that's just a one-liner here. Over in app.js, I'm going to create another instance of a joke, and I'll put it at the top so we can see it more readily. Now, in this case, there really isn't a setup for this one, it's just a punchline. So what's going to happen if I just include a punchline? Well, we can see that I really don't have anything being rendered up above here. However, if we did go into the dev tools, we would see that up above this paragraph, there's actually an empty H3 sitting up here. Honestly, it's not that big of a deal the way we currently have things set up. But what if I went to my joke and instead of just putting the setup and the punchline, I said something like setup, and punchline, Now when I hit refresh, we can see that, well, it's a little bit broken here. Again, this isn't something that we've taught, so I didn't necessarily expect you to fully grasp this concept quite yet. But as an advanced sneak peek into conditional rendering, something that I can do is actually only render this H3 if props.setup exists. One really concise way that we're going to learn about is to surround my JSX in curly braces, which means that I'm putting it inside of a JavaScript interpretation. And then I can say props.setup and this H3. We're going to learn about how a lot of the neat little tricks that we can do with React are just using vanilla JavaScript principles, and this is a good example of that. This is saying that if props.setup is a truthy value, then render the thing on the right side of my AND operator here. If it's a falsy value, however, it won't render anything at all. So I can hit save and it will look very similar to the way that it looked before. Again, we're going to talk more in depth about that. It doesn't need to make perfect sense quite yet. And one of the cool things about this is we could decide to do it in another way. For example, what if instead of conditionally rendering it this way, I decided to say, well, the style of this H3 is that it has a display of none when props.setup does not exist. Well, I could do that with something like a ternary. I could say the display, if props.setup does exist, then I want it to be block, but otherwise I want it to be none. Obviously, this is a much more convoluted way than what we just saw, but it essentially accomplishes the same thing. The point is we can use those props and vanilla JavaScript principles like a ternary operator or this more concise AND operator to accomplish our goals. I'm hoping this was a helpful practice. I'm really looking forward to seeing people's best jokes. And when you're ready, there's still one more little thing we're going to learn about props before we can finally take all of this and apply it to our section project. Okay, I'm sorry that we're still here on the jokes, but I realize there's one more thing we need to cover before we jump back into our section project. And that is, how can we pass a prop that is not just a string? The concept of props, like we talked about, is very similar to the concept of attributes in HTML, and with HTML, we always pass in a string as our data type here. However, we are not limited by that in React. So far, we've only done strings. However, because this is JavaScript, it's React, which is JavaScript, we can pass in any JavaScript data type to our components as props. So I want you to think critically here. How might you pass in a prop that wasn't a string data type? Let's say, for example, you want a number passed to each one of these jokes that eventually will represent the number of upvotes and downvotes for this joke. Or maybe you want to pass in an array of comment objects. And then you might say, I want to allow people to filter out the puns or only show the puns in my jokes. In which case I might pass a prop called isPun, which is the value true or false, not the string true or false, but the actual Boolean value true or false. Accomplishing this uses something that you've already learned at this point. And so I want you to try and think critically. See if you can figure out how you would pass in a non-string value as the prop to your component. And be curious with it, play with it. Actually give it a try, don't just think about it. Pause here and see if you can figure that out. We learned previously that we can jump back and forth between JavaScript and JSX by using curly braces. And the same thing works with our props. For example, these 3 jokes here are all puns. So if I wanted to indicate that, I could say isPun equals, and then jump into JavaScript and send in a Boolean value like true. And then I can do the same thing for these others. And then of course, for the ones that are not puns, I can change this to the JavaScript value, Boolean value of false. And then do the same thing for my jokes up here up top. Actually, I'm struggling now to think if this joke is a pun or not. This might be a pun because it's talking about puns. Anyway, you get the point. By introducing these curly brackets, I can put any JavaScript value in here. So again, if I wanted to pass in a number, I could say upvotes is 10, downvotes is 2. And if I had an array of comments, I could say comments equals, and then this can get as complicated as I want. I can say an array of objects, and maybe those objects have an author property, and it's got some author ID, and then the body of the comment itself, and then maybe there's even a title to the comment and whatnot. Of course, it's an array, so it could be multiples of those and so forth. I can even put JavaScript expressions in here to determine what the value being passed into the props should be. That's getting a little bit more advanced than I want to jump into now, but the point is these curly braces essentially give us free rein to throw any JavaScript we want inside of the curly braces, and whatever that JavaScript expression resolves to is the value that the prop will pass down to our component. So let me fix my syntax error here and go over to my joke component, and let's just console log props.isPun, and you'll see we get a bunch of Boolean values. I could even do props.comments.title, and actually that's going to cause an error because I didn't pass a comments prop to all of them, but let's do props.comments, and we'll see we get a bunch of undefineds, but one of them has an array of objects. So I think you get the point. That's going to help us as we go back to our Airbnb experiences clone. So that's what we're finally going to jump back into now. Okay, we're finally back to our Airbnb experiences clone. Your challenge is to pass these props that I've outlined here into our card component, and then inside of our card component, receive those props and make use of them. As a little bit of a hint and a heads up, there's a couple instances that we're not passing in strings, or strings that we are passing in that we need to slightly modify in order for them to work. I guess so that's not too cryptic, the image that we're passing in here, you'll notice, is only the title of the image file. It doesn't include any path to the image itself. The astute of you might know that what we're doing here still is requiring us to hardcode data into our component, and in the real world, that's not what we're going to do. However, we haven't quite gotten there yet. In an upcoming lesson very soon, we're going to see a way that this would actually be structured a little more realistically. But I want to get your hands on the keyboard practicing, like I always say. So work on this challenge until you can show our card component looking essentially exactly the way it is now, but without the hard-coded data inside of the card itself. Pause here and start on that. Okay, I already know that I'm going to have too many props to put on one line, so I'm just going to start them on the next line. And we'll set the image equal to this string. I'm going to copy and paste these just so I don't make a fool of myself making a typing error. The rating is going to be 5.0. Now, this is a string right now. I suppose if we were ever planning on doing math on this rating, then it might be sensible to change it into a floating point number here by surrounding it with curly braces like that. I'm not going to be too concerned about it at this point. The review count, maybe just for good measure, and because I didn't put quotes around the 6 up here, I'll send in a number. The country will say USA, mostly because Katie Zafiris is from the USA. For the title, we'll once again copy this. And the price I'm going to send in as a number. We'll say 136. In this case, I don't think it makes a huge difference because I'm not going to be doing any math on this number probably, but what the heck, just for good practice. Okay, I can clean up this challenge, but I do need to now go to my card component, and the very first thing I should do is actually receive props here. And maybe just so I'm not flipping back and forth between the files to see which props I sent in, I'm going to console log the props so that I can see them down in my console. And that will give me a chance to actually look at the properties that I sent in. Now, right away, we run into a little bit of a challenge. Like I mentioned, we're only passing in the file name and extension. We're not passing in the whole path. But I can't just do string concatenation like saying ... images / and then plus my props.image, because this plus is not going to make sense. Now, I could do that by surrounding this entire thing here in curly braces, but I'm going to make use of the ES6 templating string syntax with these backticks, and that way I can put my $ curly braces. Now, this is probably starting to get confusing. Inside of a template string, I can insert values by using $ curly braces, and that's where my props.image will go. However, I can't just put backticks surrounding everything here because that doesn't make sense in JSX. Now, this is the tricky part. If I surround the backticks because they are a JavaScript expression in curly braces, then suddenly this expression makes sense. I think this is probably the trickiest part of this challenge. I'm hoping it didn't frustrate anyone too much, but I totally understand if it did, because it's a confusing back and forth. Remember, up here we're in JavaScript, then we jump into JSX, then with the curly braces we jump back into JavaScript, and that's why I can use my backticks. Inside of JavaScript and inside template strings, I can use the $ curly braces to insert JavaScript values into this string. I think it's called interpolation. I end my backtick, and then I get out of JavaScript, and I jump back into JSX. Hopefully you could follow all that. I understand if that's confusing. The rest of this should be really pretty straightforward. My rating is right here. Instead of putting a hard-coded 5.0, I can put my curly braces, props.rating. Instead of my 6, and I'm actually going to just put in my curly braces inside of my parentheses here, I'm going to put props.reviewCount. Again, the parenthesis is still part of JSX and therefore will be interpreted as text. The curly brace gets me into JavaScript, which is why I can then put my JavaScript value, and then I get out of JavaScript and I have my second parentheses to surround it. My country, I can put props.country. In this paragraph, we'll put props.title. And right here for the number, I'm going to leave the $ because I still want that to exist. However, the price that I'm passing in is just the number 136. So I will put props.price. Okay, moment of truth. Let me get us a little extra working room here. I'll hit refresh, and awesome. Everything looks like it is still working the same. Now, it does kind of look like we don't have this space showing up after our dot, but we won't be too concerned about that right now. Okay, last thing, I'm going to clean up my console log up here. And excellent. We now have a reusable component as long as every time I create an instance of my card, I pass in these props. I should be able to get different cards showing up in my list. Really great work. If you were able to follow along with this entire lesson, I really hope that this has been helpful. And hopefully you are just as excited as I am to learn this, because this is giving us more tools in our tool belt, more power for us to create really awesome web applications in React. We obviously have a lot more to learn, but really at this point you should be really excited for everything that you've learned, especially if you're understanding it. If you are feeling lost, of course, as always, go back, revisit these, and ask lots of questions in Discord. Coming up, we're going to be addressing that issue where currently we are still hard-coding this data into our code here. And so that's the next topic we're going to tackle. This is a total spoiler alert into what we're about to learn with React, and that is how to use the .map method to take regular JavaScript data and turn it into JSX elements that React can render. So I figured at this point it would be a great opportunity to revisit the map method just in case it's been a while since you've used it, or especially if you never really understood it in the first place. If you fall into that latter group, then I highly recommend you go check out the MDN docs on map, look through the examples, play with the code, and work with it until you at least grasp a basic understanding of the syntax for it. Because you should already know .map by now, I'm going to assume that that's the case, and we're going to work through these challenges. Instead of having you do all of the challenges right away at once, I'm going to let you do challenge number 1, and then we'll go over it together, and then I'll have you do challenge 2, we'll go over it together, and then challenge 3, we'll go over it together. So, of course, we'll start at the beginning with challenge 1, pause the screencast, and work on this challenge. So as a refresher, map is a method on every array. Because I've declared nums to be an array, nums has a method called .map. .map is a higher order method, which means that it takes a function as its main parameter. This is a great example of a method that is declarative, because under the hood, .map is going to handle the regular for loop for us, and all we need to do is provide a function that the map method can use to run on every single item inside of the array. Whatever we return from this function, as part of our return here, is what will get placed in the same index in a brand new array. And in the end, nums.map is going to return a new array, so I need to save that array in a variable. We'll say const squared equals the array that gets returned from nums.map. An important part of this is that the function I provide to .map is going to receive each of the items in the array one at a time as .map loops over the array for us and runs this function. So if I were to, for example, console log item, I would see that I get each of the original items in the array, and they each show up on their own line because this console log is running 5 separate times. So all we have to do is simply return item squared. I could use the math library, or I could just say item times item. And now if I console log squared, I should get this array, which was my original goal. And sure enough, there it is. Okay, that was just to get our feet wet. This next one has a little bit extra challenge, includes potentially some string methods, but again, it's just a regular JavaScript challenge. Pause the screencast and work on challenge number 2. Okay, just like before, we'll create a variable to hold our destination array, or our returned array. Let's call it uppercase, and we'll get that by using names.map. Now above I used a function declaration like this, but this time I'm going to use an arrow function just to simplify my code a little bit. It's essentially the same. I can open it up and use return. I'll fix this later for anybody that's yelling at me that I can simplify this even more. And inside my function, I'm going to be receiving an item. Now, I could call it item, or I think a little more intuitively, I'll call it a name. In fact, usually I would call this item probably num or number. Let's call it num just to kind of clean that up, make it obvious what we're working with. Now, with the name, what I want to return is the first letter capitalized in that string. Now, I'll be totally honest, string methods are not something I usually just have memorized. I usually end up looking them up. I'm going to wing this and see how it works. Essentially what I'm trying to return is the first index, so I'll say name at the index of 0 dot to uppercase. And that should be a string of the first letter that's now capitalized, and then I'm going to add name dot, I think slice will do it, and I'll start at the index of 1, which I think will give me the rest of the name starting at index 1 inclusive. Again, this is kind of a shot in the dark, so we'll see how this goes. Console log, uppercase. And oh, I was so close. I think I just need to add my parentheses here. Awesome. I probably could have done something like name.slice 0, 1 maybe, and then change that to uppercase. I also could have done something a little more complex, like surrounding these in template strings and then using interpolation to figure that out. And that might help me get rid of my plus. Now I'm just kind of playing around. Nope, there's my space. I don't need a space. Okay, that to me is a lot less readable than what I had before, so I'm going to keep it this way. I guess that's one of the fun things about these challenges. You can try to solve it in multiple different ways. Okay, let's clean this up. I'm going to comment this out, and I'll send you now to challenge number 3. Just to clarify, because we're just working in regular JavaScript here, I'm not expecting this to work in React or JSX or anything. Essentially, all we're doing is taking this string and then adding what looks like paragraph tags, the opening and closing tags, on the beginning and the end of that string. Of course, this is leading to a point that will then take us to React. Pause the lesson here and start working on challenge number 3. Okay, let's say maybe const elements, even though these aren't real elements. And that's going to be Pokemon.map. I'll use my arrow function again, and this time because I'm only going to be using a single parameter, let's see, I think Pokemon is both singular and plural, right? Maybe I'll say mon for monster. Because I only have a single parameter, I can get rid of those parentheses and just put my arrow here. And well, before I simplify the rest, let me actually open this up and we'll do it the way we did it before, and then we'll clean it up. Now, this time around, I think it probably will be easier to use a template string, so I'm going to put my paragraph text here, and then inside of my paragraph text, I will put my monster's name. Let's console log elements, make sure that this is going to look the way we expect, and awesome, that looks great. Now, regarding cleaning things up, because an arrow function has the ability to have an implicit return, if I start that return on the same line as the arrow, I can clean this up that way. I can also do the same up here, get rid of my explicit return, make it implicit, and because I only have one parameter, I can get rid of those parentheses. If you're still feeling hazy with arrow functions, don't worry, I'm kind of with you there. But once you do get used to them, they can really provide a nice, simple syntax for you to perform operations that otherwise might take a number of lines of code. That's another one of the benefits, like I mentioned, of having declarative methods like .map. It's handling the for loop for us. We simply have to follow the rules, and we get back exactly what we expect. Now, again, what we're ending with here looks like an array of HTML elements. In fact, if we were to be doing regular DOM manipulation, we probably could use these using the inner HTML method to have the browser actually turn these element strings or DOM strings into real HTML elements on the screen. But since we're not doing that and we're doing React, we're going to see how we can basically use this exact same principle to take data from an array and turn it into JSX elements that get displayed on our screen. There's one more really small step that I want to cover before we get there, so let's cover that next. I think now is probably a good time to remember that JSX just returns a regular JavaScript object. We can see that if I were to set, let's say, a new variable called element equal to some JSX, and we'll say just an h1. And then if I console log element, what we actually get back is just a plain old JavaScript object. The properties and the shape of this object get determined by React in order to describe the element that React eventually will be turning into a real DOM node that shows up on our screen. But the reason that I mention this is because when you get deeper and deeper into web development, and actually programming in general, you'll discover that most arrays don't end up being an array of simple strings like we sometimes use for examples like this. Instead, it's probably most common to find arrays end up being an array of objects. Let's keep this example simple. We'll say it's a first name and a last name in this object. That's because data is usually a lot more complicated than just what can be represented by a simple string, and so we use objects to represent pieces of data in a lot more detail. Well, there's a little special feature of React, and that is that if we provide an array into what we're rendering from our component, React will know how to essentially map over that array and turn it into elements. Let me clean some of this up and show you a little bit more what I mean. Let's say we create this array of colors, and I'm just going to put in the colors of the rainbow. Of course, I just got done mentioning that usually we don't have an array of strings, but this is just to illustrate a point. Inside of my return, when I'm returning the elements that I actually want to put on the page, I can give React this array and let it render it to the page. Now, I can't just say colors, because then it's going to put the actual word colors on there, so I'll surround it in curly braces, and now essentially what it's going to do is copy this. Basically, I could have just done this in its place. So we'll take this one step at a time. Let's look at it this way. Now, obviously this is not beautiful, and we can tell already that it's essentially just putting these together as blank text. I haven't taught React that I want these to be paragraphs or headers or ordered lists or anything like that. Now, of course, if I do want to use my variable colors up here, I can essentially just put colors here, and I still, of course, need my curly braces here. When I hit save, I get the same result. But now I want you to do a little challenge to experiment with what will happen if you change these from strings into JSX elements. Okay, simple enough. I just want you to essentially change these strings into JSX elements, and I said H3. You can do whatever element you want. Then I want to make sure that you hit save or refresh and see exactly how what we have currently changes when you do that. Pause the screencast and work on this challenge. Okay, maybe this is getting into the realm of busy work, but let me do this really quick. Okay, let's see what happens when I hit save. Awesome. Now I actually got a list of JSX elements that are being displayed as H3s. In some ways, it's kind of like React took the elements here and just copied and pasted them onto the screen. Of course, I would need to get rid of all these commas for that to work correctly, but I get the same result this way. But let's put it back to colors so that it works the way it's supposed to work. Okay, now we are poised to take what we just talked about and reviewed with .map and what we just learned about where React can render an array of JSX elements and put those concepts together, which will allow us to, instead of hard coding our data directly into our components like we're doing here, instead we can get data from outside of our little system, map over it, and render a new component for every piece of data. In other words, in the next screencast, we're going to see a jokes.js file, which has essentially the same thing, but in a JavaScript array of objects. Then we'll get to pull those in and map over them, create an array of JSX elements, and then render those to the screen. So when you're feeling ready, let's go forward. Let me walk you through a couple of changes I've made to the code that we were just looking at. Of course, you probably noticed I moved all of our hard-coded joke components outside of our component here and just commented them out so we can still reference them. I've also changed our jokes.markdown file into a jokesdata.javascript file. Now, we're not quite ready to make API calls and then make use of the data that comes back, so I'm going to be kind of mimicking that with this jokes.js file that's exporting an array of these joke objects. Over in our app.js, I'm going to import the jokes, I'll say jokes data, from that file, /jokes_data. And we can see that if I console log jokes data, I should get the array of jokes. Okay, great. Now combining what we just learned with .map and with creating an array of JSX elements, I can put those two concepts together. What I'm going to do is create a variable, let's call it joke elements. And this is going to be not an array that I'm defining right now, but instead the array that gets returned when I call jokesdata.map. Inside of my .map, I'm going to take a look at each one of my joke objects, and what I can return, I'll do this on its own line just so we can see a little more clearly what's happening. I'm going to return a joke component. However, I can pass the data from this individual joke object to my joke component. So maybe this is a good opportunity for you to put on your thinking cap and do a quick little challenge. Your challenge is to see if you can pass the props to our joke component in the correct way, and then of course render our joke elements array so that when you're all done, all of our jokes show up on the page again. Pause the screencast and see if you can complete this challenge. Each of the joke objects that I am looking at inside of my .map is each of these objects that we see here. So they have a setup property and a punchline property, which means over here I can say my joke has a setup prop, and this has to be spelled exactly this way because our joke component is expecting props.setup. this setup prop will be equal to, and then I need to use my curly braces because I'm leaving JSX and going into JavaScript. We'll say joke.setup. Now it just so happens that I'm using the same name for the prop that I'm passing to my joke component, props.setup, and the object property that I chose in my actual data setup here. However, it's not always going to be the case that these are the same. If, for example, these were question instead, then over in app.js, I would still say setup because I'm the one that gets to choose what the prop name for my component is, but then my actual data would need to change to joke.question. Now, a question doesn't always make sense in this case because they're not all questions, but hopefully that illustrated a point. And next, I will need my punchline. And this is going to be joke.punchline. Again, because the actual data has a punchline property in each of these joke objects. Now, I'm not quite done. I can hit save. Nothing's going to show up on the screen, and that's because I'm still returning an empty div in my app component. The last thing I need is just to render my joke elements, hit save, and there we go. We've got all of our jokes back on the page. Now, if I clean some of this up, you can see just how much simpler this makes our lives as React developers. And then if I were being really stingy, I could use the implicit return to just return my joke element. I'm not going to worry too much about that, especially because it makes it a little too wide horizontally there. Awesome. Okay, we have taken a number of asides. Once again, I'm going to bring us back to our Airbnb experiences clone, and we're going to take this concept and actually build the separate experiences in their own cards. This time, using data that we get from a file instead of hard coding things into our code. Make sure you have studied this and understand it before you move on, and when you're ready, let's jump back into our section project. All right, it's time for another quiz. We're going to look at the .map array method, read through these questions, click into the editor, type down your answers, and when you're ready, click play and we'll go through the quiz together. Number 1, what does the map array method do? And I'm referring here to JavaScript in general, not specifically React. Well, the array map method takes a function as its parameter, and whatever gets returned from that function will be placed in the same index of a brand new array. So maybe let's say it returns a new array, and whatever gets returned from the callback function provided is placed at the same index in the new array. And well, yeah, that's good enough. Theoretically speaking, our callback function, we could just hard code something like return the string hello, and then we would have an array filled with hellos. But usually what we're trying to do is take items from the original array and modify them in some way. In fact, maybe I'll type that down. With that in mind, number 2 asks, what do we usually use .map for in React? Well, in web applications, it's really common for us to have an array of raw data, usually an array of objects, and to want to turn that array of data into something that's visible on the screen. So in React, we'll take an array of data, we'll map over it, and turn each of those items into some kind of JSX element that gets put on the page. So more concisely, it allows us to convert an array of raw data into an array of JSX elements that can be displayed on the page. And number 3, why is using .map better than just creating the components manually by typing them out and putting the props in that we want? Using .map in this way is a lot more dry. Obviously, if you think in terms of something like Amazon, every time a new product is uploaded to Amazon and Amazon sells that product, there isn't a developer out there who's going to go copy and paste the elements from a product and then put in different props, let's say. No, instead, the data will change, and using something like .map will automatically convert that raw data into something that gets displayed on the page. One way you could put it, like I wrote here, is that it makes our code more self-sustaining in a way, meaning that it doesn't require additional changes whenever the data also changes. It makes me think of when we're typing out a C-style for loop and we say something like for, let I equal 0, and then we use I is less than some array dot length. This makes it so that if the length of the array ever were to change, our for loop would not require intervention. Instead, it would automatically check the length of the array, and that's what it uses in this parameter in the for loop. Alternatively, if I just said something like I is less than 5, but I'm looking through the elements of an array that maybe now has, let's say, 10 elements in it, my for loop is broken and it requires intervention from a programmer. I think you probably understand, so I'm just going to erase this for loop and leave it where it is. Awesome work on this quiz. Hopefully you were able to answer all of these questions. When you're ready, let's move on and start applying what we just learned to our section project. I am coming to you from the future again because in the next challenge, for anybody who is following along using Create React App on their local machine instead of following along here in Scrimba, the upcoming challenge might throw you for a bit of a loop, technically speaking. What we're about to do is go back to the Airbnb project and use a data file that includes links to the local images so that you can map over it and display those images as well as the other pieces of data. And you'll see that just kind of works out of the box here in Scrimba. But if you're following along with Create React App, you'll get something that looks more or less like this. Obviously, this is not ideal. The last time that I spoke to using Create React App, I mentioned how it's gently advised against putting any assets inside of the public directory. However, this is an instance where I'm just going to recommend that you put your images inside of your public directory. I'm going to go to the next slide. This has an animated GIF that might take a minute for some people to load. But you can see that what it's doing is it's taking the images directory from the source folder and moving it up into the public folder. The reason I'm recommending doing this is, well, first of all, normally you're not going to have a data file that includes all of the data you need. Instead, you would actually be getting that data from some online resource. And second of all, because it just magically works. When you move the images to the public folder, things just kind of start working again. So that was just a quick heads up for anybody using Create React App. If you're following along here in Scrimba, you really don't have to worry about any of that for now. Okay, with that said, let's jump in. Okay, it all comes down to this. We are going to put all the things that we just learned together to progress our section project here with the Airbnb Experiences clone. I've written out your task here, and let me walk you through just a couple things. First of all, there's now a data.js file, and this contains an array of the objects that represent the data that we're going to be displaying on the screen. Part of your task is to import that data as it mentions, map over it to create our card components, kind of like we have hard-coded here, and then render that array in place of this card component. One little change that I did make is I changed the country prop to location, and I also made that change in the data here. So in case you were curious about why that's changed, I just decided it made more sense since we might have some online experiences. And another thing is you'll notice there are some properties here that we won't yet be using, like open spots or description. That's okay. For now, just ignore those. We'll decide later if we want to make use of them. Also, as I mentioned in the note here, because we haven't done styling to our group of components or anything like that yet, they're going to stack on top of each other because they're block element divs. For now, that's okay. Don't worry about them being stacked vertically. We'll fix that later. Okay, now is the time. I know that you can do it. You've worked hard up until this point. Hopefully you have studied and rewatched everything you needed to in order to understand what we're doing. So let's jump right in, pause the screencast, and work on the challenge. All right, let's do this. First, I need to import my data, and I probably will just stick with the word data as my variable name here. So we'll say import data from /data. And maybe just before I get too far down the road, I'll console log this just to make sure that I'm getting the data I think I'm getting. Okay, yeah, that looks right. Again, as a quick reminder, usually you won't be importing a hard-coded data file. We'll be covering API calls and how to get data from an online source later. But until we learn a couple more things, we're not going to be able to do anything really except for importing our data. Then down in our component, I don't want to erase this comment because that's my whole hero section that we commented out for space sake before. Let's take our data and, I don't know, maybe call them cards. We'll say cards is equal to data.map, and we'll let map look over each of those experiences. Maybe I'll just call it item for now. And then for each item in that array, I want to return, well, let me just copy this here because it's got all the properties that I want. And then instead of having these hard-coded values, I will just replace them with the values from our object. So let me just make sure that I get all these properties right. We have, this is called cover image, not image. So I guess some of these might change. So that's cover image. Again, this is another instance where the data had a different property than what we chose to call our prop that we're passing into our component. That's entirely okay, and actually ends up being pretty common, especially if you're not thrilled with the way that the data was designed. Oftentimes you're consuming data that someone else has put in their database and you don't get to choose these property names. Okay, our rating. Let's look at our data. Now we have this stats property, and that's where our rating is. So we're going to have item.stats.rating, and similarly with review count, item.stats.review count. So here, item.stats.rating and item.stats.review count. Okay, in the data we have location, that's going to stay the same, so location will just be location, item.location. Title, I believe, was item.title, and this, I believe, was item.price. Let's just double check those. I like to double check them because otherwise I might see missing data and then get really confused about why it's not working. Title, price, title, and price. Okay, now that we have created our array of card components, we need to render it. So let's get rid of our hard-coded card. I'll put curly braces because I need to enter into JavaScript here. My array of JSX elements is still considered JavaScript, so I'm going to put that in curly brackets, say cards, hit save, and look at that. We're getting all of our experiences showing up. Of course, again, they're vertically stacked. Each one has its own unique data being displayed, and awesome. At this point, we have covered a bulk of the material from this section that I wanted to cover. And don't get me wrong, we've covered a lot of things so far. There's a lot here to practice with, and as always, if you're not feeling comfortable yet with some of this material, it's important to stick with it, practice it over and over until you understand it. That being said, we do have a couple more things that I want to cover before we finish off this section. First of all, we need to style this, so we'll do that in the next screencast. And then I want to give you a sneak peek into some of the topics we'll be talking about in the next section. So when you're ready, let's polish off our project here with some CSS. Okay, I've got to be honest with you. I was going to have you style the list of cards here so that they would horizontal scroll inside of a container. But we've already spent a pretty fair amount of time doing CSS inside of React. And so for all the hard work and effort that you have put in so far, I've got a little present for you. Bam! We've got the styling done. Of course, if you're interested to see how I did this, basically I made a flex container, made it so that none of the items would grow or shrink as the container got bigger or smaller, and then just set the overflow to scroll, essentially. You can check the CSS for the details on it. I've also included little tags that will tell you exactly what I added so that you could easily see what actually changed. Also notice that I used a section element here to surround our cards. That allowed me both to give this a class name and give it specific styling, but it also allowed me to make use of our styles that we put way back in the beginning on sections so that it had some padding on the left and right. Now there are two things that I want to talk about here. One is how awesome it is that we are now mapping over our data, because it means that if the data ever changes, our page will automatically update. So if I were to, for example, paste in 3 more items here, I just copied the one and pasted it again, and then updated, our page is going to automatically update with all of the new activities that are included in our data. Clearly, this is a much better way to work as a developer where the data will change and your page doesn't need to. Your code actually stays exactly the same, and all that really updates is how that data is being used to display your elements on the screen. The second thing that I want to cover is this error that we have been seeing, or rather a warning that we've been seeing that says each child in a list should have a unique key prop. It's a little bit beyond the scope of this course to dive deep into why this key prop is necessary, but you will see this warning anytime you are using .map on data to create JSX elements, or rather an array of JSX elements. First, let me go to data.js and get rid of those 3 extra items we had. Now over on our card, the way we can get rid of this warning is by simply adding a prop called key, and it very specifically needs to be key, K-E-Y. And I need to set key equal to something unique about this individual item. In this case, pretty much everything about these different experiences is unique. The image is different, the title, the price. However, for example, the rating is not different between this first one and the second one, so that's not something I could use as my key because it's not unique. Fortunately, when we're pulling data from a database, almost always we'll receive some kind of ID property that we can guarantee will be unique because the database is creating that as a unique property in the database. Now, obviously I typed all of this in manually, but I gave it an ID so that we could mimic this concept. Over in app.js, I'm going to assign the key to be item.id. Again, I probably could have used the title or the price for this warning to go away, but when I hit save, we'll see that warning disappears. So those were just a couple of miscellaneous items that I wanted to cover. I'm not going to put our hero back in quite yet because there is one more thing that I want us to talk about, and that touches again on a sneak peek of conditional rendering. And we'll talk about that in the next cast. A phrase you might hear from the React community is that people love React because it's just JavaScript. Now, of course, under the hood there's things like JSX, which is a little bit of magic being performed by React. But I wanted to show you what that means by giving you another sneak peek at conditional rendering. Now, I've updated the little screenshot that I have here to show you this little badge down here that says sold out. And you might have noticed that in the data we actually have a property called open spots. Now, I intentionally set this first one to open spots of 0 so that we could conditionally render this little badge if the open spots is ever 0. You might remember from the first time I did a little sneak peek on conditional rendering, the term is referring to when we only will sometimes render a part of our page. Right now, everything on here will render every time this component gets called. However, what we can do is take a look at props, and if props.openspots, let's say, is equal to 0, then we can display the little sold out badge. Otherwise, we just won't display it at all. Now, there's two parts that we need to make this work. First of all, over in app.js, we aren't currently passing in the data from OpenSpots into our card component. So the first thing we need to do is create a new prop called OpenSpots, set that equal to item.OpenSpots. Another thing you may have noticed is that we sure are passing a lot of props into this component. We're going to cover a truncated way to essentially do this same thing without having to add a new prop to our card component every time we want some data from our item. But for now, we'll stick with what we know. So we now have a prop called OpenSpots. We're passing in that number value from our data right here. Now in our card.js, let's just make sure that this is working. I'll go ahead and console log props.OpenSpots and check our console, and sure enough, we get 0, 27, and 3, because that's how many open spots there are for each of our experiences. So let me get back to what I meant by it's just JavaScript. First, let's go ahead and actually create a little badge that will float in the upper left of this image. The way I'm going to do that is by setting my card to be position relative and have a div here that's position absolute. Of course, for now, this div will always show up. We'll fix it so that it conditionally renders as soon as we have something that looks good. Let's go ahead and just hard code in sold out, and I will give it a class name. Let's call it card, probably badge. And honestly, just to save time, I'm going to paste some styles in here so that you don't get too bored. Then on my card, I need to make it position relative, and I need to refresh this. Okay, now obviously it's hard-coded, so every one of these has a sold-out badge. And you might remember that the way we handled conditional rendering before was we surrounded our div that we only sometimes want to display in curly braces, and then essentially included a condition beforehand. Now we used a very short version of that condition, which we'll use again. I can say props.OpenSpots equals 0 and the div that I want to render. This is kind of a clever example of how in React we typically use just plain JavaScript to handle things like the display logic that our component needs to know about. If this first statement is truthy, then this second statement, or this JSX element, will run and therefore get displayed. However, if this first statement is falsy, then the second one will actually never even get called or run, and therefore this div will never display on the screen. So if I hit save, we'll see that now I only have a sold out badge on the element that had exactly 0 spots in it. Technically, because 0 is a falsy value, I could say that if not props.openspots, but that's a little less easy for me to read, and if another developer were to come see this, they might expect openspots to be a boolean, and so I'm going to keep it as =0 to be very explicit. Now, if you actually go look at the Airbnb Experiences website, you'll notice that even in our design here, we talk about online experiences, and some of our locations are online. The actual website itself has a little badge that says online in order to help people understand that it's going to be, well, probably through a Zoom meeting instead of an in-person live meeting. So I thought I'd show you yet another example of how we can use just plain JavaScript to help determine the display logic of our components here. Right now, I have this badge that says sold out. Now, I could come up with something kind of complicated by putting my display logic in here that says if openspots is 0, then display this div. Otherwise, if the location is online, then display another div. Otherwise, display nothing. But as I was preparing this, I came up with another way that I figured was a little more concise, and so I thought I'd show that here. If you've ever done a code challenge on, well, any number of the websites that exist out there that allow you to practice code challenges, this might feel kind of familiar. My goal is to dynamically render not just this entire div, but also the text inside of it. So I'm going to set a variable using let, and I'll say this is badge text. Then I can just use regular JavaScript and say if props.openspots is equal to 0, then I want badge text to read sold out. Or let's put it all in caps to stay consistent. However, if it's not sold out, I also want it to check if props.location is equal to online. And if it is, then we'll have badge text say online. Now there's two things that I need to change with this line of code in order to make it so that primarily if it's sold out, it has a badge that says sold out. Secondarily, if the location is online, it displays a badge that says online, but otherwise it displays no badge at all. In fact, let's make this a challenge for you. Okay, your challenge is to display the correct badge text instead of this hard-coded sold out. And secondly, to only display the badge when it's either sold out or an online experience. I've given you some hints basically in the language that I used for this challenge number 2. Pause the screencast and work on these challenges. Okay, for the first challenge to display the correct text, all we have to do is erase sold out and instead render whatever the value of badge text is. Now, of course, currently this will only get rendered if openspots is exactly equal to 0. So we also need to change our condition upon which this gets rendered. Kind of a clever way that I thought of was, well, when we initiate badge text up here, its value is going to be undefined. And then if props.openspots is 0 or props.location is online, then badge text will have a real value. I can use the truthiness of a real value or the falsiness of undefined to just say if badge text exists, or rather if badge text has a real value, then I want you to display the badge. Now, maybe this is contrary to what I said before about assuming truthy and falsy values. This one seems a little more logical to me, however. So if I hit save, awesome. Now we have sold out on anything that's sold out. Notice even if it's an online experience, it will prefer sold out first because that's our first condition up here. And then if it does have open spots, but it's online, it has an online badge. And if it's neither, then there's just no badge at all. Now we will be covering conditional rendering in more detail later. However, the point that I'm trying to get across is that in React, we very often use plain JavaScript, like this kind of regular algorithmic JavaScript, to determine how things will get displayed on the page. That might not seem unique or strange to you until you've worked in another framework like Angular or I think Vue as well, where there are actually properties built into the markup that you see that provide logic for using for loops or conditional statements and so forth. I'm not necessarily vying for one over the other, but hopefully this sheds some light into why a lot of proponents of React will say they like it because it's just JavaScript. And along those lines, the next thing we're going to do is go clean up this card component that is getting pretty lengthy. We'll do that in the next lesson. When we have a component that's in charge of maybe displaying one or two pieces of data, it's not that big of a deal to pass each of those pieces of data down individually as separate props. However, we can see our card component is starting to get a bit lengthy, and honestly, we haven't even included things like maybe there's a description or a set of tags that can categorize these experiences. Whatever the case might be, along the theme of React being just JavaScript, what we can opt to do instead of passing each of these properties of our data down individually is we can just say, I'm just going to give this component the entire item object. Notice I kept key here. That's because it's something unique that we need to include anytime we're using map. But for all the other properties of data that I need my card to know about, I'm just going to pass the entire item object down. Of course, because I'm changing the structure of my card, over here when I hit save, well, everything is broken now. But if at this point you truly have an understanding of how props works and how the things that we pass down to our components can get received by the component, you should be able to complete the following challenge. Fix our component. I'm intentionally being a bit vague here because I want you to challenge yourself. If you have felt a little bit confused about props and what exactly this object is that we're receiving and so forth, this might be a good indicator that it's time to go back and just review the stuff, practice the stuff that we've already learned. But if you have felt pretty confident here, then I want you to pause the screencast and work on this challenge. Well, one major hint that we can get is if we console log our props. And it might be a little bit confusing to read through here, but you'll notice in the console below that there is an item property in our prop, so props.item, and that item is the object with all of the properties from my data. It might clean it up a little bit if I just log props.item. So with that, it means that all I really need to do is change anywhere I was referring to individual props as a part of the props object, like props.image. I just need to change it to props.item.image. However, we are going to run into one little problem. And what I'll do first is just change everywhere I see props dot to say props.item dot and then the property there. Let me hit save. We'll see where we run into a problem. So it looks like some of it is coming through. We have our title, our price, and our location, but it looks like our review count, our rating, and our image are not working. So if you haven't already figured out why this is broken, I want you to pause the screencast, poke around the code, see if you can figure out how to fix the rest of this component. Because we are passing in the entire item, we now are beholden to exactly the structure and the property names of our data itself. So for example, in our component, we were saying props.img, but in the data, it's the object.coverImg. So if I replace in my card component img with coverImg, now my images should come back. Similarly with review count and rating, these were both part of a sub-object called stats. So if I add stats as a part of my card now, props.item.stats.rating and review count, the rest of that should come back the way we wanted it. Now we can see that our badges are still missing, and that's because way up here when we're doing this logic, we also need to add props.item so that we're correctly looking at item.location and item.openspots. Let's see if that fixes it. Awesome. We're back to the way we were, but now our component as we use it is a lot simpler. Awesome work. We are so close to done. There is one more little tweak to exactly what we've done here that you might see pretty commonly in React, and so I wanted to make sure that I covered that before it became really confusing when you saw it in the wild. So that's what we will cover next. There is one more little trick to passing properties into a component that I wanted to teach you about, so that when you see it in the wild, it's not terribly confusing, because if you don't know about it, it looks rather confusing. This trick has to do with the object spread syntax. And if you are either not familiar with it or it's been a minute since you've done it, it's an ES6 feature, and I've linked here the MDN docs on using the spread syntax with object literals. But the idea is that instead of creating my own prop called item that I pass the entire object down through, what I can actually do is just put a set of curly braces and spread the item into my component's props. Essentially what this does is it takes the properties of the data, like ID, title, description, price, cover image, stats, location, and open spots, and creates a separate prop for each one of them, kind of like we had before we were passing in the item individually. So it would look like ID equals item.id, title equals item.title, description equals item.description, and so forth and so on until it has covered every property in our data here, or rather every property in the item that we are passing into our component. Now doing this does fundamentally change exactly what props the card is getting because, well, we just changed props so that it said props.item because it was receiving an item object prop. Doing it this way means we would basically go back to the way that we had it before. So if I were to go back to that, I do curly braces, ... item, which spreads all of the properties of this item as separate props into my card component. Back in my card component, I need to go back and get rid of all of my .items here. Okay, just like that. Oh, I missed a couple here. And actually, you know what? Let me leave those in and we'll see that this is breaking. And well, it looks like it's breaking a little deeper than it was before. So then when I make those changes in the correct way, hit refresh, everything's back to the way that it should be working. On a personal note, I do tend to struggle with this method of passing data down to a component, only because it obscures exactly what we're passing to our component. I personally would rather pass the item down as a very explicit, specific prop that says item is item, and although it does clutter my component a little bit where I have props.item.stats.reviewCount and whatnot, I tend to find that, at least for myself, when I go back, I don't need to first go to the data, understand what properties are there, then go to app and see that I'm spreading that in, then go to the card and look at what those properties are. I don't know, maybe it's just a personal preference. I have tended toward passing objects down like the way that I've shown you here. For your own sake of review, I'm going to put this back to the spread syntax just so you can see what it looks like as the spread syntax. Hit save so we see that it's still working. I'm sure as you write more and more React, you'll settle on which one you like the most, or maybe just stick to a standard in whatever code base you're working in. I'm going to take a second to clean some of this up so that we buy some more horizontal space. And last but not least, let's go back to our app.js component. Let's bring our hero back in, and let's see how things are looking. Awesome. And that, folks, marks everything that we had planned to learn in this section. So before we keep pushing forward in React, let's take just a minute in the next screencast to look back on everything that we've learned in this section and give you a chance to complete another self-assessment project. Before moving on to the next section, we have another solo project for you to work on. Like we talked about before, it's a great opportunity for you to flex these new skills that you've been working on so far in this section, but this time without the security blanket of me being there to help you. Now, the next section we're about to jump into is the heaviest section of this whole course. So it's especially important at this time that you work on this solo project to help gauge your own skills and then decide if you understand these topics well enough to move on. Again, it's projects like these where the real internalization of everything you've been learning actually happens. So, what's the project this time around? You're going to be building a personal travel journal. It's a page where you can list all the fun places that you've traveled along with some of the details and a photo from your trip. Clicking on the image of this design will take you to the Figma design file. Once you're there, make sure to click on the arrow at the top, choose Duplicate to your drafts so that your view of the design file won't be cluttered by anybody else's cursors or selections, and also so you can make any edits to this that you want to make. The quickest way to get started will be to code your project here in Scrimba. If you click away from the Google Slides, you'll see a little menu with 3 dots. When you click that, there will be an option to fork this screencast to a new scrim, which will start you off with the starter code that we have here. Once again, I haven't given you a whole lot. I did put this boilerplate code in here for you, but that's about all that I've done for you. So let's take a look at the project requirements. We haven't yet learned how to pull data from an API, but I do want this page to be data-driven. So you'll be creating an array of this data in a separate JavaScript file, and that array should contain objects which have properties for the title, location, the link for Google Maps, a start date to your trip, end date to your trip, the description, and an image URL. If you're using your own photos, you can actually just drag and drop them into the Explorer in the upper left of this Scrimba environment. And then you can just reference the file name of the image instead of an image URL, or if you want, you could just use an image URL of an image out there on the internet. Just so this was perfectly clear, I gave you a little start here. I just took the data from the design file here on Mount Fuji and created an array with a single object in it. This way you at least know the shape of this object so you can make a copy of it and put in your own data. Once you've pulled in that array, I want you to use the map method and props on some custom components to pass that data down to the custom components and have React display the array that has been mapped. And as is always true in these solo projects, you should make sure that it's styled and really polished. You want this to be something that you would be proud to show to someone else. And of course, speaking of which, make sure that you share your work. Again, you don't have to wait until you're completely done with the project. You can always share your current progress in Discord and ask for some code feedback. You can click the Discord icon here that will take you to the I Built This channel where you can share your work. Or if you're doing something like learning in public on Twitter, you can click this Twitter icon, which will open a pre-populated tweet where you can share a link to your project. Good luck building your travel journal, and I really look forward to seeing everybody's finished projects. We find ourselves here at the end of another section, and all I can think to say is nice work. In this section, you have taken a big stride forward in your understanding of React. Let's look at a quick recap of what we've learned. First, and probably most importantly, we have talked about props in React. Props are one of the most fundamental topics in React, and they really make it so you can write more composable code. You can see in both of our projects, we have elements on our page that are essentially reused, both in the Airbnb experiences cards here and the travel journal cards here. Now that you know the concept of props and reusing components with different data, I guarantee as you start paying attention to the websites and web apps that you use online, you're going to see this concept everywhere. Then what props really enables us to do is use data to drive the code and map over it in order to create the website that we're trying to create. Now, although there's only 2 topics here in this recap, those topics are extraordinarily important as we move forward. As always, you should be extremely proud of what you have worked on so far. So I highly recommend that you go over to the Discord server. If you click on the screenshot, it will take you to the Today I Did channel. And even if you don't feel like sharing your code or a screenshot, at least post a message in there that tells people that you have now completed section 2 of the Introduction to React course. Also, this is a very natural time to take a break from your computer. If you've been working on this for quite a while, make sure that you stand up and move around a bit, get something to eat or drink. Your brain does need some time to digest all of this new information that you've been learning, so even if you need to come back tomorrow, that's completely okay. And then whenever you're ready, I will see you in the next section. You have done an amazing job so far, and now we have arrived at probably the most exciting section in this whole course, and that is how we can create interactive web apps in React. Until now, we have basically just been recreating static websites in React. And of course, along the way, we've also learned how we can use props to create reusable components in React. But really, so far, that's only allowed us to create reusable parts of what is still considered a static website. If you think of the Airbnb experiences clone that we just finished building, we left it off in a state that really still didn't allow for any kind of interactivity with the user. On the real Airbnb website, a user can click into those experiences, they can save them to their favorites, and then of course they can actually book that experience and pay for it. So that lets us know that there is so much more that we get to do with React. And that's where you've arrived in this section. To help us better understand what I'm talking about, let's take a look at the difference between static websites and dynamic web apps. The static web pages that we've been doing so far, they're really read-only. They don't allow for any kind of changes to the data. And that's probably the defining attribute of a static web page. Especially in the early days of the web, but still pretty common today, you'll find static web pages like a blog, a news site, recipe sites, and a bunch of others that really don't allow you to change any data, but rather just to read or consume the content that exists on the page. In this section, we are going to be learning how we can use React to also create dynamic web applications. And the defining attributes of these web applications is that they are both read and write. In other words, the user has the ability to change the data that drives the app. As such, they tend to be highly interactive. And instead of displaying the same content for every user, they will display your specific data. And these kinds of web apps drive entire businesses. If you think of, for example, your bank website or the real version of Airbnb. And this list goes on if you think of social media websites or online games or anything that is highly interactive and displays data that's specific to you as the user. You could say they all exist on a tier sort of above a static website because of the amount of interactivity they have. Of course, we're not quite ready to recreate an entire site like Airbnb, so we'll be using this meme generator project to drive forward the curriculum in this section. In this project, when the app first loads, it's going to reach out to an API and get 100 of the most popular meme images at that time, and give the user the ability to enter the text that shows up on top, the text that shows up on bottom, and also to click a button to randomly choose a new meme image. Just like before, you can click the screenshot here to go to the Figma design file. And again, I recommend you copy it to your drafts. So if you click the arrow at the top, duplicate to your drafts, and choose this option, it will put an editable copy in your own Figma drafts that you can use as reference. In order to build this project, we're going to be learning about event listeners and how we can add that dynamic interactive aspect to our web application. We're going to spend a lot of time learning about something called state. We'll officially cover conditional rendering, which you've already had a few sneak peeks at so far. We'll talk about forms and how we can gather data from the user, and we'll learn about side effects and how we can manage side effects in React. Once again, we'll be starting off by building some of the static components of our page here. So if you already feel like you're 100% good on CSS in React, you can skip the first couple lessons where we're mostly just doing some setup and styling for this app. However, I do encourage you once again, if you haven't been practicing your CSS inside of your React, or honestly, even if you're feeling a little bit hesitant on CSS in general, not specific to React, then don't skip those screencasts. Go through those lessons, do the challenges, and that will be a great way to get some additional practice on those topics and set you up for success with the rest of this project. So click the screenshot to open it in Figma, copy it to your drafts, and when you're ready, let's get started on this section, which I'm the most excited about in this whole course. Sometimes if I'm feeling overwhelmed by a project like the meme generator here, where we haven't learned some of the things we need to know in order to complete it, I will break the app down as much as I can into pieces and then see which of those pieces I actually can create. For example, we've spent this entire course so far learning how to build static React sites. And the truth is there are static parts of this site. So the first one we're going to start with is the header. Remember, you can click this screenshot in order to go to the Figma design, which you can use to determine the font sizes, the spacing, this cool purple gradient here, and so forth. So let's start out with that, pause the screencast, and work on building the header component. Well, first I'll get the pieces into place. I'm going to create a separate components folder, although this app is probably small enough that it's not really necessary. I'll just do it for practice sake. I'll create a header.js file inside of my components folder, and I'll just spin up a basic React component here. I'll do that little sanity check that I like to do just to see that it's working on the page. In my app.js, I will import my header. Let's put everything here in a div since I know that I'll have multiple things here. Okay, my header component is showing up. Next, let's get the content on the screen. I know it's not just an H1, so I think I'll surround this whole thing with a header element. And I probably wouldn't call this an H1 because it's not really the main headline of the page. It's sort of in the header itself. So let's maybe call it an H2. Before that, I'm going to have an image. And I already know the source is going to be my image's troll face. And let's see, it needs to be relative like this. That's probably going to be bigger than we want it to be, but we'll fix that in just a minute. And last of all, we have this React course project 3. I can't really decide what it should be. Let's just call it maybe an H4 or something. I know that I'm going to style my header, so I'll go ahead and give it a class name. We'll just say it's header. I'll hit save and go to my styles. Usually with two-dimensional layouts like this in a single line, I will revert to Flexbox. So we'll say this is display flex. We'll align everything to the center. From the design, it looks like the height is maybe about 65 pixels. That's making my image overflow a bit. We'll fix the image in just a minute, but I'm going to grab my background, which is from the design, so I'm just going to paste it directly from the design there. The color of the fonts and the text should be white. And there probably should be a bit of padding. I think we have something like 15 on the top and bottom and 20 on the left and right, although it might just be 20 all around. We'll just call it 20 all around. Then I will give some class names to the other elements here. We have header image, header title, and header project. So we'll start with the image. And we'll make sure that this fits within the boundaries of its parent by saying you have a max height of 100%. In the design, it looks like there's also some space, about 6 pixels, so I'll give this margin right of 6 pixels. The header title, it has a font size of about 20 pixels. And I can push my React Course Project 3 all the way to the right by giving my title a margin right of auto. We can see that a little more readily if I make this wider. Oh, and this still says header component. Let's update that to say meme generator. And let's lastly style our project text. That has a fairly small font size. We'll say that's about 12 pixels. And I think the weight is maybe different. Let's give it a font weight 500. And yeah, that does change it, so we'll leave that on there. And you know what? One thing I'm trying to get better at is using rems for my font size instead. 20 pixels over 16 pixels equates to about 1.25 rem. And 12 pixels over 16 is about 0.75 rem. Well, it's exactly 0.75 rem. Awesome work. This is a great start. The next thing we can do is attack this form here. We've got 2 inputs and a button. We're not quite ready to make them functional, but we can at least get them on the page. So let's do that in the next challenge. The next piece of our project that we can bite off is the form that we have right here with the 2 inputs and the button. So that's your challenge for this screencast. Don't worry at all about creating any functionality for it. I've outlined exactly the steps that I want you to do here. We're going to create a component called meme. Inside that meme component, we'll render a styled form, which will have our 2 inputs and our button. Pause the screencast and work on this challenge. Let's actually work backwards this time. I'm going to pretend that I already have a meme component created, so I'll just import it and render it, since I'm already here in this file, and then I'll actually create it. So inside of components, I'll create meme.js and set up my component. Now, I didn't talk about this specifically, but I happen to know ahead of time that I'm going to put both my form and the actual meme image and this text all into this same component. The reason I want to do that has to do with when we start talking about state and where state needs to live. So in an effort to reduce complexity, I'm just going to put everything in the one component. The reason I mention that is because I already know ahead of time that I'm going to use a main element to surround everything else on my app. If you didn't do that, it's completely okay, but this inside of here is where I'm going to put my form. I already know that my form has 2 inputs and a button. I've already got my button text copied and I'll paste it here since it's got the little emoji there. I also know that I want these to be a type of text, so I'll add the type text there. Let's hit save, see what we're working with. Okay, pretty generic styling. Let's give this some love in the CSS. I think the way that I would like to lay this out is using grid. I could probably use Flexbox as well, but what I'll do is make a 2-column and 2-row grid and lay the elements out there inside. The grid will be the form, so I'll make that the grid container. I'll give this a class name of form. And while I'm here, I think I'll give these their own class names as well. I'm going to put these on their own lines. We'll say these are form inputs. And I'll give my button a class name of form button. I guess I can also give my inputs some placeholder text. So we'll add top text and bottom text. It's a little more helpful. Now in our CSS, let's select our form. We'll change it to display grid. And then set up a grid template that has 2 40-pixel rows, and then evenly divide the columns with fraction units. So we'll have 2 columns, 1 FR each. Since I have 3 items, it's putting the first item filling up 1 column, the next item filling up the next column, and then the third item only filling up 1 column. The inputs look essentially the way that I want them to, but I want the button to span the whole thing. So I'll select my form button and tell it that its grid column will go from the very beginning to the very end. Awesome. It looks like in the design there's a little bit of a gap. I can use the gap property to spread things out a little bit. Then of course everything is butting up against the edges of my page here. I only am going to have one main element, so I'm just going to select the main element directly. And let's give it a padding, I think of about 36 pixels is what the design shows. One thing you might notice is that the placeholder text and the button text are not taking on our Carla font family. For whatever reason, inputs and buttons inside of forms tend not to do that. So I will specifically add that in my form button, and I will also select my form inputs. And I think I'll put this above my form button since my inputs are above my button in the markup. And I'll give that the font family as well. Let's also get some border radiuses here. I've got both of these as having a border radius of 5 pixels. My inputs have a border of 1 pixel solid, and then this color that I'm copying from the design. And we need our hash mark there. There's a fun property called text indent that I learned about here. I can make it so that my placeholder text and my actual input text will bump in a little bit or have a little bit of an indent. We'll just give it a 5 pixel indent. And I just noticed that these styles are not applying. That's because I need this to say form input, not form inputs. Okay, that's working now. Let me comment this out. Yeah, you can see what the text indent is doing. Okay, my button needs a lot of help. I'm going to take the background from the design in the Figma file that also gives us that gradient of purple. I need to change the color to white. I'm going to remove the border. I always like my buttons to have a cursor of pointer. And awesome, that's looking great. It looks very much like our design. Now, at this point, I probably could separately create this image with the text sitting on top, but I think it's high time that we jump into actually understanding what it is we need to learn in order to do the functional parts of this application, including clicking the button and typing in our text. So in the next cast, we'll talk about what that will actually take. The primary thing that sets apart a static website like we've been building so far with web applications is the ability for the user to actually interact with our page. And in order for a user to interact with our page, we have to be listening for different events on that page and then reacting when those events happen. Let's get a quick overview as to how this app will work. As soon as the app loads for the very first time, it's immediately going to make a call to an API called ImageFlip, which will return to us an array of 100 meme images that are the most popular at that time. Then, clicking the Get a New Meme Image button will simply randomly choose one of those 100 images in the array that got returned to us. And as you've probably figured out, typing into the left input box will give us our top text, and typing into the right input box will give us our bottom text. Now, there's a lot in there that we need to break down before it becomes overwhelming. So let's start off really easy. The first thing we'll do is learn how to add an event listener to our button so that we can run some kind of logic when the button is clicked. And we'll start that in the next lesson. The primary thing that separates a static website from a web application is the ability for the user to interact with what they see on the screen. By now, you should have built plenty of JavaScript applications that used events and event listeners to allow the user to interact with your application. So this topic shouldn't really be new to you. You should already be familiar probably with two different ways that in a vanilla JavaScript application you can add events to your program. First of all, there's the .add event listener, which you probably are already familiar with. If you were adding a click event, you would then provide a function, and inside this function, you put the code of whatever should happen when the element that you're listening for an event on gets clicked. Alternatively, there's a way in HTML where you would essentially put on click and set that equal to the name of a function followed by parentheses. This second way is going to be much more similar to how we actually accomplish adding event listeners to items in React. For example, let's start with our button here. We're going to make it so that when we click the button, something will log to the console. In React, all I need to do is on my button, add an onClick. And you'll notice that I used a capital C. And that's because we are accessing the DOM properties of the object that's being created here. As a reminder, what React is doing is it's taking this JSX element that it sees, which in the end returns a plain JavaScript object describing the DOM element that should be created by React. And whatever properties or attributes we add here inside the JSX are directly accessing the equivalent properties in JavaScript. If I were to select this button in JavaScript using document.getElementById or something like that, I would have a DOM element that has a property called onClick with a capital C. And this camel casing is the standard throughout all of our JavaScript elements. So all that means is that instead of using the lowercase c like you might be used to doing in HTML, we're going to have camel cased properties everywhere. So onClick, maybe on mouse over, or on mouse enter, and so forth. Let me put this back to onClick and we'll see the other difference here. Now, instead of setting this equal to a string, which has a function name, because I'm here in JavaScript, I can actually just use a set of curly braces and then put a function directly here inside of my onClick. Now, personally, I'm not a big fan of stuffing my functions inside of my markup here if I can avoid it. So what I usually do is above my return, but still inside my component, I'll define another function up here and say handle click maybe, because this is the click event handler. Then I can say console log I was clicked. Let me get rid of this, and I'm going to give you a mini challenge. Okay, pause the screencast and make it so that clicking the button will run our handle click function. A few of you may have been tricked into thinking that you can put handle click with a set of parentheses. And well, let me refresh and see what happens. Notice that as soon as I ran this code, it ran my handle click function. I don't want this set of parentheses here because that will run this function as soon as the program reads this line of code. Instead, I'm passing the function as a value so that React can add that function as the event handler in case a click ever happens on this button. So without the parentheses there, I can hit refresh, clean this up, I can hit click me, and then that's when our click event handler runs. The React documentation has a full list of all of the events that it supports. I've included here a screenshot that you can click from the React documentation. This will take you specifically to the mouse events. I've personally found that mouse events probably make up a good 95% of the events that I listen for in any program I write. And you'll probably need to use this as a guide for the challenge that we will do right now. Your challenge is to log something to the console whenever the mouse hovers over the image. I added some CSS to darken the image just so it was a little more obvious when the mouse was actually hovering over the image. Again, feel free to use this as your reference. Pause the screencast and work on this challenge. There's a couple different events that should work just fine for this challenge. We have onMouseEnter, which will run anytime the mouse enters an item that we're listening for an event on. And there's also onMouseOver, which essentially does the same thing. It just has a slight difference dealing with children elements. Right now, we don't have any children elements of our image, so it really wouldn't matter which one we use. First, let me create a function that will run when we are hovering over the image. Maybe I'll say handle onMouseOver. And we'll console log mouse over. And then I can simply add to my image, let's put it after the source, we'll say on mouse over equals, and then curly braces, because I'm going to put the name of our handle mouse over function. Pull these onto separate lines to make sure that we can see them well. Hit save. And now when I hover over the image, or rather when there's a mouse over event on the image, it runs our JavaScript code and we get that console log displaying down there. Feel free to poke around the documentation. Event listeners can be kind of fun, especially when there's a bunch that you may not have heard of. Just seeing how they work can be a fun thing to play with. Understanding this is going to be assumed from here on because you already should be a little bit familiar with events and event listeners at this point. Fortunately, doing it in React is actually fairly straightforward. And now this sets us up for one of the coolest parts of React, and we're going to jump into that next. Let's apply what we just learned about event listeners to our meme generator project. Ultimately, what we'll be doing is making an API call as soon as our component loads and getting data from an API that includes 100 of the most popular meme images right now, but we haven't quite yet learned everything we need in order to make that work. So for now, what I've done is I made the API requests and I just saved the data that came back here in memesdata.js. You can see we have the object, it's got a data property that has a memes property, and that is an array of 100 items. Each one of those items is an object that has a URL property. So you're going to have to do a little bit of digging into this memes data object, but your challenge is to make it so that when we click the button, it will randomly choose one of those URLs and just log it to the console. For now, don't worry about displaying the image yet. One modification I made to our markup here is I changed our form element into a div element. Long story short, when you have a button inside of a form, it actually submits that form and tends to refresh the page unless you stop it. But I realized that there's actually no reason for this to be collected together in a form because ultimately this button does its own thing by getting a new image. It does not take these inputs and submit them somewhere. So in this case, I feel like it's okay to have our inputs floating outside of a form, and that way it means that when we click our button, it doesn't refresh our page because it's not trying to submit a form. Okay, so the challenge is to get a random image from the memes data array, which I've already imported for you. You'll get that anytime this new meme image button is clicked. For now, just log the URL of that new image to the console. If you're feeling hazy on how to get a random item from an array, you'll probably want to turn to Google, but I know that you'll be able to do it. Pause the screencast, work on this challenge. Let's start by hooking up our button. I'm going to add an on-click event listener, and when the button is clicked, I will run a function that says getMemeImage. I haven't yet created that, so let's create that function, getMemeImage. For now, I'll just have it console log clicked to make sure that everything is hooked up correctly. I'll hit save, click the button, clicked. Okay, good. Now if we look closely at memes data, it's an object. There's the object. It has a data property which has a memes property. So I need memesdata.data.memes, and that's my array. I think I'll simplify that by simply saying const memes array equals memes data.data.memes. And then I will generate a random number. So I'll say random number, and I can use math.floor, math.random times the length of my array. So that's memes array.length. This random number should get me a random index of my memes array, and that indexed item will be an object with a URL property. So let's actually just console log random number and see how we're doing so far. 16, 50, 92. Okay, I wanted to see a high number to make sure that it was going up to 100. I probably don't need to click this until I see 100, or actually I think it would be 99. So I can get my image object, or actually I can just do it all in one. I'll say const URL equals, and then I'll index into memes array at the index of random number. This is my object with a URL property. So I'll just save that as URL so it's nice and short. Or if we wanted to do some object destructuring, I could just say, get me the URL property from this memes array. I don't want to conflate a few things here, so I'll just keep it straightforward like this. And then we'll just console log the URL. Of course, I could do probably most of this in a single line, but I find that sometimes separating it out makes it a lot easier for other people to read. We'll hit save, and I guess I have no way to ensure that these are in the correct index, but I can't see why they wouldn't be. So this is awesome. We're getting random images every time we click our button. At this point, we are a little bit blocked, and I'll show you why. If I create, let's say, a paragraph down here, and I try to stick my URL in there, well, first of all, I have a problem because my URL is only declared inside of this function. And so this is not going to know what I'm talking about. If I hit refresh, it's going to say it doesn't know what URL is, essentially. So you might think, well, let's declare URL outside of the function. You could say let URL, and then just set URL equal to this and console log URL. Let me hit save, and now at least URL is, well, of course, my styling is all messed up because my paragraph is, let's put this outside here so we have that above. Click new meme image. Okay, well, we set URL equal to the new meme image right here. However, my UI did not update. This has everything to do with the way that React looks at variables and decides when it should update the UI or the user interface. And spoiler alert, it doesn't do that by just looking at every variable that we declare inside of our component. In the next cast, we're going to dive a little deeper into this conundrum that we have and start figuring out how we can make it so that we can update a variable that will then replace what we have on the screen with the new value of that variable. At this point in our journey, we have mostly been dealing with static websites. In the previous section, we showed how we can take data that we pull from, for example, an API. We were just using a little JavaScript local data file to mimic pulling from an API, and then we mapped over that array of data to display items on the screen. However, in order to interact with those items on the screen, we are still missing something. I want to demonstrate what I mean, but before we do that, just in case it's been a little while, let's get our hands in the keyboard with a quick challenge. I have here just a locally defined array with two strings in it, thing1 and thing2. I want you to map over the things array, generate a paragraph element for every item in the array, and then render those items below the button right here. This challenge harkens back to the last section where we learned about .map and how to take an array of data and turn it into elements on the page. So pause the screencast and work on this challenge. Okay, what I'll do is create a new variable called maybe things elements, and I will set that equal to the array that comes back when I run .map on my original things array. We'll look at each thing in this array, which is just a string, and we'll return a JSX wrapped version of that string, so really just a paragraph element in JSX, where what we insert on the inside is the text of that thing. Thing is just a string, so it's fine if I just put it inside of my paragraph like that. Then things elements is an array of paragraph elements, and I can just put that inside my curly braces here, hit refresh, and now I have thing1 and thing2. I did get that warning about key So I should probably just add a key prop here, and every one of these strings will be unique. We'll see why in just a second. So I'm just going to say that thing is the key, and that should set them apart and get rid of my warning there. Cool. Well, this is great, but we've got this button that doesn't currently do anything. Let me set up another quick challenge for you. The concept is going to be that you click the Add Item button, and it adds another thing to our things array, namely thing 3, and then you click it again, it'll be thing 4, and so forth. I'll type up this challenge now. Okay, your challenge is to add an event listener to our button so that when it gets clicked, it adds another thing to our things array. In your event listener, you can use thingsArray.length +1 to determine what number should get added to the next item in this array. And it also will be a good idea to make sure that at the very end of that event listener that runs when you click the button, that you console log your things array. And the reason is because, spoiler, the page is not going to update when you add new things to the array. I decided it would be important to let you know this little fact ahead of time so that you weren't pulling your hair out trying to figure out why the heck things weren't changing on the page. So pause the screencast and work on this challenge. Well, let's create a function called, we could call it handle click, or I could say add item maybe. And add item is going to, well, first let's just console log things array and set up our onClick add item so that we can see that it's working. Okay, so it's logging thing 1 and thing 2, the static array that we have there. So I probably could add the whole thing in one step just using thingsArray.push. I'm going to determine what the text of the new thing is first. So let's say new thing text, and that's going to be, I'm going to use a template literal so I can say thing space and then insert some JavaScript where I say thingsArray.length +1. And then I can say thingsArray.push new thing text. And then of course I'm going to log the things array after I push the new item. Let me open the console so we can see that a little more clearly. I'll hit save. Add item. Okay. Oh, not a number, of course, because I spelled length wrong. Let's try that again. Add item, thing 3, thing 4, thing 5. Great. Well, our array is changing, but of course what we see on the screen is not. And this brings us to our conundrum. At this point, React is not looking at local arrays that are just saved within a component to determine whether or not something should get re-rendered. Or rather, if the return here should run again with an updated value for things elements. Actually, maybe more specifically, I'm determining my things elements way up here at the top, back when things array is just 2 items long, and then it's sort of cementing this things elements into its memory, and no matter what I do to change things array, it's not going to automatically change things elements. In my early days, I thought maybe if I put this below add item or something like that, it might make a difference, but that's not going to change the fact that this line of code will only run one time, and that's the very first time the app component gets rendered right here. Let me clean this up real quick. Now, one thing that might be tempting to do is inside of our add item function to say, well, let's not just update our array, let's actually select the elements on the screen using document.getElement by ID and finding out where the container for these items is, and then pushing a new paragraph element to that list. And the truth is, when you're just using plain JavaScript, that's essentially what you have to do. But if you think back to one of our earlier sections, we talked about how React is declarative. And this is one of the major benefits of having a declarative library like React. It makes it so that all we really need to do is update our data, and React will automatically, well, react to that change and update our UI to display what has changed in the data. All we need to be in charge of is making sure that the data updates correctly, and React will handle the rest. However, for that to work, we need to access something called React State. And State will allow us to sort of hook into the component and make it so that whenever we update our state, which is really just values that we're saving inside of this component, it makes it so React will update the user interface based on any changes that happen to those values that are being saved in state. And truthfully, if you think of pretty much any website that you interact with, if it were made in React, any kind of interaction you had would change the state. The first thing that comes to mind is maybe, I don't know, a playlist or a recipe where you hit the little heart icon or maybe a bookmark icon, and it fills it in and likely sends a message out to a database that updates the fact that you have liked a recipe or a song. Or maybe it's an accordion or a carousel where you click something and an image shifts over or a portion of the page expands so you can read more information. Any of those interactions in React are going to be updating state, which then makes it so that React can update the user interface to respond to however you interacted with the page. So now let me update this using state, and you can see how it will actually start to work again the way we originally expected. Obviously, at this point, some of this will look a little bit foreign, and that's totally okay. We're going to dive deep into understanding how to actually write this ourselves, but you can see that not that much changed in my actual code, but suddenly I have an app that's working the way that I expected. The example is a little bit contrived, obviously, but hopefully you can see the exciting world of state in React that we're approaching and start to imagine some of the cool things that it's going to allow us to do. So buckle up and get ready to jump into React state. One thing I've learned over my years of teaching React is that one of the major points of confusion for students when they're first learning React is understanding the difference between props, which you have already learned, and state, which we are about to learn. So let's take some time and clarify the differences between the two and when you would want to use one over the other. And the first thing we'll do is look at props. We've seen how we can implement props in practice, but let's take a second to actually talk about them. When we refer to props, we are referring to the properties that we are passing into a component in order for that component to work correctly. This is similar to how a function can receive parameters, quote unquote, from above. Just like a function that receives parameters, a component that receives props is not allowed to modify those props, or in other words, those props are called immutable. Let's first take a look at a regular function. Let's say I define a function that says add two numbers, and I pass in my parameters of a and b. As I'm writing the logic of this function, I'm going to assume that this function will be passed a and b. Of course, I could always do some kind of check that says if there's no such thing as a, or if a is equal to undefined, then throw some kind of error that says you need to provide both a and b. But other than that, inside of the body of the function, I can just assume that I have a variable a, which is a parameter that has been passed to this function, and I can assume that I have a parameter b, another parameter passed to this function. And that's what I mean by being passed from above. When we actually use this function, we'll say add two numbers. I'll provide my actual values that I want to represent the parameters a and b, and my function can then do its job. The main point that I want to come across here, however, is that inside the body of this function, it wouldn't make a whole lot of sense for me to modify or mutate these parameters. For example, I wouldn't want to say, forget what you just gave me for a, I'm going to set it equal to 42. Naturally, this should feel wrong to you because essentially we're ignoring anything that is passed in as the first parameter here and just setting it equal to 42. Technically, this probably works. If I were to console log the result from add two numbers, 1 and 2, of course I would expect it to be 3, but we'll see that it's actually 44, and that's because we've overwritten a to be something different. Similarly, in React, I would never want to have a component, let's say a navbar, that takes props, but then automatically sets props dot, I don't know, let's say cover image equal to something else. This is a huge red flag. You would never want to set props.anything or props itself equal to anything different, because incoming props should be immutable and they should never change manually. Or maybe more specifically, those props should never change from within the body of our component itself. Now, that's not to say that when I have an instance of my navbar that I can't provide a cover image that changes. Let's say it starts out as some image 1, and then, I don't know, maybe there's a button on the screen. When the user clicks that button, I want my navbar's cover image to update to some other image. Maybe this is a little convoluted because I'm not really using images here. But the point is, I can change the values that I pass to my component That's fine. That's something I'm allowed to do, and as we jump into state, we're going to see why that's even useful. But from within the body of the function, I should never ever change my props, in the same way that I would never want to change the parameters being passed to my function. Another way to think about props, here we read that they are the properties being passed into a component in order for it to work correctly. If it helps, you could think of it as the properties being passed to a component in order to configure it. As we saw in our last section project, we passed props to our card component in order for that card to be reusable and configure it to display the correct image, the correct price, the correct stats like the review count and so forth. And oftentimes you'll find components that do more than just take in the data that should just be displayed as a part of the component. Sometimes they will receive configuration objects or properties. Let's say, for example, off the top of my head, if we had a component that we wanted to display either in light mode or dark mode, well, then maybe I would have a dark mode property that I could set to true. In this case, I'm not necessarily displaying the literal text true for dark mode or the text dark mode is activated or anything like that, but instead this is a property that is configuring my navbar in order for it to act and display correctly. Okay, I might be beating a dead horse here, so let's move on, and we're going to see how the use of state will differ from our usage of props. If props are data that a component is receiving from above and shouldn't be changing, state, on the other hand, are values that are defined within a component and essentially should be changing. So as we see here, state refers to any values that are managed by the component itself, kind of like a function that declares its own variables from within that function. Long story short, anytime your component has changing values that should be saved and displayed, you're most likely going to be using state. We'll jump into what this looks like in React in a second, but I think it might be helpful to see how this compares in a vanilla JavaScript example, kind of like we did with our add to numbers and having what we can equate to props being passed in as these parameters, and how we shouldn't be changing them from within the definition of this function itself. In order to create an equivalent in vanilla JavaScript of our concept of state, let me write out a challenge for you. Let's say we have a function called greeting. It takes a name as a parameter, and what it should return is a string like good afternoon and then followed by the name. Of course, afternoon will change depending on the current time of day, as you can read from the challenge description up there. At this point, this is more of a vanilla JavaScript algorithm challenge for you, but I think it's good to incorporate those into our React course here. And maybe just so that I'm not making you chase Google a whole bunch right now, I'm going to give you a couple hints here. So you can get the current time of day by following these two lines of code. Essentially, first you create a new date object in JavaScript, and then you use that date to get the current number of hours. These hours are 0 index, so 12 a.m. is 0, 11 p.m. is 23. And just to be clear, I have included the 11:59, 4:59, and everything up here just to be clear what hours should be included in morning. This one's kind of funny because I don't know that I would ever say goodnight to someone at 3:59 a.m., but whatever. My point is you won't need to get the minutes here. You can just use the hours like I've shown you here. Pause the screencast, see if you can complete this challenge, and then we're going to bring the concepts back into understanding state in React. Now, I won't spend a bunch of time talking about the logic of this. We'll just put in a solution here and then talk about how this equates to state in React. I have the number of hours now. If I console log those hours, it's 12 p.m. my time, so my answer should say 12 there. Yep. So I will type out some logic that I think will just kind of intuitively make sense. The first thing I'll do is just declare a changeable value here, time of day, and then depending on the current number of hours, I will change the string time of day to be either morning, afternoon, evening, or night, just like I talked about in the challenge. And now that I have a time of day value, I can simply return the string, and I'll use some interpolation here. We'll say good, and then we'll stick in the time of day, comma, and then I'll use the value for name that I'm receiving as the parameter to greeting, exclamation point, and let's go ahead and see if this works. Again, it's about 12 o'clock my time, so I should, when I'll need to console log this. the value that gets returned. Good afternoon, Bob. Okay. Now the point here is my function is receiving a parameter. This parameter is not something that I will want to change in the way of saying name equals something different, because that would just be a kind of a strange thing to do when you are expecting the outside user of this function to provide you the name. Similarly, in React, we are not going to take any props and then just change them, which is what we talked about in the last screencast. However, there are definitely reasons for us to, within our own function, create values that we can either use or even change, like our let time of day here. In React, values that are created by the function or the component itself are usually handled with state. Okay, I think that's more than enough of the conceptual difference between props and state. At this point, it's probably best for us to just get our hands dirty and start actually seeing how we can implement state in React. And then as we build our section project, we will get much better exposure into how state and props will work together and how they are different from each other as well. It's time for another quiz. This one's going to specifically be looking at the difference between props and state. So as always, read through these questions, click into the editor, type down your answers, and when you're satisfied with your answers, click play and we'll go through the quiz together. On a higher level, the concept of state is sort of like saying the way things currently are. Here in the United States, the president gives a yearly address called the State of the Union. Growing up, that always confused me because the United States is made up of 50 states, and I thought it had something to do with that. But no, it means the way that things currently are. In React, state refers to values that a component can maintain between render cycles. This will make more sense when we get into the syntax of it, but let me type down a more concise answer to this question. The concept of state is essentially a way for React to remember some saved values from inside of a component. This is similar to declaring variables within a component, but there are a few added bonuses to it, which we're going to get to later. So when would you use props instead of state in React? I think the easiest way to think about this is to compare it to regular JavaScript functions. Props are like passing parameters into a function that the function then uses to help it determine the output, what gets returned. So in React, you would want to use props anytime you need to pass data into a component so that that component can use that data to determine what should get displayed on the screen. In some cases, the data that we pass in will directly be data that is displayed, like in the instance of text. But sometimes it will be data that's really just meant to, so to speak, configure the component so that the component can use it to determine how something gets displayed. Okay, so when would you want to use state instead of props? Continuing with our function analogy, state is kind of like when inside of the body of a function you declare new variables, and you use those new variables to help you accomplish some task inside of the function. In React, you would use state anytime you needed a component to maintain its own values. As we mentioned earlier, it's slightly different than just declaring a regular variable. We're going to see the syntax of it later and how it differs, but for now that should be a sufficient answer to this question. So you would use state anytime you want a component to maintain some values from within that component, and by the way, also remember those values even when React needs to re-render the component. Again, we're going to see that much more in detail a little bit later. And a little bit out of left field, what does the term immutable mean? And then are props immutable and is state immutable? Immutable technically means unchanging. The reason I bring this up is because we learned that props are immutable. We should not ever change props from within the component that's receiving props. Doing so essentially defeats the entire purpose of props. Think of it like a function that receives a parameter but then just decides to change the value of those parameters to something different. It pretty much invalidates the whole purpose of passing parameters into a function. So props are immutable. In this case, I don't think props are literally immutable. You can try to set them equal to something else, and I don't believe it will crash your program, although it may throw a warning. But maybe a better way to describe it is saying that you should not change props, and therefore they are immutable. State, on the other hand, is not immutable, or in other words, state is mutable. The purpose of declaring state in a component is because you do plan on changing state. Okay, we're done with the quiz. Nice work. When you're ready, let's keep moving forward. We saw in an earlier lesson how it's not going to work for us, at least in React, to just declare regular variables like, let's say, state is equal to yes, and expect React to re-render our component if for some reason that state ever changed. If you recall, we had an array of items, and we had a button that allowed us to push new elements to that array, but whenever we did that, it didn't actually update our page. And that's because React doesn't watch for local variable changes. So the first thing we'll do is learn how to actually declare state inside of our component, and in the next cast we'll talk more about how to actually change that state. As a part of the React library, there is a method called useState, and useState is one of many what are called hooks in React. There's a little bit of history as to why it's called hooks. We're probably just not going to worry too much about it right now. But the point is I can declare some state by simply calling react.useState. Now, another way you might oftentimes see this is people will destructure it directly in the import statement. They'll grab the useState method from React as well, and then they can just use useState. In fact, I would suppose this is the more common way you will usually see it happen. However, just for perfect clarity and for it to be very clear that useState is part of the React library, I'm actually going to use react.useState because I do find that it makes it a lot more clear where this useState method is coming from. Let's go ahead and see what comes back. We'll say const result equals react.useState, and then we'll console log result, just to see what actually comes back by calling react.useState. I'll open the console, hit save. And look at that. Okay, so that's interesting. We get an array back, and the array has its first value as undefined, and its second value, well, in Scrimba it says f parentheses. That just means that it's a function. Now, let's see what happens when I put something inside the parentheses. Let's say the string hello. I'll hit save, and now the first value of my array is the string hello. So whatever I put inside of my parentheses when I'm calling useState is going to be the default value for the state variable that I want to save. Okay, so now that leads me to a little mini challenge that will require you to think a little bit critically. I'm going to type the challenge out now. Okay, your job is to replace this yes with a string yes that isn't just hard-coded inside, but rather is created by using react.useState. Remember, what we get back by calling react.useState is not just the string hello, it's actually an array. So let that guide you as you work this challenge. Pause the screencast and work on this now. The first thing I can do is change hello to yes, and then my result is an array, and the index of 0 should be, let me just log this, should be my string yes. So I could replace this yes with a set of curly braces because I need to jump into JavaScript, and then I can say result at the index of 0. I'll hit save, and we get yes the exact same way we had it before. But now if I were to change this to no, which is not true, state is important to know, awesome, our page actually updates with the state that we had created with react.useState. Change this back to yes, because it certainly is important to know. Okay, well there's a couple of problems we have. First of all, this is kind of clunky to say result at the index of 0. In the next screencast, we're going to learn a little bit more about what we can do with this array, and then we will bring out the real power of using state by allowing the user to interact with our page and change state themselves. So when you're ready, let's jump into those topics. As we saw, what we get back by calling react.useState is an array where the first item is the value of the state that we are hoping to save, kind of like initializing a variable inside of our component. And the second item of that array is a function. So we saw how we could use result at the index of 0 to get our value. However, there's actually a much smoother way to deal with this. And this requires us to use array destructuring. Since react.useState returns an array, what we can do is actually destructure that array immediately upon receiving it as a variable, and then we can provide two values, and let me just put func because we know the second value is a function. Now in this case, if I rerun console log result, what we see is that we have pulled out the first item in the resulting array of React.useState and destructured it into its own variable called result. What's nice about using array destructuring is that we get to call this whatever we want. If this were object destructuring, we would have to use the property name of the object that comes back by calling React.useState. But because they return an array, we can call it whatever we want. So if I console log whatever we want, we get the same thing, yes. Oh, and now my result down here is broken, so if I change that to whatever we want, we get back to the way we were. Now, don't use silly names like whatever we want. Instead, let's say maybe is important. We'll choose a variable name that makes a lot of sense for what the value is that we're trying to keep track of. And that's the concept of using array destructuring in order to more smoothly get values from React.useState. In the next screencast, let's talk more about this function here. Let's take a look now at the function that we receive here when we destructure the array that comes back from React.useState. Normally, if we had a variable where we were saving this, if we just said something like let is important equal yes, then we already know we could simply say is important equals something different, like no. However, when we're working with state, we can't simply say is important equals something different. Instead, we are given a function that allows us to make these changes so that React can handle those changes accordingly. Let me delete these lines here, and let's take a look at this function. Now, normally we wouldn't just call this func, so let's give this a more meaningful name. The convention that you'll oftentimes see is set, and then the rest of the variable that we called our state. So set is important. In this case, I need a capital I to make my camel casing correct. And this set is important is a function that I can run, and whatever value I provide to it is going to be the new version of state. Now, of course, running this function immediately after generating state is kind of silly. In fact, I'm not even certain that it would work. Instead, we would normally want to set or change the state whenever something specific happens on the page. So let me type up a challenge so we can do something like that. Okay, just to avoid confusion, I created the actual function body for you, but your challenge is to have this function run this line of code, and then to set up an event listener on this div so that it runs handle click whenever anywhere inside this circle gets clicked. Pause the screencast and work on this challenge. Well, simply enough, I can copy this line of code, put it in there, and then I need to set up an event listener here. So I'll say on click, again, capital C. We will run our handle click function. Hit refresh. And when I click my button here, awesome. Okay, notice that as soon as I clicked, it changed from yes to no. What happened is we took the function that we were given when we called React.useState. This function's job is to give us the ability to change state if we wanted to. And we used it in the most simple way possible, which is to simply provide a new version of state. As soon as this line gets called, which of course happens as soon as we click our div here, then set is important gets called, and the state changes to no. And well, at this point we've kind of hit a dead end, because obviously this is incorrect. State is very important to know, but notice that if I click this again and again, well, nothing is changing, and that's because every time I click it, it immediately sets it to no. In the next screencast, let's work on a challenge that will help get your hands on the keyboard practicing using state. All right, here we have something that's a little more dynamic. The idea is we will create a little counter. When I hit plus, this number should go up. When I hit minus, this number should go down. To start us off and to get your hands on the keyboard, I'm going to have you complete this challenge where you're going to set up state to track our current count. And our initial value is going to be 0. Pause the screencast and see if you can complete this challenge. To create new state, we simply use react.useState. And we can provide the initial value of 0, and then we need to essentially catch what this returns in some variables. It's an array, And because what we get is an array and I can destructure it, that means I can call it whatever I want. In the first index, I receive the value, which I'll call the count. And by convention, I will call my setter function setCount. This is the function that when I call it will allow me to update the state here. One last thing that I didn't specifically say to do and wouldn't be very obvious unless I did is to use this count value to replace our 0 here. Now at this point nothing is going to look like it has changed. I still don't have the ability to raise or lower this number. Now let me build up to the next section by updating our challenge. Okay, your challenge is to create a function that's called add that runs whenever the plus button is clicked. This is just practice on event listeners in general. For now, you can just have it console log the string add or something along those lines. A good rule of thumb to use is to declare these functions inside of your component. So instead of going up here outside of your component and creating your function called add, it's better to declare that function right here inside of your component. Pause the screencast and work on this part of the challenge. Okay, let's declare a new function called add. And for now, we'll just console log add. And let's see, here is my plus button, so I will add an on click of add. And now I should click this button and get my console logging add. Awesome. Okay, at this point, we're running into an issue, and that is how we can update our count. What we most recently saw is that I could say set count and then provide some kind of immediate hard-coded value here. However, that doesn't really help us because even if I provide a 1, if I run this code, it will work. Notice that when I click the add button, it sets the count to 1. Therefore, it re-renders our app and changes the 0 to 1. However, of course, if I hit plus again and again and again, it's just constantly setting it to 1 and it doesn't really accomplish what we want. So I want you to think critically. I'm going to update our challenge. I want you to see if you can think of a way so that clicking the plus button will increase our number by 1 every time and display it correctly on the screen. Obviously, hard coding a 1 here is not going to work. Pause the screencast and see if you can figure out this challenge. Hopefully you were able to figure out that we do have access to our current count. And so I can just say, I want you to set the count equal to whatever the current count is plus 1. Let me hit save. We'll see that this is working. Okay, that's awesome. But I wanted to use this as a chance to show you a common misconception or fallacy that beginners in React tend to fall into. And that is trying to do something like count plus plus, or even plus plus count if you're familiar with the differences between those two. Let's look at count plus plus, for example. In the philosophy of React, something like count plus plus is strictly forbidden, and that's because we never want to modify state directly. What I mean by that is this. Count plus plus is a shorthand for count equals count plus 1. And in this case, using count equals is just a big no-no. You will never ever do that when you're modifying state. The entire reason that we have this set count function is so that we can simply provide a new updated value, but we will never ever want to run an equal sign after our state value. So let me put this back to count plus 1. We'll see that this is working. And now I want to update our challenge to finish off the basic portion of this app. Okay, your task is to add functionality to the minus button now. Of course, clicking the minus button should decrease our number by 1. Pause the lesson and see if you can figure this one out. All we need to do is to create a subtract function instead. So I'll create a new function called subtract. Of course, this one should take count and subtract 1. And then we need to add our on-click handler for the minus button. So that will go right here. Subtract. And once I hit save, we should be able to go backwards as well. Awesome, great work. However, I do have a little bit of bad news. Although we were able to use our count state value here in order to help us determine the new count, it turns out we're not actually following best practices when it comes to using this state value here. So in the next screencast, we're going to see another way that we can use the setCountSetter function to update our state value. Although currently it's technically working for us to use our current state value in order to determine the new state value when we're setting our count, it turns out there's actually a better way to use setCount in this case whenever we need to use our old version of state to determine our new version of state. We've seen how we can simply provide a new value to our setter function. However, there's another way that we can use this setter function, and that is to provide a callback function inside. When we provide a callback function as the parameter to our setter function, this function needs to return the new value that we want state to be. If we essentially wanted to recreate what we did by passing a simple value to our setCount function, we could just have our callback function here return count plus 1. However, this is where the best practices comes in. Anytime we need to use our old state value to determine a new state value, if we provide this function, React will pass this function the old value as the parameter here. What we can do is then take this old value and use that as our reference to what count was at the time that this function was called. This might be really confusing at this point. It would require us to jump a little bit deeper into how React handles state changes and re-renders to truly understand why this is best practice. For now, I think it's going to be enough to simply say if you ever need to use the old value of state in order to determine the new value of state, you should just always plan to pass a function to setCount. This might be a little disheartening because this already looks way more complicated than what we had here. Fortunately, if we use arrow functions, we can simplify this quite a bit. I can just say, given the old value, return old value plus 1. Usually what I'll do is use the prefix of prev and then use my state value. So I'll say prev count as in previous count. So this is the convention you'll usually see me using whenever I'm using a callback function as my parameter to setCount. Because that was a little bit confusing, I'm going to type this out as a note so that maybe those of you who are more visual learners will be able to comprehend it a little better. So again, if you ever need the old value of state to help you determine the new value of state, or in other words, if the new value of state depends on knowing what the old value of state was, you should always pass a callback function to your state setter function instead of using the state directly like we're doing down here. Then this callback function will receive a previous version or the old version of the state value, which you can then use to determine the new state value. With that said, let's do a quick challenge. Okay, your challenge is to update our subtract function to use this callback function as the state setter instead of what we currently have. Pause the screencast and update our subtract function. Fortunately, with arrow functions, this is still very concise. I can say prev count, arrow, prev count minus 1. And just for demonstration, when I refresh this, you can see everything is working exactly the way as it was. You're obviously more than welcome, if you're really curious, to deep dive into this, do a bunch of Google and YouTube searches to truly understand why this is better. Frankly, I would say probably 90% of the time you would never notice a difference between what we used to have and what we currently have. However, it is generally accepted as best practice to do it this way. And all of this is not to say that there's no instance in which you would want to just provide a bare value for your setter. That certainly does happen still. But in the spirit of teaching you best practices in React, it's probably good enough just to understand what I'm talking about here in this note and to move on. A good practice at this time might be to delete everything that we're doing dealing with state here and to try and recreate it from scratch. Maybe as a way to test your own skills to see if you are truly comprehending what we've done so far. When you feel like you've got a good grasp on this, let's keep moving forward. Let's pause now and do another quick quiz. Like you've done before, pause the screencast, click into the editor here, actually type down your answers to the questions that you see here, and then we will go through the quiz together. Pause now and work on the quiz. Okay, number 1, you have 2 options for what you can pass into a state setter function like setCount. What are those options? Well, option A is to pass in simply the new value of state. So if you call setCount and you provide a new value like 42, whenever this function gets called, state will automatically be updated to the number 42. And option B is to pass a callback function, and then whatever the callback function returns, we'll say whatever the callback function returns will be the new value of state. And then numbers 2 and 3 both refer back to the answer to number 1. So when would you want to use the first option? In our case, the new value of state. This is any time you want to update your state and you do not care what the previous value of state was, or rather, you don't need the previous value of state to help you determine what the new value of state should be. And then the answer to number 3 is basically the opposite of number 2. It's whenever you do need the previous value of state to help you determine the new value of state. Under the hood, React is doing some relatively complex things to make sure that it can maintain state for you. One of those things has to do with batching a bunch of different state changes together. So if you were to run 2 state setter functions back to back, the way that React handles it may or may not run one of them before the other. That's a very high-level overview of why we need to do this, but when we pass a callback function to our state setter function, we can be guaranteed that the value that callback function receives, which in the previous lesson we were calling prev_count, we can be guaranteed that it will receive the most updated correct version of that so that it can update state correctly. If that didn't make any sense, that's completely okay. That's really why I didn't want to dive too deep into it, because at this point it truly is enough to know that if you need the old value of state to help you determine the new value of state, you should pass a callback function. Otherwise, you don't need to pass a callback function. Okay, I'm probably beating a dead horse at this point. When you're ready, let's keep moving forward. Now that we've learned how to create and update our state, let's revisit our meme generator. We figured out earlier how to get a random URL for a meme image. However, the conundrum we ran into was that we couldn't update our user interface with that image because React wasn't listening to our local variables. Now that we know about state, we should be able to add an image to our meme generator. So your challenge is to first create a new piece of state called meme image that will just start with an empty string as a default. And when the getMemeImage function is called, you'll save the random URL, which we still have access to right here, in the state for meme image. Once you've done that, you should be able to add an image element below our div here with the form that has its source set to the new meme image state that you created. As a bonus, you may want to add some styling so that the image stays confined within the space that we're working with here. Pause the screencast and work on adding an image to our meme generator. Right near the top here, I'm going to create meme image and set meme image, which will come back from react.useState. The initial value is an empty string. Down in my getMemeImage function, we can call setMemeImage. And now think for a second, do I need access to the old state, the old string here, in order to determine what my new string should be? And the answer is no. I don't care what it used to be. I'm completely replacing it with the new URL, which I can get through memesArray at the index of random number.url. And that should complete these first 2 tasks. Lastly, I'm going to use my new meme image to create an image element and give it the proper source. Meme image, let's hit save. And well, it says we have an error. Let's go ahead and just see what happens. I'll click get a new image, and look at that. We've got an image now. Obviously, it's pretty large. Let's see if we can just add maybe a class name. And for now, let's call it maybe meme-image. In my styles, I'll add meme image, and let's say it's got a max width of 100%. Hit refresh. Click get a new meme image, and look at that. Now, I don't know immediately what this error is coming from. I think for now I'm going to ignore it, and we'll see if we can figure it out later down the road. Awesome work. Now, this is just the beginning. We have a lot left to learn about state, but don't let that be daunting. It's going to be really fun. So when you're ready, let's keep pushing forward. At this point, it will be helpful for us to practice the ternary operator, whether you've learned it before or not. I've written some very basic JavaScript here. We just have a variable called isGoingOut that is set to the Boolean true, and then we are using that value to determine what the answer should be that we display in our H1 over on the page. Obviously, if isGoingOut is true, then we'll say yes, and otherwise we'll say no. If it's been a while since you've worked with the ternary or you never really fully grasped it, I've included a link here to the MDN docs on how to use the ternary operator. So once you feel prepared, pause the screencast and see if you can clean up our code using a ternary. A ternary allows us to put an if-else statement onto a single line. Technically, you can also manage if-else statements and get as nested as you want by using nested ternaries, but at that point, I really don't see a reason in using a ternary. It becomes much more difficult to read than a simple if-else statement. So here, what we're going to do is set our answer equal to, and then we'll use a ternary to determine if we are going out. So I could say is going out is true, and then I use a question mark that says if this is true, then I want you to use this expression. In other words, I want let answer equal to yes, the string yes. Otherwise, and this is my else, I'll say I want answer to equal no. I can get rid of all this down here, and I've been able to clean up my code from before to a single line. And if you're not terribly familiar with ternaries, the more you see this, the more natural it's going to seem. This is actually a really easy thing for me to read now because I've seen it so many times. So I can hit save, and everything is working here. We can see if I flip this to false and hit save, then we get the answer no. I can simplify this ternary even further because isGoingOut is already a Boolean. I don't necessarily need to equate it equal to true, so I can simply say if isGoingOut, in other words, if this is true or a truthy value, then set answer equal to yes, otherwise set it equal to no. And of course, we get the same values. Switch this to true. No will change to yes. Awesome. Okay, let me tweak this challenge just a little bit. There's one more way that you will oftentimes see a ternary used in React, and that is when the ternary actually exists inside of our markup. If you remember, our curly braces allow us to put JavaScript, not just variables, but entire expressions directly inside of our JSX. So your challenge is to move the ternary inside of the H1 in the JSX, and as a hint, you will no longer need the answer variable at all. Pause the screencast and see if you can figure out a solution to this challenge. All I need to do is take this part of my ternary here and replace answer with it, and then I can get rid of my answer completely. Now what will happen is every time my component renders, it will check the value of isGoingOut, and it will determine whether the string yes should be used as the text of this H1 or if the string no should be used as the text of this H1. So just like we had before, I can hit save. We get yes because our value is true, and if we switch it to false, we get our answer of no. Awesome. This sets us up perfectly to work on the next challenge where we will actually save this value in state and then flip it back and forth between true and false. And that's what we'll work on next. Similar to last time, we have the question, do I feel like going out tonight? I've hard-coded this time the answer yes, but you will want to change that in the challenge. So your challenge is to initialize some state for a variable called isGoingOut, and you will just begin it as a Boolean. You can choose true or false as the default. And then make it so that clicking anywhere in this div will flip that Boolean value from true to false or false to true. And then instead of a hard-coded yes, you should display yes if isGoingOut is true, otherwise it should display no. This rolls together the topics of the past few screencasts, so if you need to look back and remind yourself how everything works, that's completely okay. Pause the screencast and work on this challenge. To initialize some state, I will simply use react.useState. As a reminder, you could also decide to pull in useState as a separate method from the React library by destructuring it up here. I'll set the initial value to true, and I will save it in a variable that I will use destructuring on because I receive an array back and will use isGoingOut. And I will, by convention, use set isGoingOut as my function name. Next, I need to make it so that this div, when it's clicked, will flip that value. There's a few different ways I could do this. In fact, I think I'll show you them. I'll set an onClick here. And one way that you may see from time to time is somebody providing an arrow function directly inside of your onClick. One benefit of this is that you can just declare it right here, and it is nice and concise, short and sweet. In fact, I'll start going down this path, and then I'll probably change to move this function into its own defined function outside of my return. But let's go down this road for a second. When a click on this div happens, I want to run this whole function, and the main thing I want this to do is to use set isGoingOut. And now I need to think, do I need the old value of state to determine the new value? And yes, in this case I do. I need to know if it used to be true, then I want it to be false. If it used to be false, I want it to be true. Now think to yourself, when I need to use the old state, what do I need to provide as my parameter to my setter function here? If you said I need to provide another callback function, then you were right. And that's because this callback function will give me the previous version of state that will help me determine the new version of state. And now that I've typed that out, I can see that this is already a little bit crazy. I have an arrow function calling this function, which takes a function as a parameter, and it becomes one too many levels of inception for me. So I'm going to move this to a function out here. Let's call it changeMind. And it's going to run set isGoingOut. And then I can replace this all with just changeMind, which looks a lot more concise and, to me at least, is a little simpler to read. With set isGoingOut, I'll take my previous version of state. You can call this whatever you want. And we will return the opposite of whatever previous state used to be. Now, this is a little shorthand trick that I've learned over the years. If you did something more like an if statement that says if prev state was true, then set it to false, and if it was false, then set it to true, that's completely okay. This is another instance where a ternary might be useful. We could say if prev state is true, then return false, but otherwise return true. But all of that is a little bit unnecessary because I can simply say just return the opposite of what it currently is. Now, last but not least, I need to change what is actually displaying on my page. Now, if you struggled to get to this point, first of all, I'd recommend going back and reviewing what we've learned, keep practicing until this first portion of what we just did makes sense. But before you do that, I'd also like to encourage you to pause the screencast and see if you can apply what we learned about ternaries and what our current value of isGoingOut is to determine what we should replace our yes with here. So if you weren't able to complete this far, then pause the screencast and try to figure out what we should put here in our H1. Well, we can just put a ternary directly in line by putting a set of curly braces to tell us that we're going into JavaScript. And I can use a ternary that says isGoingOut is true, then I want you to display yes, but otherwise I want you to display no. And at this point, we should have everything completed. Let's open this app, we'll refresh it, and when I click, it changes us from yes to no. One thing I like about using a Boolean for our state here is that it's a lot more realistic to a real scenario. I could have possibly made things a little bit simpler by just having this be the string yes or no. I would obviously need to change this down here and say if previous state was yes, then change it to no, and if it was no, then change it to yes. But personally, I like the separation, especially if I'm going to use variable names that start with is or has that indicate a Boolean, to just use a Boolean like true or false, and then translate that true or false Boolean value into something that makes a lot more sense for a user to actually see on the page. Again, if any part of this was overwhelming or too confusing, or you weren't able to do this from memory, then I highly recommend going back, reviewing this, trying to do this challenge again. Don't just push forward. But all in all, you are doing a great job. Whether you understood this or not, you've gotten very far. Also, don't forget to take breaks, stand up if you need to, go get a drink of water, and when you feel refreshed and ready, let's keep moving on. Hey, this looks familiar. This is the little app that we used when we were learning about how saving local variables does not update our UI. And now that we've learned about state, to start us off, your challenge is to convert the code below to use an array that's held in state instead of what we currently have with our local variable here. You can just initialize the state as an array with these same two items. And if I were you, I would call the piece of state that you create things array, just like we had before, so we don't have to change anything else in our code here. Pause now and work on this challenge. Let's go ahead and create, in fact, I'm just going to reuse what I have here. I'm going to put this into an array and have a setter function that says setThingsArray. And that will equal react.useState, which I will initialize with this array. And well, let's hit refresh. I think this should work just fine. Okay, well, this is showing up. At least that tells me that things array still contains my two items. The last piece we need to fix is making it so that our add item button will add something to our things array. However, the reason that I'm making this video is because there is a small gotcha in here. And that is that it's tempting to want to do something like thingsArray.push. However, I want you to think for a second, what is wrong with saying thingsArray.push? If you remember back, we should never ever directly modify our state. In this case, our state is thingsArray, and here I'm directly modifying it. .push is a destructive action. It modifies the original array, and therefore we would be changing thingsArray ourselves, and this just isn't a good idea. In fact, not only is it not a good idea, but if I try to do it, let me put a test in here, hit save, and add item, you can see that nothing is going to happen here. Okay, so we know we need to use setThingsArray in order to modify our state, which will actually update the user interface on our screen. So let's use setThingsArray. And if you remember back, with setThingsArray or whatever setter function I have, I can provide one of two options here. Pause and think for a second, what are the two different options that I could put into the setThingsArray? Well, I can either provide it with, and I'm going to put these inside of angle brackets to show you this is not real syntax. I could either put in a bare new value, completely replacing the old value of state with this new value, or I can provide it with a callback function, and that callback function would receive as its parameter the old version of state, which I can use to determine the new version of state. So now I want you to pause for a second and think, which of these options should I use? Should I use the new value option, or should I use the callback function option? Well, if I just provided a new value, then I wouldn't really be able to add anything to my existing array. I would be simply replacing my existing array. Because what I want to do is add an item to the array, that means that I do depend on what the old version of state or the old array is in order to determine my new array. So I need to provide a callback function here. I'll do this as an arrow function, and I can put in my, let's say, prev things array, or I could simply say prev state if I wanted to. I'll keep it as prev things array so it's contextual. And now that I have gotten us this far, I want you to pause and see if you can figure out what I need to add or what I need to return in this callback function to correctly update my array with the new thing that I want to add. And if you remember, every time we click add item, we want to determine the length of the array and just add thing space and then the new length of the array. So it should automatically put thing3 when I click add item. This one can be a little bit tricky. If you spend more than maybe 5 minutes or so without figuring it out, you can just hit play again, and I'm going to show us how to do this. But I do want you to pause and see if you can figure this one out. Another really tempting thing to do at this point is to say prev things array.push. However, again, this is not correct. This prev things array is still a reference to my existing state, and using .push on it is not a good idea because that would be modifying state directly. Not only that, but .push actually doesn't return the array that is modified, it returns the new length of the array. So this would be like replacing all of our state with a number, which would just be 3. So I guess in 2 ways, this really isn't going to work for us. Remember, I need to return a new version of state, and my state starts out as an array. In fact, my program expects things array to be an array because I'm using .map on it. So I need to make sure that when I'm setting a new array that I return a new array. This is a new version of state. Fortunately with ES6, there's a really easy way for me to spread in my existing array, which I have access to with prev things array, which by itself would get me an array of everything that used to be in there. So this is not yet updating it. However, I can very simply add a new item to the end of my array. These are strings, but I'm going to be using some JavaScript to determine the array length. So I'll use some template strings here, and I'll say thing space, and then interpret some JavaScript by saying prev things array dot length. And because that's the previous array and it's not 0 indexed, and I want this to say 3, I'm going to add 1 to it. In other words, my previous array was 2 items long, and I want it to say thing space 3, so I'm adding a 1 at the end. This is getting a little long, so I'm going to put this onto the next line, which means I then have to use a return. And well, let's just see if this works. I'll hit save, add item. Awesome, look at that. We've got things adding to our list with the correct numbers and everything. If you're feeling hazy or forgetting the array spread operator and how this works, that's totally okay. Although I would recommend that you go study up on the array spread operator because it's so useful. You're going to find yourself using it all the time, especially in React. However, this isn't the only way to do this. There certainly are other ways to make a copy of our original array or to return a new array. We could even use a for loop that loops over this array and pushes those items to a brand new array. Then we add our string here at the very end before we return that whole new thing. Obviously, this is why I'm saying you should just go focus on learning the array spread operator because it's extremely useful. Okay, I do have one big challenge for you. Okay, it's time to put all the knowledge that you've learned lately together into this challenge. In fact, if you want an extra challenge, you could delete this line where we set up things elements where we're mapping. I figured because it's been a minute since we've looked at this, I wouldn't necessarily make you do this, but if you really want to challenge yourself, you can delete line 13 here and try to do everything completely from scratch. Like I said, I'll leave this here just in case that's a little too much to bite off at this time. So see if you can build this all again from scratch. Let me refresh this so we start from a new spot. Of course, this is broken because some of the values are missing. Pause the screencast and see if you can bring this back to a working state. Okay, let's do this. I'll use things array and set things array as the values I get back from react.useState. I'll initialize my values with thing1 and thing2, and I need to spell things right. Then we will use set things array using the previous array. I could say previous things array or previous array. Maybe this time I'll be a little more generic and just say prev state. And this will return a new array that has all the items from prev state, as well as a new item, which says thing space, and then the number of prev state.length plus 1. Of course, if I leave this on the same line, I don't need to open curly braces and use the return keyword. Just in case this is bleeding a little bit long for anybody, I am going to put it back that way. And hopefully this didn't drive too many of you crazy. You can see I refresh and everything comes back. I also had taken this on click out. Sorry if that threw anybody for a loop. I'm going to add it back in and say when the button is clicked, I want you to run add item, which will run the set things array function and do all the stuff that we just typed in there. I'll hit save. Awesome, we're working again. I really hope that you attempted that challenge. I know that might have been difficult, but truthfully, that's where the learning happens. You won't be able to truly internalize these things that we're learning unless you put your hands on the keyboard and really challenge yourself. In fact, I would say that as you come to challenges in this course and really any course on Scrimba, if you don't immediately know the answer, don't just hit play. Go to Google, ask the community, go back to previous lessons in that course. Do whatever you can to try and figure it out on your own. And then, of course, if you are completely stuck, you can always hit play. In the next cast, we're going to see something similar, but working with objects in state instead of arrays in state. Now let's see what it looks like to use an object in state. Here we have a simple contact card. It's got a first name, last name, phone, email, and a property called isFavorite. To kick us off, I want you to see if you can figure out how you might fill in some of these values below instead of using the hard-coded values, using the properties from state. Of course, they will look exactly the same because I just copied and pasted these values from the state up above, but you can always test it by changing one of these values in state and seeing if it reflects on your card there. Pause the screencast and work on this challenge. Let's start with the name. We have the first name and last name together inside the same H2, but they're separated in the state up here. The simplest way to do that is simply to put the first name in its own set of curly braces, put a space, and then the last name in its own set of curly braces. Now, because my state is an object, I need to reference the entire contact and then use the dot syntax to access its properties. So I will say contact.firstname, and then the space, which will be interpreted as an actual space in the markup, followed by contact.lastname. Hit save. Nothing looks like it changes. That's good. If I change this to Jane, our contact changes. Great. And then I can simply do the same thing for these other properties. This is contact.phone and contact.email. Now, I mentioned that we're going to ignore the isFavorite property for now. I have another challenge that I'm going to type out now. You might notice in the images that we have two separate PNGs, one called star_empty PNG and one called star_filled PNG. Right now we're just using the star_empty PNG, but if this were filled, and let me comment this out so it doesn't break our code, you'll see that it fills in the star nicely as if this contact were a favorite of yours. However, following the declarative nature of React, we want the isFavorite property to be the determining factor as to which of those two images gets used. So your challenge is to use a ternary right here in this line, I'll uncomment this now, to look at the contact.isFavorite property and determine which of the following file names should be used based on the value of the isFavorite property. Then you'll want to use that star icon value, which will just be a string here, to figure out what the source should be for the star image. In fact, I'll add that to our challenge. Okay, best of luck. Pause the screencast, work on this part of the challenge. On line 21, I'll replace this comment and we'll simply look at contact.isFavorite. I technically could equate this to true or false, but because it's already a Boolean, I just need to say contact.isFavorite. If so, I want to use the star_filled PNG, and otherwise, I want to use the star_empty PNG. And now that I have a value for star icon, I can simply replace whatever is here with star icon. You'll notice I had put backticks here to begin with just to make things a little easier. That's because I knew you were going to be putting in an interpolated value like that. I'll go ahead and hit save. Everything looks the same, but now if I change my isFavorite from false to true in the hard-coded initial value, we get a little filled star. Now that we've learned how to apply state that's in the form of an object to our actual markup, in the next screencast, let's learn about how we can update state when state is an object. Our goal is to be able to click the star icon and have it flip our isFavorite value from true to false or false to true. However, currently our isFavorite property is nested inside of this object. When I call setContact, I need to provide a new version of state to replace the old version. However, in our case, I don't want to replace any of this other information. I only want to change the isFavorite value. Many people's first thought is to use setContact, and here you'll see I already have set up a toggle favorite function, which is called anytime the little star icon image is clicked. Right now it's just console logging toggle favorite. A temptation is to use setContact, look at the previous contact information, and return, and I guess for simplicity I'll put this on its own line, we'll say return an object where the isFavorite property is the opposite of the previous contact's isFavorite property. However, there is a major problem with doing it this way. I'm not going to hit refresh yet, but I do want you to pause the screencast and see if you can figure out what mistake I have right here. Remember that in this callback function, whatever I return from that function will become the new replacement for our contact state. Currently, I have an object with 5 properties, first name, last name, phone, email, and isFavorite. But what I'm replacing it with is an object that only has one property, isFavorite. So if I hit save and then click our toggle favorite, you'll see that all of our other information just disappears. However, it does look like our star is working. I can click our star and it is correctly flipping back and forth, but obviously this is a bug. If you do happen to be coming to this course having had experience in class-based React, this might seem confusing to you. If you've never worked with class-based React, you can ignore the next thing I'm about to say. But in class-based React, when you use this.setState, it would automatically figure out how to combine your old object with the new property that you're trying to replace it with. However, using hooks with React.useState no longer does this. Okay, everybody can tune back in now. The main point is that I need to make sure that I bring in all of the properties of my old object and then replace the 1 or 2 or however many properties you need to replace in what you're trying to accomplish. A very simple way for me to do that is to spread in all of the properties of my old contact. And in this case, I have access to the old contact using prev_contact. So I'll bring in all of the properties, and this, by the way, does include the isFavorite property, but then I will overwrite the isFavorite property with a new value. In effect, it's like taking this whole thing, copying it, pasting it in, just like this, where we have our old first name, old last name, old phone, old email, the old isFavorite, and then we're saying, actually, I want a different isFavorite. Believe it or not, this is not a syntax error. Instead, it just takes the second one that's declared, or rather the last one that's declared, and uses that as the actual value for our new object. This is much more verbose than it needs to be, so I will use my spread operator instead like I had before. I'll hit save. Notice this is filled in because my value is true by default. I should probably set that to false by default. And then when I click it, all of the other information stays the same except for the value of isFavorite, which is then redetermining which icon is going to be used based on that contact.isFavorite property. I totally understand that this can be complex. This was one of the more difficult things that I had to grasp when I was first learning how to do state in React. So to see if you were paying attention, this is your time to shine. Your challenge is to simply rebuild what we just had. Again, if you get stuck and you don't remember the syntax, don't just hit play and watch me do it. Open a new tab, do a quick query on Google, see if you can find a resource that will help you figure this out, or even go back earlier in the screencast and see how I did it so that you can then come back to this point and type it out yourself. So pause the screencast and see if you can rebuild our toggle favorite function. Okay, let's do it. We're calling setContact. We do care about the previous value of our state in order to help us determine the new one, not only because we need to know what the value of isFavorite was, but also because we want to make sure we maintain all of the other properties. So in that case, I'll use my callback function. I'll let it pass prev_contact to it, and I will use that to return a new object. And here's actually a quick aside. It might be tempting to say, well, I just want to use the implicit return and say, take this function, return an object. However, these curly braces are being interpreted as the opening part of the function body. If I do want to literally return an object, I need to surround my object with another set of parentheses. This looks a little bit crazy. Maybe just to show you that it works, I will leave it here, and for brevity, I suppose. So given our previous contact, I want to return an object that has all of the values of our previous contact, but changes the isFavorite value to the opposite of whatever it currently is. I'll hit save. It's empty by default because isFavorite is false, and I can toggle that on and off. I hope that challenge went well. If you felt like it was a struggle, then of course, as always, you can go back and try it again. As I've always said, the easiest way to learn something new is to do it the hard way. And I imagine some of you out there, when you saw me delete all of the code inside of here, maybe had a little panic moment and you thought, oh no, he's going to make me do this by myself. But your growth in understanding of React will only happen as you type this stuff out yourself. Watching me do it alone is not going to help you learn it. So as always, once you feel comfortable enough that you could write this out again all by yourself, that means that we're ready to move forward. When we last left the meme generator, we were getting a weird unknown error being thrown from React. I looked into it and I realized that it was because we were initializing state as an empty string and React was not taking too kindly to having our image source set as an empty string. So I just went and grabbed a placeholder image for now, and that seems to have gotten rid of the error. Just thought I'd give you a quick update on that error. Our challenge in this screencast is to update our state so that we can be well prepared as we learn more to save that state and ultimately finish our meme generator. So your challenge is to create an object in state. We'll call it meme, and it should have a property for the top text, bottom text, and the random image that we choose. You can default the top text and bottom text as empty strings, and I would default the random image to the string that I have below so that we don't get that same error we had before. Next, I want you to create a separate state variable called allMemeImages. This allMemeImages variable is going to hold an array of all of our memes data, which for now you can default to the memes data array that we imported up here. Then lastly, you'll want to update the rest of our code to use these new state variables so that in the end we have a working app the way that it's currently working. So pause the screencast and work on this challenge. Let's comment out our old state here, just so we don't get confused, and we'll create some new state with meme and set meme equal to react.useState. And this one's going to be an object, so I'll put my curly braces, and we'll put in our three properties. We have top text, which is an empty string, bottom text, also an empty string, and random image, which will be the same as what we had before in our old meme image state variable. Then we need another state variable, so we'll create a new one. We'll say this is all meme images. And we can say set all meme images as our function here, react.useState, and the initial value is going to be our memes data array that we imported above. With those set up, we really just need to update the rest of our code. So anywhere I was directly accessing memes data, I'm now going to use all meme images. And then we have a bit of a gotcha here. Before, when we were just saving the meme image as a string, we were able to just completely overwrite whatever the old string was and replace it with the new URL. However, now the random image, which represents our new version of meme image, is nested inside of an object. So first of all, we need to use set meme instead of set meme image. And instead of what we had before, we do need to look at what the previous meme was in order to determine the new one, because we have properties like top text and bottom text that we don't want to lose. I think I'm going to save this as its own variable, so I'll say URL equals the memes array at the index of random number.url, just to make my life a little bit easier. And now I'm going to access the previous meme and return an object. I'll surround it in parentheses so I can use my implicit return. We'll pull in all of the properties of the previous meme, and then we will alter the random image property to be our URL. Let's scroll down and see down here we have onClick get meme image. That's still going to be the same because that's our self-defined function. However, here instead of meme image, we want to say meme.randomImage. And let's cross our fingers. We'll hit refresh. I can click get a new meme image, and awesome, we're working just the way we were before. Obviously, our top text and our bottom text is not yet doing anything, but we're first going to have to learn about forms and inputs and how to save state, which will be happening later down the road. All right, awesome work. Let's keep moving forward. At this point, we've learned to use a number of really cool tools in React like state and props. Now we get to start using those tools in creative ways and putting them together. Your challenge here is honestly pretty contrived. I can't think of a reason why you would actually want to do this, but for the sake of practice, I want you to create a new component named count, which will essentially replace these 3 lines of code. In other words, you'll create a new component named count, it will render this div with this h1, and in an effort to practice props, we're going to pass that new count component a prop that we'll just generically call number. The value of that prop number should be the value of our current count. I promise this isn't just busy work. We are building toward a point. Pause the screencast and work on this challenge. Okay, I'm going to do this working backwards. So my div here, I'm going to cut this, but keep it in my clipboard so I can paste it later. And I'll render a component called count, which I obviously haven't yet created. We said we're going to pass to it a number prop, and I'm going to set that equal to the current value of my count up there. Now I need to import it if I'm going to use it here. Obviously it still doesn't exist, but we'll just pretend it does. So I'm going to import count from a file called count, and then I need to create that file and work over there. So I'm going to create count.js, import React from React, and I'll just spin up my basic component here called count. And I need to make sure that this is receiving props because I'm going to use that number prop. I'll have it return, and then I'm just going to paste that div that I had before. Okay, and now it doesn't have a count variable anywhere in here. Remember, before this was referencing the state value of count, but now I'm receiving it through props. So I can say props dot, and it's not props.count because the prop we passed to it was called number. Props.number. I'll hit refresh, and you can see everything is working exactly the way it was before. Now, as I mentioned, this is pretty contrived. I can't imagine why you would care to put a count component in its own component that just displays a number, especially when it's only 3 lines of code, unless for some reason you are going to be reusing this component in different contexts around your application. Let me clean up this challenge, and then we'll talk about why I had you do this. As I've mentioned, we've learned how to use props for a component to be able to receive values like we've done here. And we've learned state and how to have a component declare its own values that are intended to change and update the user interface when those changes happen. And now all we're doing is we're combining those two concepts. We are still initiating state inside of our app component, but then we're passing that state value down to a separate component called count, and it's receiving that value as props. Now we're going to see something cool that React does. Let me, inside of my app component, console log app component rendered. Anytime React creates an instance of our app component, which is happening here in index.js, it will run this function, and part of that function will console log app component rendered. Then we'll go ahead and do the exact same thing in the count component. And we'll change this to count component rendered. Now, before I hit refresh, as a reminder, the word rendered simply means that it placed the elements that React knew it needed to place on the screen. So when I say app component rendered, it means that it took the markup of our app component and it painted it to the screen, or it placed it on the screen. It created the DOM elements and the styles that it needed for it to display correctly on the screen. And you can see there's a sort of cascading effect here. Over in index.js, we render an app component. When we go to app, we see that it renders a count component, and it's doing that down the line. So it will first say app component rendered. I'll open the console and hit refresh. We see app component rendered and count component rendered. Now there's a really cool thing that React does for us, and that is whenever state changes, it will re-render the component where the state exists and any child components that may rely on state to be working correctly. And if you think about it, that makes sense. If I'm going to change my state from 0 to 1, I'm going to need my component here to re-render, which will then cause this count component to re-render, and it will pass the new value of count. And that way it can very quickly and seamlessly update what I see on the page just by re-rendering those components. We're not going to dive deep at this point into understanding exactly how React is re-rendering, which components it's re-rendering, and optimizing which components it's re-rendering. That's a topic for a more advanced course. But for now, it's a good experiment to have these console logs here and see that every single time we change our state, it's re-rendering the component in which the state is declared and any children components like our count component here that may or may not depend on the state value for count. Awesome. Now we've seen an example of a child component receiving a state value via props. Now we'll look at how a child component might be given access to make changes to its parent's state. Okay, here we are back at our little contact card with the favorite icon. Your challenge to start us off is to move the little star image, just this one little image element, into its own component, and maybe we'll just call it star. That'll be the name of the component. And it should receive a prop called isFilled that the star component will use to determine whether the icon should display the filled PNG or the empty PNG. Then inside of this component here, you'll need to import and render the new star component and make sure to pass the correct value of isFavorite, our contact.isFavorite, to that isFilled prop. At this point, it's not going to work the way it was before where we could click it and flip it on and off. For now, in order to test it, you can simply change this value from false to true, and it should, if it's working correctly, display the filled in star when you change that to true. There's a few different moving pieces here, so this is a slightly more difficult challenge than the ones we've done up until now, but I know you'll be able to do it. Pause the screencast now and start working on this challenge. Once again, I think I'll work backwards. I'm going to cut this image out, and I will render a star component, which I have not yet created. I'll give it this isFilled prop, and it will be the value of contact.isFavorite. Let's import this, and then we'll go and create it. So I'll import star from /star, and then I'll create that file star.js. Okay, and in this case, I need to make sure that I'm receiving props because I will need them. I'm going to return, and then this image element. I'm going to get to this on-click in just a second, but for now, let's figure out our star icon. I'm going to just set star icon equal to, and then I'm just going to go take exactly what I had here and then make a slight change. Okay, now we don't have access to our contact state because we're not passing it down. However, we do have a replacement isFilled, and that's part of props, so it's props.isFilled. And then this will determine which image should be used. Let me remove my onClick so I don't get an error. We'll hit refresh and see if we missed anything. Okay, awesome. Now my star is empty, and that's because this value is false. Let's test this by changing it to true, and the star is filled. Awesome. And at this point, I can remove this line because I'm not needing that anymore. And at this point, that leads us to the topic of this screencast, and that is, how do I make it so that I can change this value? Clicking it is not doing anything. The conundrum that we have is that we have a child component that's receiving the value of isFavorite through props, but it is not receiving the ability to change that state. So think for a second, how can I give my child component the ability to make changes to the state that lives inside the parent component, which is app? In fact, I want you to pause and try to think through a solution to this. You don't actually have to type it and try it out. but just try to think, how could I give my child component the ability to make changes to the state that lives in the parent? One thing that can be tricky when you're first learning React is the thought that you can just add a click event listener on your star component. So what if I just said onClick equals toggle favorite? Let me hit refresh and click this, and you'll see, well, it's not quite working. Why do you think that this isn't enough for this to work? Remember, when we have a component that we created, a custom component that we created, all of the properties that we pass it are custom properties. So simply putting onClick here doesn't magically register it as an event listener. The onClick attribute needs to exist on native DOM elements like these ones that begin with lowercase letters. That's because these are what will actually get created into real DOM elements by React. However, star with a capital S is not a real DOM element. Instead, what's happening is React is looking at the star component and it's rendering this image. This image has the ability to receive an onClick event listener. So what I could do is still pass onClick here, but realize that onClick is just a custom prop that happens to be called the same name as the event listener. In fact, oftentimes this will be changed to handleClick just to make it very obvious that it's not a native event listener. And then over in our star component, I can add a real onClick event listener and say the value of this onClick will be the function that comes from props.handleClick. In this case, my app component is passing this toggle favorite function to a child component and allowing that child component to run it whenever a certain event like the click event happens. However, it's important to note that the context in which the toggle favorite function exists is still here in the parent, which means that it can change the state that lives inside the parent. Let's hit refresh. We'll click our star and we see that we're back to working the way we thought. So as a recap, we created our toggle favorite function, we passed it to our custom component in a custom prop called handleClick, and then over in the star component, it's receiving props and it's registering a real event listener onClick whose functional value is the function that we received through props.handleClick. The ability to pass state setter functions like this one down to children components is especially crucial in React. And that's due to the fact that the way that React's hierarchy is set up when it passes data. And this is what we're going to talk about in the next lesson. At this point, I think it's worth taking a high-level look at how data is passed from one component to another in React. Let's imagine we have a fairly simple app which has the following components, just represented by rectangles for now. In this tree, this top component represents a top-level component, for example, our app component in a system set up like this. And the lines indicate that this top component is rendering these other components. In some cases, that component may just render regular DOM elements like divs and h1s, or it may render additional custom components like we see in this box where it's rendering two other components. I didn't put any names on here because that's not that terribly important. The point is that there is a parent-child relationship between these components. Let's imagine on one of these bottom-level components we initialize some state. And then we find that a sibling component, in other words, a component that is also rendered by the same parent, is in need of some of the data that lives in the other component's state. Well, what exactly can we do then? Think for a second, is there a way for us to pass that state to a sibling component? It turns out that no, this is not possible. And that's because if you look in the file of a component that has a sibling component, it has no reference or knowledge about a sibling component on its own. If we look in our code here, we have an app component that is rendering a header component and a body component. But if we were to go into, let's say, the header component, we see that I've initialized some state here. I can open up this preview so you see what we're working with. And it's using that state. But then if a sibling component like the body needs access to that state, well, the header has no idea that body even exists. Only its immediate parent, app, is the component that knows that both of these components exist. So think for a second, what is it that we need to do if we're facing a situation like this? Well, what if we took our state in this child component and we raised it up into the parent component? Now that it's up in the parent component, do we have a way in React to pass data from this parent component to the child components? Yes, we do. That happens through props. So now the parent component is in charge of the state. It passes the necessary state down to the child components that require it, and they can simply consume the state. If that state were ever to change, React will update this component where the state changed, and it will also update any children components as well. And so therefore, if that state changes that's being passed through props, the child component can update as well. As your application gets more and more complex, you will find yourself having another component that sometimes needs access to that state as well. And just like before, there's no way for us to pass the state or any kind of data from one sibling component to another component, but it's also important to note that there also is no way to pass data upwards in React. This child component has no idea that this other, I guess you could say, uncle or aunt component exists, and therefore there's no way to pass data that way either. So this brings us back to the same solution we had before. We simply raise state up a level, and we pass more props downward. Now, over time, this can get pretty tedious, especially if your state ends up raising up multiple levels above the component that needs it, in which case React does offer a solution to this called context. There's also third-party state management systems like Redux that can help solve this problem. However, both of those are beyond the scope of this course, and we are just going to be sticking with regular state and props for now. So that leads me to a challenge. I want you to take the state that currently exists only within the header and raise it up a level into the app component, and then pass it back down through props to both the header and the body. Then in the body, now that it's receiving the state from above, replace this underline with the state, which is the name of the user. Pause the screencast now and work on this challenge. To raise the state up, we'll simply take this line where we're initializing our state, and we'll move it into our app component. And then I will pass those props down. In this case, it's a very simple state of just the string Joe. So we will create a prop, maybe let's just call it user, and we'll set that equal to our user state variable here. Then in both the body and the header, we'll need to accept props, and we'll display props.user, and in the header, props.user. Clean up this challenge, hit refresh, and there we go. Now if I go to my app and I initialize my state differently, say Bob, and good, it updates in both places. Understanding that this is the way data flows in React can be really crucial in helping you architect your application in a way that you can share state amongst only the components that need it. And in fact, that's an important distinction to make at this point. It wouldn't be a great idea to initialize state way up near the top of your component if you don't have components along the entire tree that need it. Now, I'm not saying that every component needs to have access to that state for it to work, but if this component down here is the only one that needs state, there's no reason for me to put state in its parent or its grandparent and then pass stuff down through props. As a rule of thumb, keep state as local as you can, or in other words, keep it as closely tied to the component or components that need it as you possibly can. With this under our belts, I think it's about time for us to jump in and do a round of challenges to really exercise what you've learned up until this point, and we will start that in the next screencast. This is the beginning of a series of small challenges to really reinforce some of the past topics that we've been learning about. The first thing I want you to do is to take a look at boxes.js. You'll see I created an array of objects which have two properties, ID and on. And your first challenge is to initialize some state inside of our app component with the default value being this boxes array. And then I want you to map over that state array and display each one as just an empty square on the screen with a black border and a transparent background color. I don't think you necessarily have to set it as transparent. I think it'll just be transparent by default. For now, don't worry about using the on property at all, although you probably will want to use the ID property, and I'll let you figure out why. If you're using something like a div, don't forget to set a height and a width in the style on it. Ultimately, the goal is to make it so that if the box is set to on or on as true, then the box will be filled in with a color, and in the end, we'll make it so that clicking the box will flip its on value from true to false or false to true. But for now, let's just get some boxes displaying on the page, pause the screencast, and work on this first part of the challenge. We'll start by initializing some state. So I'll say, I don't know, maybe for now we'll just call them squares. And by convention, we'll say set squares. That's going to be from react.useState, and we'll pull in the boxes as the initial value. Then we need to map over the boxes. I'll save my array of elements. I'll maybe call it square elements. And that's going to be squares.map. For each square that we're looking at, I want to return a div. And notice here that I'm using parentheses instead of curly braces. That's simply allowing me to use the implicit return to return the element, and I'm just moving it onto its own line so it doesn't go too far to the left and right. We'll give this div a class name. Let's call it box. And actually, this is a class name, so it can just be the string box. I also know because I'm mapping that I'm going to run into that issue where I need to provide a key. In this case, I can use the ID property that's coming from each of these objects. Let's display our square elements, and then we'll go into the style so that it will actually show up. Or rather, I should say, let's render our square elements. I don't think they are going to look like anything on the screen. Yeah, it's just empty. Over in our style, we'll set a style for box. And we'll give it a height. Maybe we'll do 100 pixels and a width of 100 pixels. We'll give it a border that's black. And then maybe just so we can see everything, I'll put these into a really simple grid just so that I can put them side by side a little better. Actually, I might not even bother with that. Let me give these a display of inline block. And I'll just put a little bit of margin right on them. Honestly, this is going to be good enough for right now. And awesome. Okay. The main things that I wanted you to take away were to practice setting state or initializing some state, and also practicing the .map method to create an array of elements that we can display on the page, as well as reminding you about this key property. If I take this out, I'm going to get that warning that React always gives if you use a .map to create elements but forget to add a key prop. So I will put that back in. Awesome work. On the next cast, let's do the next part of this challenge. Before we can do the next challenge, we need to learn about the style prop. You might be familiar with the concept that in HTML, I can add an attribute called style, and in here, I can insert CSS code. For example, I could give my div with the ID of root, or actually, you know what, let's do this on the body. I could add a style and say the background color is black. Hit refresh, and sure enough, my entire background color becomes black. Just like I can do this in HTML, I can do the exact same thing in React. However, because it's React and it's JavaScript, I can change the style dynamically depending on, for example, the value of our state or the value of incoming props on a component. Let me refresh this so we get our boxes back. And actually, I think I might just add a tiny bit of border radius to those boxes. Okay. To add dynamic style, I can add a style prop to my div. And in React, I'm not going to put a string the same way we did in HTML. Instead, I'm going to provide an object. Now, here's something that really confused me the first few times I saw it. This set of curly braces does not represent an object. It simply represents me entering into JavaScript outside of JSX, or rather it allows me to put JavaScript inside of my JSX, as we've learned before. Since I need to represent my style as an object, I'm going to put a second set of curly braces. This inner set of curly braces represents an object, a JavaScript object, and this first set of curly braces, or the outside set of curly braces, represents me going into JavaScript from JSX. Oftentimes, to avoid any confusion, what I'll do is I will not define that object directly inside of my markup, but instead I will create a separate variable, maybe called styles, and set that equal to an object. This makes it a lot more clear, and I can just put styles directly inside of my markup here. One thing to know about these styles is that they need to be camel cased. So if I'm changing the background color, I can't say background-color because this is not a valid key name in a JavaScript object. Not only that, but when I'm modifying the properties of a DOM element, you might remember that I could do something like document.getElementById, we'll say some kind of ID, and I can say .style, .backgroundColor with a camel-cased property name, and set that equal to something. Essentially, that's exactly what we're doing here. We are setting the style attribute of our DOM element to be an object, hence I can use the dot syntax here, and then I'm using the background color CSS property, but of course in the camel-cased version for JavaScript. Then because this is an object, I'm not going to use the equal sign, I'm going to use the colon to give my key a value, and I don't know, let's set it to black for now. Let me get rid of this equals so that, actually let me get rid of that whole line since I don't want to be doing manual DOM JavaScript here. Oh cool, look, I refreshed. My styles, which include a background color of black, are now being applied as the style of every square that I'm rendering, or every div that I'm rendering. So why is this beneficial over just using CSS? Well, because I'm using JavaScript, I don't necessarily have to have a hard-coded black value here. Let's suppose for a second that my app component is going to receive a prop that's called dark mode. In fact, let's go over to index.js and we will say that the app component is receiving a prop called dark mode, and let's set it to true for now. Over in my app, I'm accepting props here, and I will have a prop called props.darkMode. And let's say that if my props.darkMode is true, I want it to be black, and if it's false, I want it to be, I don't know, something light. Well, this is something I can use a ternary for, and maybe I should be more specific. This is something that you can use a ternary for. Using your knowledge of ternaries, make it so that if props.darkMode is true, it will set the background color to this hex value here, and if it's false, it will set it to this hex value here. One important thing to note is that these values need to be strings because we're in JavaScript, we're not in CSS. Pause now and work on this challenge. Let's take props.darkMode and we will put it here. And I'll say if that's true, then I'm going to use this string. And if it's false, I'm going to use this string. And it looks like I might have deleted my curly brace there. Okay, awesome. Now we can test this by simply changing my dark mode value from true to false. And awesome, look at that, it worked great. This can be a really fun one to play around with. If you'd like, you can pause and just play around with some of the other properties that we can change in the styles. Or you could try a little challenge of your own to see if the number of squares in this array is even, then make them all one color, or if it's odd, make them all another color. Really, your imagination is the limit here. When you're ready, we will move on to part 2 of our original challenge. It's time for part 2 of this challenge. I want you to move our div here into a separate component called box. And then when you're mapping over our squares, you will render that box component. That box component should receive a prop called on, and it will be the value of this square dot on. From our original boxes.js, each one of them has an on property, and that value is what you're going to pass to your new box component. Then inside of that box component, I want you to create a dynamic style like we did in the last screencast to determine the background color of the box. If the box is on, then you should set the background color to this hex value. And if it's off, you can just set it to the string none. Pause the screencast and work on this challenge. Let me create a new file called box.js. I'll set this up like normal. I know that this component will be receiving props, and I'm just going to copy this div and have that get returned. Now my key is going to be broken, and actually I'm going to pass this key into the box component. So let's go ahead and render our box component, which will be self-closing. This class name is already handled on the div that box is rendering. However, I will keep the key right here. The next part says to pass it a prop called on. So I'll say on equals, and then the value will be square.on. Again, each square here represents one of the objects in my array, and that has a property called on. Let's just make sure that everything is working so far. In my box component, I will console log props.on. And because I have 6 instances, I should get 6 values here. Oh, and of course, I did not import my box component, so I need to import box from box. Okay, let's try that again. Awesome. Okay, so I get my 6 values, true, false, true, true, false, false, and that's matching perfectly with what I see in my data here. Then the last part of this challenge is simply to make use of props.on to determine what the hex value or the background color should actually be. So using dynamic styles, I will create a variable called styles, and that's going to be an object where the background color is going to look at props.on, and if it's true, it will be this dark color, and if it's false, it will be none. Then I can simply add a style prop. Notice that my variable is called styles. You really can call this whatever you want. However, this attribute or this property needs to be style exactly that way. So I'll set that equal to the object that I created above. And I think I should see this one is dark. It was true, false, true, true, false, false. So this one should be dark, this one, and this one should be dark, and the rest should be clear. And that's exactly what we get. Next, we're approaching probably the most challenging part, and that is where clicking the box will actually flip the on value from true to false or false to true. I'll give you some hand-holding in that challenge, but honestly, it's going to be a pretty fun one, so that's what we will work on in the next lesson. In the next 2 challenges, we are actually going to be starting to dip our toes into some intermediate React topics here. The concept of changing state is what we have been practicing this whole time. However, we're going to see 2 different ways that we could structure this project and talk about which one is going to be the better of the 2. I put together a little diagram to make this a little simpler to understand. Right now we have an app component, and this app component is keeping track of an array of data. We're then using that array to create box components for every item in that array, and passing to those box components a prop called on, which will have the value either true or false. Currently, those box components are then taking this incoming prop and determining what the background color should be. However, at this point in time, they have no way to modify that incoming prop. Keep in mind that in reality, a component should never modify props. In other words, my box component should never say props.on equals something different. However, we do have some ways that we can still make changes to the background color of our box, and that's what we're going to be talking about. The first way we're going to see is to initialize new state in each one of these box components and set its initial value to the incoming props.on value. One benefit in doing it this way is the simplicity in allowing each box to then update its own state. Of course, by doing so, automatically every instance of our box component will also have the ability to update its own state. When I first started learning React, this was the most obvious way to allow each of these boxes the ability to flip its own value. And so that's what your challenge is this time. I want you to create some state inside of our box component. You'll determine its initial value based on the props.on value. You'll also create an event listener so that when the div of the box gets clicked, it can flip the value from true to false or false to true. While you're at it, don't forget to update your styles here in this ternary. Currently, it's looking at props.on. You'll want to make sure that you're looking at the local state instead of the incoming value of props.on. And the last thing is a quick change I made. In the previous screencast, I had set this to none, but it turns out this should actually be transparent if I want this to empty out the color. So don't let that be confusing. Okay, this is your time. Pause the screencast and work on this challenge. In truth, this is very similar to what we have already done so far. I'll initialize some new state. We'll call it on, and it will also receive our setter function, which I'll call setOn, by calling react.useState. The initial value should be determined by looking at props.on. I'm going to update this to not look at props.on anymore, but to look at my new state value of on. And that way, when I make a function, let's call it toggle, and it calls setOn looking at the previous version of on and simply giving me the opposite of whatever that previous version of on was, I can then set this up as a click event listener to run toggle. Should be able to clean this challenge up, hit refresh, and sure enough, I'm able to flip the value. Now it's not readily apparent, but keep in mind that what we've done is we've given each one of these boxes its own value of state. So basically, we've given it the ability to control itself. We've given it the control over its on value. Now, I understand the boxes seems a little bit contrived. However, this same concept would apply to something like a to-do list, for example. Our app would be like the to-do list, and each of these boxes would be like a to-do item. The value of on might be replaced with a value called maybe completed as to whether or not that to-do item has been completed. Structuring it the way that we just did here, every item in our to-do list would be in charge of knowing if it by itself has already been completed or not. When I first started writing React, this seemed like the most obvious thing to do. However, I've since learned that there actually is a better way to structure our application so that state is only held in the app component in our example here. There certainly might be situations where creating state in each one of the child components and initializing that state based on the incoming props might make sense. However, general consensus is that if you find yourself initializing state by using the incoming value of some prop, there's probably a better way to do this. And that's what we'll be diving into in the next lesson. Previously, what we did is we created new state inside each of our box components and initialized that state based on the incoming prop of on. And it turns out there's actually a name for when you create state that is initialized by incoming props. And it's called derived state. And I'm sorry to break this to you, but it turns out that you probably don't need derived state. This is an article that was written in 2018. You can click on the link. It's in the React documentation. It will probably get a little bit heavy if you're still a beginner in React, but it turns out that there can be some weirdness that happens if you pass a prop to a component and then just take that prop and set state based on that prop. If you think about it, in app.js, we actually created some state in app.js to maintain all of the squares already. So when we set state in each one of our boxes, we had state both in the app and in every one of our boxes, which in the end means that there are two sources of truth. When the box had the ability to update its own state, it was not updating the state on the app component. It was only updating its local state that it had derived based on the incoming props. And because of that, there were multiple sources of truth. Now, certainly there are circumstances where derived state makes sense. This article does talk about some examples of that. However, it's far less common than I think most people end up using when they're writing React applications. And the whole reason I decided to talk about this in this course is to help you navigate a scenario that, at least for me, was really tricky when I was learning. So we're going to approach this in a different way. Instead of putting state and a setter inside of each one of our boxes, we're going to make use of the state that already exists in our app. And instead, we're going to create a function called toggle inside of our app component, and then pass that toggle function down to each one of our box instances. Anytime one of the box components gets clicked, it will run this toggle function and essentially tell the app component, hey, the state that you're maintaining needs to change. Then when that state changes, let's say this first object gets clicked and it changes from true to false, React will re-render the app component because its state has changed, and therefore will re-render the box components, but now with the first one having an on value of false. You certainly are going to notice that this way of doing things is more complex. However, in the end, it is a better practice than using derived state to manage our state. Because of the additional complexity, I'm going to give you a challenge that has you doing part of this, and then we're going to walk through completing it together. So let's go ahead and get started. The challenge is for you to create that toggle function that for now is just going to log clicked to the console. Then I want you to pass that function down to each of the box components and set it up so that when they get clicked, it simply runs the function, which means it will console log clicked. I've already removed the state from our box component, so that isn't something you have to worry about. Pause the screencast and work on this challenge. Okay, let's create a function called toggle. Simply enough, it's going to console log clicked. Then we're going to pass that function to each one of our boxes. We can choose the prop name we want. Sometimes I'll use what looks like the onClick event handler, but keep in mind that because this is a custom component, it won't automatically register this as an event listener. I think more often I'll choose something like handle click that makes it very clear that I'm talking about handling an event. However, I also could just give it the name of the function. Really, we can do whatever we want here. Let's stick with toggle for now, and we'll pass down the toggle function. And now inside of box.js, I'm receiving a prop called toggle, and this is where it does need to be on click with the capital C. We'll use props.toggle. I'll hit save, and clicking it, awesome, runs the function that we defined. This is the point where some additional complexity needs to be added in order for this to work correctly. When each box was initializing its own state, it was really simple to know which box was flipping its value because, well, each box was maintaining its own state. However, now with our toggle function, the toggle function has no idea which box just ran its code. So in my app component, if I wanted to use set squares, because squares is an array, I need to figure out which of the items in the array triggered set squares so that I can update the correct one and leave all the other ones exactly how they were. And this is where we are essentially forced to do something a bit clever. And I figured at this point it would be better for me to walk you through some examples of how we might solve this problem. Let me clean up our challenge. Our goal is to give the toggle function the ability to know which box was clicked so that we can correctly update the state array. One way we could do that is to make it so that the toggle function takes the ID of the box as a parameter. However, as it's currently set up, this is not going to work. And that's because in our onClick here, we really don't get to decide what parameter gets passed to our function. Every browser will pass an event handler function, the event itself. It's an event object that describes a bunch of information about the event. In fact, I can see that really quick. Here I will, instead of console logging clicked, let's console log ID, which we're going to be disappointed in what actually happens. I'll hit save, click a box, and you'll see I get a synthetic base event, clearly not the ID of the box that was clicked. However, we can work around this by, instead of just blindly running props.toggle, we can run our own function, which then runs props.toggle. This is the function that is going to receive the event. However, we're not going to make use of that, so I'll just delete event. And then this function can run props.toggle, and now we have the ability to pass whatever we want here. In this case, what we should pass is the ID of this box. However, currently we're not receiving that ID. Sure, I have this key prop. However, the key prop really is intended for something completely different, and I'm fairly certain that if I even tried to access that key prop, let's console log props.key, yeah, I'm going to get a bunch of undefineds. I don't have access to props.key inside of this component. But that doesn't stop me from passing another prop, let's call it ID, and it essentially is the exact same thing. Now I do have access inside of box to props.id. So if I console log props.id, I get the IDs of each of the boxes. And now I can use props.id to pass that information, pass the ID to my toggle function. Now over in app.js, if I console log the ID that's coming in, of course this will only run when I click it. Let me click the very first box, and that is my ID of 1. This one should be 2, 3, 4, 5, and 6. Awesome. This is great news because now I can use that ID to update the correct square in my setSquares function. At this point, I think this is something that you'll be able to do as a challenge. This lesson's getting a bit long, so that's what we'll do in the next lesson. I'll admit right now, this challenge is going to be a little bit tricky. Your goal is to use our setSquares function to update the correct square in the array. Remember, we're receiving the ID and we just want to flip its on value from true to false or false to true. However, the trick is to not change state directly. As a hint, you could go back to the lesson on how we updated arrays in state if you need a reminder on how to do this. However, in that lesson, we mostly just touched on adding new items to that array. In this case, we're not adding new items, we are updating one of the existing items. At this point, it might be tempting to use an array method like splice. However, that is going to directly modify your state because splice alters the array that it's run on. So don't let any of that scare you. I really want you to try your very best to do this. If after maybe 20 minutes you're still struggling on figuring this out, you can always just hit play and we will walk through this together. So let's have at it. Pause the screencast and work on this challenge. Okay, we'll use our setSquares function. As usual, we do need access to our old version of squares in order to determine the new value of our squares. So I'm going to say previous squares. And instead of getting really clever and figuring out a way to do this on a single line, I'm just going to open up this function so we have some breathing room to create variables and do whatever we need. In fact, let me solve this in maybe the least clever way I can think of. I'm going to create a new array. We'll say new squares. I'll set that equal to an empty array, and I'll do a very simple C-style for loop. We'll say let I equals 0, I is less than previous squares.length, I++. And my goal here is to look at each square in the array of squares, and if its ID is equal to the ID that our toggle function got, then we will simply flip the on value to the opposite of whatever it currently is. If we are looking at a square that is not the one with this ID, then we'll simply push that to our new squares array. So let's say our current square is the array of previous squares at the index of I. And now I'll say if our current square that we're looking at has an ID that's equal to the ID given to our function, then I'll say maybe updated square is equal to an object that has all the properties of my current square, except the on property is going to be the opposite of my current square.on. And then I have this new object, and I will push that to my new squares array. So I'll say new squares.push updated square. However, if the ID is not the same, so I'll say else, we're just going to simply push the current square to our new squares array. At the end of this for loop, we should end up with an array that looks almost identical to the original array, prev squares. However, one of the items should have a flipped value for its on property. And so we can see this is getting a little bit long, but there's my for loop. At the end, we'll simply return, because that's what we need to do from our setSquares function, is return the new value of state. We'll return our new squares array. To be totally honest, I haven't tested this out. Let's hit refresh, see if this works. Oh, look at that. Awesome. Let's walk through exactly what this is doing. Let me clean up my challenge to buy us some room here. Every time I click on one of these squares, it's running the click event handler that we defined here. That click event handler is running the toggle function that it received through props and passing in the ID that it also received through props. That toggle function is taking that ID, running setSquares, and running this function to determine what the new square should be. We look at the previous array of squares and simply generate a new array, loop over the previous array, and when we run into the square in our loop where the ID matches the ID passed into toggle, we create a new object that will replace the old object and push that to our array. If the IDs do not match, we just push the current square in its current form without any changes made to our new array, and we return that. By returning this new array, React will update our squares state array, which means that it will then re-render this component, remap over all of our squares, and create 6 new box components, pass the on value, which was the same in 5 of the squares but different in 1 of them, and then in our box component, it will simply take that prop and determine what the background color should be. All of that seems really complex. I totally understand that, but you can see it's quick and there really is no lag in doing this at all. At this point, we could just move on from this. Let's say it's a feature we're adding to some app we're creating. However, as we've learned, React really adheres to the principle of writing declarative code. What we have here is very imperative. Doing a C-style for loop this way works perfectly without any problem. So if you're happy with this, you can just move on. But I think it might be worth our time to take a look at how we might write this slightly differently using something a little more declarative instead of imperative. So that's what we'll do in the next lesson. I'm not going to bother making this a challenge this time. I think I'll just walk you through how I oftentimes will update an item in an array using a more declarative method instead of using a C-style for loop like we have here. So let me go ahead and just delete everything inside. And I think what I'll do is use the .map method to help me create a new array and return that array all in one go. So I can say return the previous squares.map, and whatever I put into my map function here is going to help determine my new version of the array, which then gets returned from my .map and returned from setSquares. This is a lot of returns happening all in one, but let's just see how I would do this. I need to look at each square inside of my map, and whatever I return from this callback function inside of my .map is what will get placed at the same index in my original array in the new array that I return. So what if I were to use a ternary that said, does square.id match the ID passed into my toggle function? If so, I want you to return a new object that has all of the properties of square except for the on property, which is the opposite of square.on. However, if the ID does not match, that's my else here, then I can simply return the square. The only thing I'm missing now is the return keyword. I tried to leave it out in the beginning because these two returns can be a little confusing at first. So fingers crossed, let's hit save, and look at that, everything is updating beautifully. Obviously what we have here is a lot more concise in terms of lines of code, but it does require a bit more of an advanced understanding of JavaScript to fully comprehend. In my experience, what I have here is not so clever that other software engineers would not understand it, and therefore I personally would prefer a solution that looks more like this. I would definitely spend some additional time understanding this if this is confusing, but I will walk us through it one more time. Every time box gets clicked, it runs this function, not just props.toggle, but this function that we've defined inline here. That function will run props.toggle. Remember, we did that so we could pass a parameter, a custom parameter to props.toggle, which we decided to be the ID of the box itself. Then if we go over to the toggle function, it will call setSquares, our state setter function, and we need to use the callback function version of setSquares because we do care what the previous array looked like. So we look at the previous squares and we're going to map over those squares. As a reminder, .map returns a new array without modifying the original array that will have the same length as the original array, and whatever we return from the callback function of .map is what will get placed in the same index in the new array as what was in the original array. What we're doing every time we loop over an item in this array is we're checking if its ID matches the ID. This ID here is the ID that we passed into our toggle function. If those IDs match, then that means it is the square that was clicked. If that's true, then I want to replace the old object with a brand new object, which is why I have these curly braces here. And this is crucial so that I'm not updating state directly. This object is going to pull in all of the values of square exactly as it was, but then it's going to overwrite the on value with its opposite. However, if this is not the box that was clicked, then just give me the old square. In this case, because I'm not making any modifications to it, I don't need to create a new object and spread in the old square or anything like that. I can just hand the old square object directly to my new array. Awesome work. I really hope you were able to follow along with that logic. This truly is something that just takes a lot of practice. At this point, one of the very best things you could do is just delete our toggle function completely and try to recreate it from scratch. In the end, this toggle function is the most complex part of what we have here, so that would be a great place to start if you really want to challenge yourself. I did want to show you one other rather clever solution that we could use instead of passing an ID down to the box, and that is that we could just say our toggle function that we're passing down, just like we did inside of our box, is going to be an individualized toggle function, this entire function here. However, we can pass the square.id immediately as we're passing this toggle function down. In essence, this creates something called a closure, where each instance of our box will have its own toggle and it will remember its own ID, which means I can get rid of this ID prop, and over in box, I can change this back to just toggle, or rather props.toggle. If I hit refresh, we can see that it's working exactly like it was before. Again, awesome work. I really hope that as you have followed me in this mini series on setting state and creating this rather silly little app, that you have worked on the challenges that I've given you. If you haven't, it's not too late. Don't just push forward. Go back and work on these challenges. Make sure that you really understand everything that we've done so far. Pushing forward without understanding this is not going to help you. It's only going to make it harder going forward. Spend the time now to really clarify these things. Ask questions in the Scrimba Discord, and then when you really understand it, you can be happy knowing that you are ready to move forward. Okay, well, this might look familiar. This is our joke component from the previous section, and we're going to use this to kick off a sort of mini-series on learning about conditional rendering in React. Using and understanding conditional rendering is very important in React because you will see it everywhere in React code. To start us off, I have a challenge for you. You're going to create some state called isShown. Its value will be a Boolean, and you'll just default it to false. The idea is for it to be a piece of state that will decide whether or not the punchline should be shown in each of these jokes. And then I want you to add a button, probably just right here below the paragraph, that will toggle that isShown value back and forth. Pause the screencast and work on this challenge. At the top of my component, I'll have my state called isShown and set isShown. That'll equal react.useState. The default value will be false. And then we'll add a button. Let's have this say show punchline. Then let's create a function that will help us toggle our value back and forth. We'll just call it toggle shown. And all it's going to do is run set isShown. We do need to know what the previous value of isShown was, so I'll say prev shown. And that way we can return the opposite of prev shown. That'll just flip it from true to false or false to true. And let's add our onClick event listener here to run toggle shown. While we're at it, I'll go ahead and console log the current value of isShown. And when I click show punchline, okay, now you'll notice that it said false, even though I'm flipping it. That's because it first console logged isShown, which initialized as false, and then I called set isShown. If I click it again, I'll see the old value right before it got changed. This console log's not terribly important anyway, so we'll take it out. One of the reasons I use this joke component to help us learn conditional rendering is, well, I used it already as a way to give you a sneak peek into conditional rendering. Since we have a template here already, even though this might seem a little backwards, I want you to make it so that our paragraph here only shows up if isShown is true. Again, you have a template to help you understand how that works, and then once you have that working, we'll talk through the logic and really fully understand exactly what's going on. Let me update our challenge text here. Okay, make it so that this paragraph only displays if the isShown boolean is true. Pause the screencast and work on this challenge. Well, as we see here, what we did is we surrounded everything in curly braces, and that allows us to put a JavaScript expression in here. In our case, we're going to say if isShown is true and this paragraph. First, let's see if this is working. Okay, all of our paragraphs, our punchlines are gone. And if I click Show Punchline, awesome, our paragraph displays. Now, why on earth does this work? When you first learn JavaScript, we usually learn about how this AND logical operator, the double ampersand, is used to make sure that both sides are true or truthy. So let's say you have a couple variables. We'll say condition 1, we'll call it true, and condition 2, let's say that's also true. And if you have an if statement that says if condition 1 and condition 2, meaning if both of those are true or truthy, then the code inside this code will run. We also learned that if either one of these are falsy or false, so if I change either one to false, this code will not run. However, if we look deeper into how the computer is actually running this code, it can be very enlightening. For example, let me change condition 2 to a console log statement. This is kind of a strange thing. You're not really going to see this in the real world, but it's just to prove a point. We'll say, hello there. Let me open the console, and I'm going to click Save, and we'll see that we immediately get the console log running of hello there. Now, let's see what happens if I change condition 1 to false. I'll hit Save, and nothing gets console logged. That's because what the computer does is it first checks the truthiness of this first statement, and if it is not truthy, if it's false or falsy, it actually completely skips whatever it sees after the double ampersands. Since it already knows that this condition will not satisfy what the AND is expecting, in other words, for both sides to be truthy, it knows already that it can completely skip whatever it sees here. So we can take advantage of this in React anytime we have an element on the screen that we want to display if something is true, or completely hide or not even render to the page if that thing is false. Here with the setup, we realized that some jokes were just one-liners. They didn't have a setup and a punchline, they just were the punchline. And in that case, we looked at our incoming props.setup and said, if that's falsy, then don't display this h3 at all. Similarly, with our local state of isShown, we can say, I only want to display or render this paragraph if isShown is true. By doing that, we can have a toggle button that when it's clicked will change isShown of this individual joke component to true, and therefore it will display our paragraph. More specifically, when I click this button, React will re-render this component because its state has changed, and therefore when it's running the return value again and determining what should actually be placed on the screen, isShown is now true, and therefore this expression gets run and put onto the page for us. So as a recap, in React, when you have an element that you either want to display or not display at all, using the AND logical operator is a really concise and great way to do that. This challenge is a pretty straightforward one. Based on what you just learned using the AND logical operator, make it so that this h1 will only display if our array of messages is not empty. If this array is empty, then this h1 should not display at all, and we should end up with a blank page. While you're at it, go ahead and fix our little underline for the number of unread messages we have in our array. Pause the screencast and work on this challenge. Well, first let's replace this underline. We can put in a set of curly braces and simply say messages.length. Okay, that's a good start. Now, if we're deciding whether we want to display this at all or not, then we can use the logical AND operator to say messages.length is greater than 0 and display this h1. That way, if messages.length is greater than 0 is a false statement, in other words, if messages.length is equal to 0, then this h1 will simply not render at all. A more concise way might be to just say messages.length and this h1, and that's because the number 0 is considered a falsy statement. However, I think it reads a little better to be explicit and say the greater than 0 there. Sometimes if this line gets a little bit long, you can break it out onto its own line, something like this. And we can test this by emptying our initial state array. And there we go, we have nothing on the screen. Awesome work. Next, we're going to see another method for doing conditional rendering in React. We have a funny UI bug right now. When we click Show Punchline, it shows the punchline, but the button still says Show Punchline. Knowing what you know so far using the AND operator to conditionally render something, I want you to think for a second, how might you change it so that it says Hide Punchline instead of Show Punchline when the punchline is shown? One thing we could do is make a copy of this button and display them at different times. So I'll do my similar conditional rendering and say if is shown is true, then I want this to say hide punchline. And if is shown is false, or if not is shown, then I want this to say show punchline. Technically, this will work. So it says show punchline, and then it changes to hide punchline. However, we can do better than this, and we can do so by using the ternary operator. The ternary is really helpful when you want to display one thing based on a condition, or another thing if that condition is falsy. So instead of duplicating our button, I can keep my button here and simply change the word from show to hide using a ternary. Let me show you what that looks like. I'm going to delete the word show, put in a set of curly braces because I want to use JavaScript now, and we're going to use a ternary looking at the Boolean value is shown, and I'll say is shown question mark. Now if is shown is true, then I want the string hide to be displayed at this point in the button. Otherwise, I want it to say show. I hit save. It's showing show punchline, and when I click it, it changes it to hide punchline. As far as conditional rendering goes, probably 95% of the time you will see conditional rendering handled with either the double ampersand or a ternary. Again, the double ampersand is great if you either want something to display or not display, and the ternary is great if you want to choose between one of two things to display. If your conditions are more complex than just having one of two options to display, usually it'll be best just to turn to a regular old if statement as we have seen in the past. You can save a variable for your text and do either a switch statement or a series of if, else statements to determine what that variable should be, and then just display it in your return down here below. Since we've already seen what that looks like in the past, I'm not going to cover it now. I mostly just wanted to look at these two methods for conditionally rendering something in React. Now that we've learned that, let's get a quick practice in. Let's do some conditional rendering practice. One thing I've done with our messages app is I changed this to just say messages instead of num messages because, well, that just makes more sense because this is an array of messages, not a number of messages. Anyway, your challenge is to display the correct thing on the page. If there are no unread messages, it should display you're all caught up. And if there are any messages in the array, it should display you have n unread messages, where n represents the length of the array or the number of messages in that array. As a caveat though, notice I put this parenthesis s here. That's not literally the text parenthesis s. Instead, I want you to, if there is exactly one unread message, put the word message there instead of messages. So pause the screencast and work on this challenge. There certainly is more than one way to accomplish this. For example, I could always render an H1 and then use a ternary inside for the text of that H1. For some reason, that doesn't sit quite right with me. I'm honestly not sure why, but I think the way that I would choose to do this is just to open my curly braces, look at the messages.length, and say if that is exactly equal to 0, and here I'm going to use a ternary, so I'll start a question mark. On the next line, this will be what should display in case there is exactly 0 messages. So I'll do an H1 here and say you're all caught up. Otherwise, I'll put a different H1 that says you have, and let me just put the number hard-coded here for a second, unread messages. Okay, I'll replace this 2 with messages.length. And well, let's see where we are right now. I'll hit save. You have 2 unread messages. If I remove the items from the array, you're all caught up. Awesome. At this point, it might be tempting to do some kind of nested ternary here that says if messages.length is exactly equal to 1 and put another ternary as the else of this first ternary. Personally, I think this is nearly impossible to reason about, and so I never do nested ternaries myself. I suppose one thing I could do is just render this s if messages.length is greater than 1. I think that would look something like this. I would put message and then a set of curly braces and put in my JavaScript here that says messages.length is greater than 1 and the string s. Let's just see if that works. Personally, I don't love this solution. I'll add in a couple items here. Okay, we have 2 unread messages, and if there's only 1 item, okay, you have 1 unread message. However, when I look at this, it's not quite as clear as what I think I would prefer to do, and that is to type out the whole word message or messages and use a ternary. Let me show you what that would look like. You have blank, unread, and then I will open up some JavaScript here and say, is messages.length greater than 1? If so, I want it to say messages, but otherwise I just want it to say message. I'm going to put this onto its own line just so we have some extra space. And although this does take up more characters, I think, than what I had before, to me this is a lot easier if I have a fellow developer who's going to be coming onto this project and needs to understand what I'm doing here. I think this is easier to reason about and understand. As you can see, there are multiple ways to use conditional rendering, and this is the kind of thing that I'm talking about when we say that React is just JavaScript. Just like in JavaScript where there's multiple ways to solve a single problem, it's the exact same in React. Because you're just using JavaScript, like ternaries and the logical AND operator and so forth, you truly could solve this in probably dozens of different ways. Most people will tell you to find a way that is easy to think about in the future, and then to stay consistent throughout your entire code base. Let's go ahead and test this before we call it a good solution. And yeah, see, I need a space there, so we'll put an extra space in there. Oh, and I guess breaking this onto its own line might not have worked. So let's just leave it like that. Okay, 1 unread message and 2 unread messages. Awesome work. When you're ready, let's keep moving forward. It's that time again for another quiz. Pause the screencast, click into the editor, type your answers down, and when you are satisfied with your answers, click play and we'll go through the quiz together. Number 1, what is conditional rendering? Conditional rendering is just a way to determine whether or not something should get displayed, or, as we're going to see, what among many choices should get displayed. Unlike a regular HTML page, which will always display whatever you hard-coded into the HTML, with React we can use conditional rendering to sometimes not display that thing, or to sometimes display one thing instead of another. So conditional rendering is when we want to only sometimes display something on the page, usually based on some sort of condition. Or maybe I should say always based on some sort of condition. So far we've learned a few different ways to handle conditional rendering. When would you want to use the double ampersand or the AND operator? The AND operator is great to use if you want to decide whether or not to display something at all. So in other words, when you would want to either display something or just not display it at all. In that case, what you put before the AND operator is the condition, and if that condition is true or truthy, then the JSX element that you put on the right side of the AND operator is what will either get displayed or not get displayed based on the condition of the thing on the left of the AND operator. Number 3, when would you choose to use a ternary? Where the AND operator is great for deciding to display or not to display something, a ternary is great for deciding which among two things you want to display. Technically speaking, you can nest ternary operations inside of other ternary operations, but personally, I highly recommend not doing that. If you find yourself needing to choose between more than two options, you probably should just be using regular conditionals with if, else if, and else, or possibly a switch statement. And well, I guess I just answered number 4. So if you do need to decide between more than two options, you should use a regular conditional statement using if, else if, and else, or a switch statement. There's one slight difference between the and ternary and what you can use with an if, else if, else block, and that is that the and the ternary can happen directly in line inside of the returned elements of your function, whereas with the if or else if or the switch statement, those will have to happen outside of the return of your function. So if I have a functional component, let's say it's app, and I'm returning some kind of UI, the and the ternaries can happen right here in line. So I can have something and some JSX. Or I could use a ternary that has the condition and the ternary, and then an else inside the ternary, which is some other element. But if I need to use an if, else if, and else, or a switch statement, I can't do my if inside of the JSX directly like this. Instead, I need to go up above. I can set a variable, and then use my if, and else if, and else block to set some variable to some kind of JSX. I won't type out the whole thing, but that allows me to then just inside of here display some variable, because previously in my if statement it was determined which JSX element it should be. Great work on this quiz. We still have a lot left to learn in this section, so let's keep moving forward. We're going to spend a fair amount of time talking about how to manage and deal with forms in React. From the outside, this might seem like a kind of strange segue for us to be taking. However, I have found that forms are one of the most difficult things to understand, and truthfully, one of the most difficult things to use in React. If someone were to ask me what I think is one of React's greatest weaknesses, I would probably say forms. Fortunately, there is a plethora of really awesome form libraries out there that, in my experience, many people end up turning to in order to manage forms and not have to build everything that we're about to see and learn about from scratch. However, that being said, it is really important to know how to do this because, especially when you're dealing with a really small form like what we're about to see in the meme generator, it's not that difficult, and once you get enough practice under your belt, it's pretty straightforward. So why are we talking about forms in the first place? Well, in the old days, you would create a form in your HTML and you would give it an action, which had the URL usually of some kind of PHP file that would process your form. You would give it a method, usually of posts, and then when your form was submitted through some sort of submit button, your PHP would pick everything up from there and process the data from the form. Fast forward a little bit to slightly more advanced JavaScript, but still vanilla JavaScript, and you would likely see something that looked kind of like this. This selector goes and gets the form, it adds a submit event listener, and the function that runs whenever the form is submitted would simply gather all the values together and then submit it to an API somehow. Of course, my function is just console logging stuff. If I were to type in a first name and last name here, let's put Joe Schmo, and it's just console logging our data. The main takeaway here, though, is to know that when you're submitting the form, it would gather all the data immediately at the very end of the process and then submit it immediately after gathering it. So how is this different from React? The main difference in React is that instead of waiting until the very end of the process and filling out the form when the form is submitted and then gathering the data, instead what we do is we create state, and every keystroke change or checkbox change or radio button change or whatever it might be, we update state, and therefore we are watching these inputs every keystroke or every change that's made to our form. Then when the time to submit comes, there's no more work really to be done. We already have gathered the data and we simply submit that to our API and pass in the state that we have been tracking all along. Coming up, we are going to jump into the specific syntax of how to do this. However, I really think it would be a good idea to sort of pre-game for these lessons by reading through the React documentation on forms. I know forms can seem like a rather mundane topic, but I promise this documentation from React is really excellent. They've done a great job explaining it. Think of this like reading the textbook before coming to class. Once you've had a chance to at least skim through the documentation and gain some level of understanding on forms in React, you'll be ready to move on to these next lessons where we start learning about how to deal with forms in React. Let's see how we can manage these forms in React, and we're going to start very simple with a single input. I'm keeping this as simple as possible so not to distract us from anything but learning forms. As a reminder, in vanilla JavaScript, we would have a submit button, and when we click that submit button, it would run a function, gather all the data at that time, and then submit it to an API or wherever. What we'll be doing in React instead is maintaining up-to-date state for every change that happens in any input in our form. To accomplish this, there's a few things we need to do. First of all, we need some state to hold the current data that's typed into our input. Just like we've been learning, I can say, let's say first name and set first name is equal to react.useState. I will set an empty string as the default because I would expect my input to be an empty input box in the beginning. And now what I need to do is listen for any changes that happen to this input. Can you think what event listener I might need to add to my input to accomplish this? Most or all form elements have an event called onChange, and I can set that equal to a function, let's call it handleChange, which I obviously haven't declared yet. So let's declare that function. And for now, let's just console log changed. I hit refresh, and now we can see every keystroke that I make is running our function. Now, one thing we haven't spent much time talking about is this parameter that I can actually receive as a part of my event listener function. In this case, I don't get to decide what actually gets passed to my handleChange event listener function. Instead, what will get passed to it by the browser is an event object. This event object is really large. It has a lot of information in it. And if I console log event in Scrimba, it's simply going to put synthetic base event. So at this point, I'd recommend you actually open your developer tools in the browser and see exactly what got logged to the console. You'll be able to dig into all of the properties of this event object. However, there's one property in this event object that I care the most about, and that is one called target. If I log event.target, we'll see that it gives me what Scrimba shows is the HTML element that triggered this event. Now, it looks like HTML in the console down here, but in reality, it's just the DOM object that triggered this event. That DOM object has properties that we care a lot about. For example, the value property. Let me hit refresh, and I'll just start typing letters, and you can see in the console, we're logging the current value on every keystroke of that specific input box. So let me set up a quick challenge for you. Your challenge is to update the first name state on every keystroke. I've set everything else up for you. You should be able to complete this challenge fairly quickly. I've added this console log here. What this will do is every time the first name state changes, it will re-render your component, and therefore it will rerun this console log. This is a really simple way for you to see that everything is working. Assuming you hook everything up correctly in our handleChange function, this console log line should fire every time you type into the input box. Pause now and work on this challenge. Simply enough, we should be able to use the set first name state setter. And in this case, I don't really care what the state used to be, or rather, I don't need to know what the state used to be in order to determine what the state is about to be, because I have quick and easy access to the information that's currently typed into the input box by accessing event.target.value. So I should be able to get rid of these lines. I'll hit refresh, and I'll start typing in my input box, and sure enough, our state is updating with every keystroke. And there we have it. As you can see, at least starting out, this isn't that terribly complicated. However, I am about to throw some wrenches in here. We're going to see that the complexity level will rise a little bit. However, before I do that, I want to get your hands on the keyboard, and we'll do that as part of a challenge. In this challenge, we want to add a last name input to our form. As I've done before, I'm being a bit intentionally vague here, and that's so that I can get you to think of all the steps that you would need to run through in order to get this to work. So do your very best in this challenge, and when you feel like you've got a good solution, you can hit play and I will show you how I would do it. Pause now and work on the challenge. As you worked on this challenge, you might have started to see places where we were not being dry in our code. In other words, we were repeating ourselves quite a bit. For example, I could duplicate this line, and I will change first name to last name. We'll say set last name. I then could duplicate my input, and we'll change this to last name. Now, of course, there's a problem with using the handle change function on change, and that is because, well, handle change is only changing the first name. So maybe we make a change that says handle first name change. We'll update our on change there, and then we'll duplicate this function and handle last name change. You can probably see where I'm going with this and how this is not going to be the ideal solution. And then last of all, we need to change this to set last name. I'll add a console log here just so we can see if things are working the way we expect. We'll look at both the first name and last name. We'll hit save, start typing. We're looking at Joe, Schmo. Okay. Of course, this seems to be working, but we can clearly see this is not ideal, especially when you think of some of maybe the crazy forms that you filled out before that have, let's say 20 or maybe even upwards of 50 input boxes. It's not going to work great for me to have a separate change function for each one of those and a separate piece of state for each one of those. So next what we'll do is we'll learn how to combine our state into an object and how to use the event parameter that we're receiving in our event handlers to determine which property of that state object we should be updating. So when you feel confident with everything that we've worked on here, let's jump into that next. Let's see how we can improve our form and how we're managing state so that when the time comes to add, let's say 20 or 30 more inputs, we don't end up drowning in duplicated code. Now, if you do just have 2 or 3, maybe even 4 pieces of data in your form that you care about, doing something like this might be okay, or at least manageable. Once you get to 4 or beyond, however, it starts to make a lot more sense to save your state in an object instead of in separate variables. A benefit of doing that is we'll receive one setter function, which we're going to learn how to use to update the correct piece of state in the object. Let's just dive into the syntax to make more sense of this. I'm going to remove this extra function here. Let's change this back to handle change so we can figure out a way to make it more universal, and I'll set my on change to work for both of those. Let's also get rid of our extra piece of state here, and instead we're going to choose to save an object as our default, and that object will have a first name property as an empty string and a last name property as an empty string. Let's move this onto its own line. Then I'll change first name to something more generic like form data and set form data. Lastly, let's get rid of this so that we don't have broken code. And awesome, this is a good starting place. If you remember back when we talked about the event that we're receiving in our handle change event listener function, If you did spend some time in your developer tools poking around that object and looking at its properties, you probably saw event.target, which we talked about in that previous lesson. Now in Scrimba, if I console log this event.target, it gets a bit truncated to look like an HTML element. However, under the hood, it's really a DOM object that we can access properties on. In fact, we saw how I can look at the value property to get the specific value that was typed into the input box. However, at this point, because an object is what we're saving in state, I can't simply say set form data to event.target.value because that would erase my object and replace it with just a simple string. And because I'm using the same handle change function on both of my inputs, I need a way for the handle change event to distinguish between which input it was that triggered that event. Well, it turns out that a good practice that we're neglecting to do right now is to give each of our inputs a name property. This is true of regular HTML forms in any case, but in React, it's going to play a special role for us. What I can do is make the name property match exactly the property name in the state that we're saving. In fact, a good idea is to just copy and paste it so that you don't misspell it. And now I have access to event.target.name. Let's hit save. I'll trigger the event to happen in the first name property, and you can see it logged the first name property there. If I do it in the last name, it logs last name. Well, this is a great start. We have access to the property of state that we want to change, and we still have access to event.target.value, which is the value that we want to change it to. So now we have everything we need to call set form data and update our object correctly. Let's go ahead and call set form data. Before, when we were simply updating a string, we didn't care about what the previous version of that string was because we were just going to overwrite it with whatever was in the input box. This time around, however, we do need to know what the old version of state was because we have a lot of other properties. Well, in this case, we only have one other property, but imagining a larger form, we have many other properties that we need to maintain instead of just overwrite. So I'll do a callback function in here. I'll use an arrow function and call my previous state, let's say prev form data. I'll use an arrow function and open up the body of that function. My goal is to return a new object, and I want to make sure I keep all of the old object intact. So I'm going to spread out the previous form data, but then I'm going to overwrite the specific property that we are trying to overwrite or that we're trying to update in this handle change event listener. Well, on your first attempt, the inclination might be to try something like, let's use event.target.name as the key and event.target.value as the value. Of course, as we can see in the editor, this is a syntax error. However, with ES6, there was a feature introduced called computed properties. And what this allows me to do is to surround my key here in square brackets. Long story short, it makes it so I can turn a dynamic string like something saved in a variable and use it as the property name for my object. If that doesn't make a whole lot of sense, don't worry too much. Just know that you can fix the syntax problem by having dots here by surrounding it in square brackets. That's an overly simplified way to describe it, but don't worry too much about that. That's not the important part to take away from this lesson. Let me add back my console log so we can look at our state every time it changes. We'll hit save. We can see in the console that it's empty to start with, and as I change the first name, my object is updating correctly. My last name is also still a part of my state. As I update the last name, awesome. This is great news that my entire state is staying intact. Honestly, what we just learned in this lesson might be one of the most difficult parts of understanding forms in React. So for those of you that were able to follow along, awesome, good job. For those that were struggling still, that's completely okay and completely normal. Don't be afraid to go back, rewatch this a few times, and because of that, in the next screencast, we're going to practice this a little bit more. Hopefully in this challenge, you'll get a chance to see why it's beneficial to structure things the way that we just learned how to do. Your challenge is to add an email field and associated state to our form. Pause the screencast and work on this challenge. Previously, when we were saving all of our state as strings, anytime we wanted to add new state, we needed to create new variables and new event handler functions. Now, however, we simply need to add a field to our state object here. We'll add an email property that starts as an empty string. And as long as with my input I give it the correct name, I really don't need to change anything about my handle change function. So let me add another input here. I'll just duplicate this one. For good measure, I'll change the type to email. Of course, we'll change the placeholder. I don't need to change my onChange. We'll make sure that this name exactly matches the name that we chose in state on our property here. And, well, I believe that should do the trick. I'll hit save, type in a first name, we'll say it's Joe, last name Schmo, joe@schmo.com. And sure enough, our state is updating exactly as we would expect, now maintaining all three of these properties. Now, for those of you that followed my directions a few screencasts ago and actually read through the React Forms documentation, you would have come across a section that talked about controlled inputs. As of right now, our inputs are not controlled, and so in the next screencast, we're going to see one simple addition we can make to turn them into controlled inputs, and we'll talk briefly about what a controlled input is in the first place. A term you might hear floated around as you're learning about React is something called controlled components. Again, if you read through the React Forms documentation, you'll have come across the section called controlled components. If it's been a minute or you didn't have a chance to read through that, you can click this slide in order to go directly to that documentation. But when we're talking about maintaining state inside of a component, there's a common concept called the single source of truth. The idea is that the state that you're maintaining in your component should be the single source of truth. If you think back to when we were learning about changing state and we had our boxes or squares example, one solution we came up with was allowing each box to take the incoming on prop and then set its own internal state based on that incoming prop. And then the box itself could change its own internal state and therefore display either being filled in or not filled in. If it's been a minute since you've seen that lesson, of course, you can always go back and watch that to refresh on what I'm talking about here. The problem, as we learned then, is that we have two instances of that state that exist, and they don't necessarily match up. In other words, there isn't a single source of truth. The array of these objects was being held in state in the app component. However, each box was then changing that state essentially without telling the app component that it was changing, and therefore there was state that oftentimes would not match with one another. We have a similar concept happening here, where in the markup inside of our inputs, each of these inputs in effect is holding its own state. Think how in a regular HTML form, no React involved at all, when a user types into an input box, essentially that input box is maintaining its own state. Well, in this case, we have two pieces of state. One is being held by the input box just in regular HTML, and the other is updating on every keystroke held in our React code. Of course, we have set it up so that the state of our input box then perfectly gets mirrored by our state in React. However, a good practice in React is to make it so that your React state is what drives the state that's visible inside the input box. I totally understand this might seem like I'm splitting hairs here, but if it helps, all this really boils down to is simply adding a value property to each one of our inputs. So here at the bottom of each one, I'll add value equals and then a set of curly braces. And then all we need to do is add the piece of state, in other words, form data dot, and then the name of that specific input into that value. So we'll add form data dot, and then in the first one, I'm going to have first name, last name, and email. Visually, we're not going to see any difference here. Conceptually, however, when I type into the first name, Bob, the value of this input box is no longer being controlled by the input, but rather by React. Every change that I make runs my handle change function, which then updates the correct piece of state, which re-renders my form, and it sets the value of my form input to be whatever state is. So now state is in the driver's seat telling the input box what to display rather than the input box telling the state what to be. The main reason to learn this about controlled components is because sometimes if you don't set this up correctly, React might sometimes complain about having uncontrolled components. Fortunately, the concept itself is more difficult to understand than actually implementing it. So if you don't feel like diving deep into understanding controlled components, honestly, that's going to be completely okay at this point. Just remember that you need to set the value of your inputs to be equal to your state that represents that input value. There are a few more small things that we need to learn regarding forms. So at this point, we're going to speed through some of those so that we can get to a challenge that will help you practice all of this together. If only all form elements were as simple and designed the same way as the inputs that we've been working through, these text-based inputs, then our life would be so much easier. However, forms have more variety in the types of inputs you can have. For example, radio buttons and checkboxes, text areas, and so forth. Each one of these has some special considerations we need to keep in mind when we're using them in React. To start us off, let's look at the text area element. In regular HTML, text area is a little different than an input because it is not self-closing. It has its own separate closing tag. And in HTML, whatever you put inside the opening and closing tags is the value of that text area. You'll see I'll hit refresh and we get a text area that's a little bit larger. We can also set the size with rows and columns. The user can make this bigger or smaller if they need to. However, what the React team has done is they've chosen to make the text area much more similar to a text-based input. And so they've taken the closing tag away, they've made it a self-closing element. And just like our inputs, we will now add a value property to it, and that's going to be the value that's inside of the text area. Once you understand that they've changed the text area to be a self-closing element, essentially everything else we've learned about text-based inputs remains the same. I suppose in the text area case, we're probably not going to include a type because the text area is sort of its own type already, but everything else should essentially be the same as our inputs, which means that it's time for a challenge. Okay, your challenge is to add a text area for comments to the form. We do want to include these comments in our state as the user is typing into the text area itself, so make sure to update our state as well. Pause the screencast, work on this challenge. While we're up here with our state, I'm going to add a comments property to my state object and initialize it as an empty string. Then at the bottom of my form, I'll render a text area element. Again, it's self-closing. And just like the other ones, we will put a value in here that will be formData.comments. That way it can be a controlled component. We'll add a placeholder that just says, let's just say comments. We'll use the same onChange handler, so we'll have handle change. And in order for handle change to work, we need to make sure we assign the same name that we have in state. So comments and comments. Now I've added some styling. I did that directly to input, so my text area isn't going to be styled that way. Maybe I can get lucky and just add text area directly to my styles here. Let's hit refresh. And okay, well, my height's a little funny, but that's something I could always change later. Let me add a console log here so I can make sure that it's hooked up correctly to state. We'll just log formData.comments to make sure that just that one piece is coming in. Okay, awesome. Now, I guess those styles aren't really going to work out because it's doing that text indent thing. That's kind of silly. Let's just put this in its own thing. Okay, that's a little better. Awesome job. The next form element we'll talk about is checkboxes. Let's take a look at the checkbox element. Now, checkboxes aren't just an HTML element on their own called checkbox, although to be completely honest, I kind of wish they were because that would just be a lot easier. But no, they are an input with a type of checkbox. Checkboxes are fundamentally different than what we have been working with so far with our text inputs because they just hold Boolean values. In other words, there's not going to be some kind of string text of my checkbox. Instead, there is a checked property that will either be true or false, based on whether the user has checked the box or not. Before we jump into checked, let me clean up my input for just a second, because right now I just have a bare box sitting here. While I was cleaning up this checkbox, I was reminded of something that we haven't yet talked about, and that is this HTML4 property. When we have something like a label that is supposed to be tied to another input, you have a couple options. You could nest the input directly inside of the children of the label. What that does is if the label gets clicked, it will automatically propagate that click down to the input. However, my personal preference is to keep the label as its own separate element and then point that label using HTML4 to the ID of an input so that they can be associated with one another. In plain HTML, you're probably used to using just for, but if you were to look under the hood at the underlying DOM element, it's really called HTML4. That's the JavaScript property for that element. Anyway, that's a digression. So now we have a checkbox that asks the person if they're friendly or not, and we want to maintain this in state. Well, because it's a checkbox, we're not maintaining a string. So up in state, I'm going to add another piece of state and actually start separating these onto their own lines to save some space here. And we'll call it isFriendly. And just to give them a benefit of the doubt, we'll call it true as the default. As I briefly mentioned, to associate our state isFriendly with our checkbox, we're not going to use something like a value property, but instead we're going to use a checked property. Now, because a checkbox is either checked or unchecked, the value that we put in here for checked needs to be a Boolean, or at least whatever you put in will be interpreted as a Boolean. So if I put something truthy in like the string hi, it's going to check the box. If I put in something falsy like an empty string, it's going to not check the box. But in the end, that doesn't really matter because this should be a Boolean value. So I'm going to say formData.isFriendly. Now, when I hit refresh, do you think that this checkbox will be checked or unchecked? It should be checked because our default value is true, right there. So when we say this box is checked, we are having React dictate to the box that it is checked, in fact, because that's what state is. Of course, now we've introduced a bit of a bug. I can't uncheck the box. Maybe that's a good thing. For this specific form, we don't want people to be unfriendly. But for the sake of argument, let's say we want this to act like a normal form. If we look closely at our handle change function, we have only been looking at event.target.value. However, with a checkbox, we are not looking at the value property anymore. We're looking at a checked property. So, of course, I could go out of my way to create a completely separate handle checkbox change function, but we can do better than that. Let's assume for now that we can reuse our same onChange function. We'll put in handle change as our onChange. And then let's go up to our handle change and we're going to make some modifications here. The first thing I want to talk about is a best practice that we should be following, and that is not to put the entire event.target.value and event.target.name down here inside of our set form data. At this point in the course, it's not that important that you understand why we're going to do this, but a much better way to handle this is to destructure event.target and pull out the values that we need. So we need name and value from event.target. And then I can switch this to name and switch this to value. And then, as I mentioned, when we're handling a checkbox, there's a few more things we need to pass in. One property that will come in is this type property on all of our inputs. We have a type text, email, and down here, our type of checkbox. So let's bring in that type so we can check whether or not the input that's making this handle change function run is a type of checkbox. And if it is, we're also going to need the checked property. And this is either going to be true or false, depending on how the user has interacted with the checkbox. Now comes a bit of a trick. When I'm setting my form data, I want everything else essentially to be the same. However, the piece of state that I want to update if it's a checkbox, in our case, the isFriendly property, should not take on value, but rather should take on the value of checked. So I can use a ternary here that says, is the type equal to checkbox? If so, I want you to use the checked property. But if not, I want you to use the value property. Let me get rid of this console log because that's from a previous screencast. Let's refresh. We'll hit the checkbox and oh no, there's a bug. So I'd like you to look at the input that we've created, perhaps compare it to some of the past inputs that we've created, and see if you can figure out what we're missing. All of our other inputs have a name property, and that's something that I simply forgot to add in. So I'm going to add a name. This needs to match exactly what is in state. We'll say is friendly, and that way, when I hit refresh, I should be able to now check the box. Awesome. This is probably a good time to mention that everything we're learning here with forms can be really confusing and especially hard to try to memorize. Honestly, as I've been preparing this lesson, I've had to go back to some of my old notes and some of my own recordings to remember what the syntax for this actually looks like. So just think of this as a pep talk. Now, if as I'm teaching it, you're still feeling totally lost and it's not making any sense at all, that's a cause for alarm. You should be able to generally follow along, but in this case, I'm not necessarily going to quiz you on the exact syntax for everything because, well, it's just as easy to look it up if you really need to. Okay, so let's get back on that horse, and we're going to next look at radio buttons. In React, radio buttons are kind of an interesting combination of checkboxes and text inputs. I'll talk about what I mean in just a second, but in the meantime, I've put together this field set that asks about our current employment status. To skip some of the mundane stuff, I've already added the type of radio and some IDs in order to associate the labels using HTML4 with the correct inputs. So now let's talk about how we can hook these radio buttons into our form and connect it with our state. First, we need a place in state to hold all of this information. I'll add another property to our state called employment. And where checkboxes are either true or false, radio buttons, similar to inputs, will have some kind of text value to them. In this case, I want employment to be some kind of string, either unemployed, part-time, or full-time. So on a high-level overview, what will happen is when the user clicks one of these options, we will be watching for changes in these inputs, and when a change happens, it will take the value of that specific radio button that was clicked and set our state to that value. In order to associate my inputs with the correct piece of state, and also to make it so that I can't click all of my inputs the way I can now, I need to add a name property to each one of these inputs. Like we've done before, I'll set the name equal to employment, which exactly matches the property that we are saving in state. The reason we're giving the same name to all three of these radio buttons is, first of all, in HTML, that's the way that we make it so only one of these radio buttons can be selected at any given time. But it also intuitively makes sense because we're only updating one property of employment based on which one is selected. Each one of these inputs will have its own unique value, and this value is what will actually get saved as the value in state when this specific input is selected. So for the unemployment or the unemployed one, I'll put unemployed. For part-time, we'll use part-time. And for full-time, we'll use full-time. Next, I need to make sure that I'm listening for change events. So I'll add my onChange of handle change. Believe it or not, we'll also be able to use the same handle change function, and we'll see why in just a minute. And technically speaking, this should now be hooked up correctly to state. I can test that by coming up here and console logging my state. We'll just console log the employment part of it. So we'll say console log form data.employment. If I hit refresh, we get an empty string, and then when I choose unemployed, it switches to unemployed, part-time, and full-time. There's one more small thing that we need to change, and it's essentially mirroring what we did when we were setting our value equal to the state. Radio buttons are a little different because we need to specify what value the state should take on if the radio button is selected or checked. However, that means that we can't do controlled components in the same way that we did with our inputs by setting the value equal to whatever the current value of state is. But that doesn't mean we can't control these components. It's just that radio buttons are controlled in the same way that checkboxes are controlled. Here we were able to say checked equals formData.isFriendly. However, if we try to do the exact same thing with our radio buttons, we're going to run into a little bug. We'll see that here. I'll say checked equals formData.employment. And when I click one of them, well, some weird stuff is happening. This is where radio buttons differ from checkboxes in that when we are controlling the checked property, we don't simply say checked equals formData.employment because, unlike a checkbox, this is not a Boolean value, but we can make it a Boolean value by checking if the formData.employment is equal to the value of this specific checkbox. So I'll do the exact same thing over here. And now React is in charge of controlling this input rather than the input having its own HTML state. Let me walk through that one more time. Let me hit refresh. Initially, the value of formData.employment is an empty string. When I click unemployed, it runs the onChange for handle change, which we have defined here. We're pulling the name, value type, and checked out. We're setting the form data. We're bringing in all the old form data. Now we're using name, which we had set to employment, as the key for our state that we're updating. And it looks here, says, is the type checkbox? In reality, no, this is not a checkbox, it's a radio. And so it skips the checked value and instead uses this value. This value is the value that we defined here, where we said it's either unemployed, part-time, or full-time. Then when we change state, React re-renders our form. It checks to see if the current formData.employment is equal to unemployed. In our case, since that's the one we chose, then that becomes a true statement, and therefore checked is true, and all of these other checks are false. That makes it so that only one of these can be checked at any given time. In my opinion, radio buttons are probably the most confusing element to deal with in React, so if you have understood everything we just walked through, then kudos to you, truly. This is a big accomplishment, so you really should be proud of yourself. Again, you don't need to have memorized this necessarily. You can always come back to this lesson or find something on Google to help you through the syntax of this if you need it again in the future. But if you were able to follow along with the logic that we just talked through, then that really is a good signal that you understand state, you understand event handlers, and some of these little quirks about forms in general. There's one more form element I want to talk about before we move on, and that is select boxes, and we'll do that in the next screencast. The last form element we're going to talk about in React is the select box with its options. In regular HTML, it's usually set up something like this, where you have the select box. I've added an ID just so we can associate our label with it, and it has a number of options inside with a value for each option. In regular HTML, in order to grab the value of whichever one is selected, you will look for a property called selected, although that would happen in the JavaScript. But all of this is a bit beside the point because React has decided to make it a lot more similar to some of the other input elements that we have seen so far. So just like we've done with some of the other elements, we are going to add a value property here on the select itself. And this value, similar to our text inputs, will just mirror what we have in state. Now, currently we're not saving a favorite color in state. So let's go ahead and add fav color. We'll start it off as an empty string. And then down here in our select, we will say formData.favColor. We can reuse the same onChange handler that we've been using with handle change. And in order for handle change to work correctly, we need to make sure that we mirror our name to exactly equal the property that we're saving in state. So at this point, I should be able to click my dropdown, and you won't see this dropdown in the recording, but if you click onto this app and hit the refresh icon, you can test this out for yourself. I'll click the dropdown, and I see the different colors, red, orange, yellow, green, blue, indigo, and violet. I can choose green, and that will change our dropdown to green. And actually, let's go up here and change formData.employment to console log our favorite color instead. So that way, whenever I make a choice like green, our state is updating according to the value of the option that was chosen in this dropdown box. Now we do have one little issue here. If I hit refresh, we see that I'm initializing state as an empty string for the favorite color, but currently I don't have an option that represents the empty string value. One way I can change this is by providing a new option where the value is an empty string, and then maybe I put in something like choose that makes it so that the user will see choose here on the first option. I'll hit refresh. We see choose as our option, but I can still drop this down and change it to any of these other colors, just like we would expect. And that pretty much does it for any of the form elements that we're going to be talking about in this course. There's one last small thing we need to cover about forms, which is how to submit a form. And so that's what we'll cover in the next lesson. Now that we have a way to gather all of this information from our user, we need to be able to submit the form. In HTML, you might be familiar with an input of type submit. An input type submit is, well, basically just a button. And of course, the default option there is submit. We can change the value to something different, like, I don't know, send it in or something. Okay, and that changes the text of the button. Let me put a couple breaks here just to move that down a bit. However, in HTML5, they made it so that the actual button element, if it's found inside of a form, acts like a submit button. What's nice about the button element inside of a form is that you're not doing this weird value thing because it's not really a value, it's just the text of the button. So I could just put submit here, and because this button is found inside of a form element, its type is actually automatically submit by default. In fact, if you didn't want it to act like a submit button, you'd have to actually change the type to button, which looks kind of funny, button type button. So let's just make use of that default. We'll get rid of our type completely, and therefore the default is type submit. And clicking this button, because the button is found inside of a form, will actually trigger the form's onSubmit event handler. Now, back in the day, instead of having a JavaScript onSubmit handler, you might have something like a method that tells you this is going to be a post request, and you'd have an action that probably led to some PHP file.php, and then PHP would take the data and process it, do whatever you needed to do. However, we're going to essentially bypass that entire system. We're going to set up the onSubmit event handler, and let's create a function called handleSubmit. And up here, I'll actually create that function. And what's nice about the way we have set up our form in React is now, instead of having to go through every one of our inputs and gather the values right at the last second before we submit this to maybe an API, we've been doing all that work all along as we've been updating state on every change of the inputs and elements in our form. So if we pretended that we had some kind of submit to API function, we would really just be able to probably pass our form data object into that function because it's already updated. It's been updated after every change of the form. Now, just like in vanilla JavaScript, if you have built a form and gathered the data in JavaScript, you know that clicking this submit button will actually refresh this page, and it'll put all of the form values as part of a query string in the URL. That all harkens back to the original way that forms were submitted with an action property. So the first thing we will always want to do in React when we're handling a form submit is to take that event object that will get passed to this event handler and run event.preventDefault. Preventing the default means that it won't refresh our page and essentially re-render our app with all of these default values and state. Prevent default just stops all of that from happening and makes it so that we can then run code the way that we actually want to. Just to see this working, I don't actually have a function called submit to API, so let's just console log our form data. So before we test this out, let me remove some of these console logs so we can actually see what we're working with. I'll hit refresh, type in some generic values here. Okay, and we'll hit submit, and we can see we got our state object. Everything has been automatically updating as we've been typing things into our form. And maybe just to drive the point home, let me comment out this prevent default, and I'll type in some stuff here and hit submit. And you can see my form refreshed and then my URL actually updated. I'm not sure if that comes through in the recording, but this is the URL, and it took all of my values based on the name property, stuck it as query strings in the URL, and it's just not what we want to do. Okay, with all of that behind us, I do want to get your hands on the keyboard practicing some of the things we've learned with forms, so that will be what we do in our upcoming challenge. Okay, we've covered a lot of ground, so before we move on, I want to test your skills and your knowledge, make sure you were paying attention. So with this quiz, pause the screencast, click into the editor, type down your answers, and when you've answered all the questions, click play and we'll go over the quiz together. Number 1, in a vanilla JavaScript app, at what point in the form submission process do you gather all of the data from the filled out form? All of that data gathering happens right when the form is submitted. Or I should say right before the form is submitted. Usually you listen for the form submit event and then you'll go to each one of the elements in the form and gather the data. So in number 2, it asks basically how is that different in a React app? Well, in a React app, we're basically not allowing the form elements to maintain their own internal state, but instead the component that houses the entire form has some React state, and that state is updated on every change of the elements in our form. So for a text form, it's every keystroke that the user types into their keyboard. For a checkbox, it's every time the checkbox changes or the radio buttons change, and so forth. So in short, we gather all the data as the form is being filled out. And of course, all that data is held in local state. Number 3, which attribute in the form elements, for example, the value, name, onChange, etc., should match the property name being held in state for that input? Well, it's the name property. Essentially, we use that name property to help us in our onChange so that we know which property in state to update whenever a change happens. Number 4, oh, that A should not be there. What's different about saving the data from a checkbox element versus other form elements? In all the other form elements, we're using the value property to know how we should update our state, but with a checkbox, we're looking specifically for the checked property. Okay, and number 5, how do you watch for a form submit and how can you trigger a form submit? Simply enough, we can add an onSubmit handler on the form element. That's how we can watch for a form submit, and we will pass a function to the onSubmit handler that will run whenever the form is submitted. So then how do you trigger a form submit? Usually that will happen with some sort of button click. As a quick reminder, in the markup, if you have a button element that's inside of a form, it will automatically act as a submit button for that form. Alternatively, and what kind of seems like the older way to me, is to use an input type submit. But to me, there's not really a benefit to doing that. Okay, awesome job on this quiz. Hopefully you were able to answer all these questions. Next, we're going to put what we've learned about forms into practice. In this challenge, your job is to connect our existing form to some local state and update that state whenever the user interacts with the form. As we've been doing, I want you to make sure that you only create a single handle change function that can manage the state of all 4 of these inputs: the email address, password, password confirmation, and the newsletter checkbox. Then when the user clicks sign up, you'll run through some logic that makes sure that the password and password confirmation match each other. And if they do, you should log successfully signed up to the console. And if they don't, you should say passwords do not match in the console. Additionally, when the form submission happens, I want you to check if the checkbox for the newsletter was checked. And if so, log thanks for signing up to our newsletter to the console. If not, don't console log anything. There was a lot of syntax that we learned when we were going through the different pieces of the form, so don't be afraid to open up in another tab some of the previous lessons that we've gone through as a reference. So pause the screencast and work on this challenge. All right, let's do this. I'm going to start with some state. I'll create state called form data and set form data using react.useState. That will begin as an object, and I can provide this object some default values. Let's have an email property that's empty, a password property that is empty. We'll call this password confirm. And let's say maybe joined newsletter. This one will be a Boolean because that's what checkboxes deal in, is Booleans. And so we'll default it as false. Or maybe if we're good marketers, we'll default it as true. And then what we can do is add these properties as a name field in each one of our inputs. So we'll add name equals, and then we'll put exactly what those properties were from up above. While I have all of these selected, I'm going to add an onChange for every one of them that will point to a function that I'll create called handleChange. And then we'll also give a value property, and I'm going to change this on our checkbox because that should be checked, not value. This way they can be controlled elements or controlled inputs, and I will make sure that we're pointing form data dot, and then we'll paste in the values that we copied above. Let's fix our checkbox. So this should say it's checked if form data dot joined newsletter is true, or not checked if it's false. And now let's go create our handleChange function. From the event, I'm going to pull out the name property, value property, type, so that we can check if it's a checkbox that made the change, and the checked property. We'll get all of those from event.target. Target represents the element that was modified in the event. Then I can run my setFormData function, and I need to access my previous form data. So we'll say preFormData, and this will be the parameter to my callback function. And I'm going to use that little trick where I can return an object by surrounding it in parentheses. That way I can make use of the implicit return without having to open the body of this function and then use the return keyword and so forth. And so I'm returning an object, and that object should have all of the properties of the previous form data, but then I want to update the property based on the name value that we pulled from the input that is making this change. That's using this computed property syntax, and the value would normally just be value if I didn't have this checkbox here, because all of my other inputs are updating a value property on the input itself. However, because I do have the checkbox, I'm going to check if the type is checkbox, and if it is, then I want to set the checked property of that checkbox. That's what's going to either be true or false based on whether the user has checked the box or not. If the type is not a checkbox, then we can just use the value property to update our state. Let's do a quick check before we get to the handle submit part of the challenge. I'm just going to console log my form data, and let's see if updates happen. Well, it's good to see that my checkbox is automatically checked, because that means that it's connected correctly to state, and our default was set to true. So if I uncheck it, we get false. That's good. Email address, password, and confirm password. Cool. Everything seems to be connected the way I would expect. So we can get rid of this console log to clean up our logs down there. At this point, all that's really left is some vanilla JavaScript logic that we need to write inside of our handle submit. And hopefully when you were doing this challenge, you noticed that I already set up our onSubmit to run the handle submit function. And because our button is inside of the form element, it acts as a submit button automatically. So clicking the sign up button will trigger the submit event on the form, and therefore will run the handle submit function. And well, I accidentally deleted the event.preventDefault. I don't want to delete that. I need that. Otherwise, submitting the form will submit it as if it were submitting to an old PHP or backend, which would then take all of these values and submit them as query strings in the URL and refresh the page and everything. Essentially, I just don't want to do any of that. So event.preventDefault is always going to be the first thing that you'll do at the top of your handle submit function. And yeah, like I mentioned, we just have some vanilla JavaScript logic to work through. So if the password and the confirmation match each other, we need to log successfully signed up. So I can just say if formdata.password is the exact same as formdata.passwordConfirm, then console log successfully signed up. And in any other instance, we will console log passwords. Oh, this says to not match. That should say do not match. Passwords do not match. And then separately, we can process the data for the newsletter. And if formdata dot, let's see, what was it called? Joined newsletter. If that's a true value, then we will console log Thanks for signing up for our newsletter. Okay, let's give this a test. I'll open my console, put in an email address, password, confirmation that is matching, and we'll have the checkbox checked. I'll hit sign up, successfully signed up, and thanks for signing up for a newsletter. Let's say I change this password to something different. Passwords do not match. And well, you know what? That leads me to something that I didn't mention in the challenge, but probably would make sense to do. If the passwords do not match, I don't want to make the person think that they signed up for the newsletter. So I think I'll just put a return right here after my passwords do not match so that this if statement never gets run in case they don't match. Let's try this again. We'll hit refresh. And we will make the passwords not match. Hit sign up. And we just get passwords do not match. Okay. Then if we do make them match and we uncheck, we get successfully signed up without the thanks for signing up to our newsletter. Awesome. Obviously, we didn't touch on every aspect of forms that we've learned about, but a form like this is a lot more common for you to develop than something that has every kind of form input under the sun. Awesome work on this little mini section on forms. Believe it or not, we're really rounding the corner, almost at the finish line for this section. We just have a few more things to learn before we can really tie together the remaining aspects of our meme generator project and finally tie a bow on that and call it complete. So when you're ready, let's jump right in. Now that we've learned how to save input data from text fields into state, let's revisit our meme generator and get it to an almost complete state. We created earlier the top text and bottom text fields, but they're not hooked up to anything right now. So your task is to connect the inputs into state so that every keystroke, they update the top text property in state and the bottom text property in state. Now, I've done a little bit of CSS heavy lifting for you, and that's because I really want to focus on the state part of React right now. But in short, I've added a wrapper around our image so that the whole thing is considered the meme. I made that meme a position relative so that I could set the H2s to be position absolute. This meme text is styling it to look kind of like a classic meme text. And the top and bottom classes simply stick it at the top or at the bottom of the container element. And as you can see down here, I've hard-coded the top text and bottom text, but part 2 of your challenge is to replace that hard-coded text with the text that we are saving in state. Pause the screencast and work on this challenge. I think the first thing I'll do is add the properties that I need to my inputs so that I can be watching for changes. Let's add a name property to each one. Say name equals, and then we'll have, this one is our top text, and this one is our bottom text. Next, we'll add our value properties so that these can be controlled components, and those will be meme dot, and then top text for the top one, and bottom text for the bottom one. And then we're going to need an onChange event handler. We'll call it handleChange, and then we'll create that function. I'm going to pull in the event so that I can get the name and value properties from our event. So I'll just destructure those now. And that's going to be from event.target. And then I will essentially be doing exactly what I did with getMemeImage here with setMeme. I'll type it out for the practice. We're going to set the meme, and I do need access to the previous version of the meme. I need to return an object, which if I want to do that as an implicit return, I need to wrap my object, my curly braces that represent an object, in parentheses so that it doesn't think I'm just trying to open up the body of the function. And we'll copy over all the properties of the previous meme, and we will change either the top text or the bottom text property depending on what name gets pulled in from the target. So I'll use that computed property name and set its value to value. Lastly, I will update my hard-coded text to look at our object values in state. So this will be meme.topText and meme.bottomText. Okay, let's cross our fingers. I'll hit save. One does not simply walk into Mordor. Ain't that the truth? Now it's kind of like playing roulette here. If I click get a new meme image, it's probably not going to work out so great, but we'll see that our text is staying on top and on bottom. And switching the meme image can actually be kind of a fun exercise because your text may or may not apply to the new meme image very well. Awesome work. This is super exciting. Basically, our meme image is sort of at an MVP, a minimum viable product, to push this out to our customers. In reality, we are still importing our memes data from a JavaScript file when what we really want to do is get that from an API. There's a few more things we need to learn in order to do that successfully, and that is what we're going to start talking about in the next screencast. A very common thing you'll need to do in React is interact with an API that lives outside of your application. Usually what you're doing is either requesting information from an API or sometimes submitting information to an API. Whenever you're requesting information from an API in React, usually you want to display or use that information somehow. So getting data from an API in React consists of essentially two parts. First of all, you need to get the data. And that would be using something like fetch or another tool for getting data like Axios. The second step would be to then take that data and save it to state. Once it's saved in state, your application can interact with it, it can display it on the screen, and all of the other benefits that come with saving something in state. So let's see some preliminary syntax as to what that might look like, and then as a spoiler alert, I'm going to show you why this is broken to do it this way. To start us off, let's do a fetch request to the Star Wars API. This is just a very simple API that will get us some information about Star Wars characters and planets and movies and stuff like that. I'll go ahead and resolve the promise that I get back from fetch. It will receive a response, which will be JSON. I want to turn that into a JavaScript object that I can use. And then with that data, we'll just console log the data for now. Okay, awesome. We have this object here. I'm not going to bother digging into this object. I'm just going to stringify the entire thing. So let me put that into state. And you know what? I'm actually using data in a couple places. Let's maybe call this Star Wars data and set Star Wars data. And then instead of console logging, we will set Star Wars data with the data that we get back. And then I need to make sure to update down here as well. Let's hit refresh and see what we get. Okay, there's the data from my API. Awesome. Everything seems to be working swimmingly. However, let me illuminate something that's going on behind the scenes right now. I'm going to console log component rendered. Every time the app component renders or re-renders by React, it will run this console log. So let me open my console, hit refresh, and look at this. We've got an infinite loop of component rendering. Let me comment this out and hit refresh. Now, I want you to pause and think for a second, why was this console log running over and over and over again? Pause now and see if you can come up with an explanation for why it was doing that. The reason we were stuck in an infinite loop is because this fetch lives on sort of the top level of our component. Because of that, anytime the component renders, it's going to call fetch. And every time it calls fetch, it's going to set the Star Wars data, which is updating our state and therefore causing React to re-render this component. And then it's running fetch again, setting the state, re-rendering the component, calling fetch again, setting the state, re-rendering the component. I think you get the idea. In fact, even though we're not seeing that happening with this console log commented out, it's still being re-rendered in the background. So I'm going to comment this out so that it actually stops re-rendering. And in fact, the only thing we really need to comment out is where it says set Star Wars data. When we had a console log here, I'll uncomment this component rendered and open my console, we'll see that we're no longer in an infinite loop. And that's because we're not setting state, causing the component to re-render. So this acts as a perfect springboard into the next topic that we're going to learn about, and that is how to handle side effects in React. So that is what we will tackle next. We're now embarking on a journey that leads to oftentimes considered one of the most confusing parts about React, and that is how to manage side effects. To really understand what I mean by side effects, let's take a look for a second at what React's primary tasks are. First of all, React is in charge of working with the DOM and the browser to render some kind of user interface to the page. The React team has created a really simple interface to allow us as developers to accomplish this with JSX and elements that look just like HTML. Under the hood, of course, React is taking that JSX and turning it into elements that can be displayed on the page. Another task, which we have mostly been learning about in this section, is to manage state for us. And if you think carefully about it, it's managing that state between the render cycles. In other words, React can remember state values from one render to the next. So that's another thing that React does, and we are allowed to hook into that state using the useState hook. And then naturally, its next task is sort of a combination of these two. It needs to keep the user interface updated whenever state changes. There certainly are other tasks that React is accomplishing, but you can probably boil the main three tasks down to these three. So then what is React not able to handle on its own? The major one that we're going to be discussing is any kind of side effects, or I put outside effects here. All that really means is anything that lives outside of React's purview or reach. So some examples of this are local storage on your own browser, for example. We can of course use code to access local storage, but React has no real hand in interfacing with local storage. Along that line, any kind of API or database interactions that occur in our code, we can write that code to interact with APIs, but React is not in charge of that code. Or rather, React has no way to know which APIs we're going to be reaching out to. Similarly, any kind of subscriptions you might have, if you include WebSockets in your application, for example, you have a chat application that updates live. And as it turns out, even if you have two different pieces of internal state that you need to sync together, or have one of those pieces of state react to a change in another piece of state, React can manage the state of each one behind the scenes, but it's not really looking at any kind of crossover between those two states. So in the end, it boils down to basically anything that React is not in charge of can be considered a side effect or an outside effect. So using this API interaction for an example, if we look at our code from before, I commented it out so that it wouldn't keep infinitely rendering, we can see that React is essentially just doing what it's told. It's trying to put something on the screen, it's trying to manage state, and it's trying to keep state and the screen in sync. If state ever changes, it needs to re-render the component. As a side note, if this were receiving props and somehow those props were also to change, for example, if those props were a piece of state in a higher up component that then changed, this component would also re-render. So with our code living here on the top level of our component, React really doesn't have a way to stop us from setting the state here, causing the re-render, which would then set the state again, causing the re-render, and so forth in that infinite loop. So the React team gives us a really nice hook called useEffect. In the documentation, this is called the effect hook. And I like to think of it as a tool that React has given us developers to use sort of like a blank canvas that allows us to interact outside of the React ecosystem, which again mostly just consists of state, props, and the user interface that it puts on the page. And I like to think of useEffect as being a tool that allows us to synchronize React state with those outside systems like our local storage or an API. Now, before we jump in, I've included here a link to the documentation. If you click this slide, you will be sent to this page where you can learn about using the effect hook. Again, think of it kind of like reading the textbook before coming to class. Now, you don't have to scour every single word in the documentation, but I do want you to take a look at it, read through it, and then when you've got a cursory understanding of the effect hook, then we'll jump into the next screencast. As you're reading through this documentation, you'll run into a line that says, if you're familiar with React class lifecycle methods, you can think of the useEffect hook as component did mount, component did update, and component will unmount combined. So if you are familiar with class lifecycle methods, I actually want to implore you not to consider this tip. If you have no idea what I'm talking about, then that's totally fine. You can forget everything that I just said about class lifecycle methods. But if you are familiar with class lifecycle methods, the modern advice these days is not to try and think of the useEffect hook as a combination of these lifecycle methods, but rather to work on retraining your approach to understanding side effects in React. I know that might be strange for me to be contradicting the documentation, but I know that I'm backed up because this is an article by Dan Abramov, who is one of the core contributors to React, and he writes this giant blog post about understanding useEffect and essentially goes in depth into how we should not be thinking of useEffect as a way to hook into lifecycle methods, but rather as a way to deal with side effects in React. If you really want a deep dive, you can click this slide to go to this page. But if you're learning React for the first time, you do not need to go this in depth into useEffect at this time. So once you've had a chance to skim through the React documentation on the effect hook, let's jump in and start learning how to manage side effects in React. Let's begin refactoring our code here to use the useEffect hook. Just as we can access the useState hook on top of the React object, we can do the same with useEffect. So I can create a side effect by using react.useEffect. And useEffect has one required parameter and an optional second parameter. In this screencast, we're just going to learn about that first required parameter, and in the next one, we'll talk about the optional second parameter. The required first parameter for react.useEffect is a function, a callback function. And maybe so that's perfectly clear, I'm going to write this out as a function declaration. Although in practice, you'll almost always see this as an arrow function, and that's what we'll eventually transition to as well. And this function acts as a place for us to be able to put our side effects code. In the little example we have here, this fetch request is considered a side effect, and that's because it's reaching outside of React's ecosystem, but also trying to set some state in the process. Remember, this was infinitely looping because on the top level of our component, it was running this fetch and setting the Star Wars data, which was modifying state and therefore re-rendering the app, which then just ran all the code again in this infinite loop. So let's move this fetch request inside of our useEffect, and that's it. Inside of the callback function that we provide to useEffect, we're allowed to put our code that has other side effects that interact with systems outside of React. And maybe more specifically, interact with those outside systems to keep them in sync with our local state in this component. Now, I do have a confession to make. We're actually only halfway there. If I uncomment my console log and hit save, you'll see that we're still having the same problem we were having before, where we're stuck in an infinite loop. Let me comment this line out so that it doesn't keep setting state. So what exactly is going on? I thought useEffect was going to fix this problem. Well, it turns out that the code we put inside of this callback function, if we don't provide a second parameter to our react.useEffect function, then there's almost no difference between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one small difference, and that is anything that we put inside of this callback function is guaranteed to run only after the user interface has been painted to the screen. In other words, only after React has taken our user interface, our elements, and created real elements on our page. So this callback function is guaranteed to run in a specific order only after this has been placed on the DOM. But for our purposes here, there's basically no difference. We're still stuck in an infinite loop. So in the next screencast, we're going to start diving into useEffect and understanding first why we need to provide this second parameter, and then what that second parameter is and how it solves this problem. I've made a couple modifications to our app here to try and demonstrate exactly what's happening within useEffect. I came up with the simplest little counter app that just has a single button that says add and something that displays what the current count is in state. The reason I did this was just to make it so that we had a really easy way to trigger re-renders and state changes on our app here. I also replaced our useEffect callback function with just a console log that lets us know that this effect function ran. You can already see what's happening down in the console, but if I refresh the site, we'll first get the component rendered console log, and then we get the effect ran console log. As we talked about before, the function we pass to useEffect will run after every render of our component. It essentially makes it no different than moving our console log outside onto the top level of our function, just like we have here. Which means if we ever wanted to change the state within our useEffect, we get caught in that loop like we've talked about a few times already. Now with my little counter, I can trigger a manual re-render by just clicking the add button, and we can see that when I click the add button, It updates the state behind the scenes, so it changes from 0 to 1, and it re-renders our component now with count equaling the number 1. We get our console log, which rendered because it's a function call here on the top level of our component. It then would have skipped down here and rendered our UI so that it could display the correct count now that count is set to 1. And last of all, it ran our effect, which of course runs after every render. As we talked about, the first parameter to use effect is this function, but there's a second parameter, which, although I mentioned is optional, is something that you will almost always include. And that is something called a dependencies array. Now, don't let the name confuse you. The concept is actually not too terribly difficult. The array that we pass as a second parameter to use effect will contain values that, if they change from one render to the next, will cause this effect to run. In other words, it limits the number of times that this effect will run, or rather it determines when this effect will run instead of running after every single render. Now, if I leave this as an empty array, it effectively tells React, I want to run this function on the very first render of my component, but then there are no dependencies to watch and trigger this effect to run again. So it ends up being it runs once when the component first loads, and that's it, never again. We can see this in action by refreshing our app, seeing that we did get effect ran, and then adding to our count. And from here, adding to our count is no longer running this effect. And that's because we have an empty array which is not looking for any changes between one render and the next. Now, if I wanted to run this effect every time count changed, I would have to make sure that my effect knew that count was one of the dependencies that signaled to the effect to run again. So now I hit refresh, it will run once, which is why we get effect ran in the console. And now every time I hit add, I'm also running my effect again. Under the hood, this is what's happening. When I hit refresh, state starts out as 0, and the component will take count and replace it with a 0 everywhere it can find it. So here we have an array with the number 0 in the first index, or the 0 index. Then when I click add, React will update the count from 0 to 1, and it will rerun my function, or in other words, re-render my app component, where everywhere I'm using count is now 1. Remember, this used to say count. Well, the second time around, it changed from 0 to 1, so now it's running this component with an array where 1 is the first index, or the 0 index in that array. Then it's going to look at the last time it saw this dependencies array, and it's going to compare an array with the number 0 to an array with the number 1. Now, I probably shouldn't use triple equals because that's not exactly what's happening here. Let me say, okay, compared to, it's going to compare this array to this array, and if any item in this array is different, then it knows to rerun this function. Now here's a question. What if I were to hardcode an array with the number 0 in here? Let me hit refresh. We can see that our effect did run, but now what will happen when I cause a re-render to trigger? If you need to, you can pause and think through that for just a second. Well, I can click add, and we'll see that my effect is not running again. Why do you think that is? Well, with a hard-coded 0 in here, every time the app re-renders and useEffect looks at my second parameter of this array, it's comparing the array with the 0 as the first item in it to an array with the 0 as the first item in it. It's going to see that those are exactly the same values, and therefore it will not run this function. And that's why it's called a dependencies array. useEffect depends on these values to know whether or not it should rerun our effect. So again, when I put count, I refresh the page, count starts at 0, I hit add, count is 1, it notices that that has changed, and therefore it reruns our effect. I feel like I've repeated myself a lot here, but I'm hoping that the concept will sink in the more times you hear it. Okay, it's high time that you get your hands on the keyboard, so let me type out a quick challenge. Okay, it's your turn to write the useEffect. The useEffect should run anytime the count value in state changes, and for now, it's just going to console log something like effect function ran. Pause now and work on this challenge. We can start our effect by using react.useEffect. As a side note, just like we could destructure useState from the import statement up here, we can also destructure useEffect if we wanted to and just say useEffect. In fact, I would suppose this might be the more common way that you'll see it. But just like with useState, I'm going to use react.useEffect just so that it's very clear where useEffect is coming from. UseEffect takes a function as its first parameter. Before we had a function declaration like this. However, I am going to use an arrow function because that is how you will most commonly see it. This is just going to console log effect function ran. Now here's something tricky. Without the second parameter, we know that this function will run anytime the app component re-renders. And right now, the only way we're causing re-renders is by clicking the add button. Let me hit save. I can click the add button and we'll see basically the same thing that we had when we had a dependencies array. However, as I mentioned, there's almost never a reason to not include your dependencies array. There certainly are instances where it may be required, but especially on the beginning end of learning React, you almost always will need to include your dependencies inside this array. If you have no dependencies, remember that means that your effect function will only run once the very first time your component is rendered. However, our challenge specifies that it should run anytime count changes, so let's very explicitly put count in here. And now I hit save. Anytime count changes, we get effect function ran. In the next lesson, let's bring back our Star Wars data and get that displaying on the screen again, but this time without an infinite loop occurring in the background. It's quiz time again. Pause the screencast, read through the questions, type down your answers, and when you're ready, hit play and we'll go through the quiz together. What is a side effect in React and what are some examples? Put very basically, a side effect is essentially any code you want to run that React is not in charge of handling. A majority of the time you can think of that as your code that will have some kind of effect on an outside system. So some examples of that might be local storage, anytime you interact with an API, something like WebSocket subscriptions. However, another example of side effects is whenever you have two pieces of state, two states that you want to keep in sync with each other. So those are the examples maybe to answer the first part of the question. A side effect is any code that affects an outside system. The two states keeping in sync maybe doesn't fit perfectly in with that, but hopefully our examples clarify that a bit. So then what is not a side effect in React? Basically anything that React is in charge of. So some examples of that is maintaining state between one render to the next and keeping the UI basically in sync or displaying correctly with the data, whatever that data might be, whether it's state or props. There's certainly other things that React is doing, but it mostly boils down to these two or three things I think we have in the slides about what its primary tasks are. So yeah, to take our elements and render them to the DOM as well. So we'll say render DOM elements. Okay, number 3, when does React run your useEffect function and when does it not run the effect function? Well, it will always run your effect as soon as the component loads. So that's on the first render of your component. And then by default, assuming we don't pass any dependencies to our dependencies array, like we ask about in question number 4, it will run our effect on every re-render of the component. So that's assuming no dependencies array. And when does it not run the effect function? Well, it will only not run the effect function if there is a dependencies array available, in which case it will not run the effect when the dependencies in the array stay the same between renders. And maybe I should say when the values of the dependencies in the array stay the same between renders. Okay, that leads us in perfectly to number 4. How would you explain the dependencies array? Well, syntactically, it's the second parameter to the useEffect function. And its purpose is to allow React a way to determine whether it should rerun the effect or not. It ends up being an array of values that when React is in charge of re-rendering a component, it will compare the values in the original array with the values in the new array that the effect is running when the component re-renders. And if any of those values is not the same, it will rerun our effect function. So on a high level, it's simply a way for React to know whether it should rerun the effect function. Okay, awesome job on this quiz. We're really rounding the final corner on this section. We just have a few more things to cover. So when you're ready, let's jump right in. I want to work through together getting our little app back to a state where it can pull the Star Wars data without some kind of infinite loop happening in the background. So I have a small series of quiz questions I'm going to ask. First of all, what will happen when I uncomment this code and hit save? How is my app going to act with my useEffect function set up exactly this way? Make sure to look very carefully through the code here. Don't refresh the app or anything like that. Just use what you have learned so far about useEffect and the dependencies array to figure out exactly what a useEffect that looks like this means. Well, for one, we can see that we're telling useEffect that it depends on the count variable, which means that if count ever changes, it's going to run this function again. And if we look closely in the function, we see that we're receiving the data, but we're just console logging it. We're not currently updating our state with that data. Let's open the console and see if this holds true to what we expect. I'll hit save. The very first time around, it's console logging the data that we got back from the Star Wars API. And then if I change my count, it's logging it again. Not only is it logging it again, it's actually going out to the API and getting the data a second time. So that leads me to the next question in our quiz. The second question is, how will this useEffect be different if I use set Star Wars data instead of the console log? Like before, I want you to pause and look through this code, try to analyze it, and see if you can understand how things will be different now. The main difference, of course, is that we are actually going to be updating our state when we receive that data back. Updating that state is going to trigger a re-render of our entire component. However, that re-render will not change the value of count, and therefore will not change this array from one render to the next, and therefore will not rerun our effect. So let's hit save. We'll see that our data populated. It all happened kind of quickly, but really what happened in the background is our component rendered the first time, which ran our useEffect. If I haven't said it explicitly, useEffect will always run on the first render. That triggered the fetch request to go get our Star Wars data, which eventually set the Star Wars data. Setting the Star Wars data updated state, which caused the component to re-render again. So now Star Wars data is the object that we see. It rendered the Star Wars data as a JSON object to our screen. And then the effect checked to see if the old count still matched the new count. And sure enough, it did. And therefore, it did not rerun our effect. Because it didn't rerun our effect, we did not get our Star Wars data again, which would have caused that infinite loop. If I remove my dependencies array completely, then we're back where we started, where setting the Star Wars data re-renders the component, which runs our function, which sets the Star Wars data, which re-renders our component, and so forth. Now, it is pretty contrived to have a dependencies array that is looking at the count. Because if you thought all the way through this, you would also notice that if I scroll down and I click my add button, it's going to make another call out to the API. We don't have a console log or anything like that. I bet if you were to open your developer tools, you would have seen in the network tab that it did make another request out to the Star Wars API, and it did set our data here, which would have caused a re-render. We just didn't notice anything because the data that came back is exactly the same as what we had on the screen before. So that leads me to the third quiz question. What exactly should be in our dependencies array in this case? We can see that our code is not making use of count. Usually what you put in a dependencies array will also show up somewhere in the function. But right now, we're not using count to determine how this function runs at all. So if count shouldn't be in our dependencies array, what should be there? Some of you might have thought that it should be Star Wars data. But if we think through what we've learned about the dependencies array, we'll know that if I put Star Wars data in here and set Star Wars data inside the body of that function, I'm going to get an infinite loop again. Because when I set Star Wars data, it's going to change Star Wars data and it's going to re-render the app, which will then run our effect and we'll end up in that same loop. Assuming I only want this API request to happen when the app first loads, if I leave this empty because there are no dependencies for this to run, then I can successfully set up my effect so that it will just run the API request on the very first render of our component. Now we can see if I hit save, it updates our data, and actually, you know what, let me put a console log here. I'll say effect ran. I'll hit save again. We get our data, we get the log for effect ran, but now even updating my count is not running our effect again. I know this has probably been a lot to take in, but I'm glad you've stuck with me so far. I really hope you thought through those quiz questions as I gave them to you. If not, you always have a chance to go back and re-answer those quiz questions. And when you're ready, in the next screencast, we're going to extend this example just a little bit to try and help drill in the way that useEffect is working. We're going to start right off with a challenge. I want you to combine our count with our current URL that we're using to get our Star Wars character so that clicking the Get Next Character button will do the fetch request, but for the next character ID. Right now, it's the character of 1, which, as we can see, is Luke Skywalker. And I've updated our state to begin with 1 because I don't think that there's a character with an ID of 0. So essentially, clicking Get Next Character will increment count, but instead of having a hard-coded 1 in here, it should look at whatever the current count is to make this request. While you're at it, don't forget to consider your dependencies array. Pause the screencast and see if you can get this new feature to work. There should only be 2 small changes that we need to make. One is, instead of hard coding a 1 there, we can add to the end of the string our current count. Now, I prefer to use the template strings if I can, so I'm going to change this to a template string. And then instead of using plus count, I will interpolate the count value inside. Now, if I didn't make any changes to my dependencies array, think for a second, what's going to happen when I refresh and I try to get the next character? When I refresh, my component is going to run, and it will run this effect because it will always run this effect on the first render. Count will be set to 1, and so it will make a fetch request to the Star Wars API where the endpoint is people/1. However, because I have nothing in my dependencies array, nothing is going to trigger this function again. Let me put count back in here, and I need to make sure that I will rerun this effect anytime count changes. So now I'll hit save. After the first render, it went to the API and got the character with the ID of 1. We can even see here it says the count is 1. Then I'll click Get Next Character. The count is 2. And after a little bit, we get our next character, the one with the ID of 2, which is C3PO. So when I click Get Next Character, it updates count. Updating count reruns my function, or rather re-renders my component. The effect then looks at the old array, which was an array with one item with the number of 2 in it, and then it looks at the new array, which is an array with the number of 3 in it, and notices that something has changed, which is then a trigger to run my function again with the new number of 3 as count. We have a couple more things to learn about useEffect before we can check that one off our list. But before we do that, it's time that we go back to our meme generator and we use our new knowledge to apply what we've learned about making an API request and saving that data to state. So that's what we'll do next. All right, we've made it to the very last challenge of the meme generator, and then we'll have completed the project. If you remember, up until now, we've been importing our memes data from a file that I created, and this data just came literally copy and pasted from an API request to the ImageFlip API. But since that's not usually how things work, instead we're going to make that API request ourselves, and we'll do that inside of the meme component. So your challenge is, as soon as the meme component loads for the very first time, you should make an API call to this URL. Once that data comes in, you can save the memes array part of that data, so the data will look like this object, and you can save just the memes array part of that data to our all memes state. You might notice I renamed this from all meme images to just all memes, and that's because the meme data that comes in is not just an image. They are objects that contain a URL, but I thought that all meme images might be a little bit misleading. Since you know that you'll probably need to use useEffect to accomplish this API request, you should think carefully about what the dependencies will be, if any, that if they were to change, you would want to cause to rerun this function. If there are any dependencies, make sure to include them, and if there aren't any, then make sure you understand why. As a hint, if you have used async await functions before or you feel really comfortable with them, for now, don't use them. We're going to learn in the next screencast how we can successfully use async await inside of a useEffect, but it turns out it's a little more challenging than it might seem on its face. So for now, just use .then blocks to resolve the promises that come back from making a fetch request. All right, the time is yours. Pause the screencast and work on this challenge. All right, maybe right here below our state, I will make a call to React.useEffect. The first parameter is a function. I'll use an arrow function since that's the more common way you'll see it. And let me actually think about the dependencies first. Now, I want this API request to happen as soon as the component loads. And if you remember, what we're doing is saving all of those memes in our state, and then we're accessing a random one of those memes to determine what image should get showed in here. However, there's nothing that is changing in state that will actually require me to make another API request. And so since I have no dependencies for this effect, I'm just going to leave an empty array. Then inside of our effect, we will make a fetch request to this URL. So I'll call fetch, put in that URL, resolve it with the .then. We're going to take the response and parse the JSON into JavaScript. And then we'll have some data back. And before we jump into setting state, let's just console log that data and see how we're doing. We'll hit save, and awesome. Okay, that looks very similar to what we have in our memes.data.js file. So now we should be able to use set all memes instead of console log. So we'll put in set all memes. However, if you read carefully, it says that we just want the array part of the data that we get back. So I'm not going to put the data in there. If this object represents data, then I actually have data.data. Maybe data wasn't the greatest choice because we have data.data. That's an object that has a memes property, so data.data.memes. So let's put that in here, data.data.memes. Outside of my effect, I think I will just try console logging all memes. And so what should happen is on the very first render, we have no dependencies, so this effect will not run again, but on the very first render, it will fetch our memes, obviously parse the JSON, and then set all of our memes to the data memes array. Setting our state will cause a re-render, which should then run our console log a second time. This console log will run the first time that it gets rendered, and then again after the state changes. Now, of course, if I left this here, it would also console log all memes for every character that I typed into my inputs or every time I clicked the button. But for now, let's just see what this gives us. And that was confusing to me because we are initializing it with memes data. Let me actually delete memes data and then put in an empty array here. The empty array is, I'd like to think of it as an empty box that we will then fill with our memes as soon as our component loads the first time. Let me hit refresh again. Okay, and that time we got an empty array first from our first time this console logged, and then we got the array of memes from the API. Awesome. So I can delete my console log. Actually, let's see. Now every time I type something here, we're going to be logging the all memes array to the console. So we don't want that. Let's go ahead and make sure everything else is working correctly. We'll click get a new meme image. And we actually have a bug in our code. I think I'll actually make this a challenge for you. Okay, your challenge is to try and figure out why our code is broken. As a hint, it does have to do with the difference between what we were importing before from our memes.data.js file and how we were using that versus what we're setting as our state in set all memes inside of our use effect. Pause now and see if you can fix the bug that we've introduced. As we saw before, when we were importing the memes data, we were receiving this object. So we had this object, which we called memesdata.data.memes. However, in state, when we were setting state, we were initializing it with the entire object, not just the memes array. So we kind of switched things up when we were setting the array in state instead of the whole object. However, down in our get meme image, we were accessing the memes array by using allmemes.data.memes. But now all memes is an array, it's not an object with a data property. So I think I can actually just get rid of this line completely and replace memes array with all memes. And I won't need this line anymore. So now I'm accessing allmemes.length and I'm indexing into all memes at our random number to receive the random meme image. So let's try again. We'll hit save. One does not simply walk into Mordor. Get a new meme image. Very nice. Just to polish things off, I'm going to clean up this challenge. I'm going to delete our memes data file. And awesome, everything is looking great. Before we can tie off a nice little bow on this section, I want to talk about useEffect for just a little bit longer. As I mentioned, if you're familiar with async await, it may have been tempting to say, well, I want this callback function to be an async function so that I can use the await keyword here and use a little bit more tidy version of our promises here. So that would look something like this, where you say the response is wait for the fetch to come back, and then you would say data is await response.json, and then you would just set all memes to be data.data.memes. If you're familiar with async await, obviously we can see this is tidier and this would be really nice to use. However, you'll never want to make this function an async function. And to really understand why, we need to talk about one more thing that we can do with this function inside of our useEffect. So before we move on, let me undo that. And let's talk more about that in the next lesson. We'll start this one off with a pretty simple challenge just to make sure you're still awake and keeping your hands on the keyboard. In our app component, we are rendering a button and a component called Window Tracker. And over in Window Tracker, right now, all it's doing is displaying the current inner width of our window. Because it's directly accessing the window.innerWidth as soon as the component loads, that's not updating, but we're going to get to that later. So if I hit refresh, it'll give me a new window width, but we're eventually going to make it so I can change the window width and that number will dynamically update. However, for now, let's focus on this challenge. Your challenge is to create some state called show, which we will default to true. Make it so that when the button gets clicked, it will toggle that show value back and forth, and conditionally render window tracker only if show is true. Pause now and work on this challenge. Okay, let's create some state. Const show set show equals react.use state with the default of true. I'll create a function just called toggle that will run set show. It'll look at the previous version of show and return the opposite of that. Then we'll set that up as an onClick on this button. And last of all, we will conditionally render the window tracker component if show is true. So I'll say show and the window tracker component. Easy enough. We'll refresh and it's toggling on and off. Awesome. Now here's something to take a look at. If I widen my window a little bit and then toggle this off and back on, you'll see that our window width changed. And that's because when this component window tracker gets toggled off, it essentially is what's called unmounted. Is completely removed from the DOM. When I click it back on, it's remounted, and therefore it will rerun this window.innerWidth, which gives me the updated version of window width. The truth is, though, we can do better than this. What we can do is add an event listener to our window that listens for the resize event, and then whenever the window is resized, we can set some local state to our window tracker so that we can display the correct window width at any given width without having to toggle it on and off or refresh our page completely. However, because it's an event on the window, I can't simply add something like an on resize event like we have with other event listeners up until now. And so I'm going to have to do a little bit of manual imperative DOM manipulation. And because I'm going to be interacting with a system outside of our window tracker component, in other words, the window itself, think for a second, what tool does React give us to interact with some kind of outside system and keep our local state in sync with it? That's right, it's useEffect. So I'm going to set up an effect. We'll say react.useEffect. And I'll put my callback function in here. And when we think about our dependencies, at first glance, it could be really tempting to say, well, I want to rerun this effect if window.innerWidth ever changes. However, something to keep in mind is that this function, our component function, gets run each time the component is rendered. Right now, when the component is rendered, window.innerWidth is equal to 474. And that's a constant value that's not going to change on its own. So let's say, for example, I refresh this, I change the window size just a little bit. There has been nothing to trigger a re-render of my window tracker component because window.innerWidth is not something that automatically re-renders a component in React. So that was a bit of an aside, but I'm going to remove that. And instead, we're going to listen for a resize event on our window. So I'm going to say window.addEventListener. We'll listen for the resize event. And then we will run the following function. For now, let's just console log resized. Okay, now I resize and we get our console log running. Awesome. The next step is something I think you can do pretty easily by now, and so I will type that out as a challenge. Your challenge is to create some state. We'll call it window width, which you can default to the current window.innerWidth whenever the component is rendered. Then inside of our event listener, you should update the window width every time it changes. And you should change our h1 to not display the window.innerWidth that it calculated the first time the component rendered, but instead to point to our new window width state variable. Pause now and work on this challenge. Okay, we will create window width and set window width. React.useState, and we'll default it to the current window.innerWidth that it calculates when the component first renders. Then inside of our callback function, instead of console logging resized, we will set the window width to be the window.innerWidth at the time that this function runs. And last of all, we will look at the window width instead of window.innerWidth. So now when I make changes here, okay, our window width is updating dynamically. Awesome. Well, now let's take a look at a little bug that we have. I'll clean up this challenge first. Remember, our window tracker component is only mounting when its parent is allowing it to render with this show variable. When it rendered the window tracker, it immediately launched or created an event listener anytime the resize event happens. That event listener is registered with the DOM itself. So even if I toggle off my component and then try to resize the window, we see that we get this warning. And it tells us we can't update React state on an unmounted component. So in the end, what happened is our window tracker is no longer a part of the DOM, but the browser itself is still listening for the resize event and trying to set the window width of an unmounted component. This is something called a memory leak. And for now, it's good enough to know that you don't want a memory leak. Now, due to the challenges that you just completed, this screencast is getting a bit long. So in the next lesson, let's address this issue of the memory leak and see what we can do to fix it. Previously, we saw that if I were to turn off my window tracker component, or rather stop it from rendering, and then run my resize event, we get this warning that talks about a memory leak. As a reminder, it's because we set up an event listener on the window, which registered it with our browser, and even removing the window tracker component by toggling it off does not automatically remove that event listener. One thing you should always try to be aware of when you are interfacing with side effects using useEffect is any potential consequences that might happen if you don't clean up the things that you do in that side effect. This is just one example where we're adding an event listener that is not getting cleaned up when this component unmounts. But there certainly are other instances of this. Let's say, for example, you are creating a WebSocket connection with maybe a chat API, and you have a little chat app that will update your screen automatically every time there's a new chat message on the server. Well, when you create that subscription to the chat API and then try to unmount the component, it's always a good idea to then sever that WebSocket connection as a way to, so to speak, clean up the effect that you have created in your useEffect. And in fact, that's actually what we're about to learn is called. It's called the useEffect cleanup. Fortunately, it's pretty easy to do. Remember, we have a function as our first parameter to useEffect, but currently we're not actually returning anything from that function. Well, as it turns out, what we can return from useEffect can be a function, and you can think of this as a cleanup function. In fact, to make that more obvious, let me put this as a function declaration. So when React runs our useEffect function here, it will receive in return another function that it can use to then clean up any side effects that you might have created. In reality, it has no idea what the side effects are that we created, so what we put in the body of our cleanup function should be something that, well, we write to clean up our own side effects. In the case of adding an event listener, there's a sister method called removeEventListener. Now, with removeEventListener, we need to pass the exact same function that we provided when we added it. And so I actually need to move this outside of the event listener and set it up. Let's call this watch width. Then I can pass in the name of watch width when I'm adding my event listener, but this allows me to then say window.removeEventListener, the resize event, and the event listener function I want you to remove is this watch width function. Okay, let's see that this is working first. I'll put a console log that says setting up inside of my watch width event listener, and then inside of my cleanup function, I'll console log cleaning up. I'll hit save. Let's resize the window. Look at our console. Okay, it's running setting up every time the watch width function runs. Maybe setting up isn't the right way to phrase that since we're actually running this every time the resize event happens, but that's okay for now. So we get a bunch of setting ups, and now let me toggle off the window tracker. Actually, let me refresh and then do one little resize, and then I'll toggle the window tracker, and we see that we get the cleaning up function that ran. And now if I resize my browser, I don't get that memory leak warning like I had before. So let's take a step back and walk through this logically to understand exactly what's going on here, because this can be a confusing topic. Our app component is deciding when the window tracker component should be rendered. As soon as we toggle that on and it renders it to the screen, it sets the window width state. It determines what that should be based on the current window width at the instant that this component gets rendered. Remember, useEffect will only run after the DOM has been painted, or in other words, once the H1 has been rendered to the screen. So after creating the state, it will render our H1, and then it will register our useEffect. This useEffect has no dependencies because there's nothing inside of here that's going to make me re-register a new event listener. And so it registers this event listener on the resize event of the window. And then anytime I resize, it's reacting to the event listener that I set up. And then when I toggle off the window tracker, React recognizes that this component has reached the end of its life cycle and it's about to be removed from the DOM. And so it takes the function that it received from us when it first set up our useEffect, and it just runs it. In fact, it runs it kind of blindly. It doesn't know what that function contains, but we as the developers are expected to successfully clean up after our side effects. And so we remove that event listener, and it is gone. So one last recap. useEffect takes two parameters. The first one is the effect that you want to run. The The second one is any dependencies that React should watch for changes in to rerun your effect function. And that effect function is allowed to return another function that can clean up after any side effects that might be lingering in case your component dies. Now, for many effects that you set up, you might find yourself not actually needing to provide a cleanup function at all, in which case that's completely okay. This is not a required part of useEffect for it to work. As always, feel free to play around with this code. I know that this can be a confusing topic, so the more time you spend in it actually playing with the code yourself, the better off you'll be. Understanding this return function does bring us back to the topic that we were talking about a few screencasts ago on how we can't use this as an async function. And so let's go back, revisit that topic, and then we'll finally be ready to recap this entire section. I mentioned in a previous screencast that we wouldn't be able to simply put async in front of our callback function for useEffect. And now that we've learned about how we can return a function from useEffect to act as a cleanup function, we will probably see why we're not able to put async in front of this callback function. If you're familiar with async functions, you know that by putting async in front of your function definition, it alters the way that function, functions in JavaScript. Whatever I return from an async function does not become a bare value return that we can receive in a variable when we're calling this function, but instead an async function will automatically and always return a promise. As I'm writing my async function, whatever I say should be returned is actually what will be resolved as the successful promise completion of my async function. However, since React is expecting the return value from my async function to be another function that it can use to clean up any side effects that I create in the process of running my effect, if what it receives instead is a promise, it's not going to be able to run our cleanup the way that we want it to. Fortunately for us, there's a really easy workaround to this, and that is to define a separate function inside of useEffect. And remember, if you're okay using .then syntax with promises, then you don't have to do any of this at all. But let's say you really are anxious to use an async function. Well, I can just call a new function. We'll call it an async function. And maybe let's say get memes. And now because it's an async function, I can move this content in here and say something like const response equals await the fetch request. Const data equals await res.json. And then with that data, I can set my memes. Now, this is just a function definition, so the very last thing I need to do before I'm done is to call my own function here inside of this callback function. This is a lot of functions to be dealing with for sure. We've got a callback function which has a function definition, a function call, and then a returned function. But again, if this is too much, then you can just go back to using .then syntax with your promises, and that's completely okay as well. In our case, with our effect, we probably don't need a cleanup function here because we're just making this one call one time. It's happening as soon as this component loads. There isn't really a built-in way for us to unmount the meme component or anything like that. And so we can just delete our useEffect cleanup function that we were returning from our callback function. I tried to take everything that we just talked about and boil it down to a written summary. So if you're interested, you can read through the summary that we just put here. And now we'll take the opportunity to take a look back at all the new things that we learned about React in this section. And we've covered a lot of ground. So when you're ready, let's take a look at all the cool new things that you are now able to do as a React developer.
Holy cow, I can't believe we are finally here at the end of section 3. We have covered an insane amount of topics, and you have built your first interactive React app. I mean, even try to think back to section 2 and what we knew then versus what we know now. It's crazy. Before we wrap up this section, let's do a quick recap of everything that we've learned. One of the key components of an interactive web app is the ability to listen for events. So we learned how to add event listeners in our React app. And that was a crucial springboard for us to learn state. Then, even though we had seen a sneak peek of conditional rendering beforehand, we officially learned conditional rendering and saw a few different ways that we can implement it in our code. Then we kind of waded through one of the heavier topics of forms in React.
For better or worse, you'll end up using forms pretty regularly in React. And on a side note, I hope you mostly just have to do input boxes instead of worrying about all those other kinds of types. But it's important that we learn them so that we can apply them when we need. And then we dove deep into understanding side effects and how we can handle side effects in our React code. These topics, combined with everything that we learned in the previous 2 sections, make up a really robust introduction to the React library. And of course, there's a ton more that you can still learn about React, but these foundational pieces give you the tools that you need to build your own basic web apps. Especially considering the depth of the topics that we learned in this section, you should definitely go over to the Today I Did channel in the Scrimba community Discord server and post a celebratory message saying that you finally finished section 3 of the Introduction to React course. In fact, if you click this screenshot, it'll take you right there. And the end of this section essentially marks the completion of the topics that we'll be learning in this course. However, if you know me at all, you know that I'm not going to let you go before I get you to practice this a lot of times. So the next section is completely dedicated to practicing everything that we've learned. And along the way, there's a couple new things that I'll introduce here and there. I'm really excited to jump into the next practice section, and I think you should be too. We're going to be working on some really cool projects. Before that, though, you should bask in the glory of having completed this section. So once you're all done basking, I will see you in the next section. If you're jumping into this section because you have completed all of the other sections, all the exercises or challenges, and all the projects that I have thrown your way, then congratulations, you have done a lot of work to really learn and hopefully deeply understand React. Naturally, there's a million more things you could learn about React. It's a framework you can dive really deep into and get very complex with. But at this point, you really have all of the fundamental tools you need to build highly interactive web applications on your own. So at this point, this section is dedicated completely to, you guessed it, practice. I know I've said it a million times before. I hope you're not terribly sick of me saying it, but you will not get good at anything unless you practice it over and over. We know this intuitively when it comes to something like learning a new instrument or learning a new language, and it's absolutely no different when it comes to web development. So for the remainder of this section, we will be working on 3 projects, and I want to take a second and give you a preview into what those projects are. Now, this will be a little bit different than what we've done in the past. So far, we've mostly been creating something completely from scratch. However, the first 2 projects I'm going to have you work on, you'll actually be jumping into an existing code base. And we're going to ramp up to this a little bit. The first task you'll have is to revisit our React Facts site from the very first section in this course, but now to apply the knowledge you have about state in React to implement a light mode and dark mode toggle, which will allow the user to toggle between those 2 color schemes. This one will end up being more of a warm-up project because it will only be 1 screencast long. Then you're going to jump into a new project, which is sort of a markdown version of an Apple Notes clone. Some of the basic code for this will already be written for you, but some of it will be broken, and along the way, you'll also be learning something new as you implement a new feature that interfaces with local storage so you can save these notes in a little bit more permanent way. Then for the third project, we'll go back to our roots. We'll be creating it completely from scratch, and that is this dice game called Tensies. Every single step along the way with these projects is going to be a challenge for you to complete, so you will get your hands on the keyboard and you'll get lots of awesome practice to help you really solidify the things that we've been learning about React. So what are we waiting for? Let's jump right in. We're going to start off with a sort of warm-up challenge here. Usually when you join a team as a web developer, you probably aren't going to be creating your projects completely from scratch, but instead will sort of be tossed into a new code base that you then have to spend some time becoming familiar with before you can do any kind of work on it. Now the code base here, fortunately, is something that you have worked on in the past, and that's the React Facts site that we worked on in the first section. But I'd like you to imagine that when you finished the first version of this code, you handed it off to a team, and in the meantime, they've been working on implementing this light mode and dark mode toggle, but are needing some help for you to add the functionality to it. So a major part of this challenge is to spend a really good amount of time looking through the existing code because it has changed since you last looked at it, and make sure that you spend some time understanding how everything is working. In my little advice section here, you see it says to first start with index.js, work your way to app.js, go to main.js and navbar.js, and then to follow the CSS class names in the style.css so that you can understand how things are working. While you're at it, make sure that you're looking closely at the conditional class names in the JSX to help you decide what props need to be passed down to the components that need them. You should also think carefully about which components will need state. This is going to help you decide where you're going to write the code that initializes the state and how to then pass it down to the components that need to access it. In the slide down here, I included a couple screenshots that have both the light mode and the dark mode. You can click on either one of these to go to the Figma file that has the specific colors and other design aspects. However, in reality, the design has already been implemented. You shouldn't need to do too much in changing the design because it all is existing in the CSS. On this next slide, I also have a little animated GIF that shows you exactly what should be happening. Of course, you click the light and dark mode up top, and that will change every aspect of the site to its light mode or dark mode color scheme. Again, jumping into an existing code base like this is going to be a really common task as a developer. So when you're working on part one of my advice here, spend a real significant amount of time doing this. I imagine it will realistically take you at the very least about 5 minutes, but even upwards of 20 or 30 minutes before you maybe get a good grasp on the code that we have here. Okay, the time is yours. Pause the screencast and work on adding this light and dark mode feature. Let's start off by looking in index.js. I think we're going to find it's not that impressive here. We're really just importing app and rendering it. So let's follow that down and go to app.js. Looks like it is rendering a div with a container class name that is containing the navbar and the main elements, which we're importing up above. So let's go to navbar. Okay, this one's a little more significant. Like I mentioned, looking at the conditional class names is going to give us some good hints as to what we need to do. Here we can see that navbar is expecting props, and specifically one of the props called dark mode. I'm assuming this is a Boolean because of the way it's positioned in this ternary here. It says if props.darkMode is true, then apply the class name of dark, otherwise don't apply a class name at all. And if we look really closely, we also are expecting a prop called toggle dark mode, which makes sense because our toggle here exists inside of the navbar. So clicking this toggle should change the dark mode from true to false or false to true. The other thing app.js was rendering is this main. So let's go look at the main. It looks like main is also expecting props. Again, props.darkMode, so it's going to do essentially the same thing. And I think that's it. This one is not expecting to toggle the dark mode anywhere, so we should be set up now to create the state we need to make this light and dark mode work. Now, because both the main and the navbar are expecting an incoming prop called dark mode, that means that the parent of those, this app component that contains or renders the navbar and the main, should probably be where the state is being held. So let's go ahead and create our dark mode and set dark mode, which is react.useState. Maybe since the code right now is showing that it is not in dark mode, let's set this to true so that when everything is hooked up correctly, we'll see the page update. I'll pass the dark mode prop to both of my components since we saw that they both are expecting it to come in. And then the navbar specifically is expecting something called, I think it was, well, let's just go look at it. Navbar toggle dark mode. So I'll copy that. That's the name of my incoming prop. And now I need to provide a function which will change the dark mode. I could do that inline, or my preference is to create a separate function. So we'll say toggle dark mode. And that's simply going to call set dark mode looking at the previous mode. And it'll just return the opposite since it's a Boolean. And now let's pass our actual toggle dark mode function down to the navbar. I'll create some space here. Let's hit save, and when we do that, it should switch to dark mode. Awesome. Okay, and then we can click our toggle. Great, this is working just like we'd expect. Obviously, what we have worked on here might be a bit contrived because in our case, somebody already implemented some of the major features that make this work. But that's what makes this a warm-up. We're really gearing up to work on something that's a little more in-depth. And the main takeaway I want for you in this challenge is not so much implementing the actual feature in this case, but instead taking the time required to look through the code and to understand the code. Of course, if you're working on this with a team, you'll probably have access to the developers that had written this code, and that's when you could ask them questions. Why did you write something the way that you wrote it? And that way you can get some good insight from them on how it's written and how you should proceed when you're adding new features. Okay, I feel like we're nice and warmed up, so now we're ready to jump into another existing code base, which is one of our major capstone projects for this section. As a developer, it can be really fun to start new projects from scratch, especially when that project is one of your own ideas. However, a much more common task as a developer is to be thrown into a code base that you're unfamiliar with and asked either to fix bugs or add new features. Naturally, before you're able to be productive on any code that's new to you, you need to be able to read through the code that exists to get a sort of lay of the land and make sense of what you're seeing. Only then can you start to feel confident enough in the code base that you'll be able to add new features or fix bugs without actually causing new bugs in the code or breaking an existing feature. Now, in reality, this is where something like automated testing comes in really handy. But unfortunately, you won't always have the luxury of working on a code base that has robust testing already set up for you. And so I'd like to introduce you to the Markdown Notes app. I guess I didn't get very creative with the title. This app already has some bones set up for you. You can see that there's a list of notes that will be on the left. You can create new notes like I just did with this plus button. And on the right, there's a Markdown editor where you can toggle between preview and write. Now, this editor is not something that I wrote. This is built by another team that made a package called React-MDE Markdown Editor, and we've simply implemented that package into our code here. So on each one of these notes, I can type new things into the note. I can switch back and forth between preview and write mode. Everything here is Markdown, so when I bold something, it will surround it with the double asterisks. But when I go into preview mode, it will render that as HTML, and so we see a bolded paragraph. If you haven't spent much time doing Markdown, you can play with the editor here and get a general sense of how Markdown works, toggle back and forth between write and preview. But as it stands, this Notes app has some very limited features. First of all, we see that it's just calling our notes Note 1, Note 2, Note 3, Note 4. We also have no way to delete any notes. And probably worst of all, if I refresh this app, all my notes disappear. This is the screen I set up if we have no notes, and we can click the button to create one. So before we even dive in to look at what features we plan on adding to this project, I have your very first challenge, which is to understand the codebase. I'll type it out to be more specific. Your first challenge is to spend a good 10 or 20 or maybe even more minutes reading through the code and trying to understand how it's currently working. Now, I say 10 to 20 minutes as a guideline, but you really should spend as much time as you need to feel pretty confident that you understand this existing code. Although, in reality, you don't need to fully understand everything you see here just to move on. I will walk you through a high-level overview of the app, but I really urge you to actually pause, spend this time reading through the code, see if you can understand it before I get to my explanation of it. This kind of exercise is crucial when it comes time for you to actually jump into a real company's code base. So now is not the time to shrug this kind of exercise off. So pause now and spend some time to gain an understanding of this code. I think it never hurts to just start right at index.js, although we can see here that, well, we're really not doing anything. We're just rendering the app component. But it's good to know that we're not missing out on something important here. Then I'll go to app.js, and we can see this is where the bulk of our logic is happening. We have quite a few imports. These top ones, because the path is starting with a /, indicates that it's one of our own components. Here we've got the sidebar and the editor. If I had to guess, I would probably say that this section on the left is the sidebar, and this whole section on the right is the editor. If you looked closely, you might have seen data and gone over to data to see that, well, we have some really basic seed data, or rather it's data that could be used to create some initial notes for us for testing purposes. Although it looks in our case like this is not really being used right now. Back in app.js, we can see we're also importing something called split from React Split. If you really went above and beyond, you might have actually done a Google search for React-Split to see what it's doing. And it turns out it's a third-party library that we installed as one of our dependencies right here. And it allows us to have this split pane that is easily resized by the user. So that's pretty cool. We're also importing NanoID, which you may or may not have seen already. And it looks like we're using it right here when we're creating a new note. Hopefully this also illustrates the importance of naming your functions and variables with a meaningful name. When my function is called createNewNote, it becomes really obvious what this function is supposed to do. So then we come down to our actual app component, and it looks like we're saving all of our notes in state, initializing as an empty array, and then we're creating this state called currentNoteID, and it looks like it's initializing it either as the ID of the very first note or an empty string. Now you may have seen this first part and been a little bit confused. Honestly, that's okay. But as a side note, this is one way to essentially say, I need to make sure that notes at the index of 0, because notes is an array, exists before I try to access the ID property of that note. When we initialize state as an empty array, in other words, when I refresh this app and I have no notes, notes at the index of 0 is undefined, and trying to say undefined.id will actually throw an error in JavaScript. Again, that wasn't totally necessary for you to fully understand, but that is an error you're going to run into quite a bit. In more updated versions of JavaScript, there are different ways around this, but that's outside the scope of this course right now. Next, we've got this createNewNote function, which is relatively self-explanatory. Based on this setNotes call, it looks like it adds the new note to the beginning of the list, and then it looks like it sets the current note ID based on this note's ID. At this point, I might not totally understand what the purpose of setCurrentNoteID is, but that's okay. This update note looks like it is a way for us to save in state any changes to our notes that we create, which allows me to actually type something here and have that be saved, at least locally in state for now. Find current note. Well, this isn't setting state or anything, so that doesn't seem immediately obvious what it's doing. But if we look a little further down, we can see that it might be a helper function that is helping us determine what the current note is. And we're doing it both in the sidebar component and the editor component to pass the current note down as props to that component. Again, if I were looking through this code base for the first time and I saw this split component, I would probably end up going to the React split documentation to try and better understand how that works. It looks like we are conditionally rendering this split component if the notes array is greater than 0 in length, but otherwise we have this section here, which is what we get when we first refresh the app, and we have our title and our button. So that's a good enough start in here. Let's go look at our sidebar. Immediately, I see this props.notes.map, which looks like it's taking the array of notes and mapping it into some note elements, which are then being displayed down here. This will show up better when I actually create a note. And if I create more notes, it looks like we have this class that actually changes the sidebar style when one of these notes is selected. That's this selected note dynamically rendered class name. It also looks like when we click anywhere inside of a div, we can set the current note ID, which I presume is what's helping us change this class, and also should be changing what actual text is being shown here. If I call this note 1, note 2, note 3, and then toggle between them, yep, that seems to be saving, or rather correctly displaying, the text that gets shown up in our editor. Then in our editor itself, this one seems fairly straightforward. It is maintaining its own state, and it says selected tab, although the default here is right, and so I'm guessing that has more to do with this little tab up here, right or preview. And if you did take the time to go search for React MDE, you might have seen that this React MDE component, it takes a prop called selected tab and on tab change, and that is something that's built into React MDE. Now something like this, which is creating this converter object and has something called showdown.converter, I assume unless you have done some kind of Markdown to HTML conversion before, this is probably completely foreign to you. Something like this is probably not super imperative for you to fully understand in order to understand the rest of the code base. However, it certainly wouldn't hurt to go to Showdown and look at the documentation to see if you can at least gain a general understanding of what it's trying to do. Okay, now I know that was pretty long-winded, but the truth is I'm really hoping that you spent even more time than that trying to understand everything here. Fortunately, in this environment, you also could have just started clicking in here and making changes to see what kinds of things you could break. Curiosity like that is going to be really helpful for you when you're trying to understand how something works. Now, since this screencast is getting a bit long, I want to, in the next screencast, start talking about the features that we want to add to this note-taking app. Let's take just a minute to look at the features that we will be adding to our Markdown Notes app so that it's at least a marginally usable app. The first thing we're going to do is sync all of the changes that happen to our notes with local storage. We won't be saving anything to a database in this project, but at least so that we have a way to save our notes between refreshes of the app, we're going to be using the browser's local storage to save every little change that happens to those notes. Next, we're going to fix the thing that's just showing note 1, note 2, note 3, because, well, that's not very helpful in terms of trying to find our notes going forward. Essentially create a note summary and use that as the title. In reality, it's just going to take the first line of our note and put that in our summary title right there. Next, we're going to add a feature where every time we modify a note, it bumps it to the top of our list. That way we have our most relevant notes living near the top of our list instead of possibly buried way deep down on the list. And then last, but certainly not least, we're going to add the ability to delete notes. Along the way of adding these features, we are going to learn another thing or two about React, so that's going to be exciting. So assuming you've taken the time to really dive deep into the code and understand how this project is working currently, that means you're ready to jump in and start working on this first feature, which we will be working on in the next screencast. Let's start with the very first feature, and that is to sync your notes with local storage. In case it's been a minute since you've used local storage, or if this is the first time you've ever accessed local storage, I created a little slide here that should help you get started. This link up here will go to the MDN docs for reference, but essentially you'll be using localstorage.getItem and localstorage.setItem to interact with the local storage API. When you're using getItem, you provide a key, and that key is like an object, a way to access the data that you saved in local storage. In our case, I'd probably recommend calling this notes instead of key. And then when it's time to set the item in local storage, you will both access the key where you want to save this and the value that you want to save. Now, it's important to remember that value has to be a string when it's saved in local storage. So if you have something that's a little more complex, like an array or an object, you'll need to use json.stringify to turn that array or object into a stringified version, or rather a JSON version that can be saved in local storage. And when it comes time to pull that out of local storage and use it as regular JavaScript, you'll need to essentially reverse that by using json.parse. So that brings us to the written part of our challenge. Every time the notes array changes in state, you should save the array of notes to local storage. Once again, I put here that you'll need to use json.stringify to turn that array into a string in order to save it to local storage. And as a second part of this, when the app first loads, you should initialize the notes state not as only an empty array, but instead with the notes that are saved in local storage. Since at this point you'll be pulling things out of local storage, you'll want to use json.parse to turn that stringified array back into a real JavaScript array. Now, to avoid a kind of confusing bug, I'm going to add a little extra piece of information here. Your code for part 2, when you initialize the state, will go right here in place of this comment. But what I added was an or empty array. What that really does is if you are trying to get data from local storage and it doesn't exist, it's going to return undefined, but we can't set our notes array as undefined. So if that does return undefined, it will instead use a brand new empty array. So I'll put this back to indicate where you should be adding your code for part 2. The last thing I'll say is that this challenge is a little bit trickier, and it's because I'm being a little bit vague. I'm telling you the feature I want you to add, and I'm giving you a little bit of a hint onto how to actually code it. But the tricky part is that you are going to have to reach back on the knowledge that you've learned throughout this course to figure out exactly how this should work. So the time is yours. Pause the screencast and work on this challenge. The main thing that I left out for challenge part 1 is that in order to interact with the local storage every time the notes array changes, we will want to set up a side effect in React. And of course, that's what we do with React.useEffect. I'll provide a function here for the first parameter, and the second parameter I can add now because I want this effect to run every time the notes array changes. Okay, so every time the notes array changes, I want to use local storage.setItem because I'll be updating the notes key inside of local storage. And I can use json.stringify to stringify the notes so that my array can essentially be turned into a string and successfully saved to local storage. And I believe that's it for part 1 of this challenge. Now that it's saved in local storage, part 2 is for us to actually access that local storage so we can, in a way, preload our app with whatever notes we've previously saved in local storage. So here I can move this onto its own line just to save a little bit of room. And we'll say I should initialize state by accessing local storage, getting the item with the key of notes. And because this will come back as a stringified value, I need to use json.parse on the value that gets pulled in from local storage. And you know what? A small correction to make. If local storage is unable to find anything at that key, it doesn't actually return undefined, it returns null. The only reason that makes a difference is because if you try to json.parse null, it will return null, which is a falsy value, and therefore it will use the empty array. But if instead it tried to json.parse undefined, you actually get a syntax error that would crash your program. So in that case, it's probably good that it returns null instead of undefined. Okay, let's test this out. I'm going to clean up this challenge. I'll hit save. And oh, I was so close. This should be get item, not get. Let's hit save again. Okay, we have no notes. I can create one. Even just creating that note should have updated the notes array, which means that if I hit refresh, awesome, we're starting with the notes that we left off on. If I make a change to the note here and hit refresh, those changes are here. Awesome. If you wanted, you also could open your developer tools, go to the application tab, and see that you have local storage that's being saved here on the Scrimba site. Now, obviously, local storage is not a perfect replica of a real database that will permanently save your data. But you can see in just a few lines of code, we were able to add a feature that made this app much more usable than it was before. So awesome work adding this feature. However, there's one tiny thing that we need to learn about to make this a little more performant than it currently is. So we're going to take a quick aside before adding any more features and learn a new little fact about React State. There's one little thing that I wanted to talk about regarding how we're initializing our state when we're pulling from local storage like this. Now, of course, whatever value we put inside of React.useState here in the beginning is just an initial value. So really, we know that it will only set this value when the app first loads. After it loads, React is going to maintain any changing state internally behind the scenes. However, there is something that we need to see. And I can illustrate that by creating some new state. In this case, it really doesn't matter what it is. We'll just say state and set state is equal to React.useState. The reason it doesn't matter is because I'm actually going to put a console log statement which will run every time this line of code runs. Let's just put state initialization. I'll open up my console, and when I hit refresh, we can see that we get that console log running, state initialization. But now I want you to think about the nature of React and what happens when any other state in the app will change. For example, if I add a new note. Anytime state changes, like adding a new note, the entire app component will get re-rendered. Well, if React is in charge of saving the initial state in the background, then it might seem intuitive that it's not going to run this line again. However, if I maybe add a new note, we can see that it does run this line again. And that's because all that's really happening is React is rerunning this entire function. In the background, it is ignoring the state that is trying to reinitialize here, but if there is code, such as running a console log, or in our example, getting something from local storage, it's going to run that code again, even if it doesn't use the value as its new initial state, because it's maintaining that state elsewhere in the background. Now, for direct commands in JavaScript, this is not a big deal at all. For example, running this console log is so minuscule in the amount of time it takes for the browser to run this line that it's completely negligible. So even when we're making changes here, you can see that it kept running that state initialization console log, but because it takes so little effort for the browser to run that code, it's not a big deal at all. However, something like localstorage.getItem is a bit more of an expensive call, or rather it takes more effort for the browser to dip into local storage and get something every single state change that happens in our app. As such, React has implemented a way for us to really easily make it so that any expensive code that might be running inside of our state initialization can happen only one time. And this is called lazy state initialization. It sounds a lot more complicated than it is, because in the end, all I need to do is instead of providing a value, I can provide a function that returns a value. So here, if I provide a function that returns console log of state initialization, and let me put this down onto its own lines here, I'll hit refresh. We get the very first state initialization, but then any changes I make don't rerun that code. In the end, this might seem a lot more verbose than what we had, but if we make use of arrow functions and implicit returns, I can undo this to the way it was. All I really need to do is put a set of parentheses and an arrow. Even still, this is getting a little bit long, so I'll put this onto its own line so you can see the whole thing. But we get the same effect. I can hit save and start making more changes to state, which don't rerun our state initialization console log. Now, this state was completely contrived. Running console log inside of state is pretty useless, but it does lead us to our next challenge. Your task is to lazily initialize our notes state so that it doesn't reach into local storage on every single re-render of the app component. If you were paying close attention, you'll know that this will only require a few extra characters on your part to type in. Pause now and work on this challenge. All we should need to do is add a function here at the beginning of our call and have it implicitly return the value that we had before. Just adding the parentheses and the arrow should lazily initialize this state so that it will only reach into local storage the first time the app loads. In this case, we may not notice much of a difference, especially since we got rid of our console log that we had before, but we can rest assured that this is going to work the way we want. I can hit save, which refreshes our app, and it is successfully pulling in the notes from local storage. Okay, so that checks off this sync notes with local storage feature that we just added. Next, we're going to think through how we can add some more meaningful summaries here instead of Note 1 and Note 2. So let's do that in the next challenge. Next, what we'll work on is adding some real note summaries as the title for our notes instead of Note 1 and Note 2. Right now you can see when we're mapping over the notes, we grab the index and we display note and then the index plus 1. Unfortunately, this doesn't give our users any idea as to the contents of that note. So your challenge is to try and figure out a way to display only the first line of the note's body property. By the way, note.body is the text that is showing up here in the editor. And that first line should be pulled out and used as the summary that shows up here in the sidebar. The CSS should already be set up so that it will truncate that so that it doesn't wrap around really long in case you do have quite a long first line in your note. And I've added a couple hints here to help you along the way in the challenge. First of all, the text of note.body, if you console log it, will not show that every time you hit return in the text editor here, it's actually inserting a new line character. Let me show you what I mean. If we go to app and we're just going to piggyback on top of this use effect that is running every time the notes changes, if I console log notes at the index of 0.body, and we open the console, you can see the text shows as if it were just a space in between the note summary and the beginning of the note line. However, if we actually JSON.stringify this, we can now see that there are two new line characters that are sort of hidden between that first line note summary and the second line beginning of the note. And since we have a new line character that can help us out, your challenge here essentially becomes one of a JavaScript algorithm challenge. So in reality, it's not even really a React-specific challenge. I've given you a second hint here that you can look at if you feel like you need it. I'm purposefully a little bit vague in the language so that if you need to, you can go out to Google and try to find some resources that will help you solve this challenge. Speaking of which, it's time to start. Pause now and work on this challenge. Hopefully while you were working on this, you came across the string.split method. While I'm testing things out, I can actually make use of what I have here. Let's get rid of our JSON.stringify, but we'll just access the body of the very first note in our array. That's going to be the string that we can run a split method on. And the divider we can use is the new line character, which is \n. Let's just see what this returns. I'll hit save, open my console, and awesome, it looks like we get an array that's split on the new line, or in other words, it uses the new line character to determine when a new item in that array should be created, which means that if we just want the first line of our note, we should just be able to access this array that .split returns by the 0 index. So over in sidebar.js, I have access to each individual note, and instead of this note with the index, we'll just insert some JavaScript with our curly braces, and we'll say note.body, that's our string, .split on the new line character \n. That will return an array, and we'll just say at the index of 0, which should access the very first line of our note. Let's see how we did. We'll hit save, and awesome, look at that. I suppose if you want to get picky with it, you could remove the hashtag, although if somebody decides not to put this hashtag header the way that we have, maybe they wanted to make this bold instead, then we would no longer have a hashtag to parse out, but instead some asterisks. Personally, I don't think it's that big of a deal. We'll probably just leave whatever markdown marks end up in that first line just as they are. Now I can see I'm console logging everything because I set that up here on line 18. I'm going to clean that up. And now if I change my note summary to something else, looks like that summary is updating on every keystroke. Awesome work. Speaking of modifying the notes, that leads us to the next feature that we're going to add, and that is to move any modified notes to the top of our list. If we had, say, 50 notes here and we scrolled down to the bottom and modified one of them, that might be a good indicator that we're interested in updating that note more regularly. Let's say we instead had, I don't know, maybe 50 different notes here, and we decide we want to make a change to this bottom one. We probably want to bump that to the top of the list so that it's more easily accessible going forward. So that's the next feature we're going to add in the next screencast. It seems like a sensible feature to add to our app that if the user ever edits a note, in the sidebar it should pop up to the top of the list. So in an effort to give you real practice on adding a new feature, all I typed out was what the user experience should be, and it's up to you to figure out how to implement it. Whenever the user edits a note, reposition it in the list on the sidebar to the top of the list. I suppose as a quick hint, I'll let you know that you will have to refactor some of the existing working code in order for this to work. Pause now and work on adding this new feature. We have a function that exists that we can tap into whenever the user is editing a note, and that's our function down here, update note. Currently, we're using the map method so that the array of notes stays in place in that array. In other words, if they edit note 1, it will always stay in the third position because that's just how .map works. It returns a new array where every original item is at the same index in the new array as it was in the original array. So if we're wanting to rearrange this array, there may be a way to use .map to do that. However, off the top of my head, I can't think of it, and I'm guessing it would probably be so clever that it might be difficult to understand if we're reading our own code or another developer is reading this code in the future. So sometimes when I'm making modifications like this, what I like to do is just duplicate and comment out the code that was working, and then even make a note for myself, something like, this does not rearrange the notes, or something like that that will help me remember what I'm doing. And then up here, at least temporarily, I might say something like, try to rearrange the most recently modified note to be at the top. Okay, I'm still going to be running set notes, and I will still need access to the old notes array, but instead of immediately returning the array that comes back by calling .map, I think I'm just going to start fresh. So let's see, I think that's here, yep. And to give myself some breathing room, I'll open up this function. And honestly, I think the easiest way to do this might be a pretty imperative way. I'll type this out as pseudocode to start. So I'm going to create a new empty array, loop over the original array, and if the ID matches, in other words, if the ID of the note that we're currently looking at in our loop matches the current note ID that we're saving in state, just like we have here, note ID triple equals current note ID, then that means it's the note that we're currently editing, and that means that I want to put the updated note at the beginning of the new array. If it doesn't match, so else, push the old note to the end of the new array. And after my loop is all said and done, we will return the new array. Hopefully that pseudocode makes sense. It makes sense to me, but that's kind of the point of pseudocode. Write it so that it makes the most sense for you. And I like doing this as a way to lay the problem and the solution out and solve any issues I might see at this point before I dive deep into the syntax of the code that's required to actually solve this challenge. So let's do this. We'll create a new empty array. We'll say new array. We'll loop over the original array. I'm just going to use a good old-fashioned C-style for loop. So we'll say I equals 0, I is less than the old notes.length, and I++. Move my pseudocode inside here. So if the ID matches, in other words, if old notes at I.id equals the current note ID that we're looking at in state, then I'm going to use new array.unshift to push a new item to the beginning of the array. And I can just take my old code here because I'm accessing the old note. Now, one issue with copying and pasting is I have this object called old note, which I am not referencing anywhere in my code. So I'll need to change this to old notes at the index of I. Before I get too far down this road, I really don't like indexing into things a whole lot. I think I'd rather say old note equals old notes at the index of I. And that way I can use old note over and over instead of having the weird syntax of the index there. So as we're looping through our old notes, if the ID of the one we're currently looking at matches the one that the user is currently editing, then add this new object to the beginning, which has the updated text and all the old properties, just like we were doing before. But otherwise, we can just push to the end of our new array the old note, because we don't plan on modifying it at all. We can clean up some of these comments. Then lastly, we just need to return new array. As you can see, this is a lot more imperative with our C-style for loop and everything, but let's hit save. We'll go to note 1, make any kind of modification like hitting return. Uh-oh, it looks like we have a bug here. Oh, and you probably saw this while I was updating my old note here, but I left this as old notes instead of old note. Little things like that will get you all the time. Let's try this again. I'll hit save. Note 1, hit return. Awesome. Note 1 just popped to the top of the list. We can test this with some other ones. Maybe I make a change here. And sure enough, it's at the top of the list. And note 1 is still modified. And of course, now it's at the top of the list. Awesome. At this point, I can probably clean up some of my comments if I'm not going to be needing any of that old code or anything like that. Although it might be helpful for a future developer to see that your code is written the way it is because you want to put the most recent change at the top. So maybe I'll just update this to say, put the most recently modified, well, that should say note at the top. Awesome work, and that does it for this challenge. The next and final feature that we are going to add to this app together is the ability to delete notes. So that's what we'll tackle in the next challenge. The very last feature we're going to add to our Notes app is the ability to delete notes. I've made a few changes since you last saw this app, so let's talk through those. First of all, in the sidebar, I added a button that has an icon inside. And this icon has a trash icon that's a pure CSS trash icon. I didn't create this, I copied this from a site that has pure CSS icons, before you think I'm some kind of genius in CSS. And I set that up so that it will only show up when you hover on one of the notes. So as I hover over the sidebar note, the little trash icon shows up. Right now, clicking it doesn't do anything. That's going to be your challenge. However, you can see that clicking the trash icon is also changing the selected note in the sidebar, and that caused me to run into a bug. And so I started some of this code for you. We've got the function delete note that will receive an event and a note ID, and I wrote this line out for you, event.stopPropagation. Without going too in-depth, what it does is it says when this trash icon handles the click event, stop propagating that click event to the parents, like the sidebar div that's holding this entire note. In other words, this trash icon is a child element of the note on the side here. And so when I click the trash, currently it's propagating that click event through to the parent, which is also handling a click event. Now, the fact that it is still propagating that should tell you that my trash icon is not correctly using this delete note click event. So that's going to be part of your challenge. Before I read through it, let's go to the sidebar. You can see I specifically indicated where you need to add your onClick event handler. So let's look at the challenge. It's to complete and to implement the delete note function. Now, I've given you a couple of hints here. The first one is to think about what array method you can use to return a new array that has filtered out one of the items, in our case, because we're just deleting one item, based on some kind of condition. Hopefully the language of that hint can give you a pretty good indication as to what array method you can use. I also want you to look closely at the parameters that we're passing to delete note. Keep in mind that normally on an event listener, we don't get to choose what parameters we're passing. So you'll have to find a little workaround, which we have talked about in the past, in order to pass both the event object and the note's ID. And this is the ID of the note that is going to be deleted. As an aside, the reason that I had to do the stop propagation isn't just because I didn't want to select that note, it's because I was getting an error. I would delete the note and then it would try to select it as the current note after it was deleted, and that was throwing an error because that note no longer existed in my array of notes. Okay, I've talked long enough. Now's your chance to complete this challenge. Pause the screencast and try to implement the delete note function. Before we work on the code here, let's test to make sure that we can successfully add the event listener to the trash icon button. I'm going to just add a console log that says deleted note, and then maybe I'll add the note ID just to make sure that I'm successfully passing down the correct note. And then we need to pass this function down through props to our sidebar component. We'll add a new prop called delete note, which will just be the delete note function. And then in the sidebar, we're already receiving props, so I will add an onClick event handler here. And your first inclination might have been to just pass props.delete note here. However, that's why I provided you the hint about what parameters we're passing to this function. By default, whatever function we pass to an event handler will receive the event as its parameter. And in order to pass something else along with that, I'd either need to do some kind of magic with .bind, which I'm not going to get into, or more simply, I can say this is my function that I want to call, this entire anonymous function, and the first line or only line of that function will call delete note. That way I can take the event that I'm receiving as a part of the onClick callback function and pass it along to my delete note function, but then I can also tell it to pass the note's ID. Remember, we're here inside of .map, and we have access to this note variable, which has an ID property, and that's what we're passing down to delete note as we're calling it. I'll get rid of this line here. I'll hit save. Let's open up the console and click the delete icon here, and awesome. Okay, and it's good that these IDs are different so that I'm not getting some kind of captured value or anything weird like that. So now let's go to app.js and finish implementing the delete note function. I gave you a pretty good hint in my first hint when I talked about filtering out an item, and that's because we are going to use array.filter, but in our case, we're only going to filter out the one item based on this ID. Since I'm updating my state, I'm going to call setNotes. I do need access to my old array of notes, so I'll use the callback function with old notes as the parameter, and I want to return a new array that results from calling oldNotes.filter. .filter takes a callback function, and whatever we return from this callback function needs to be a Boolean to indicate whether the current item we're iterating over in the original array should be included in the new array or not. So we'll say that for each note we're looking at, I want to make sure I include items whose ID property does not equal the note ID that we're trying to delete. This only has one parameter, so I can remove these extra parentheses. So once again, we're looking at all of our notes. We want to run the filter method. We're going to look at each note in that array, and if the ID does not equal the one we're trying to delete, then this will result in true, which means I do want it included in the new array that I'm returning from .filter, which means essentially if it's not the one that I click delete on, it will leave it alone and continue to exist in the array. However, for the one note that I did click delete on, note.id will equal note ID, and therefore this will be false, and therefore that note that I click delete on will not be included in the array, and thus it'll get removed from my state. I'll hit save. Let's click delete on note 2. And awesome, we have note 1 and note 3 left. I can click delete on note 3 and note 1. We have no more notes in our array. If I hit refresh, we're still at no notes. I can create notes, and everything seems to be persisting exactly as we would expect. Now, I totally understand there were probably two really difficult parts in this challenge. One was understanding how to use .filter. In truth, you don't have to use .filter. You can do something a little more imperative, like what we did up here, where we just created a new array and manually iterated over with an old style for loop. If you did it that way, that's completely okay. Obviously, this .filter gives us a chance to do it in a really succinct way, but that doesn't necessarily mean it's the only or best way. And then the other tricky thing that may have tripped some people up was adding this callback function that calls props.delete note. But as a quick reminder, if you ever really need extra parameters other than just the event in your callback function, then you're probably going to pass a whole callback function here instead of just calling props.delete note, so that you can pass whatever parameters you want to your own function. And that brings us to the end of this Notes app. Hopefully you were able to complete all of these challenges that we worked on together. I know that it's difficult to jump into a new code base and try to add features, but there's almost no better practice for you as you're learning React than to jump into an existing code base and try to figure things out. We've come a super long way since we first started React. So as a final hurrah in this course, the next thing we'll be working on is the final capstone project for this course. And this will be one that we create completely from scratch. Since we're going to be jumping into a new project, I highly recommend you really soak in everything that you are able to learn from this Notes app and even go above and beyond with it. If you don't feel like you've gleaned all the information you could from this app, then stick with it. Try to add new features. Even try something small like changing the design of it to better fit your personal preference. Then once you feel like you've soaked up all the information you can from this app, we're going to jump into the final capstone project for this course. Here's the game we're going to be building as our first major capstone project. If you haven't played Tensies before, it's a dice game that's usually better suited for younger children, but because of that, the complexity is low enough that it makes for a pretty good project here. The idea is to try and roll 10 dice that are all the same, and in our game you can click on one of the dice to hold it, and when you click roll, those held dice won't change. We'll click the other 2s and we'll just kind of play this game until all of the dice that we roll are the same number. And as soon as we hold the last dice, the game is going to notice that we have all 2s. It'll play this fun confetti drop here. It'll change the button from roll to reset game. And of course, when we click reset game, it will start us all over from the beginning. The design for the game can be found here. If you click this screenshot, it'll send you to the Figma file for this game. And I included a little animated GIF just in case you forgot how this game is supposed to work, so you can reference this as well. Feel free to peruse the code that we have here. You can see it's less than 100 lines of code in the main app.js component, which contains most of our logic. So get geared up to create an awesome React project. When you're ready, let's jump right in. All right, we're starting from the very beginning. The only thing I've added is some really basic styling for you, and I've included some Google Fonts for you, but there is nothing in our React code at all. So your challenge is to create a brand new React app. I want you to create a separate app component that will live in a separate file. And then here in index.js, make sure to import that app component and render it. Inside the app component, it should render a main element. And then for now, I just want you to style everything to look like the basic outline for our game. You can click on the slide to go to the Figma file where you can find some of the design elements, well, specifically this background color. So pause the screencast and set up our Tensies game. Okay, let's import the things we need. We know we need React from React. And because we're going to be using Reactdom, we'll have to import Reactdom from React-DOM. While I'm importing things, I'll import app from a non-existent app file. We'll get to that in just a second, and we'll use reactdom.render to render an app component. And the place we want to render it is in the element that we get from getElementById root. Let's create our new file for app.js. We'll import React from React and export our component. Like I said, we'll have it return a main element. Maybe I'll just put something here so I can see that things are working. Okay, pretty underwhelming. Now let's get to some style. I can see that from the design, it looks to me like the entire body probably has this background color, and then the main element is this white box here. So in the body, I'll give it a background color, which from the design we can see is this color. And since my main element is essentially going to be the container for everything, I don't think I'm going to bother with adding a class name really. I'm just going to have the main element that I style. And it looks like that background color is not white in the design. It's this very close to white color. Let's add a little bit of padding to the body so that there is that blue outline around our main element. We'll say maybe padding 20 pixels. I'll add a height to my main. We'll say it's maybe about 400 pixels. I could probably use a percentage or use view height. For now, this will do the trick. And if I need to, I'll come back later and update that. And then maybe instead of a width, I'll add a max width and say something like 800 pixels. Because of the padding we have, we still have that little outline on the sides. The max width makes it so that it doesn't get too wide if we get really wide, but I don't think that's going to be a problem that I'm going to be too worried about right now. Looks like we have a bit of a border radius, so we'll add maybe 5 pixel border radius. And there certainly will be more styles that we decide to add to this later, but for now, I think this is good. I'm going to get rid of my something text here. And awesome, this is a great start. Next, let's see if we can add our little dice components onto the screen. We won't worry about any data or generating the numbers quite yet. We'll just get these components working. So when you're ready, let's move on to that. The next thing we'll do is get some die components rendered to the page. For now, we'll just manually put in 10 instances of our die component, and in the end, it should look like this. Once again, you can click this slide to go to the Figma file so you can get things like the box shadow and the font size for these and everything. The challenge is written out here. Create a die component. This will be in a separate file. And that die component should take a value prop, or a prop called value. Then inside of our main here, you'll render 10 instances of the die component just manually, and provide a number between 1 and 6 for the value prop on each one of those for now. And then make sure to style the main component and the die component that you create to look like they do in that slide. And just to make your CSS life a little bit easier, I added a couple hints here. I'd recommend making a container that will surround all 10 of these dice instead of just putting them directly as children of the main element. And that way you can make that container a display grid, so you can make it always display in 2 rows of 5 columns. And to get the separation between these elements, you can use the gap property, which will provide this spacing here. And then I would turn the main element, the one that has this white box, into a Flexbox so you can easily put that container in the center of the screen. Okay, pause now and work on adding some die components that will display our dice to the screen. Let's start by making a new dice component. So I'll make die.js. Sounds a little violent, but that's the correct singular of dice. We'll import React from React and export our component. I know that this is going to take props because we want to display a value prop. And looking at these dice, because I see this white outline around it that is the shape of the die, I'll probably actually make this a nested element, or rather I'll return something like a div, and inside that div is where I'll put the text element itself. Let's call it an h2. And this h2 is going to display props.value. We'll get to styling this in a minute, but let's, in our app.js, import our die component. I'll create that container that I was mentioning. And let's just render 10 instances of our die component. We'll pass in a value, which will just start as 1. And I'll just duplicate this 10 times. Okay, let's see where we are. Okay, that's about where we expect to be. Now let's start adding some styling. First, let me create my grid here. So I'll give this a class name. Let's say this is the dice container. And we'll set that up to be a grid. So display grid, we'll give it a grid template, and I'm going to be specifying a height and width on each of the die components themselves. And so I think what I'll do is just say this is going to be 2 rows that are each auto-determined in their height. And then I'll use the repeat function to say each one of the columns will be 1 fraction unit wide, and we'll have 5 columns. Let me actually refresh one of these components here so I can see this applying live. Okay, that's looking not too bad. Maybe before I provide some styling here, let's go ahead and create the little dice look around it so it has the white box. I'll go to die.js and this div here. Let's give it a class name of maybe die face, since that's the face of each of the die. And I'll save that and go to style.js. Let's style up die face. And we'll give these a height of 50 pixels and a width of 50 pixels. I'm going to paste in a box shadow from the design just so we can see the surrounding area without actually giving it a border. We'll give it a border radius of 10 pixels. And then I want that number to be perfectly centered in the middle. So let's make this die itself display flex, which will allow us to justify the content to the center. And we'll make sure that we align the items to the center as well. Then in our container, let's go ahead and add a gap. So we'll say a 20 pixel gap so that the items can spread out a little bit. Okay, I don't love how they're jammed all the way up to the edges of my main element, so I think I'll add some padding to my main. Let's say maybe about 20 pixels. And then as I mentioned in the hints, I think what I'll do as well is make my main a display flex, which kind of screws it up temporarily, but we'll set the flex direction to column so that the elements are being spread out top to bottom. And that will allow me to justify the content to the center, which allows me to put that directly in the center. Maybe for good measure, I'll say align items center. I don't know that that's going to make a difference. Well, yeah, it actually pushed the items a little more evenly spaced together, so that was good. The last thing I think I'll do is add cursor pointer. Even though this won't necessarily show up in the recording of the scrim, if you refresh this app, you can see that it now changes to that little Mickey Mouse glove hand. The only other thing I can think of is these numbers are looking a little bit smaller than I was hoping. So let me actually render dice with all of the different values on a regular 6-sided dice, just so I can see a comparison of the numbers. And then I'll give a class name to the number itself. We'll say class name is maybe die-num, and we'll add some style to that. We'll say .die-num. Let's give it a font size of maybe 2 rems. Is that too big? Let's see. It's pretty large, but it really helps highlight what the number is. And since that's the most important part of the dice, I think that'll probably be good. It also looks like these dice are blending into the background. I'm assuming they probably have a transparent color, so I'm going to give them their own background color of pure white. And awesome, yeah, that really makes them stand out better. Okay, that was a lot of time being spent on CSS, but now what we can do is go in and instead of manually putting in these die components like this, we probably should be generating an array of 10 random numbers and mapping over that array to create these die components. So that's what we'll do in the next section of the project. We'll break up the generation of these dice components into smaller challenges. This is a really good habit to get into when you're problem solving. Instead of being overwhelmed by a larger problem like let's generate 10 random values and create multiple die components based on those values. Instead, break that down and say, let's just make a function that generates an array of 10 random numbers. And then we can tackle the creation of the die components later. So that's exactly what we're going to do. Your challenge is to write a function, you can call it allNewDice, that returns for now an array of 10 random numbers between 1 and 6 inclusive. If you can't remember how to generate a random number in JavaScript, a quick Google search will certainly help you out. And then for now, let's just log the array of numbers to the console. Pause the screencast and write our allNewDice function. A quick side note on algorithm challenges like this, I really highly recommend that you try to come up with your own solution. I mentioned turning to Google to learn how to generate a random number in JavaScript, but for practice sake, I hope that you didn't just Google, how do I create an array of 10 random numbers in JavaScript? Instead, I really want you to put on your thinking cap and try to find solutions on your own before turning to Google. Something like generating a random number is not really a challenge in JavaScript so much as a syntax that you need to use. But the rest of this, creating your function that returns an array of 10 numbers, is really a problem-solving challenge that you should be practicing and not just finding other people's solutions for right away. Okay, I'll get off my high horse there. I'm going to create this function inside of my app component, so we'll say allNewDice. And I think I'll break this problem down into smaller parts. So first of all, I need a new array to hold my numbers. I'll probably need to loop 10 times. And as a part of that loop, I'll need to push a random number from 1 to 6 to my array. And then after the end of my loop, I can return that array, which will at that point have 10 new numbers in it. And that should say my numbers. Okay, so we'll say maybe new dice is going to be an empty array. And then I can use just a C-style for loop should be fine. I equals 0, I is less than 10, I plus plus. We can say new dice dot push. And to generate a new random number, you have probably come across a solution like math.floor, math.random, and then you can say times 6, and then you have to add 1 to the end of it. And honestly, I can't remember what order these are supposed to be in, but instead of adding 1, if you want it to not start at 0, but start at 1, you can actually use math.ceiling, math.random, and I forgot my parentheses there, and the times 6 should be in here, so that was all kinds of problematic. But the point is, this will create a random number from 1 to 6. And then once that number is created, it will push it to the new dice. It will do that 10 times, and at the very end, I can just return my new dice array. Get rid of my pseudocoding planning comments. And then let's go ahead and console log what comes back by calling allNewDice. Open my console, Hit run. Oh, and so close. And you probably saw this when I typed this out. It should be new dice, not new nice. Okay, cool. All of those numbers are between 1 and 6 inclusive, and there are 10 of them, so awesome. That probably does it for this challenge. In the next screencast, we will take this array and we'll turn it into actual dice components. All right, here's the next part of the challenge from before. Let's make use of the allNewDice function that we created and create new state to hold this array of numbers. And in fact, when you are initializing state, you can set its initial state to be a call to the allNewDice function. And that way, as soon as the component loads, it will generate all new dice for us right at the beginning. Then with your brand new state, you should map over that array and generate the array of die elements that we will use to replace the manual 10 items that we wrote here. Pause now and work on this challenge. Okay, let's create some state here at the top of our component. We'll say, maybe we'll just call this our dice and set dice. And that's react.useState. We're going to initialize the dice state by calling our allNewDice function. And then to generate the array of die elements by mapping over our dice, I could either do it directly here inside of my return. I could put my curly braces to put in some JavaScript and say dice.map, whatever. I personally prefer to generate an actual variable that holds that array of die elements, but outside my return, really only because it helps me separate the logic a little bit. Either way is completely fine. So I'll say const dice elements equals dice.map. I'm going to look at each individual die, and I'm going to return a die component with the value prop set to the number of that die. Now, remember right now we're just iterating over an array of bare numbers. And so here, die really just represents the number itself. And now dice elements will be an array, but instead of an array of numbers, it will be an array of die elements with the value prop set to the same number as the item at the same index in the original dice array. Now I can just render this dice elements array right down here. Before, these were hard-coded and we could see it went 1, 2, 3, 4, 5, 6, and then a bunch of ones. Now when I hit save, we should get a bunch of random numbers that show up here. In fact, it should be random every time I hit save. We'll get a different set of numbers. Now, because we're mapping an array into an array of components, React is warning us that we need to provide a unique key prop to each of these elements. Right now, we actually don't have a great piece of data to use as a unique key prop, but later down the road, when we refactor our dice elements that are in this array from a set of numbers to a set of objects, we'll come up with a solution for providing a key prop here. However, that's not the next step we're going to take. Instead, we're going to create a button that will allow us to re-roll all of our dice so that we can roll our dice without having to refresh our application. So for now, we'll ignore that warning, but we will solve that in a bit. When you're ready, let's move on and create our roll dice button. The next thing we want to add is a roll button that, when it's clicked, will generate all 10 new dice for us. Down the line, we'll be modifying it so that we can hold dice that are exempt from this roll button, but for now, just make it so that it rolls all new dice. You can put your button right here below the dice elements, and well, the rest of it I'll let you figure out. Pause the screencast and work on this challenge. First, I will create a new button, and we'll just have it say roll. Actually, let's just hit save and see where that gets us. And as a reminder, we will be having this warning every time we hit save. We're going to address that really soon. And well, that's pretty abysmal in terms of styling, but it looks like we've got a button there. Maybe let's hook it up first and then we'll style it. Clicking the button should run a function that will generate new dice by using setDice, and we could probably just combine our all new dice to determine what the new dice are. So I'll go ahead and create a function called rollDice, and this will just call setDice. And for now, we don't care what the old dice were, we're just generating all new dice. So we'll just run all new dice to generate the new numbers. And then let's connect the rollDice function up with an onClick handler. Okay, I'll hit save, and when I click roll, Awesome, we're getting all new dice. Well, that was simple enough. Now let's add some style to our dice. I'm going to add a class name to the button. Maybe let's just call it roll dice. And then we'll add some styles to the roll dice class. And I'll mostly just be following what we have here in the Figma design. I think I'll set the height to about 50 pixels, the width to about 100 pixels, and I might need to hit save so these can apply live. Yep, there we go. We'll take away the border with border none, but it does have a border radius of about maybe 6 pixels. It's got a background color that we can find in the design, and we just need to spell that right. There we go. The text color is white, so we'll change the color to white. Looks like the font size is a bit larger. Let's call it 1.2 rems. And if I remember right, buttons, I believe, don't take on the correct font family. So let's grab the font family. And oh, it looks like we never set the font family on the body. Let's go ahead and do that now. I'm using this Carla font that I'm bringing in from Google. Okay, we can see that making a difference. We're going to do the same font family on our button. Now this, I don't think, is the greatest practice for accessibility, but just for our visuals right now, I'm going to take away the outline whenever the button is focused. So we'll say outline is none. And this wasn't something in the design, but it's a nice little touch. I'm going to add an active class, which means when you're in the process of clicking the button, it's going to add this inset box shadow. And that will just make it so that it looks like it's being pressed or indented into the screen, which is kind of nice. Now, right now our spacing is a little funny. Let's go ahead and fix that. I think one way I could easily do that is to, instead of doing justify content center, I might try space around. And it puts our numbers a little bit high, especially when eventually we're going to have some text up there. But when we add the text, it might rearrange everything in a pleasing way. So for now, I think I'm okay with the way it is. And yeah, I should be able to click roll and everything is working great. Again, in the recording, you won't see this, but I think I also will add the cursor pointer just to make it very clear that it's a clickable button. And awesome, great job. At this point, it's a great idea for you to do a little self-assessment and see if you were able to accomplish that challenge all by yourself. Everything we did in this challenge should almost be second nature to you now based on the amount of repetition that you've had the opportunity to do. If you did struggle with this challenge, now would probably be another great opportunity to jump back in the curriculum, rewatch some of the lessons that we've done, and more importantly, redo some of the challenges that we've assigned to you. And that way, when you come back to this roll dice button challenge, you can do it comfortably without it being overly difficult. And then, of course, whenever you're ready, the next thing we're going to work on is being able to hold the dice so that when we click roll, it does not change the dice that are held. And that's the challenge we're going to tackle next. The next thing we'll work on is the ability to hold dice in place so that when the roll button is clicked, those dice that we've held don't change. Up until now, we've been saving just bare numbers or integers in an array, but in order for each dice to also contain information about whether or not it's being held, we'll want to change those to an object. So that is your challenge here. Update the array of numbers in state to be an array of objects instead. Those objects should have a value property which contains the number of the dice, or rather the number that is being displayed on each die, and an isHeld property which we will default to false. Don't worry about styling the dice or fixing the roll button quite yet. We're going to do those over the next few challenges. But simply making this change from an array of numbers to an array of objects is going to break other parts of our code. So the next part of your challenge is to bring it back to a working state. Pause the screencast and work on this challenge. I purposefully didn't show you exactly where these changes need to be made so that you would have to do some thinking about it. The place where we are generating the numbers and pushing them to the array is right here. We're creating a new array and just pushing a number that's randomly generated. So let's simply update this line of code. Instead of pushing a number, I'm going to push an object with a value property that contains that number and an isHeld property that contains a Boolean. We'll default every one of them to false. I think I'll put these on their own lines so it's a little bit easier to read. And now every time we call all new dice, we are creating an array of objects. That means down here, when we're mapping over our array of objects and die is no longer a number but is an object, the value needs to be die.value. Let's hit save and see how we did. Okay, well, we still have our warning from React about adding a key property. We're going to work on that in just a second, but let's test to make sure that everything is working. And awesome, looks like we're in a good place. Now, the next thing I'm going to do wades into deeper waters of intermediate or advanced React. So I'm going to explain it in a very surface level way, but just know that for now, it's not terribly important that you truly deeply understand exactly what we're going to do. I want to address this warning that we're getting where each child in a list should have a unique key prop. When you're pulling data from an API and it receives some sort of unique ID generated by the database, that's perfect. That is the ID that you should use for your key prop. In our case, we are not receiving that because, well, we're not calling out to a database at all. We're generating these objects on the fly. Now, the reason this key prop is important in the first place is so that React has a good way to keep these in the correct order in case anything were to be removed or added to this array. In our case, we will always have 10 items in this array, and we don't plan on removing or adding any new dice to our game here. So one solution is to get a third-party package, which I can add as a dependency. I'm going to add one called NanoID. And NanoID is just a really fast way for me to generate a random ID on the fly in my code. What I can do at the top is import NanoID from the package NanoID. And then every time I'm creating this object, I will create a new ID property and just call the NanoID function. Let's take a look at what this generates for us. So I'll console log new dice and open my console. We'll hit save. And you can see the IDs are a little bit crazy. They're not just like 1, 2, 3, 4, and 5, but there's enough bits in that ID that we can essentially be guaranteed they will be unique. And now that I have an ID, I can fix my warning and just say my key on these die is going to be die.id. Let me push some of this onto its own lines. I'll also remove my console log here, and now I should be able to get rid of my warning. Awesome. Okay, so now every one of our dice has the ability to know whether or not it's being held, but we currently have no way to change that. So that's what we'll start addressing in the next part of this project. Very soon we'll be working on making it so that every die knows that when it's clicked, it should toggle its held property from true to false or false to true. But for now, let's add some styling to the die so that if it is held, it can put this green background color. That's going to make our job a lot easier to test when we add the clicking ability for holding or unholding a die. To test that, I'm going to change the dice from is held to false to be is held to true, so that when you work on your challenge, you'll be able to see all the dice turning the light green color, assuming you got everything set up correctly. So your challenge is to add some conditional styling to the die component so that if it is held, or rather if that die's is held property is true, its background color will change to that light green color, which you can reference the hex code for right here. Don't forget that currently the die component has no way of knowing whether or not it's being held. So that's something you'll have to address as you work on this challenge. Once you have all the dice with that green background color, come back to our all new dice function, change this from true back to false, and refreshing the app should then clear out the green colors and it should look the way that it does right now. So pause now and work on this challenge. I think I might work a little backwards in this challenge because first I need to let the die component know whether or not it's being held. Down when I am mapping it, I'm passing a key prop, which isn't really usable except for internally by React, and I'm passing this value prop. I'm going to also add an isHeld prop, and that is just going to be the value of die.isHeld. So either true or false, or in our case, all of them will be true because that's how we hard-coded this. That alone shouldn't really break anything in our code, but if I go to the die component, I now have props.isHeld, and I can use that to generate my background color. To do some dynamic styles, I'm going to create a separate styles variable, although this could be something that you handle inline right here by saying style equals and then an object. I think that gets a little bit lengthy, especially if you're adding more than one style. So for now, I'm going to say style equals my styles object that is defined up here separately. And then I'm going to set the background color. This has to be camel cased, remember, because we're accessing the DOM properties of this element. And here I can use a ternary. I'm going to say props.isHeld. If it is held, then I want to use that hex code that we saw before. But otherwise, I want the background color to be white. Let's hit save. And awesome, we get all green dice, just like we expected. For one final test, back in app.js, I'm going to change this back to false, hit save, and that has cleared out. Perfect. I suppose that technically means that my die face no longer really needs a background color that's set in the CSS because that will be handled with an inline style here in React. Maybe I'll just double check that. Refreshing gets me all white dice, and when I change this to true, all green. Perfect. Wow, that's a lot of 2s on one roll. That's amazing. It's too bad we're not playing this game yet. Okay, I'll set this back to false because that's where we really want our game to be. And perfect. Now we're ready to start tackling the challenge of having each die be able to hold when it gets clicked. So we'll start working on that next. In the past, we've talked about something called derived state and how, for the most part, it's not something you'll end up using very often. As a reminder, I've brought in this diagram, which we've seen in a past lesson, and adapted it to work for this Tenzies game we're making. In this game, we have our app component, which is holding an array of dice objects, and it's mapping over that array and creating instances of our die component. It's then passing the isHeld property down so the die knows how to display whether it should be green in the background or not. And in this diagram, what we see is each die component containing its own state, which is initialized by its incoming prop of isHeld, and then having the ability to flip that isHeld property from true to false or false to true. Although this might generally accomplish the goal of making each die be able to flip from green to white or white to green, it breaks our game because if each die component has its own state of isHeld, it isn't necessarily communicating that change up to the parent state. And in our game, we need to be looking at every single die so we know how to end the game. If every die is held and every die has the same number, then the game is won. However, if each die is flipping its own state, like I said, there's nothing communicating to the parent array state that it's changing. So a much better way for us to structure this, although it may include a little bit of extra code, is to not put state on any of these components and not have them be able to flip that own state that it initializes from its incoming props, or in other words, using derived state. Instead, we will only keep the state on the app component. We'll create a function that we'll call hold, and that hold function will be passed down to each one of the die components. In our case, we need to know which die clicked hold, and so that hold function will receive an ID as a parameter. If you remember, when we are generating our dice, we create an ID property for each one, which is unique. And as such, it's something we can pass as a parameter to our hold dice function. So that brings us to your challenge. Your challenge is to create a function, we'll call it hold dice, that takes an ID as a parameter. And for now, don't worry about the logic of this function. Just have it console log the ID that's passed in as a parameter. And then I want you to figure out how you can pass that function down to each instance of the die component so that when any one of them is clicked, it will log its own unique ID property. In other words, you need to make sure that when you click the first die, it shows a different console log than when you click the second die. In truth, there's more than one way to make this work. We have looked at multiple different ways to make this work in the past, so you can just choose whichever one makes the most sense to you. So the time is yours. Pause the screencast and work on this challenge. Okay, let's create a new function. We'll just do it right down here. Hold dice. And let's spell function correctly. This will take an ID as a parameter, and it's just going to console log the ID. Easy enough. Now when we are mapping over our dice objects and creating our instances of the die component, I basically have two different ways I could do this. One thing I could do is pass the ID to the die. So this would be die.id, and then also pass hold dice as the function hold dice. And then inside of the die component, I could call hold dice on click and pass the ID that's passed as a prop here. However, to me, this is one additional step without really a lot of noticeable gain. And so I think I'm going to take that out. And then what I can do is just create a new function and say hold dice is going to be this anonymous function. And this anonymous function will call hold dice with die.id as its parameter. Effectively, what this is doing is embedding the ID as the parameter that will be called with the hold dice function whenever each one of these dice is clicked. So I should be able to hit refresh. And of course, at this point, clicking the die isn't going to do anything because I haven't actually accepted that prop on this side. So now I'm receiving a prop called, let's see, it was hold dice here. And I can add an onClick to my div. I'm going to separate these onto their own lines. OnClick equals props.holdDice. So let's hit refresh. I click the first one and I get this ID that starts with HG. This one starts with AYZ, YJB. Awesome. Specifically, I'm checking to make sure that these were all different from each other. If they were all the same, then something would have happened incorrectly as I was passing in the ID. But they're all different, which means each one of these has their own function that can identify which die was clicked, so that in the next part of this challenge, we'll be able to update our state, which is holding all of our dice, to flip the held value, or the isHeld value, on just the die that was clicked. So that's what we'll do in the next challenge. The next thing we're going to work on is making it so that clicking each die will actually flip its isHeld property, instead of just console logging the ID. Again, the goal is to make it so that I can click the die that I want to hold, have it flip its property, which therefore will change its background color, and then coming up in the future when we click roll, we will create new dice for all of those except for the ones that are held. So your challenge is to update our hold dice function to flip that isHeld property. Again, you'll want to keep your dice array almost exactly the same way as it was, except for the one item that was interacted with based on this ID. As usual, there's more than one way to accomplish this. I'm going to be using dice.map and checking for this ID while I'm looping over the dice inside of my callback function in dice.map. But honestly, if that way is confusing to you, you can just do this whichever way makes the most sense to you. Pause the screencast and work on this challenge. Okay, to update our state, we will need to use our setDice function. So I'll start with a call to setDice. I do need access to all the old dice or the old array before we make this change so that I can determine what the new array should be. And I'm going to use the map method to create a new array or return a new array from this function. And again, almost every die object is going to be exactly the same way as it was, except for one of them, which will just have the isHeld property flipped. I remember when I first learned about this way of updating an array in state, it felt, I don't know, inefficient or something. But in truth, JavaScript does these operations so quickly that it doesn't even blink at something like this. So inside of our map, we're going to look at each die object. We'll have another function, and I think this time I'm just going to open it up so that I have some breathing room on the next line. And here I can use a ternary that says if it is the same die with the ID property that was passed in to the function, then I'll update that object, and if not, I'll just return this die. I can do that by saying return, and then use my ternary to say is die.id the same as the ID passed in? If so, then that's the one we want to change, and I'm going to take all of the properties from the original die, but update isHeld to be the opposite of die.isHeld. I'm going to move this on its own line, and then put my else with this colon, and start the next part on the next line, and I'll just say if it's not the ID that we clicked on or that we interacted with, just keep the same object that we had before. And I think this should do it. Let's hit save. And well, we have a lot of pairs here. Let's just do the twos. Awesome. I should also be able to change my mind, click off the twos and choose the sixes instead. Great. This was one of the major features that we needed to add to this game. The next thing is we need to make sure that when we click the roll button, we don't just lose all of our dice, but instead roll only the dice that we didn't hold. So that's the feature we will work on next. Other than checking if the game has been won, I think this is the last major feature that we need to add to this game. So your challenge is to update the roll dice function instead of just creating all new dice every time we click the roll button, that instead you will look through the existing dice and not re-roll any dice that have been held. As a hint, this is going to look relatively similar to what we did in the hold dice function, at least the way that I'll be solving it. Of course, if you find a different way that you prefer or makes more sense to you, then just go with that way. That'll be great. When you're creating new dice as a part of that roll, remember to use the ID that we are getting from NanoID. That way, any new dice you create will also have an ID and therefore will work when we click them to hold them. Pause the screencast and work on this challenge. Okay, instead of creating all new dice, we do need to now be looking at the old dice. So we'll pass a callback function here to set dice instead of just generating a new value for it. And we'll create a new array by calling oldDice.map. We'll look at each one of the die in the old dice. And similar to before, what we'll do is check the die.isHeld property. And if the die is being held, we want to make sure we just keep it as part of our array. If it's not being held, however, we will return a new die to add to our array. Now, looking a little bit ahead, I can see that here I'm creating a new instance of a die. Down here, I'm essentially going to be doing the same thing. I could just copy and paste this value. However, this raises something called a code smell for me. I can see that we're going to have repetitive code. So this wasn't technically part of the challenge, but I think what I'm going to do is create a separate helper function that's called maybe generate new die. And I'm just going to have it return, let's see, this object right here. And that way, anytime I need a new die, I can just call this function. I think I'll move this up above my all new dice so it's a little easier and more logical to read. Then right here, I'll probably call generate new die. And down here, I'll do the same thing. We'll just say generate new die. Again, that wasn't really part of the challenge, so if you didn't make this helper function, that's completely okay. I just thought I'd show you how I might do it if I were looking ahead and seeing how I was about to have some repetitive code. Let's cross our fingers, refresh. Looks like we have 3 2s here, so I'll probably start there. We'll hit roll, and awesome! Everything rolled except for the 3 2s that I held. I could then hold a couple more 2s. Getting a little bit unlucky with our rolls here. There we go. Get a couple more 2s in here. There's another one. We're almost done. There it is. So that brings us to the next challenge. How do we end this game? Of course, me clicking this doesn't make any difference to the game at all. I could click roll, but nothing's going to re-roll. And we basically haven't told the user anything about whether they've won or not. Speaking of telling the user some things, I think just really quick, I'm going to paste in some elements that will give some additional information to the users. If you remember in this original screenshot, we have the title of Dependencies and a little description. I'm going to add those in now and just paste them in from somewhere else because they're pretty straightforward. As you can see, we just have an H1 that says Dependencies, a paragraph with some instructions, both of which have a class name, so that I can add some code in our CSS to style them. I'll hit refresh. I think I'll probably put a little bit of margin below our, let's see, dice container. We'll say margin bottom, maybe like 40 pixels. And yeah, that's looking better. Okay, now let's get back to the next challenge where we will start actually informing the user whether they've won or not. We're going to break this up into a few different screencasts and just take this one little bite at a time. Your challenge this time is to add some new state called Dependencies, and you'll default it to false. This new state will represent whether the user has won the game yet or not. Then I want you to add an effect that will run every time the dice array in state changes. For now, you can just console log dice state changed and not worry about doing anything else. If it's been a while since you've gone through the curriculum on useEffect, this would be a great time to go back and review. And once you're ready, pause the screencast and work on this challenge. Okay, so I can create some new state. We'll say tensies and set tensies is equal to react.useState, and we'll initialize it as false. That way they won't win the game as soon as they load it. And then we're going to add a side effect, and we'll use that with react.useEffect. UseEffect will take a function as the first parameter, and I'll set up the second parameter right now because I only want this effect to run anytime the dice array changes in state. As I mentioned, for now we'll just console log dice state changed. So let's hit refresh. We get a dice state changed on the very first load, and then it should, every single time I update the dice array, even if it's one small change, like changing one of the dice to being held, then we get our effect running. Also, if I run my roll button, that also gives me a dice state changed. Awesome. Now, it may not have been perfectly apparent why we're using an effect here, and that's mostly because we only did about half of this challenge right now. In the next challenge, what we'll do is we're going to check all of the dice every single time something changes in the dice to look for a winning condition. And if the game has been won, for example, if all the numbers are the same and all the dice are held, then we can set tensies to true, and therefore the user will win the game. Keeping two internal pieces of state in sync with each other is a really common reason to use a use effect. We talk about it being a side effect as if it only concerned things outside of this function entirely, but keeping two pieces of internal state in sync is another good reason for it. So this one was short and sweet, but in the next screencast, we will make it so the user can actually win the game. Your challenge this time is inside of our effect. Instead of console logging dice state changed, you'll check the dice array for some winning conditions. First, we're looking to see if all of the dice are currently held and that all the dice have the same value. If both of these conditions are true, then set tensies to true and log something like "you won" to the console. Pause now and work on this challenge. Just like before, there are a ton of different ways that you might have solved this one. Hopefully the way that I solved it will ring true to you, but if you found a different way or even a better way, then feel free to share it in Discord. I would love to see people's different solutions for this. In JavaScript, there's a really handy array method called .every. And what .every does is it will look for a specific condition, and if every item in that array returns a true for that condition, then it will, as a .every method, return the value true. This might make more sense if I actually show you. I can check dice.every, and for every die, if every die dot is held, or in other words, if every die has true as an is held property, I don't necessarily need to say triple equals true though, then dice.every will return true. If even one of the dice is not being held, then it will return false. So I can save that Boolean that it returns as a variable. We'll say all dice held, or just say all held, and that's either going to be true or false. So that's a good start to help me have an if statement later that checks if they're all held and if they all have the same value. Now, how can I check to make sure that they all have the same value? Well, if they all have the same value, then I can just arbitrarily pick one of the dice and check all of them to see that they have that same value. For example, I could say maybe the first value is equal to dice at the index of 0 dot value. And now I have a reference point for me to say maybe all same value is dice.every, and I'll say every die.value is equal to the first value. And now I have some variables that I can check inside of my if statement whether or not they're all held and if they all have the same value. So we'll check if they're all being held and they all have the same value. Then I need to set tensies to true, and we were going to console log u1. I'll just reuse this console log here. All about recycling. u1. Now you may have asked, why am I going to set tensies to true? There's a few things in the user interface we're going to change if they have won. For example, we won't want the button to say roll anymore. We might want it to say reset game. And we can conditionally render that text based on the tensies value. And as you might remember from the preview, we have a fun little confetti thing that's going to pop out when the game is over. But we'll save that as a special treat at the very end. So let's hit refresh and actually play this game. And oh, well, it looks like we might have a bug here. And after a quick look, it looks like I did not put a callback function inside of my .every. Sorry for anyone who was screaming at me saying I did that wrong. Okay, let's try this again. I'll hit save. Okay, we're back up to working, and oh, look, that's a great start. We got 6 6s. That's amazing. Okay, we'll hold all those. Awesome, we're making good progress. And we should get our state updating finally whenever I finally roll another 6. As a side note, I feel like this is how every game of Tensies for me goes. It's the very last one that I never can get to be the right number. There we go. Okay, let me open the console. You won. Awesome. Keep in mind, this effect was running every single time the dice array changed, which means it ran every single time I clicked on one of the dice and every single time I clicked my roll button. Awesome. We have come a long way. The next thing we're going to do is update a couple user interface things. One is just procedural. That's where we're going to update this roll button. And the next is we're going to have a lot of fun with the confetti package. Both of those should be really simple for you at this point. As a reminder, if you were not able to create some version of this, it didn't have to be these exact methods. But if you struggled with this challenge, it's time to erase it and try it again. Make sure you understand this before we move on. The last 2 things we're going to do are more just checking boxes, but the ability to complete a challenge like this on your own without any kind of outside help will be a really good self-assessment for you to know whether or not you're ready to move on. So when you are ready, let's tie off the little loose ends of this app and call it done. Okay, it's time to tie off a few loose ends inside of our Tensies game. This challenge comes in 2 parts. First of all, if the Tensies in state is true, I want you to change the button text down here to say new game instead of roll. Secondly, and probably the more exciting of the 2 challenges, is that if Tensies in state is true, to use the React confetti package to render a confetti component. I've already included the React confetti package for you, and down here in the slides, I included a link to the documentation for React Confetti. I think you'll find it's actually a really easy package to use. In the end, you're just going to need to import confetti from React Confetti and then to render a confetti component. Now, in our case, we will only conditionally render that confetti component based on the value of Tensies. Also, in the documentation, you'll see that they provide a height and width properties. You just won't really need to worry about those in this case. In the end, once you have the confetti package conditionally rendered upon winning the game, it should look something like this, where the user completes the game and then a bunch of really fun confetti falls down. Okay, these are some fun additions. Pause the screencast and work on these challenges. Okay, let's start with number 1. If Tensies is true, change the button text to new game. Well, let's go down here to our button. I think I'm going to put some of this on its own line so we have some extra space while we're looking at it. And instead of hard coding roll in here, I'm going to put some curly braces so I can use a JavaScript expression. And we'll use a ternary because we're choosing between one of 2 options, either the word roll or the words new game. So I'll say if Tensies is true, question mark, then we want it to say new game, and otherwise we want it to say roll. Okay, let's save that, and we need to spell Tensies correctly, of course. Okay, let's see, we've got, well, it's not a great first roll, let's go with some 1s. And I'll play through this quickly so you don't have to watch me do this whole game. Okay, so clicking the last one should change Tensies to true and change roll into new game. Let's see if that works. Awesome. Well, I don't love that it's stacking on top of each other. I think I'll just go into the CSS and let's find my button here. And I think it's this one. Let's try making that 150 pixels. Yeah, that looks better. Okay, and then part 2 of the challenge is to render the confetti component if Tensies is true. Like I mentioned, I already included the React confetti package, but I do need to import the confetti component from React confetti. And again, we're only conditionally rendering this, and I included a little note here that tells you exactly where to render it. I'll keep my curly braces so I can use some JavaScript, and this time I'm just going to be using the logical AND operator, because in this case I either want to render confetti or I don't want it to render at all. So we'll say if Tensies is true, then we will render confetti. I'll hit refresh. And at this point, there's something important for you to know about this recording. At the current time, Scrimba is not really able to record anything that happens on a canvas element, which is how this confetti is being played. So I'll play through this game and I'm going to see the confetti work. You'll be able to also refresh this app and see the confetti work, but in the recording, it's not going to show up. So once again, I'll speed through this gameplay so you don't have to watch the whole thing. Okay, so I will click the 2, and sure enough, I can see the confetti dropping. I assume if you completed this challenge correctly, you also were able to see the confetti dropping. Or if you struggled with it, well, first of all, I'd encourage you to go back and try it again. But second of all, you can click to refresh this app now with the code that I've written and play the game and see that the confetti is working. Now, at this point, I'm pretty sure we still have a bug in our game, and that's if I click New Game. Yep, look at that. It says that we won again, and nothing has really refreshed or anything. So we'll have one more challenge before this project is complete, and we're going to handle that in the next screencast. Here's another example of a challenge that I'm going to be a bit vague about because I want you to think through what steps are going to be necessary to complete the challenge on your own. So the task is to allow the user to play a new game when the button is clicked and they've already won. I won't necessarily play through this entire game again, but you saw that when we clicked New Game, it just console logged you won again. And I want you to think through why that is and what you can do to fix it so that it will reset the game. Pause now and work on this challenge. As it stands, clicking the button will run the roll dice function. Currently, there's nothing in the roll dice function that will check if they've already won the game. Now, we could choose to create a completely separate function that will create a new game for us, which would require us to then conditionally render one of 2 buttons based on whether they have already won, or rather based on whether Tensies is true or not. Right now, we're only changing the text of the button when Tensies is true, but we're not creating a completely separate button with a different on-click handler. Either way would probably be fine. I think I'm just going to update our roll dice function to handle the instance when the user wins the game. Now, I really want them only to roll the dice if they don't have Tensies, if the game is not over. So I'm going to move this code into if Tensies, this conditional block here, and then I can add an else that says if Tensies is true, in other words, if they've won the game, then first I want to set Tensies to false because I don't want the game to still be won. And then I can generate all new dice. So I'll say set dice, and I previously wrote a function called all new dice that I can use to generate all my new dice. Okay, now let's play through the game one more time and see if we can get this to work. We'll start with our 4s this time. Oh, I'm going to switch to 6s because I have more of those. Okay, here we go. Okay, it says new game. We got that console log, which we can probably get rid of. Of course, the confetti package is celebrating our win. And then I click new game and everything restarts. And wow, look at that. 5 4s right off the bat. And at this point, we have reached the end of our journey together building the Tensies game. However, that doesn't mean it has to be the end. In the next screencast, I'm going to give you some ideas on how you might improve this game quite a bit more if you really want something that you can feel good about putting in your portfolio. We won't walk through how to create those features, but it could be a really excellent way for you to practice your skills instead of just moving forward. I hope you've enjoyed this Tensies game. It might not be quite as fun to play against the computer, but if you have some dice laying around, I do recommend playing Tensies. It can be really fun and high energy, especially when you're just trying to get that last dice to read the number that you need, and you're racing against other people. So on that note, let's take a look at some ways that you might be able to improve this project. Just because we have completed the Tensies project together does not mean that the fun has to stop there. Assuming you enjoyed this project even a little bit, I'd highly recommend that you spend some time adding to it. The process of adding new features to the program that we made together is going to expand your mind and really help you internalize the things that we have learned together thus far. I came up with a couple ideas. You are welcome to use them or to do something completely different. Some ideas for extra credit on this project include adding real dots on the dice. Right now we're just using numbers for simplicity in the CSS, but if you really want to challenge yourself with some CSS, figure out how to put real dots on the dice. More on the JavaScript side, you could decide to track the number of rolls that it took to win the game. Along those lines, you could track how long it took to win the game. And then you could save your best time or maybe even the lowest number of rolls to local storage so you can try to beat your record in the future. Obviously, this is not all inclusive. Be creative, add whatever you want to this project. In the end, being able to show an employer that you not only took a project that you built together in a tutorial, but also added a bunch of new features on top of it, that's going to be much more impressive on a resume and a portfolio than a project that you just sort of followed along with. Great job on the Tensies game. You should really be proud of yourself. And assuming you were able to follow along with everything and that you would even feel comfortable if, we needed to delete everything and start from scratch, that's an excellent sign that you have really learned what you need to learn from this React course. If you look back, it's pretty insane how much ground we have covered so far. So if you think about it, this is the ultimate solo project for this course. It's going to collect all of the topics that we have learned throughout this course and put it together into a single project so you can really test yourself to see if you have been internalizing all of this new React knowledge that you've been learning. And this project is a really fun one. You're going to be creating a trivia app called Quizzical. It'll have an opening screen here where you can click to start the quiz. It will then pull some trivia questions from a database and display those as a short quiz. Once the user has made all of their selections, they'll click Check Answers, and the app will score the quiz and allow them to play again if they want. Clicking on any of these screenshots will send you to the Figma design file. You can see the 3 different screens here. Just to be clear, this first screen will actually be almost like a separate screen. It's sort of an overlay. When someone clicks Start Quiz, you'll probably want to conditionally render this next section. But this third screen is not really a separate screen. It's just changing the first screen so that it gives feedback to the user on the quiz answers. As always, make sure that you go in and duplicate this to your draft so you can avoid seeing everyone's cursors or selections. And so if you want, you can make any edits to the design. And just like before, you can click the 3 dots down in the menu to fork this screencast to its own scrim for you to do all of your coding in. So let's take a look at the requirements for this project. Like I mentioned, there will be 2 screens, the first one that asks them to start the game, and the second one which has all of the questions in it. Your app should pull 5 questions from the Open Trivia Database API, which if you click the green text here, it will send you to that API. After the Check Answers button is clicked, it should tally the number of correct answers and display it at the bottom. And as always with these projects, you should make sure that they are styled and polished. Clicking the link here on this slide will send you to the Open Trivia Database, which is a really fun API to use. You can click in the upper right where it says API, which will lead you to this page. And it has a fun little Generate API URL button that you can click after putting in some specifics about the API. If you want, you can limit it to certain categories, difficulties, and so forth. And it'll just give you a URL that when you call it from your code will give you those trivia questions. As always, I highly encourage you to share your work. Click the Discord icon to go to the I Built This channel in Discord, or you can click the Twitter icon if you're sharing this in public. This project is probably a touch more difficult than what we have worked on together. So don't hesitate to tap into the Scrimba community, ask for help, and of course, when you're finished, be proud of the work that you've done and share it. So, best of luck working on this project, and I really look forward to seeing what you end up building. Before we wrap everything up, I wanted to let you know that I've made a sort of pseudo extension to this course that gives you a crash course on using class components in React. As React evolves, people are trending away from using classes in React, but there's still plenty of reasons to learn how to write React using the ES6 class syntax. In this 1-hour mini course, I talk about why they're important to learn and the ways in which they're different from writing React with function components and hooks. If you are hoping to get a job as a React developer, you will definitely want to take this course to brush up on class components, since you're very likely to come across existing code that is still using them. If you're watching this video now as a part of the Scrimba front-end developer career path and you already have a Scrimba Pro membership, then when you move on to the Advanced React course, this crash course will be the first thing that you go over. So you won't have to go out of your way to see this course, but for anybody else who's watching this course as a standalone free React course, you can click the screenshot that you see here, which will take you to the playlist for that course, and it's completely free to take. You did it. You really did it. It's been a long journey, but you have finally arrived at the end of this course. You should seriously be so proud of yourself because assuming you've actually followed along the whole way and done all the challenges, you are well on your way to becoming a serious React developer. I've said it before, but my learning philosophy is that the easiest way to get good at anything is to do it the hard way. As such, I've made it a point to include a lot of projects and hands-on work in this course. Let's take a quick look back at how those projects have progressed in each section. We started off by just working with some static pages in React. That allowed us to discover why we care about React, a bit about the JSX syntax and how to make our own custom components, how to apply our own styling so we can really polish our projects, and all of it collected together gave us the ability to build static pages. We used that knowledge to build our kind of silly little static page about fun facts about React. And for your solo project, you built a digital business card. In section 2, we moved on to learning how we can make data-driven pages in React. We discovered how to make our custom components more reusable by accepting props, and how we can make the data work for us by mapping over the data and using that to create multiple instances of our custom components using props to pass in specific data to each one. Then in section 3, we really turned it up to 11 because that's where we started making fully interactive web applications. We dove deep into understanding how to listen for events, how to save state and use state in our components, how to conditionally render certain things on the page, how to accept user input through forms, and how to handle all side effects that might happen using the useEffect hook. Then in section 4, we went all in on practice. We took some existing code with this Markdown Notes app and added a bunch of new features to it and fixed a few bugs. Then we built a dice game completely from scratch. And most impressively, in your solo project, you built a quiz app called Quizzical that accessed trivia questions from an API and scored people based on their answers. I purposefully put these projects in here to help drive forward the curriculum in this course, and each one of the solo projects you did gave you a chance to really test out your skills unassisted to make sure that you really internalize the topics that we learned about. This is truly a huge accomplishment, and you should be super proud of how far you've come. In fact, I think right now you should head over to the Today I Did channel on the Scrimba community Discord server and brag about finishing this React course as soon as you can. In fact, I made it so easy you can click this screenshot to head straight there. So what now? Well, there is a ton more to learn about React. But before I jump into the list on how you can dive even deeper into the waters of React, I'd recommend continuing to just practice everything that you have learned. This might be a great time to just use your imagination and pick a project that's similar in scope to the ones that we worked on in this course, and then just build it on your own. For example, if you don't already have your own portfolio site, you might even consider building one in React. That being said, the React ecosystem is quite large, and fortunately, the community is also quite large. So the first thing I can recommend is I have my own advanced React course on Scrimba. If you're taking this React course as a part of the Scrimba front-end developer career path, well, this advanced course is what you have coming up in the next module. One of the first things I recommend learning about is React Router. This allows you to make what's called a single-page application, which is, in a way, the opposite of what it sounds like. It means that you can add multiple routes to your website so that it becomes a little more like a regular website. Everything we've done so far has just lived in essentially one little page. React Router allows you to make a multi-page website. You can also learn something called CSS in JS. My personal favorite is a library called Styled Components, but there's a bunch of these out there. Essentially, they allow you to put your CSS directly inside your JavaScript so that you can co-locate the styles with your actual code. If you want to branch out a bit more, you can start looking at Next.js or Gatsby. These are both some really evolved and powerful frameworks that are built on top of React to help you build some really robust static websites or even full dynamic web applications. If you wanted to get deep in the nitty-gritty, you could also start learning about performance and optimization if your codebase gets more and more complex, or you're working in an existing codebase that really needs to squeeze every ounce of optimization out of it, then jumping into this realm might help you as a developer. And in this course, we only touched on 2 of the existing hooks, use state and use effect, but there are a bunch more that you can learn about as well. I'm so grateful that I've had the opportunity to prepare and to teach this React course. My name is Bob Ziroll. I've been your instructor through this course. My username is Bob Ziroll pretty much everywhere online, but these days I'm mostly just active on Twitter, so you're welcome to follow me there if you like. You can click the Twitter icon to go to my profile page. Once again, congratulations on completing this course. I'm excited to hear about all the ways in which you're able to apply everything that you've learned. I'm truly excited to hear from you. I love getting constructive feedback on the course. If you have any suggestions for me, I welcome them with open arms. And I'm excited to hear from you about all the ways in which you're able to apply everything that you've learned here.